Hi guys, welcome to the Game Asset Pack. Now in this section we are going to be mainly focused on interior modelling and also focusing on level of detail and baking. So what is all that about, Ben?
Well, let's take them one at a time. Level of detail. So the idea with level of detail is that your models need to be created not just as a single high detail model, but for purposes of A, saving your bacon, which we'll talk about in a minute, and B, making sure that in the game engine the models are provided at various different levels of detail.
Yes.
So that the thing can perform properly. At a long distance, you don't want a car to have 1,000 million polygons on it. It wants to be a very simple little block.
Yes.
Yeah. So as the model moves further away, you can afford to have less detail, and then the computer can spend less time rendering it. So that's the idea of level of detail.
Yeah.
Baking, what's that all about, Mikey?
So baking is where you've worked your way up to a high polygon model and you've got all of this detail in the geometry. Well, some of that detail doesn't actually need to be geometry. We can bake it, solidify it as an image, as a texture, and then apply it to a plane surface and make that plane surface look like it's got incredible detail on it. So wonderful tool, and again, it's optimized not only for game performance, but in Blender itself, it improves the render times.
Wonderful. So these are really useful tools, even if you stay inside Blender. If you go outside of Blender, it's going to be even more valuable because when you're in a real-time environment, both of these things are super vital, right?
Yeah.
So how's the section laid out, Mikey? What are they going to do in terms of building these models? Are they going to start with a high detail model and then go down, or the other way?
No. It's quite easy for you guys to hop in, and we'll go into this in much more detail, to really focus on this high detail model, and that can take hours and hours of your work. What's more important, and like we've done in all the other sections, is to have a placeholder in place. So the right size, dimensions, and overall shape, and then build upon that detail. And we'll be really focusing on that, making sure it's very much a lean process, so you're not wasting time.
So I said earlier that it's going to save your bacon if we think about level of detail. The reason is this. You're being contracted by a client to make something. Say it's a chair or a sofa, whatever. Let's say a sofa. And they ask you to make a sofa. If you make a high poly model of that sofa and show it to them and they don't like it, you've just wasted days, weeks, who knows. See, to get a simple placeholder for a sofa takes minutes.
Yes.
To get the next level of detail up, a little bit more, could take
tens of minutes. So maybe an hour.
And to go to the next level of detail could take days and then maybe weeks to really finish it off, right? So what we want you to do is be sure that the thing is going to be used. So we want you to provide your client, whoever that might be, with a model that is low and simple detail. Get their feedback.
Yes.
Then spend more time.
Very
and then
important.
if there is waste, you minimize that waste.
Yeah, we don't want wasted time. We've already got enough time waiting for things to render. Don't want to waste time modeling as well. So this part of the course is currently early access, and what that means is it is subject to change, and we very highly value your guys' feedback.
Yeah, so just in the discussions, anything you want to say, you'll have a bit of a chance to steer the direction of the section. You might be wondering, by the way, why there's a Gothic church section below this part of the course. That section is going to disappear from the course in a few weeks' time. It's just there because it was older content that's being replaced with this section. Mikey's going to be adding videos. How many a week, Mikey, are you going to be adding to this section?
At least 10 a week.
So Mikey's aiming to add 10 videos a week to this section. Just stay in this section, keep consuming it, keep watching it, and it's going to be great.
Okay, guys, let's dive into Blender.
He always says that.
I say hop on over usually.
That's true. See ya.
Okay, so let's talk about our project specification, what we're going to be doing in this section, and what to expect. So we're going to be creating assets to be exported straight to an external program, like a game engine or anything else you may work with externally. We will be creating our own textures and other maps from high detail models and applying them to the low polygon version. We'll be focused on modelling the interior of a building. In this case, I'm going to choose a Gothic church. You can model your own house with the lessons learnt in this video. It's entirely up to you. Now, more on the product specification. You can use any of these techniques, whether it's going to be level of detail or whether it's going to be baking some textures. And of course, there's more on that in the section itself. But you can use this technique within Blender itself for optimization to not increase your render times, increase your efficiency by lowering your render times. And that's very important. As we've already experienced, render times can take hours or even days. Some of you with the animations back in the animated lamp, I know, had to leave their computers running for a couple of days to get that out there. So if we can make this a little more optimized, then we can certainly get things out quicker and, more importantly, iterate more, which means we get a better end result. Now, I'm going to be testing my model externally as I go, so you guys can appreciate that impact on externally. And we'll be looking at level of detail in detail. So more on this, I'm going to be keeping my scene relatively simple, primarily for teaching purposes, but of course I encourage you to go to the nth degree and get some really detailed models going. I encourage you to add more detail, experiment and have fun. For instance, wouldn't the scene look a little more interesting with a chess set in it? Okay guys, let's move on now to the next lecture. Welcome to Planning Your Project. In this video, you will plan your project defining its scope and your goals. It is important to make sure we prevent scope slip. We're going to gather your reference material. Now, if possible, explore real-world locations to get a feeling of the environment. Scour the web for your reference images as well. Now, we'll be focusing on building blocks and modular thinking. Now we're going to be thinking about the ways that you make parts reusable and modular so they connect together easily, so you don't have to make bespoke parts every single time. If you think about Lego, that great kids and adults toy, there's a lot of modularity with it. You can make pretty much anything your imagination has, but it does have some restrictions too. Obviously, it's quite blocky. Fortunately, with Blender, we don't have quite that restriction. Now realise that this gives you very quick iterations because you can put things together and take them apart because they're made of modules, and it's great for prototyping from only a few parts. So you can build up a building very quickly with a couple of squished cubes. Now, if you're a supplier of assets to a level maker, or even if you've got multiple hats on yourself, you're going to love the way that they can redesign a level with your assets. If you give them one building completely constructed, they're going to struggle modifying it. However, if you give them all the pieces to construct any room, then they'll be able to make any other room from those. And similarly, the same when you're modeling inside Blender itself. It means that once you've made, let's say, a wall section, you can use that repeatedly rather than making different shaped and sized walls. So I've got a challenge for you to kick off this section. I'd like you to plan your building or room that you're going to be working with. So go ahead and gather lots of reference material. Go ahead, take photos, look around you if you're in a building with lots of different things. I'm looking around me right now and I can see an interior environment that's got a sink, water jugs, a couple of plants, cupboards. There's lots of things that you can include. And remember, of course, things like walls and windows and doors. They're very important. Of course, I don't want you to go over the top at this point in time because we're not focused on micro detail. So focus on the main items at the moment, the big things that support everything else. The walls, the ceiling, the floor, doorways, even to chair and table level as well. So we can start fleshing out a room as well. Then I'd like you to go ahead and list at least 10 models you want to include in your interior design. Now remember that I'm going to be focused on this Gothic church style building. However, you can just model the one you're sat in right now. That'll be a good challenge. And remember, you need at least 10 individual models that you're going to be making. List them, don't go ahead and make them just yet. We've got some other things to cover first that you want to include inside this building. Sketch your design and share your goal in the discussions. Pause the video now and give that a go. Okay guys, welcome back. How did you get on? What did you decide to go ahead and model? What type of interior are you going for? This is my rough sketch of where I'm going. I've got the stained glass windows perhaps at the end. I've got a rough shape of the building. I've got some pillars, some chandeliers, perhaps candles hanging down there. Lots of different options that I can go for here. But this is a rough sketch to get it into my head, the rough plan. Of course, this is subject subject to change as we go through, as it is a beginning point. It gives me an idea and a direction to travel in. Okay, so finally the list of components and items that I'm going to be, what I think so far, putting into my Gothic church. So I've got a blank wall with a window, wall with doorway, a bench, an altar twice apparently, but large windows, floor tiles, archways, candle stands, carpet, etc. Just to bring this place to life. Now, what have you guys got? I'd love to hear your suggestions as to what you're going to include in your scene. In fact, are you going to go along with me and make a Gothic church? Or are you going to make another indoor environment? Please share that in the discussions, and I will see you guys in the next lecture. Welcome to version control. Now, in order to make sure that we've got good control over our model and the stages of which we produce it, we can use something called a version control system, and that allows us to step back in time and correct things or go off in a different direction without endangering our original model. Now, I'm going to pass you across to Ben now, who's going to go through version control in more detail.
Hi, so let's have an overview of source control. I'm going to explain the what and the why of version control systems. We're going to be choosing a version control system, VCS, from now on. We'll talk a little bit about what files to include or exclude from your version control. You'll see over the coming lectures how committing is saving a local snapshot of your work at this point in time, and how resetting is rolling back to a previous state that you had before, basically getting you out of trouble. And we'll leave things like branching and pushing and large file support and other technical terms of source control till much later in the course, if at all, if needed. So, firstly, what are version control systems? They're get out of jail cards, if you like. These things are going to allow you to keep very detailed histories of your work and make sure that you can go back to your work in a state that was working and all hanging together properly at any point in time, which is going to be extremely useful. It's also very useful when you're working with other people. There's a load of different systems out there. Git is one of the most popular and becoming more popular very fast. Mercurial is another. Perforce, Subversion, SVN for short, or Tortoise SVN. Or Alien Brain. This is great for art, and it's very good for things like seeing the difference between two different image files, etc. But it's of the order of $10,000. It's out of most people's budget, but it is worth considering if you're primarily wanting to control the versions of your art files. Have a look on Wikipedia there for a complete comparison of all version control software that, well, at least all of it that's on Wikipedia. So we're going to use something called SourceTree. So SourceTree is free software by a company called Atlassian. Why do they give it away for free? Probably because it's very easy to use it with their Bitbucket service, which does have a paid tier, which is the online portion. We're just focusing on local source control for now, just on keeping on your computer local versions of your files. Of course, you need to be backing up your whole computer and your files anyway, and whatever strategy you're using for backup, whether it's CrashPlan or Backblaze or hard drives or all of the above, hopefully, if you're belt and braces, then your source control system will be backed up with that. So we're just talking about local source control. SourceTree is a visual front end for Git or Mercurial. So Git and Mercurial are two version control systems. They work slightly differently behind the scenes. Both are pretty applicable to what we're doing here. But we're going to be using Git, and we're going to be using SourceTree as a front end to Git. It just makes it a lot easier when you're learning and when you're using it to visualize what's going on. There's Mac and PC versions of SourceTree, but the Mac version's a little ahead, so the PC version tends to be lacking a few features, not quite as pretty looking, etc. And as I say, it's really good when you're learning. It's really easy to visualize using SourceTree. So that's why we're going to be showing you SourceTree. So it's challenge time. I want you to install your version control system. Pick a version control system for yourself. If you're already using one, don't change at this stage, just for us. Please just carry on. But if you're not, then we'll be using SourceTree. Now, SourceTree is available for free from Atlassian's website. Just do a Google search for SourceTree. And you will find that also comes bundled with Git. And it really makes life very easy, especially on Windows, because it just provides you with an entire environment. Git's all kind of bundled in. You don't have to be messing around with command line interfaces and stuff like that. So just go and grab SourceTree if you're new to source control. We can always dive into the details and the command line stuff and the sort of things you might see on forums if you do some searching later. But for now, just consider SourceTree. Install and register it. You will need to register it, at least within the first 30 days. And have a quick play stroke experiment. You really can't do any harm, so just make a folder, have a quick play, and as soon as you feel like you're not getting anywhere, then carry on watching the videos, and I will show you around SourceTree that I already have installed on my machine. So go ahead, pause the video, and get yourself your version control system installed now. Hey, welcome back. So this is where you go to get SourceTree. If you do a search for SourceTree, I just want to show you their official page just in case you end up somewhere funny on the web. It's a strange place, the internet. SourceTreeApp.com. There you go. SourceTree. And it'll detect your operating system and let you download. It's going to look something like this when it's installed. Now, I'm not going to go through the install and setup. It is just a piece of software. And the hardest bit maybe is you just need to register with them. But you don't even need to do that until 30 days in, I don't think. So once you've installed SourceTree, it'll open up something like this. So this is a project I've been working on recently for the Unreal course. It's a piece of code called Bull Cow Game. And this is the interface. It's prettier on Mac. So if you're taking this course on Mac, you'll be lamenting the fact that it's prettier. It's also prettier than this on a PC with a higher resolution screen. I'm running at 720p high DPI, so it all looks a bit funny, but it's here. Now, the things that you need to focus on really is we're going to have one or more repositories. Now, what are they? Basically, it's a folder containing all of your work for this section. So in a particular section of the course, all your work's going to go in one folder. And that will map to this repo on the left here. So each section will have one. And then all of these things are actually the videos. This is the last section that I produced over in the Unreal course. And each of these stages exactly what I did in that video. Now, the great thing with code is you can see precisely what changed. I can see exactly what I added to this file in this particular revision in video 10. If you're using binary assets, Blender files, image files, etc., you're not going to be able to see the details using SourceTree of what's changed, but it's still going to keep a perfect history for you of exactly how things were at particular stages in time. So I'm not going to tell you how to use this now. That's going to be in the upcoming videos. I just want you to quickly get your eye in. What it's going to be doing for you once you've set it up is this big panel here is going to show you what's changed since the last time. You'll be able to see things called unstaged files. And you'll get to choose to stage these files and then to commit them, which committing is a bit like bundling them up into a zip file and sticking them off to one side, saying, yep, I've got to that stage, it's done, I want to record that as a standpoint in history. So that's what a commit is. And then you're also going to be able to see later how you can actually go back to a previous point in time a couple of different ways. And we'll be showing you checkout and reset and the difference between those. But for now, all you need to know is this is a way of storing a very powerful history with the detail of at least what files have changed. And if you've got text in your files, then you're going to be able to even see precisely what's changed. And this means that if you always commit or save your work in a working state, if everything goes wrong and suddenly your whole project doesn't hang together properly, you can go back to a previous point in time and you are back out of trouble and able to carry on working. So that's an overview of source control. Over the coming videos, you're going to see exactly how we use it, and it's going to be a whole new way of thinking for you. You'll hate it at first if you're new to it, and then you'll love it soon after. See you soon.
Welcome to File Structure and Naming. In this video, you'll understand that there is no one way of setting up your filing system. That's certainly true, and it will often depend on the project itself. Now, if you have a personal style of filing and you don't like mine, use yours. That's absolutely fine. And of course, remember to talk with your team. You will form guidelines based from your own needs and experience moving forward. Now, there is some rigidity. In a team environment, you will have guidelines so you can discuss with colleagues what you actually need for the particular project you're working on. And it can change from project to project. Now, some software might expect certain things to be stored and named in a certain way. So if you've got those constraints, it's best to set it up from the very start to match what other software might be expecting. Now, moving on to naming, very important. In a team, or if you're just working yourself with a large project, it is very critical that you can find your assets, materials, textures, or whatever you've been creating. So naming files well will help you and others find them and know what they are by just reading the name. There are some naming conventions that we will use in this section, and we'll get to those when we need to. So at Blender itself, in the actual program, not the file system, we're going to be making much more complex scenes than we've previously made. organize it as you go. Not afterwards when it's a complete mess. Organize it as you go so it never becomes a complete mess. And use descriptive names. Cube and cube 001, etc. is not helpful to anyone, especially not yourself. It's really easy to get in a pickle when you're focused on the modeling. You look over at your outliner and you just hang your head in shame and despair because there's no way you can work out what anything is anymore. So let's just have a quick look how I've got my system set up. So I am, of course, on a Mac here, and I have my home directory, Michael Bridges, and within that itself, I have a folder called Repos. Now, the reason why I have a folder called Repos is that's where the repository is going to be, so we can actually start using SourceTree. We've got it all set up now, but there's no point in, well, we can't do anything in it yet until we have made our file system. So let's go ahead, and as you can see here in the repos, I've got the various sections of the course because I use the VCS to manage the actual lectures themselves. So mine will end up looking slightly different from yours as we hop in and out of SourceTree, but don't worry about that. In fact, everybody's is going to look completely different depending on how you've set things up. So if I go into the game asset pack now, we can see I've got a README file in there. That's just a description. The .md means markdown. It could just as easily be a text file. And I've created two folders here. An example one, sound, for instance, if you were working by adding sound into your scene as well. But the main one here for us is an assets folder. And inside there, I've got meshes and textures. Those are the two main ones that we're going to need to move forward, and I've created just a shortcut here, and we'll go into more details of what all those hieroglyphics there mean in terms of the texture naming conventions, and then the meshes themselves, what that is going to mean as well. So there's lots of things that you can do in terms of filing. You could store all of your stuff in one particular folder for one particular model and group everything by that particular model itself. I am going to go for more of a flat approach. I would recommend not going more than 3 levels deep because then it becomes a bit unwieldy. And if you've got to go 3 levels just for one item, that's going to be time consuming. And again, if you've named your files appropriately, you should also be able to use your built-in search function in order to find items, especially once it gets much busier in our file system. It's challenge time. I'd like you to set up your working directory. So place your reference material that you've gathered here, create your necessary folders that you require. Remember, there isn't a right way of doing this. And, of course, be prepared to reorganize later if you find it isn't quite working out. Just bear in mind, when you start moving things, you break links. So it is important that we don't break too many links if you need to reorganize later. I'd love to see how you guys have set up your working directory. Are you going for a similar method that I am, or have you gone for a completely different method? Please share your work in the discussions. This will be the end of this lecture. I'm not going to ask you to pause and go away. Just go ahead and go do that, and I will see you guys in the next lecture. Okay, so we are almost there where we can start actually making stuff in Blender, but there's a couple of things that we have to do first. The first one is level of detail. So welcome to level of detail, or LOD, LOD as its abbreviation. Now in this video you will focus on representations of the right size and shape, but just block work models. That's very important because that allows quick iteration of your models. Remember, higher detail often requires more processing time too. So not only do you have to input more time, but if there are more vertices to be calculated in a scene, the actual rendering time later on will take longer as well. So LOD numbers and letters. Well, LOD numbers are quite a common thing, and they range from the highest detail LOD 0, or the base mesh, and it goes up in numbers. So LOD 0 often refers to the highest detail model, sometimes called the base model. Now, to avoid confusion with this, we are going to use letters. Okay, now bear with me on this, it will become clearer as we go. Because we're starting and being nice and lean with low poly box models, we don't know what the highest level of detail model we're going to create is at the moment. So the letter A, so LODA, represents the lowest polygon model, with B, C, D, etc. increasing in detail. Now you do have to watch your time versus your level of detail. So the level of detail and time are usually directly proportional to one another. The more detail contained within your model, it's likely it's taking you longer to produce that model in the first place. Now, when fleshing out a scene and prototyping, you probably want quite a few assets, and you want to do that quickly. And you can test models in your scene when you set things up nice and quickly. That is very important. We don't want to get bogged down creating an asset that may never be used in our scene or we don't like. Say you decided to make a bench in the church or at home, and if you decided to make a sofa, well, you can test the model and make sure it fits properly. And let's take a sofa for a quick example. If we decided, well, actually, I want a 3-seat sofa rather than a 2-seat sofa, well, if you've already spent all that time modelling a 2-seat sofa, you might be able to expand it and work around it. But if you would put it into your scene in the first place, a low poly representation of it, and then decided, well, no, I want a 3. You can do that really quickly without having binning your asset that you've created, and of course, binning the time that you've used to create that. Now, level of detail versus the time taken example. Now, these are only rough guidelines. Don't take these accurately because some models can vary significantly. But what is important when we're talking about the polygon level here is that each polygon is actually doing something. It's not wasted geometry. So we've got levels A, B, C, and D, etc. An example here of around 200, 2,000, 20,000, and 200,000 polygons. Now the time taken, again, this is approximate. It will depend on the model, but you will find that you can mock up something very quickly that's a block model and is just a representation of the item, the right size and shape, in around 30 minutes or so. Maybe less if it's a more simple one, and maybe a little more if it's a little more complex. And from that, you can start to derive more and more detail. So a slightly more detailed one may take you a couple of hours. A highly detailed one may take you a whole day to work. And then finally, of course, we can all spend weeks on a project. But we need to make sure that if we ever go up to certainly the level C and D, that we need that level of detail. You may find that you're going to create something that sits at the back of a room that's far away from your camera angle and therefore never needs to be that detailed. So each polygon counts in this example, and the time taken includes other artwork too. That is very important because if we don't have the time included to make the other artwork, we're just talking about meshes. Now, on the basic level of detail, it is unlikely you're going to have anything else but maybe a base color to your model. No, very rarely would you add textures and things like that on at that level. Once you go up to B, C, and D, you're going to start to want to make normal maps, diffuse maps, and we'll go into those in much more detail later on in this section. Okay guys, so it's challenge time. I'd like you to list your models. Now, you already have a series of assets that you want to create, so we can refer to that list. But we need to bulk it out a little more. So what assets do you need? That's very important, because that is different from what assets do you want. So if you were making a room, the walls are a necessity. A certain item in the room, a small object, is something you may want in the scene to add a bit more detail, to add a bit more nuance to the scene. Now, which assets will help bring life to your scene? What's in the room that you're creating that's going to add to make it look lived in or used? Remember, at this point, we really want to break complex models down into components. This is both for easier building and modification. So go ahead, pause the video now, and go through and think carefully about what you're going to put into your scene. Okay guys, welcome back. Well, I'm going to go through my scene now that I'm creating and think about carefully what I need in my scene, what I want in my scene, anything extra that's going to help bring a bit more life to the scene itself. Whether or not I've got a few ideas in my mind, and of course this is the idea time. This is where we want to be nice and quick so we can model things and get the idea coming to life. And then finally, I'll be having a look at what is complex and actually can be broken down into components so it's easier to build, easier to modify, and in general work with. Okay, so back over to that Trello board that I was working with earlier. I've removed that duplicate altar. I thought that was a bit cheating, having, well, at least it was down to 10. Anyway, so I've broken my, first of all, into what I need and what I would like to have in my scene. So it wouldn't be a church without an altar in it. I certainly need some blank walls. In fact, the blank walls, the wall with the window, the large windows, the archways, etc., can all be classed as structural items. So I've done a bit of color coding here, and I'm halfway through. This is how I'm managing my project here as such. I'm using the Trello and I'm using some colors. So the blank wall is actually part of a modular. And I've got some labels here. Now, I'm just going to explain to you my thinking behind this. So I don't know actually what the end item will be, but I'm taking a guess at the moment as to what level of detail I'll be going to with these particular items. So in this case, a blank wall, I'm figuring is going to be pretty low detail. It's at worst, it's probably going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be a stretched cube, basically. It's also part of a component module. It's actually part of the building. Now, I could build the building as one big mesh, but that would create problems further down the line. If I needed to alter something, I'm a bit stuck. At least if I've made it out of components, it's much easier to alter. So I'm going to add a component and a modular item to that. And the same with the large windows. I'm going to make those so they slot in with the building. Now, I can imagine the large windows requiring a high level of detail because they are going to be one of the perhaps one of the focal points as I'm looking down the church towards those large windows that tend to exist at the end. I'm probably going to want some high detail in them so they look awesome. Otherwise, I would lose out on that. And again, it's a component and modular. And we can go down and we can see what's come here. Now, the floor tiles, I may vary them from area to area. Archways, again, they're actually part of the building structure. So a lot of these things, as you can see, are modular and I can put them all together. Now, unsurprisingly, the things that give the scene the most life and vibrance are probably things I want to have in the scene, not necessarily need at this point. We cannot construct this building without some fundamental building blocks. However, there are certain things that I would like to add in later in. Things like a carpet or a rug on the floor, some candles. Of course, if you were making another interior, you might go, well, I've got a desk in the room, but there's nothing on the desk. Perhaps I need a pot in there. Or if you're modelling a kitchen, well, you can make it look really stark, but real kitchens have lots of clutter in them. And those are things that are models that you probably want to have in your scene, but not necessarily need at the moment to get the general layout and feel. So it's important to make that distinction at this point in time. Now, there are a couple of things that I've also thought about a long distance away. So I'm thinking, not sure at the moment, that I'm only going to be wanting to look from probably the back of the church to the front or the front to the back. I'm not sure which way around these things are. Towards the altar, basically, looking from the doorway, if you imagine one long corridor like I drew earlier. Now, the altar itself is going to be lower detail. It doesn't have to be high detail because we're going nowhere near it. So that's why it's only a medium. And then the ceiling, well, I'm not actually sure if we're ever going to see the ceiling. So there is a case point to not modelling it at all, but I'm just going to put it in as a low poly model, and that's probably as far as we're going to take it. How did you guys get on? How did you structure your scene? Did you come out thinking, well, hang on a minute, there are tons of models I want and only a few that I need? Well, often I could have filled this model list up with tons and tons of other items, but it is important to help focus on what you really need for your scene to work, how to prototype it. You don't want to be going ahead and modeling tiny items in your scene when you've not even gotten the full thing laid out yet. So please share what you've come up with in the discussions, and I will see you guys in the next lecture. Hi guys, welcome to Building Blocks, and we're going to be talking about simple shapes initially. And this is going to be where we can crack open Blender and start making some stuff as well. So simple shapes that go together well. Well, they're all basically triangles. A right-angled triangle is a square split in two, and that can also make a hexagon, which is three general shapes, basic geometric shapes that tessellate all the time perfectly. So this is just an example of size, of course. A right-angled triangle whose sides are 1 and 1 and the square root of 2 on the long side there would go together perfectly with a square that's 1 by 1, and of course any other integer rectangles that are 1 by 1. 1 by 2, 1 by 3, whatever. Those will all go together well. Obviously, we don't want two smaller building blocks and we don't want two larger building blocks because that doesn't give us much in the way of flexibility. You can have an isosceles triangle whose base is 1 and the sides are 2 in length, which is very useful for roof components and things like that. And equilateral triangles of side length 1 as well. These will all fit together really well and consistently. Now, those are very basic shapes, so what are the disadvantages? None. At this stage. Later on, it can feel and is restrictive. That is where you want to be customizing and adding detail, not in the early stages. We really want to be quick and effortless with our development at this stage. We'll also be seeing that you can type formulas in the fields in Blender, which is incredibly powerful. And we can use this to solve otherwise complicated measurements in Blender. So let's go make some simple shapes and hop straight on over into Blender. Okay, so now we're back over in Blender. Our first thing I'm going to do is show you the two things that I've already created. Now, bear in mind, I'm in my game asset pack folder that I've created under assets under meshes. So I have gone ahead and created a mesh object that's a square with the sizes and dimensions here. It's 2 by 2 by 2.5 in the outliner. And that matches the name of the file as well. We've got the origin at 0 and it comes out by 0.25 in height. Nice, simple, straightforward shape to make. And of course, we may come back and alter that later, perhaps move the origin itself to a more appropriate location if necessary. Or if we find we're needing to import these more vertically than flat, which may be an option, then we can rotate it round and save it again. The other one is simply this cut in half. Let's go and open that now. And that's the right-angled triangle. And that is exactly the same as a square. It's just chopped in half. And that will help us with any corner pieces or braces that we need to put together. Perfect. So let's go and hop over to something more exciting. I'm going to open up a brand new Blender file. And let's go ahead and make the equilateral triangle. Now, this is probably the first and only time I've used Pythagoras since I've left school. I knew there was a reason for it, but no one really filled me in with the details. So I'm going to add a mesh, but this time I'm not going to add a plane or anything along these lines. I'm going to add a single vertex. Now, if you can't see these options that I'm currently using, that means you've not turned on something in the user preferences and add-ons. We've used it in previous ones, but if I just type in here mesh, well, it should give us the thing. Is it not mesh? Let's just have a look down here. Sorry, yes, it's add mesh extra objects. You need to make sure that is ticked, and of course save your user settings as well at the end. So add mesh extra objects, make sure there's a tick in that box. Okay, so I'm going to add a single vertex, which is very powerful because I don't want to end up having to delete lots of things. There's loads of ways that you can make an equilateral triangle. Now I want it by 2, 2 and 2, so it's equilaterals, all angles are equal, all side lengths are equal as well. So I'm going to extrude this on the y-axis in the positive direction by 2, and then it's going to line up with our other models that we've made. Now the question is here, so let's spin this round so vertical's going up. So the question is here, how do I make these sides and angles right? Because unfortunately, Blender can show you the angle that you've moved a line relative to another, but it cannot give you accurate angles. You can't say, I want this at 60 degrees, which would be the equilateral triangle. It would make it a lot easier, but unfortunately you cannot do that. So what we can do is select this edge and split it in two. And when we split it in two, we're essentially making the equilateral triangle out of two right-handed triangles. And I'm going to have to scratch my head for a few moments whilst I figure out the maths involved. This bottom one, if I remember correctly, the two right-angled sides are labelled A and B. And then the diagonal moving across is C, and it's a squared plus b squared equals c squared. Hooray, I remembered. So we need to find out this one here. No, we don't. That's 1. So this one's here is going to be 2. So that's going to be 2. This one's going to be 1. So 1 squared plus something squared equals 2 squared. And we can break that down. We know that this is probably going to be 4. This half squared is going to be 0.25, and there's an unknown here. So what we can do here is go ahead and select the vertex that we've just created by subdividing, which is smack bang in the middle, and extrude in the x direction by, it doesn't matter. Because what we can then do is either in this vector area down here in the tool shelf, or indeed on the properties panel, we've got an x-coordinate for the vertex itself, and that means we can type in a formula here, which is really, really powerful. Okay, so let's go ahead, and whatever we're going to have here is going to be the square root of something. And the shortcut for the syntax, what you need to type for square root is SQRT, square root. And then we need to open brackets and put whatever we're square rooting in there. So for instance, if we put 9 in there, the answer will be 3. When we click on that again, it doesn't keep the formula. That is important. It's not like Excel where you calculate a formula and it keeps the formula in the background. It just gives you the result of that. So SQRT, open brackets. Okay, so we're going to have, let's just see here. There's going to be 4, which is 2 squared, which will be this long edge here. So the square root of 4 minus... So not the square root of 4, the square root of 2, which is 4. Sorry, the square of 2, which is 4. Oh dear, this is complicated. And then finally this bottom bit, which is 1. So 4 minus 1, because 1 squared is 1. Okay, so that is the square root of 3. So let's go ahead and do that now. 1.73. Now what we should find now is that when we join here and here up, there we go, we'll fill that in and then do this one. I'm going to remove this vertex in the middle and keep it as one solid line. Finally filling in the face, and the other ones were 0.25 too, so it makes sense here to go 0.25, and then of course we can name it appropriately as well. Now it does look like here that I've gone the wrong way, so let's just try extruding again by is this minus 0.25? Have I made my I think yeah, it's flipped around. So I'm just going to flip the normals there. There we go. And now when I extrude in the z-axis by 0.25, it should go in the, sorry, z-axis, not x-axis. Yeah, there we go. It's gone up by the right amount. Now, of course, have I named things appropriately? It's just called vert at the moment. That is no good. So this is a, it's an static mesh because it's not deforming in any way and doesn't have a skeleton associated with it. What do we need to call this? An EQ triangle, and it's simply 2. I don't need to give any more information than that because it's going to be 2 by 2 by 2. There you go, 2 by 2.45. And then I'm just going to highlight that all and copy that so I can actually save it. And remember, we're going to save that in our directory. So let's go ahead and have that there. So there we go. Excellent. So we've got that one all laid out here. And of course, it's time for you guys to have a challenge. Okay, I'd like you to make some basic building blocks. So go ahead and make an isosceles triangle with a base of 2 and sides of 4 blender units in length. You can use the technique that we've gone through, or you could use any other technique that you so wish. Make sure it has a thickness of 0.25. Now create the plane and make it into a 3D object of 0.25 in thickness and the right-angled triangle, which you should be able to derive from the square that you've extruded out. Make a basic wall with a doorway and window in it. So you're going to take that basic plane that you've got and start modifying it slightly to create a doorway and a window. Don't worry about anything fancy at this point. Make the doorway a simple rectangle cutout and the same with the window as well. In fact, you can make the window a smaller square in the middle. I would recommend a size. At the moment we've got 2 by 2, but a nice size, and you don't have to stick to this, it's a recommendation, is 3 in height by 4 in width by 0.25 in the depth itself. And of course, if you were making different thickness walls, then you wouldn't have to use 0.25 at all for the size in all of our wall sections at this particular point. And remember to save each mesh individually. So pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender. Okay, so let's go ahead and start with this. Now, it is almost a isosceles triangle. We just need to position these vertices in a certain place. We know it's starting from 0. So we can convert this once again into 2 right-hand triangles and work it out from there. We need to know this height, so it's going to be another square root, so SQRT. So the length along here, of course, is going to have a base of 2, but this is half of that, so it's 1. So, and it's going to be something else minus that 1. So let's have a look. This edge here is going to be a 4 in length. So let's pop the 4 in. Now that's it, and it needs to be squared. So this is going to be 15. It's going to be the square root of 15. It's 16, which is 4 squared minus 1 squared, which is 1. So the square root of 15. There we go. So that is going to give us, and again, I can do that here, square root 15. I could delete it and extrude. I'm not too fussed. But there we go. There's our isosceles triangle. We can make that very quickly. And I'm pretty sure that this length here, and we should verify that really. So let's go down in the display options down here. And at some point, here we go. Overlays, mesh display, edge info, length. So if we switch to length here and select that, 4, we can see that the length is 4 there. It's quite hard to see, it's a small number on the screen, but 4. So we know that that's worked perfectly. So of course I'm going to static mesh IS triangle, or EIS, I missed the thing there, EIS triangle 2 by 4 by 0.25. So that's fine. I'm going to copy all of that and go ahead and save that as, and paste that in. Perfect. Save. Okay, so the next thing that I'm going to do is start with I'm going to start with a different shaped plane this time. I'm going to draw it with that vertex. So let's get rid of him and these from our scene. Go ahead, add a mesh, and I'm just going to add a single vertex, and that's going to sit at our origin, which is fine. I want to work in the positive direction, so let's extrude this by 4 in this direction, so 4 in the Y, so Y 4. Let's then extrude that up in the x-axis by 3, and that gives us an opportunity, of course, to create a doorway in the middle, and we can create various ways of doing this. In fact, because we're working in whole Blender units here, I'm going to abort what I'm doing. Don't like what I'm doing anymore. I'm going to change it to increments, which we can see it's already turned on to on the snapping, and just turn on snapping. Now what this means is it's going to move in increments, which is really nice because I can go across here, extrude and go up by 2 in the x-axis. There we go. Make sure I am still there. I'm going to view it from the top to prevent funny stuff from happening. Okay, I'm going to have to make it on its side, but that's fine. I'm going to go to there and then back down. And then I'm going to go across for the other 4. Now, oh, that's too far, isn't it? 1, 2, 3, 4. So I should have stopped a bit further back. Oh dear. So let's pull that back to there. Perfect. I don't know how well you can see my grid. It's broken up into tenths of Blender units at the moment, which is very useful for placement. Of course, now I can go up by 3, across down to there, and then back to the start point. Now I'm probably going to have a double there because I didn't turn on merge vertices, so I'm going to highlight everything before I do anything else and hit space, and I'm just going to type in doubles here. I could probably hit doubles over the side, and there we go, remove 1 vertex. That's absolutely fine. Now, I could just make this into one huge n-gon at the moment. That's not a problem at all. Or I can make it into smaller ones. So this edge along the top, I could have split up here and here. But I'm just going to fill it in for the moment and then extrude it up by 0.25. So there we go. That is that one done. Of course, I can put this doorway in the center if I wanted to, but I'm going to leave it like that. Finally, I need to go ahead and name it and save it. So I'm going to call this SM Wall Door. So we know where it is, and it is 3 by 4 by 2.5. So that's height, 0.25, not 2.5. So that's height by width by depth, just to make sure you guys are following what I'm doing there. So I'm going to copy that, go ahead to here, and go in and save it. So let's save that. So we've building up a nice collection of building blocks here. Well, we're going to use them soon to build some stuff. But let's start a new file and do a very similar thing. Thought I could modify that, and I think that's going to be far too much to do compared to just adding a new vertex. And this time going through and making it ever so slightly different. So again, I'm going to go in a positive direction here, and again, the orientation, I might flip that one round later on. I'm going to make this one in the way that I can see here. So let's turn snapping on, incremental on, and we want to zoom in just a little and make it 4 by 3. So I'm going to go across by 4, up by 3, which is just there, and then back across again. Before I make that final one, I'm going to merge vertices when they meet one another, which is there. And I can just check up here, vertices 1 of 5, okay. That's not a 3D object, which is also good. Worthwhile spinning around and checking that. It shouldn't happen when in orthographic projection, but occasionally it does. That seems to have created 5 for whatever reason, so I again am going to remove doubles. Now, a couple of ways you can put a window in here. I'm going to fill it in first of all. Now, I could inset and have a window there. That gives me some control over what's going on. So I can move it in by 0.1, or I can move it in by whole Blender unit. That's absolutely fine. I want a bit more control over its placement and size, etc. So what I'm going to do here is actually subdivide it. So I'm going to subdivide once. That's not going to give us enough. I'm going to subdivide it again and literally take out this middle area here. So there, 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 and there. Or indeed, I could do any number of modifications here. Okay, now once I've done that, I'm going to hit the X key and delete the faces. That's those gone. I'm going to select our entire model, and I'm going to extrude it in the Z-axis by 0.25. That doesn't look like it's moved quite where I want it to. Let's spin around and have a look. Yeah, that's much better. Now, this is a wall, so it's on its side. So what we should do here is rotate it. So whenever we import it, we don't have to keep on rotating it. We can probably do that with our door section as well. I'm rapidly running out of time, so I'm just going to rotate this one round. I need to be in object mode at this point. There we go. So rotate on the x-axis, and it looks like the normals are not quite right here. I'm going to do that by 90, and I'm going to flip my normals. Hop into edit mode and flip them. I had that dark blue thing going on. So there we go. We've got a wall piece there, and we just need to do the same for the doors itself. And there we go, we've got some basic assets all made up and saved individually. How did you guys get on? Did you make a slightly different variant on these assets? Please share in the discussions, and I will see you in the next lecture. Welcome to setting up our repo and committing. In this video, we will set up our repository. We will register source tree, make sure that we can commit later on. Learn how to exclude data from our repository, stage our files, and then finally make our first commit. So one of the questions is how many repositories? Now, on a complex project, you could use a repo per model that you create. This would give you the best level of control. But in this case, it's going to be our models simply aren't that detailed to warrant a repository just for the model. So you could track your whole project in a repo, and that is what we're going to do. Of course, it will depend on the complexity of your project and how much control you need, and that's very important. Now, talking about our repository, which is going to store and track the changes in our project for us, we can exclude data from it. And we do that to allow faster commits at a smaller size, and that keeps the database, the repository, simple and manageable. We want to avoid storing derived or generated data in the repository wherever necessary. An example here, for instance, will be our reference material. They might be photos you gathered off the internet or even gone and taken yourself. Those are going to be static and not changing. There's no point in storing them, and they're very large files in comparison to everything else. So we will want to exclude them. Then we'll go on to committing, and it is important that you'll need to save all the documents that constitute that commit first before staging them and then finally committing them. Now this is going to be like saving our working folder and zipping it up at that moment in time, but it's going to give us far more control over where we can go back to. We can even pull out files from way in the past and bring them back to the present with a new direction to them. So let's go on over and first set up our repository and then go through and manage these other things. So here we are in my file system. I'm using a Mac here. You'll be using Windows Explorer if you're on that, or whatever the Linux equivalent is. So we've got my home directory here, and I've created repos, and I've got two here that are called Game Asset Pack. One is for tracking my videos that I'm creating for you guys right here, and one of them is going to be an example. So I'm in a very similar position as you are, and then I'll show you what mine's looking at so you're familiar with it when I use it from now onwards. So I've got an example here that I'm going to make into my repository. So first of all, if you've not already done this, please pause the video now and go register source tree. If you've already done that, then let's carry on. Now I've already got some repositories here. You can see I've got 7 representing the 7 sections of the course so far. Now, you're not going to see anything here whatsoever, but now we can go ahead and create a new repo. So we can click on New Repository, and we're going to create a local repository. It's the third option down. Once we've done that, we've got this destination path here. Now, be careful. It's very easy to think that this name underneath is going to create a folder. If I just click Create now, I'd end up with a repo called My Blender Project, which is great, but it's going to contain everything in my user section, and I don't want that. So I'm going to click these 3 dots to the right-hand side and simply go and select the one I've created, which is this game pack example. I'm going to click on Open. Now, this is the name of the project here, and I'm going to name it My Blender Project. That's absolutely fine. Type Git, that's what we want. And here, also create local remote repository. Leave that one unchecked. And go ahead and click Create. And there we go. We've got a My Blender project that's appeared. And if we go ahead and double click on that, we can open it up, and you should have something that looks pretty similar to this. So I'm just going to rearrange these windows a little because it's been opened on a larger screen. So we have a series of Well, this area at the top here is staged files, and there's nothing staged yet. There's nothing ready for committing. So one of the first things we need to do is make sure that everything we've been working with has been saved and shut down. So if you've still got a Blender file open that hasn't been saved, as soon as we stage it, I say this is ready for commit in its current state, if you then go ahead and click save, even though it's been staged before, it won't be right. So what do we need to do? Well, we do want to keep our meshes. We can see here that the assets, this is our directory that we've got. So we've got meshes under here. We're just going to collapse that with that little arrow. We've got textures and my details about how to name textures. I want to keep that. And here is our reference material. And as you can see, I've just got a load of images from the internet. So I've put a warning there, do not use in the course directly, which is fine. So I've pulled a load of images there. Now I can select that, and when I select that, I can go up to Actions and select Ignore. And it gives us a series of options. So here we've got ignore exact file name. So if you've got a specific file that you want to add to the Git ignore, we can have ignore all files with this extension, and I don't want to do that because some of these PNGs, we're going to be producing PNGs later on when we produce our own textures, so we certainly don't want that. I want to just ignore everything beneath, and in this case anything that goes in that reference folder will not be added to our repository, and I'm very happy to that.
The other thing to consider is where it says add this ignore entry to the global ignore list. Now my folder name, reference material, do not use in this course, no copyright for it. We've got to bear in mind that the global ignore list will place anything with that particular folder name onto it, and that means every repo we then make going forward, it will be included in the ignore. So if you have a name something like textures or meshes, that can be very dangerous because that will mean that every other one that you ever use will be added unless you remove it from that global ignore list. So in general, I wouldn't use global ignore list. I do in this case, but I would make sure it only applies to this repository only. So I'm going to go ahead now and click OK, and that will ignore that. I've then got a README file, which is what I build up as I go. And of course, you may want to add notes as you go into a text file, perhaps, that says at what stage you were thinking, etc. And that's a good log. And of course, you can update that as you go. So now that I've got my assets, my meshes and textures, I can just click up the top here and select everything, and we can see it moves from the bottom here to the top. Now that we've done that, it's staged and it's ready for committing. Now I like to keep my commit messages nice and short and put the detail about what's going on in my README file. And here, for instance, I can say first commit, because that is what it is. We've now got stuff that we can commit, and I'm going to hit commit. And there we go. Everything's disappeared from the screen. What's gone on here? Well, we're no longer looking at our what's called master branch. So on the left hand side here, you can see it says master. If we go ahead and click on that, then we can see what's going on, and that is the first commit. Now if we go ahead and change anything, we'll have changes up on top. So I am now going to show you my particular repository so you can see how it looks after you've done a few commits. Okay, so we're back over on my repository here, and you can see I've got my initial commit down here. Then I fleshed out my README with what I want to do, basic folder structure made, one of the lectures is there, another lecture is here, and this is going to be the end of the 10th lecture. So what I would do in this particular case is I'd make sure that all of my items that I needed were staged, which is fine. I'm going to go ahead and hit commit, and these are the triangles that I've been working on, and I'm going to put in here the name of the lecture that I'm working on, which is very powerful. And I've got that in my paste buffer, so I can just paste that in. Now, ordinarily, you're not going to be using this push changes. I am, because I've got an online repo as well, and we might cover that later on. But don't worry about pushing changes here. That's something I need to do. You won't. And once I've done that, we can see that there are no more changes, and I've now got that all set up and ready to go. Okay guys, so it's challenge time. I'd like you to make your commit.
So an optional task here is to create a text file explaining what you have done. That helps you keep track of your changes, since we can't really see what's going on in individual Blender files, and we want to keep those commit names as short and succinct as possible. Make sure you save all your open documents, ignore your reference material, stage your files, and then finally commit with a short and precise name as to what it is. It's a title for that commit. I've already done mine, so no need to pause the video, and I will see you guys in the next lecture. Welcome to Repetitive Tasks in Blender. In this video, you will learn how to manage repetitive tasks. There are lots we do over and over again, and sometimes we just want to repeat the same action we've just done, but in a different location. Now, we're going to also understand good uses for appending a blend file into our scene. So let's go hop straight on over into Blender. Okay, so we're back over in Blender, and the first thing that I'm going to do is just remove everything in the scene to keep it nice and straightforward. Now, when you're appending a file into a scene, you want to do that whenever you basically want to completely forget all the history of that and use it as a base to generate something new from it. So in order to do this, we're going to go and use one of the basic objects that we've got. So we're going to go and append. We can see the shortcut there is Shift and F1. I'm going to go to my assets and in meshes, and I'm going to use the square, the 2x2 by 0.25. Now we need to go to the object. I want to bring the whole object in and all of its properties, and just pick up the square, and let's append that in. So there we go, we have our new object in the scene, and it's not linked at all. So I'm now going to first of all change the name before we do anything else. And I'm going to call this square detail. I think that would be appropriate if I could spell detail, of course. There we go. Square detail. And I'm going to copy that, go to save, make sure I'm in my assets folder, and paste that in. So we're working on a brand new Blender file based upon the other ones. We've appended it in. Any changes we make here or to the other blend file are not going to impact. That's more important, any changes we've made to the other blend file. So with this, we can now go ahead and create some detail. I'm going to make some very basic detail here. I'm going to take this top face and subdivide it. So let's go into edit mode and then select face, and I'm just going to subdivide that. Now I'm going to have this face here and inset it by, I don't know, 0.2. There we go. So that looks good. Now I want to do that to the rest of these faces. And of course, this isn't that trivial doing it to a few of these faces here. However, I can quite easily end up having a very repetitive task going on. And the easy way to do that is Shift and R. So if I select this next face and go Shift and R, it just repeats exactly the task I did a moment ago, and that is incredibly powerful. And if I can just keep doing it, and of course it will invert in this case, and I don't want to go quite that far. Of course, then I can decide, right, I've repeated that along there, and I want to extrude ever so slightly by 0.1, let's just say. And again, I can select that one, Shift R, Shift R, Shift R. And there we go. We've got a wall with a panelled wall, if you will. A very, very powerful feature of being able to repeat things over and over again. Of course, I can go ahead and save that file, and I've got that ready to use in a scene later on. Okay, guys, it's challenge time. I'd like you to add some detail. So append a few of the existing models into new Blender files. Create some geometric patterns on them, or add a bit more detail. Save them as new individual blend files, and of course, make a commit. So pause the video now and give that a go. Okay guys, welcome back. Let's go hop straight on over into Blender. Okay, so back over in Blender, I've done my square detail. Let's go ahead and start a brand new blend file. And again, I'm going to remove everything from the scene. I am tempted to set up my basic scene without anything in it at this point. Let's go append, and I'm going to work on the door, I think, that I've made earlier. I'm not sure actually at the moment. Let's go see what I've got. So I've done my door with... How about the one with the window on it? I'm going to add some detail to that. So we've got this window in the wall here. Let's go ahead and edit it. Let's focus on it as well so you can see what's going on. And I think it would look quite nice with a couple of detailed edges to it. So I'm going to this time use a couple of loop cuts to help frame the wall a little. Would it help if I knew where that was? No, I'm going to do that by eye. I'm going to put a loop cut around the top here. Of course, I could be more precise if I wanted to as well, but if that looks right by eye, that's all good for me. And I'm going to go ahead here and, in this case, I'm going to select them all individually and move up rather than repeating. Although, arguably, I think it would be just as quick to do both of those. And I'm going to pull that out ever so slightly. Or, I don't know by how much. I'm looking down there. Not by much at all, by about 0.05, I think, to add a bit more detail around there. So that's a new level of detail, I suppose, with our window. That's useful to know. And whilst I'm here adding detail, that now looks like I can pull this up ever so slightly. Not by much, just a little bit. Again, by about 0.05. And pull it out. And that will start to give us a bit of a window ledge, which is quite nice. So again, I'm going to extrude that out by about 0.1, and I'm going to do it on the other side as well. That's always very useful. So extrude by about 0.1. So then I can have an inside of the wall and an outside. Really good. So I'm going to now save this. I'm going to make sure it's named appropriately. So wall window underscore detail. I'm going to copy that so it's exactly the same over here and save as, paste that in and save. Okay, so the final thing to do is hop over to our repository. So I've just opened up where we are and I've got uncommitted changes going on from our first commit. So this allows me, of course, if I make a complete boo-boo and change things up, I can always hop back in time. So I want to make this commit now that I've added 2 new models. I could have done just it at every stage, but I haven't changed any of the other models at the moment. So you can consider when you actually change something from how it was previously, that'll be a good time to make a commit. So I'm going to click here on uncommitted changes. I'm going to have a look down here at my unstaged files. I'm just going to, I'm trying to find the little widget to pull this window up. Okay, so now I've done that, I've got 2 files here ready for staging, which are the 2 that I've done. I'm going to put a tick in the box there, which I'm happy with, and I'm going to commit those. And I'm going to put here, I've added detail to window and wall and press commit. Now I've not got any particular text file going on in here, but of course before doing that commit you could have appended your text file as well. How did you guys get on? What detail did you add to your models? Please share in the discussions and I will see you guys in the next lecture. Welcome to using our building blocks. In this video, you will set your commit message before working, and that's important because that allows us to focus on the work that we're doing. It also means that we won't slip out of what we want to do and end up doing lots of other things. It also means when we need to go back in time, if we need to go back in time in the future, that we've got a precise location and we know what we did at that point in time. We're going to start building your building, and that's very important. We've got these assets that we've made, the wall, the doorway, the window, etc., but we haven't used them in anything at the moment. So it's not a good idea to produce a load of those until you've seen their real effect when you brought them into a model and start assembling them. Not very lean if we produce tons of stuff and haven't used it yet, but we've only got a few items, so it's a good time now to bring them in and start noticing a few issues and working out a way around them, things we need to correct, things we need to modify. So let's go explore this now and hop straight on over into Blender. Okay, so of course before we hop straight into Blender, we need to make sure we're focused on what we're doing. So let's go ahead and click on Commit. Now, there's going to be nothing to commit at the moment unless you've changed something in your working folder. However, I haven't, so there's nothing to commit. That's absolutely fine. I'm going to go to my commit message down the bottom here, and I'm going to paste in the title of the one I'm working, which is using our building blocks, and I'm going to put in testing as well, just to make sure we know that we're testing the project here. Now, I can't click commit or anything, that's just ready to go in a bit. So I'm going to minimize that and put it out of the way for the moment. I've gone ahead and opened up a brand new Blender file, and I'm going to remove the cube from the scene because it bears no relevance. I'm going to leave the camera and the basic light in because we can use that for testing. So we're going to be appending all of these objects. We'll go on to linking them in a bit because that's got some additional benefits to it. But just to get a feel about what we're doing, we're just going to append them in. And we can see the shortcut there is Shift and F1. So if we go ahead and press Shift and F1, we can start importing. Now I'm going to have to navigate to my assets pack. I'm not going to bring in many at this point. I just want a feel of what's going on. So I'm going to go to my meshes. I'm going to bring in a square, not the square detail, just the plain old square. So square, object, and the square mesh. And I'm Shift and F1 again. Again, you can go through the menu system if you want. I'm going to bring in the door because that's quite a useful one to work with. And finally, I'm going to bring in the window as well. Now, I've got two choices of windows because I bulked that one out. I'm going to bring in the one with detail because then I'm going to have to rotate it at some point. Now that we've got these into our scene, what we can start doing is moving them about. Now, one of the things to bear in mind is a quick glance at the outliner. At the moment, we've only got 3 mesh objects in there. But when we start duplicating and moving and all that sort of stuff to produce our building, we'll see in a moment that that starts to get very messy and very complicated and difficult to navigate. So it's also worthwhile before you start doing this, not afterwards because it becomes a pain to do afterwards, but before doing this, we actually create ourselves an empty. And it doesn't matter which one of these you choose. I'm going to choose a plain axis. And I'm going to call it, room test for the moment. And then everything can be linked to that empty. And when I reproduce or duplicate something, I'm going to make sure it's added to the room test. So let's go ahead and start playing with these things straight away. Now, instead of just grabbing them and moving them about, because we've made them out of whole Blender units, it's very easy to quickly make something up. So I'm going to make sure that the snapping tool is turned on, that we've got the snapping set to the type increment, which is the bottom one of that list. And now we can just literally move things in increments of whole Blender units, which is very powerful since we've got things set up like that. So I've got this basic thing here. Let's let's keep moving it. I'm going to make an 8x4 room. I think that's 8x4. I'll soon find out. So we've got a window on the end and a door, and I'm going to duplicate by holding down Shift and D. Not necessarily a linked duplicate, because I may want to make these independent. So in this case, it doesn't really matter. And I'm going to place it there quickly and rotate it on the Z-axis by 90. Now, I've got a particular direction where this is the outside and this is the inside. So this is going to have to be moved to over here. Brilliant. So let's move that up and across to there. I'm going to duplicate that again. I'm going to lock it to the y-axis and place it where I need it. Finally, I'm going to grab both of them and duplicate it again. Just check it's duplicated. Rotate it on the z-axis by 180. And then I can quickly shift it over here and along to there. Now we can already see there's going to be a few issues. These corners don't line up. And there's a couple of choices as to what we can do here. I'm going to put the floor in first and make sure that it works. Now the floor's a little high, so I've got to make a note here that the floor needs to be dropped down, so every time I import a particular floor piece, it sits below the floor. Or everything else sits above, but I think it's easier if we make the floor piece sits below. So I'm going to move them all, I'll move it first. So move in the z-axis by minus, they're 0.25 thick, so that should put it at the base. And again, you can use an array modifier for this if you would like to, but I'm very quickly just building this up. I haven't saved yet, but that's okay. I don't think I'd lose too much of my day if Blender decided to crash. Now we can see there that it's gone underneath our piece here. Now that's not a particular problem because that's nice, it lines up nice and flush, but you can see in certain other places, let's just pull it back slightly. This is a great example here. So we've got the door here. If we wanted to use this externally as well as internally, we can see that these pieces don't quite line up. So there's a couple of things I can do here. I can make sure that all of my wall pieces also go down by 0.25, so that sorts out that and they sit nice and flush. I can make sure all of my wall pieces extend by 0.25, but hang on a minute, which piece do I want? It doesn't end up very modular if I have to keep adding and moving and picking certain window sizes that are an end piece or a beginning piece. What would be easier is if there was another piece that fills in these gaps. So a 4 by this is 4 across, isn't it? So a 4 by 0.25 pillar could sit in there. And then we can make a decision here as to whether or not we go all the way down, and that would be 3.25 in height. So we've got perhaps some extra pieces to make. We could fill that gap in exactly, or even make a corner piece, so an L-shaped corner piece, and that might actually be more practical than just a thin sliver to sit inside the wall, or even both to give us more options. But you can see the power of that straight away, that we've mocked up a basic room in a matter of seconds from pieces. Now obviously this is a series of pieces all strapped together, and it looks like a series of pieces all strapped together because we've not got much variety. But as soon as we get a bit more variety in there, we can start playing. Now, because all of these pieces, before we duplicated them, were underneath the empty, imagine if they weren't, we're going to have to move them all individually at this point, because they were underneath that empty, we've now got a nice clean hierarchy. We've got this single room, and then we can move the single room by just moving the empty that everything's parented to. So it's very important, just like setting the commit message before starting your project so you remain focused on what you're doing, that we start doing the actual hierarchy as well before we start modeling and putting all the pieces together. Trust me, if this was a much bigger room than this and those items, if you were trying to nest them and parent them all to something, it can take a real time to try and organize what's what and where it is. Of course, all of these at the moment are just named, well, they're kind of named inappropriately because it's just the static mesh wall window detail, whatever the size is, 01. It doesn't tell us where it is on the model. So another thing you can do, if once you're happy with it, naming them, I think is probably best done afterwards. Again, everybody's got their different ways of doing it. But until you've made it up, you don't know the position of that. So this one here, I could go in and rename it. If this was an orientation, I could call it south window or something along those lines, so I know where it is. And if this was a kitchen or the altar room or whatever that you're working on, you can even name it, south, and then be more explicit, kitchen window. Or in this case, I would probably put the room first. So if it was a kitchen, I'd put it kitchen. So all of the kitchen stuff is grouped together. Kitchen, south, window, etc. So it's entirely up to you how you do these namings, because it does depend on the project you are working on as to whether one naming structure would be better than another. And you'll find that you may even change your mind halfway through. You'll have to grin and bear with it, much like modelling itself. If you make a mistake, sometimes you just have to start over. Anyway, now we've learnt about appending these things into the scene, I have of course got a challenge for you guys. I would like you to finish off the layout. So go ahead and make a modular corner piece that we can use. Carry on appending build blocks into a new blend file. I suggest storing the blend file in a scenes directory in our working folder. Build a simple building. Don't go over the top at this point in time. Another thing to finish off the layout, did you notice any other pieces missing that you actually need? Make sure you make a note of them so you know the size that you're making and putting together. Remember to save your blend file, stage your files, and finally make the commit. Remember to share your building in the discussions. Remember, it's a prototype building at the moment. It doesn't have to be glorious in any way. Pause the video now and give that a go. Okay guys, welcome back. Let's go finish off the layout in Blender. Okay, so the first thing that I'm going to do here is just save my file because I haven't done that yet, and that's quite important. I'm going to save it into a scenes directory. So I'm going to go to save as just to make sure I'm not overwriting anything. I don't think I am, but it's worthwhile checking. I'm going to go to my game assets folder, and that's the folder I'm tracking, and I need to create a new folder, and you can do that in Blender. It's the 5th icon along here, 5th, 6th. I can't count. 4 there plus 1, 6th. There we go. So that one there with the star on it, and I'm going to call this scenes. And I'm going to open that up, and I'm literally going to give it that name again using our build blocks test room. Okay, and I'm going to save that file. Now, I know that I need to just modify a couple of these pieces. Now, because I have appended them into the scene and not linked them, that means that none of these will update when I modify the original model where these have come from. We'll learn about linking in a bit, so that's a bit of a pain that all of these models I can't just change at once. Now they do all use the same mesh data, which is useful, so I can, in theory, edit all of them here, but that's going to be a bit too much at this point in time. I'm imagining if this was much, much bigger, we'd certainly want to work and alter one thing and it affect every one of those instances. So there's a couple of things that I need to make here. I've identified this corner strip here, and I've identified this bottom strip along here as well. So there's a couple of places that I need something in place, basically, to make sure that it's not horrible. Now, the same one I'm using across the bottom here, I can then use along the bottom here as well. So there's lots of things to do. I think a small 0.25 cube will suffice for the moment for these corners, and then I can position them appropriately. Of course, I'm not going to show you me modelling some extruded cubes, essentially, so I'll be back in a few moments and place these and finish off my scene. Okay guys, so I've been off and I've created a series, as you can see, cubes here. So I haven't named them appropriately. I'm going to slap myself on the wrists for that one. But suffice to say, I've now got a sealed model without extra bits or grooves in it. Now, one might say at this point, perhaps that's a bit too much detail. I mean, you may look at this now and go, well, where's the roof, Mike? You've spent all that time on the walls and the floor, but where's the roof? Well, that's fine. We can go ahead and bring the floor up, for instance, and then do the same thing around the top. So it'll be a flat bottom. So it would be a flat-roofed building there if we wanted to do that. Or we could make a roof line, perhaps a sort of 45-degree one from the parts that we've already got. There's lots of things that we can work with here. Now, one of the things that I didn't do before duplicating is place these underneath the empty itself. Now, the pain here really comes in selecting them all. Unfortunately, there aren't too many at the moment. So if I go ahead and holding down shift select them in the outliner, because that's a lot easier than trying to select them in the 3D viewport itself. Once I've done that, I can use Control and P or go to Object and Parent. There's nothing to parent it to at the moment. We need to select the empty last, as we've done in the past, and that makes the empty the active object. See, it's a lighter coloured orange, and if we can find the empty in the scene, which I'm sure we can. There we go. We can see it's a lighter coloured orange. Incidentally, as you can see there, I did produce a cube that was a bit worthless in the end because I didn't use this small cube, but it's useful to just have it there. Another thing that I learnt whilst doing this is perhaps 0.25. It sounds like a nice number to have. and it wasn't too difficult moving things about. However, when I'm holding down Shift, which reduces the increments to 10th of a Blender unit, it'd have been quite nice if the walls were perhaps 300 or 200 wide, so that then I could have just positioned them very quickly rather than having to use the transforms to move them to the appropriate locations. Anyway, I digress. So once all of those have been selected and you have the active object set as the parent that you want them to have, we can go Object, Parent, and of course parent it to the object itself, and there they are. They've been moved, so they're now all children of the room. And then if we select the room, we can literally move everything about, which is incredibly powerful. How did you guys get on? What did you discover when you started putting things together? And this is the essence of being lean. We've taken our basic building blocks that we've done, we've put them together and realized that we've got some problems, and we can go and correct those straight away before having spent hours and hours doing some really intricate and detailed modeling. We found out these problems nice and early, so we can go ahead and correct them and come up with ways to prevent it happening in future. So the final thing here, of course, to just finish off is make sure that my blend file is saved. And then going to source tree here, there we go. We can see that we have our work there and the blend file that we've created and the folder that's associated with it. I'm going to make sure that they are staged and click commit. Brilliant. How did you guys get on? I'd love to see your room designs. What else did you discover when doing this rapid prototyping? So we've taken our assets, we've moved them into a scene to make sure they're working. We've found some problems with them, so we haven't wasted lots of time. And then we can go back, we can fix things, and then re-import them and make sure they're working. And we'll find out a faster way of doing that shortly. Please share your work in the discussions, and I will see you guys in the next lecture. Welcome to the introduction to data blocks. In this video, you'll learn about data blocks. Understand that knowing about them is about to become much more important, especially as our scene's starting to get a bit more complex. Now, we have come into contact with data blocks lots, but let's now go explore them directly. So, what is a data block and its characteristics? Well, they must have unique names. So if you've got two things with the same name, Blender will append it with the usual 001 on the end. Now they can link to each other, which is very powerful. They can even link across blend files, and that's going to become very important very soon. Okay, unused data blocks are eventually removed. Now we've seen that where we have a little 0 next to our textures or next to our materials that aren't applied to anything, because a material is a type of data block, and that's where we have used a fake user in the past to preserve that particular data block so it's not destroyed when closing Blender down. So sharing data blocks, here's an example of that. The same texture on many materials, the same material on many meshes. Now we've done that before where we have several mesh objects all sharing the same base material. We've done it with a particle system. Now we've often shared and then made the data block unique. So if you cast your mind back to the rabbit that we've created, we started off with a particle system and then used the same particle system again and then started making it unique depending on loads of different factors. And you could do the same with a mesh. You could take the same mesh data, i.e. duplicate an object, and then take it from there, make it a unique object. Okay, so let's go have a closer look at what these data blocks are and where they are in Blender. Of course, before we get started, let's press commit on our source tree. And I'm going to put in here data blocks. I don't know what it's going to be about data blocks. Well, actually I do, but I don't know what it is about data blocks for the moment, so we can amend that later on, but we know it's something about data blocks. So let's go hop into Blender. Okay, so we're back over in Blender and we're going to have a closer look at our building scene that we've just put together.
Now, what we can do here is in the outliner have a look at all of the data blocks that exist, and that will give you a good overview about what constitutes a data block. So I'm just going to make the outliner much bigger so we can see what's going on. And on the outliner's header where it says all scenes, this drop down, we can change it to data blocks. And let's just scroll up and down there, and we will see that there are quite a few things that are actually called a data block. So we've got our blend file data, and then it's broken down into all these little bits. Now, some of this is exposed. When you were going to append these objects, you saw the other things that you could potentially append, including materials and other objects in the scene. So we have objects here. Those make up all of our object data, and as we can see here, we've got this little square next to it, so that's an object data block. Most of these do have their associated icon as well, which makes it a lot easier to quickly spot what's going on. And look down here, there's another object. So this empty that's selected here is the room test object. Let's have a closer look. There aren't any materials assigned with this scene yet. We haven't applied anything. And that's reflected here, 0 items. Let's have a closer look at meshes, because this is something that we can have and use to our advantage. Because we have, let's just count them, 1, 2, 3, 4, 5 windows here that are essentially all the same. And in fact, they're supposed to be all the same. So if we go ahead and open up this, we can see that there's a lot of mesh data called very odd namings. Well, not odd namings, but very useless namings. So in this case, there's something else that we need to make sure we name correctly. Not only do we need to make sure that it's named correctly in the outliner, we need to make sure that it's named correctly when it comes to the mesh data itself, so we can identify what it actually is. So let's go ahead and select one of these windows, and I'm going to go in the outliner again and go back to all scenes so I can see what I have selected. So I have this one here selected. Again, that's not very descriptive at the moment. However, if we go to the mesh data down here, we will see, if we go down on the properties window to the mesh data tab, which again is that little mesh icon, the 3 vertices joined by edges, the upside down triangle if you will, we can see that the mesh data is vert05. Now if we click on that drop down, we can see all the other mesh data that's in our particular scene at this time. And that is powerful because I'm going to guess here that vert001 all the way to 5 is these 5 windows. I could click on each one to check, but I'm pretty certain it is. And I think this other vert is the doorway here. So let's go ahead and switch them all to vert001. So select every window and change it to vert001. Of course, yours may be named slightly differently depending on how it was all set up. But there we go. Mine are now all changed, and that one there must be vert001. Okay, so now if we have a look at this drop down again, we see those zeros. Okay, now that's important because if we go and save this file now and reopen it, those bits of mesh data, although they're all the same in this case, are going to vanish. So if that was a model or mesh data that we wanted to keep, we'd need to associate it a fake user. Don't need to do that at the moment. So what we're going to do just to demonstrate that is I'm going to save the file, which has now been done, and I'm just going to click revert here. And that's going to reload the file again. And because we've literally just saved it, it won't look like anything's happened. But if we go to this mesh data and drop down, we see there's no more verts 02, 3, 4, and 5. They've completely gone now. They don't exist in this blend file anymore. In fact, all of these are now sharing the same mesh data. So if we hop into edit mode, look at that. We can actually see that we're editing every single one of these. So if I go and select a face, let's just say, let's grab, oh, I need to be a bit more zoomed in to select anything. There we go. This is the mesh object I'm editing, not over here. So I have to click one of these faces and we can see it's selecting them on every single one. So if I extrude that out, it's affected every single one. Now that is very, very powerful. And looking at it, that's as if you did a duplicate link when we went in earlier and built this up by duplicating it. So if we've done a duplicate link, what that's doing in the background is saying that this mesh object shares the same mesh data block. Very important and very useful, because I'm just going to undo that blob that I've just made because I don't want it. But let's say that we wanted to put another door in just here. So we can select it and go and change it to, I'm assuming here it's vert. Okay, where's it gone? Okay, it's 90 degrees different. So I can now rotate that on the x-axis by 90. Yep, that's the right way around. And in one quick operation, without having to find another door and duplicate it and move it, okay, we had to rotate it in that instance, but you can see that I've changed the mesh data of that object. It now looks completely different. It looks the same as this one. So that's got incredible potential depending on the complexity of your scene, that you can just simply swap parts in and out. And that's where it's very important to make sure you construct your models themselves to be as modular as possible, because that does mean that you can literally swap one object out for another and have a completely different feel to your scene. Okay guys, it's challenge time. Unless a particular mesh object needs to be unique, remove all redundant mesh data blocks. Make sure your mesh data blocks have an appropriate and descriptive name. Pause the video now and give that a go. Okay guys, welcome back. Let's go remove all redundant mesh data blocks over in Blender. Okay, so what we should end up with in the end is literally the same number of data blocks as there are parts in our scene. Not individual parts, but unique parts. So we've got this front door here, the windows, and so that's 2. We've got the floor planes, which is 3, 4, and 5. So there's only 5 unique mesh data blocks in the scene, so that's what we're going to shoot for. We've already done these doors. They naturally share the same mesh data. However, what I can do here is actually name that mesh data. I'm going to call that, I'm going to call it exactly what it is actually. So I'm going to copy the mesh title itself, the mesh object title, and store that as the mesh name as well. And I'm going to do that to the window. Of course, in this case, I'm going to... Oh, what's going on there? 3 by 4. That's absolutely fine. By 0.0... that used to be 2.5, I think. Because that's the size of it. So let's copy that and put that in here. Now, we should find, after doing that, that the other ones have naturally inherited that. Perfect. Right, so we've got our square here. I'm going to call it floor, because that is actually what it is. I'm going to change this particular one, which is plane 006, to the floor in the title down there. Now I've done that, I'm going to select this one and switch it to floor, this one to floor, and just literally go through and do that. And then in a moment, I think there are 2 more things to do, and we'll soon find out whether or not we've got down to the right level. Okay, so now that that is done, we've got this one here. So I'm going to call, oh, I don't know what to call that. Let's find it in the outliner first of all. Okay, it's just called cube at the moment. Let's call it filler, because that's what it is. Let's do X, Y, and Z. So it's 0.25 by 0.25. So 0.25 by 0.25 by... they're 3 high plus 0.25, so by 3.25. So that is a descriptive name about what that is, and I'm going to update the mesh data name as well. So let's go ahead and fill in these ones here with filler. Oh, let's zoom out, move around. I'm just wondering whether I can do 2 at once. I'm not sure if I can, but if I can, that'd be much better, although it's presenting a
difficult selecting. So if I go here and go filler and then just check, I think it's only changed the active one. That's changed to filler. Yeah, it does only change the active one. So filler. You can also search at the top if it becomes a bit unwieldy. So there, I'm going to delete this cube from the scene because it doesn't need to be there, thus removing. And this one's a bit different. This is the same sort of filler, but it is 4 wide, not 4.25, but it's 4 wide. Oh, I've got to pick either X or Y. I'm going to pick X. Okay, so in order to save you the mundane task of literally watching me rename a couple of mesh objects here, I've just fast forwarded as I've whizzed around and renamed all of these parts. And I'm going to save my file real quick and revert it. There we go. So that means that I should have no extra ones here. And look at that. The mesh data in this scene, the data blocks are down to 5. And we can confirm that in the outliner by going to data block. The meshes, there are now 5 mesh items in here. And they have descriptive names. Brilliant. So the final thing to do, of course, after we've saved our blend file is to make sure we commit those changes so we can undo them if necessary later on. So we now know it was removing redundant data blocks. So removing redundant data blocks. In fact, let's be even more descriptive. Removing redundant mesh data blocks. I need to stage those files using our, that's absolutely fine, and I'm going to press commit. Okay, brilliant. And of course, I am now in my repository that I use. This is what it's going to look like from now on. I've been keeping it nice and simple for you guys before with how yours would be looking. Mine's going to always look slightly different because it's set up around the structure of the lectures that you're watching rather than just the tasks that are going on. How did you guys get on? Please share in the discussions if you had any troubles or challenges, and I will see you guys in the next lecture. Welcome to linking to an external data block. In this video, you will learn more about linking to another blend file. We'll be linking to an object data block, understand that there is a data block hierarchy and how that impacts your linking, and how to keep an eye out for when you might lose data. That's quite important because it can end up being very frustrating. You're not going to lose it as in it disappears off your hard drive, but you could lose it in your new blend file, the one you're linking to. So let's have a look at this data block hierarchy, and in front of us we have the outliner that you would see if you just opened up a typical default blend file, the one with the basic cube in it and a camera and a lamp in the scene. Now you can see this is a great example of a hierarchy with the scene having render layers world, the camera object, the cube mesh object and the lamp object. Now beneath each one of those three we also have more details, each of which is a data block. So the camera will contain the camera properties beneath it and the lamp would contain the lamp properties beneath it. And looking at the cube, there's a data block which holds the mesh information, which is the grayed out triangle. We've got the material information, that's another data block. And then beneath that, there's a texture information that's applied to that material. And the important thing here is if we import, let's say the mesh object, the cube object, we will automatically get the data, the material, and the texture straight away. Now, if we just imported the material, we would get that and the texture applied to that material. If we only imported the texture, then we'd only get that. So if we decide to import something that's got a hierarchy beneath it, that beneath hierarchy will also come through. That's important so you don't either flood your scene with something or miss something. So let's go have a look now at where we might accidentally start losing information. And to do that, we're going to have to hop on over into Blender. Okay, so back over in Blender, I've got my test room that we've been working on. It's looking pretty good so far. And I've got this whopping great big hierarchy here. So let's go ahead and just experience what happens when, or potentially, where we might lose information. Now, hopefully this won't happen to you, but it is always possible. So I'd like you to go to File, go down to Link, and I'm in, where am I in at the moment? I'm in my Mayan pyramid scene. That's not going to be any good. So I'm going to go to my game asset pack, and I'm going to go actually up a level and see the other projects that I've worked on, and go ahead and find something. I'm going to go back one to the Fluffy Bunny, because I know I played with materials in there. I'm going to go to fluffybunny.blend, open that up. I'm going to go into material. And I've got all of these materials that I made. And let's say that I wanted to, I really like the colour of the soil, I don't know. But I'm going to pick the soil as the material and link it. It does mean that if I change that material over on the Fluffy Bunny, it will automatically be applied here as well. So that's important to know that link exists. But at the moment, this material is not applied to anything. So it's going to have that 0 next to it in the data block. So if I go ahead and select this doorway, for instance, and then go to the materials property, now there aren't any materials assigned to it at the moment. If I click this drop down, I can see that I've got an L, and the L means that it's a linked in this case, a linked data block, a linked material, and it's got a 0 next to it, which means it's got no users. That does mean that if I go ahead and save this file right now and exit without applying that to anything or giving it a fake user, that will result in it disappearing from this scene. So you can't just go and grab a load of materials from another blend file without giving them a fake user or assigning them to an object. Otherwise, the next time you open up your scene, they would have vanished. And that goes for several other things as well. The mesh data. So if we hop over here to the data block, this here, if we were to import, well, let's do it. Let's go and go File, Link, and let's go up a level. And where is our mesh? So we've got mesh here. We've got all of these data blocks here. I'm going to go for leaves and link from library. And again, if I use this drop down here, we see that it's linked. It's got no users and it's called leaves. So we've got an inherent problem here that if we don't apply it straight away to something, there's a good chance we will accidentally lose it if we left this blend file. Of course, we can give it a fake user or assign it to something. Now, that doesn't happen if you go and do an object, because that actually brings it into the scene fully. So if we go and give that a go now and go link, and this time I am going to go back to my game assets pack, go to meshes, and under here I'm going to pick the door again. So we're going to go to door, going to go to the object, and here we go, SM wall door, and then the size of it, link from library, and it looks like it's there. Now, I'm not going to be able to move it, and we'll go to more detail about that at the moment, but it's now in my scene. I'm just going to move it to a different layer. I'm going to press M here and just move it to, I like calling that sub-layer 1. I don't know which layer actually applies to, but I'm going to put it on the layer beneath, just so I can move it out of the way quickly. Okay, so now that I've done that, if we go and have a look in the object area, we will see, oh, we've got a lot in here at the moment. We're going to have the linked SM wall door, and it's got the L next to it to make sure we know that it is linked. There's no 0 there, it's in the scene. If we go to the data properties here, and we drop down here, we can see it says LVert. Okay, it's not named properly in this case. I will need to go back to the original file and sort that out amongst a few other things I've got planned to do here. But it's there and it has an assigned user because the object is a real object, it exists in our scene. The mesh data, the materials and the textures, etc. are just properties that can be applied to an object. So if they don't have a user, they're going to disappear if they haven't been used or given a fake user. Okay guys, now I've got a small challenge for you. I would like you to link your building blocks. Now do check your pieces for any issues. They're probably going to be naming ones if anything. Fix and make any new pieces as necessary. Link the major pieces into your scene and store them on a separate layer. Remember to name the layer appropriately. Now don't worry about moving them for the moment. When you bring them in as a linked object, they will be highlighted blue. and you won't be able to do anything with them in terms of transforming them. So you won't be able to move them, scale them, or rotate them. So pause the video now and give that a go. Okay guys, welcome back. Let's go link our building blocks over in Blender. Right, before we hop into Blender, I just want to show you what I've done in the background so you guys are not shell-shocked when it changes from a simple room to more of a church style. I've gone and repeated these sort of basic building blocks. I've tucked my basic building blocks away in a basic room folder underneath the meshes, and I've gone for some church style assets. So let's have a more detailed look. I've got a floor of 3 different sizes, and I've done that for the simple reason that even though I can scale my objects, when a texture is applied to that, it will scale the texture as well. So I want as much flexibility as possible, especially with the floor, because I want large pieces and I might want small pieces to flesh out little alcoves or corner pieces. I've also made a church corner, which is very useful. It's 1 Blender unit by 1 Blender unit by 4 Blender units high. All of these are now 4 high because it's a church. It's a lot bigger in structure. I've got a front door that I've made. The vault. Now, that was one of the most challenging ones to make. But it's perfectly possible using all the skills we've got already. Have a quick look at that in a moment. And a plain old wall, which is 4x4 by 0.2. That's the other change I've made. I've made the thickness 0.2. So when I'm moving in tenths of a Blender unit, I can actually match it up. And the church window, so there's an archway window in there as well. So let's just have a quick look at the vault and explain how this was put together, because it was more of a challenge than the simple building blocks that we've got. Now, I realised that in my designer, they're about 8 Blender units apart where the pillars are going to go that come up to this vault. That I had to look up what the vault was called. It's the ceiling bit that looks like this in a church. Okay, so I produced an archway, just a series of edges joined together to make an arch, and I mirrored that around one of the axes. I then duplicated that around the other way, but keeping the mirror modifier actually applied. Now, when I performed a Boolean operation to produce a union between the two, I ended up with a hole just where I wanted it. So I then used that, mirrored it again, rotated it again, and there we go. I ended up with this object, which then I used the solidify modifier, which I think is still applied. Yes, it is. So it's still active, it's not applied yet, just in case I need to change the thickness. So I've made it then solid, so it was just very thin before and would cause some artifacts when rendering. So that's looking pretty good now. And so I now need to append all of these into the scene. I'm also going to turn on smooth shading to make that look a bit prettier. Excellent. So let's go. I don't need to do anything there. I'm going to create a new Blender file and just append them all in, because all of my old assets, well, it's just going to be an absolute pain to try and use them again in any way whatsoever. So let's go ahead. I'm going to use the shortcut keys Control, Alt, and O. Now I need to go to my assets folder, meshes, and literally go through and add all of these to the scene. Okay, so the final piece is now coming in, the church window. We'll select the object and bring that into our scene. So we've got everything there, and I'm going to move it to a working layer. So let's select all of those. I don't want to select the camera or the other bits, the lamp itself. So I'm going to select them in the outliner instead, because that's a bit easier in this case since they're on top of one another. I've got all of those selected. I'm going to move them to this layer here. I'm going to go into my layers, into my layer management, and just make sure that that is named. In fact, I'm just going to put them on layer 2. That would make far more sense here. So move to layer 2, and then if necessary I can move them later. So let's give that a name, and let's call that parts layer. Brilliant. So the final thing here to do is, because I've created a new file, I'm going to save as. I'm going to come out, into the scenes using our building blocks test room. Well, now I've moved my files. That's actually dead, so I can delete that. Because I've done this hierarchy here where in the meshes where I've moved them to basic room, it's broken a lot of the links. So let's just remember that for future. So it's okay because it's a test scene. So I'm going to go into scenes and I'm going to call it Gothic Church. Excellent. The final thing to do is go to my source tree. Have I got everything in here? Let's check and see what assets have changed. Meshes. Yep, it's got all of my data there ready to go. So I just need to make a commit message. I've updated my README file, so I know what it's all about. I'm going to commit, and this is the 14th lecture, so I'm going to call it Game Asset Pack 14, linking to an external data block. I'm going to make sure that I've staged those, which I have done, and click commit. Brilliant. How did you guys get on? Please share your work in the discussions, and I will see you guys in the next lecture. Welcome to Linking Blend Files, Making a Proxy. In this video, you will learn more about linking data blocks, understand what is happening when you link, realizing, of course, when you need to use a proxy. And we've already got some issues at the moment that we can't move our linked objects. Perhaps that's a clue of what's coming next. So about making a proxy, what is happening in the background is it creates a new object that is a parent of the linked data. And what that in turn allows us to do is transformation of an object. It allows us to edit the parent, the new object that's been created, the proxy object that's been created, and that allows us to do things like scale, move, rotate, etc. And it also allows us to change the object properties of the parent, which in turn will modify the linked data. Otherwise, it's exactly the same as the linked file. It is identical to the source file that you brought in to Blender. The object data blocks is linked to the original and any dependent data blocks as well. So if you've got, you will probably have a mesh data in there, but you might have imported a lamp, so that won't be there, but that will have light properties. So in a mesh data, when you brought that in, so you will have the object data block, you will probably have a mesh data block along with that. And if you've got materials applied to that, those will come across, and any textures as well. So let's go experience making a proxy over in Blender. Okay, of course, we're on our way to Blender at the moment, and first of all, we need to make the commit message, what we're going to do. In this case, it's going to be the title of the video that I'm doing, and in your case, it's going to be making my linked objects a proxy or something along those lines. Or, of course, if you're working on something else in between, remember to give it an appropriate name so you know what you've done. Right, now that that is done, we're ready to hop on over into Blender. I just want to say at this point, this is going to be the last time I'm actively going to be showing you source tree working in the background. I'll just be doing this as I progress. Please do continue making your commits whenever you make major changes to your model, because it's going to allow you to go back if you have a problem. We'll be visiting how to go back in a future lecture, so don't worry about that. That's still coming, but otherwise you won't see much of source tree from now onwards. Right, so now we're back over in Blender. We've got a series of linked objects, and we can see in the outliner that they're linked because they have this little bit of paper on them with the arrow, which means they're linked to another blend file. We can't see anything at the moment because we shoved them all onto layer 2. So let's go over to layer 2 now. That's looking pretty good. And we need to make these things a proxy, which will allow us to move them and therefore construct our church from these pieces, or your interior building if you're working on something different. So I'm going to select that now, and this is an object operation, so we can go down to the object menu, and if we go up here, we've got make proxy. It's about halfway down the menu, and you can see the shortcuts there are Control, Alt and P. When we do that, we get an OK message, so we have to click again, and now it is a proxy. So we can see here that it's ever so slightly different. It's been renamed _proxy, and if we open it up, it's got a little bit of a hierarchy. We've got the linked
church vault mesh down here and the linked object there as well. So this is great. This is showing us that it is a proxy. It's renamed it for us. And now, of course, what we can't do with any of the others is move it about and translate it in our world. We can even rotate it and scale it. Of course, what we do have to be careful with is the whole scaling thing. And that's one of the reasons why I've made a series of church floors here. Because later on, when I go to apply a texture to those floors or walls or wherever, if I decide to scale that object, so for instance, the church floor that's 2x2 can quite easily be scaled to fit either 2x4 or 4x4. However, the textures will also stretch. So with the church floor 4x4, what we'd have to do is remap the textures. But if we've got the original object already mapped properly, and we're going to that soon, then we don't have to worry about stretching it and rejigging all of the texture mapping to sort that out. So that's why I've got a series of objects there. With the walls and everything else, I think I'm going to be fine with the settings that I've got. Now, I'm just going to undo the movement that I've done with this particular church vault here. And of course, I've got a very quick challenge for you guys. I would like you to proxy your linked files. So make the rest of your linked objects proxies in your scene. Pause the video now and give that a go. Okay guys, welcome back. Let's go make those other linked files proxies. So I'm going to hop into Blender. And here we go. Now I am just I've not tried this. I'm going to try selecting all of these, going to Object and Make Proxy. No, it's only done the selected one. So I'm going to do Control-Alt-P, Make Proxy. Control-Alt-P, Make Proxy. Select it, Control-Alt-P, Make Proxy. Make sure your cursor is not over the outliner, but over the 3D editor window itself. Otherwise, your shortcut key is not going to work. If I try and use it whilst I'm still over the outliner, it's not going to do anything. So make sure you're over the 3D editor window. And there we go. All of these have been made proxies. Finally, I need to make sure I've saved my blend file. And then, if I hop on over into Source Tree, I can see my uncommitted changes, which will be my Gothic Church blend file, which is the scene I'm creating, and my README updating what I've done. Perfect. So let's stage those files, go to commit, and of course, the name is correct there. Hit commit, and we're sorted. Brilliant. How did you guys get on? We're almost ready now to start constructing our church. But we've got one more thing to learn about when it comes to linking files, and that's so we can have some more control over these files locally within this blend file. But we'll be discussing that in the next lecture. Welcome to Linking Blend Files, Making Local. In this video, you'll learn why you want to make a linked data block local. Understand we are starting to sever links by doing this. Learn about the various stages of making it local. And decide when would be a good time to localize that data block. So let's go over a couple of advantages and disadvantages that this does. So one of the advantages is you will have more local control. You won't have to keep opening up a separate Blender file and modifying it before seeing the changes in your scene. So it can be a bit quicker working with it on this way. External files, if they're moved, the project can stay together, which is very useful, especially if you're working in a team or you want to deviate from a path and test something out, perhaps. Now, potentially, there's a disadvantage, there's more work involved, and we have to be careful that when we decide to make something local, that we really don't need that link anymore, or which links do we need and which ones do we not need. Remember that any edits that you make on the original affect all linked data blocks, but not the ones made local. So when do you localize? Well, when the link is not required. I know that's a bit woolly at this point in time. How do I know whether the link's not required? Well, if that's the question you're asking, then perhaps you shouldn't be actually making something local.
So when you want to make the asset unique in this particular file, so say we're building up this building and we've generated a texture and a material that go along with this, but you want to take it off on a different direction and see what it looks like with a different material applied to it, a chrome finish to the wall, so it's all mirrory, whatever you want to do with it. Well, this may be a time to make the material data block unique. So you don't have to make everything unique. You can make individual parts of the linked file unique and local to the blend file that you're working on. And the other thing is when you want to make changes irrelevant to other potential projects. So we certainly don't want to change the material of a wall that we create just so it affects this one, because if we're linking that in any other projects that we're working on, if we've got a nice asset store, then we don't want to go ruining every other project that we've got with changes that are specifically local, hint there, to this scene that we're working on. So we've got 4 options. Option 1, selected objects. So what that does is it clones the object data block and anything in the hierarchy beneath it to the new blend file. All the other data blocks remain linked to the other file, and this allows changing of anything in the object data block. So now we can scale it, rotate it and move it, etc. But it does sever that first link. Option 2 is a little bit more selected objects and data. So this clones the object and the data block to a new Blender file. And this allows editing of the mesh data, breaking that link and making it a local file. Now, it is important, if that happens, any mesh data that you update on the original will not come through. So that's great if you're trying to make a particular part fit an awkward place in your scene, but don't want to edit the original. The materials and the other data blocks remain linked to the original object. So if you go ahead and change or update any of those, when you open up your blend file again, you will find that those come in to this blend scene. Option 3. Well, as you can probably guess here, the selected objects, data and materials clones the object, the data and the materials data block, making all of those available for editing. This allows the editing of all of those data blocks and breaks those links, making them local to this file. Option 4, and this is the final one, all. As it sounds, this is exactly the same, actually, not pretty much the same, but exactly the same as appending the object into the scene. It is now entirely local with no links at all to the original file. You can do whatever it was. It's as if you had made it in this particular blend file. So now we've had an overview of all the different ways that locals can happen. Let's go experience this and hop on over into Blender. Okay, so we are back over in Blender and I want to demonstrate this making local. So the first thing I'm going to do is actually bring in something else so I can work with it. So I'm going to link, I'm going to go into our meshes. I'm going to bring in my mannequin so I can work on that in the scene. Go into object, mannequin and link from library. So that's now in here. Now I don't have to make it a proxy first. I can make some of it local straight away. And we can do that under the object menu, just like before. And we've got this make local, and you can see the shortcut key is the L key. And here are the 4 selected objects. And here are the 4 selections that we've gone through, the selected objects in data, which will then enable us to, let's say, move it, rotate it, scale it, and then we've got enable us to edit it, enable us to change the materials, and just the same as appending. And instead of clicking one of these at the moment, we're going to have another look, because we know we can do these, but these don't give us full control. We can make a decision about each one of these items completely individually. So let's make sure the mannequin or whatever you've brought in is selected. And then we are going to, first of all, take a look at the major ones here. So this mannequin I know has object data, and we can see it's grayed out at the moment. We have mesh data just here,
And moving forward, we have material data. Now, the mesh and material data are part of the object data, so there's no making that local just at the moment. What we'd need to do first is work down that hierarchy. So in this case, and here's the material laid out here, we can see they're all linked. The mesh data is linked, the material is linked, and the object data is linked. So let's go to the object data first, and there's a little button on the end of the name, the object data itself, and that will click to make it local. Perfect. That's the same as pressing L over here and doing selected objects. The moment we've done that or clicked on this button here, we can see that this is no longer grayed out and is enabled for editing. That's now local to this file. Any object data that we change in the source file will not be updated. Now that does allow us to move it about. So it's very similar to making that proxy. However, it has now broken the object data link. So if we changed any of these other items in the object data block, it would not transpire, it will not come across to this blend file anymore. If we go down to the next area, which is the mesh data itself, that is grayed out, and we can click here and make it local if we want, and that will enable editing. So now when we hit tab, it actually goes into edit mode, and we can go about editing this little mannequin. Perfect. What else do we have? We have the material. The materials are still linked as well. So at any point, we can bring in the material. It says material 001 here, so not very well named. We can see that is a linked material, which means if we change that in the source file, even though the mesh data and the object data are now local to this file, if we go ahead and change that, it will update here. And I'm going to go demonstrate that right away. So what I will do is I will make sure I save the file I'm working on, hop over to this other file and just play with it for a moment. First of all, I'm going to change the material here. I'm going to rename it. I'm going to call it mannequin rough material, so I know what it is. Now that I've renamed that, what I will need to do to make sure it's absolutely clear is go ahead and change the color. I'm going to change it to a bright yellow and hop into material mode just to make sure that's happened. It has. Perfect. Save the file. Again, this is a rough file, so I don't mind playing with it. And let's say on here we want to give them a Pinocchio nose. So I'm just going to select a couple of faces here and pull it out. So I'm just going to grab that, turn proportional editing down a little. There we go. We've got a nose coming out. I'm going to lock it to the y-axis completely. So our mannequin now has a nose. I'm going to save the file. And when I go and open up the Gothic church that I'm putting together, we will see that the linked data has been severed. This mesh isn't updating. And because we changed the name of that material, that has also disappeared. And we can't even see that in the materials list anymore because we've severed the object data, which itself contained the mesh data and the material data along with it. Now, that's not a big deal. We can go and link that back in straight away. We can go File. We can't do it in Edit mode, so let's hop into Object mode and go to Link. We've got the mannequin here, but I'm going to go upper level, go to material, and here we go. Because we've removed the other material, it's just disappeared. It's as if we've deleted it. And if we go ahead and open up that material, we can then assign it. Notice it had L0 initially. That's now gone because I was very quick in clicking it. And that's now applied to here, and we've got ourselves a yellow mannequin. Okay, let's go and just experiment once more and make sure that wasn't a fluke. Let's go and save the file. Let's change that mannequin material color to something else. Let's change it to a green or a red. I'm going to change it to a green. Save the file. And now, because I've not updated the name, we should find that it comes across green. Perfect. Okay, so a quick challenge for you guys. What would you make local? Think about what's in your scene at the moment. If you've not already done, arrange your parts into your interior design. And think about, do you need to make anything local? Have you designed your design so that's not applicable? That is entirely possible.
And if you do need to make anything local, think about why you would want to make it local and which data blocks, if any, you would make local. Now, do think carefully about whether you need to do that now or whether you're going to develop your model a little and do that later. I'm sure at some point you are going to have to make some of your mesh or materials local to the particular scene, especially if you're experimenting with multiple scenes with the same building blocks coming in. You might want to make a red building or a yellow building or a green building. Obviously, well, it might not be. If it was a kid's toy building, then you might be making them that bright colour, but you may be doing subtle shades of sandstone or granite or something along those lines where you want to change the material but only locally in this particular file. And that's a great way of using the same mesh but actually making it look completely different by changing the material applied to that mesh. Anyway, enough of me rambling. I'd like you to go and pause the video and give that a go. Okay guys, welcome back. Let's go hop back on over into Blender. So the first thing that I'm going to do here is just lay out my pieces and see what I've got to work with. Okay, so there we go. There's my pieces all laid out, ready to start organising into certain sections. And I've just glanced at Wikipedia, in fact, wonderful place for research, the parts of a church, because I hadn't actually got a clue what they're called. So I'm going to have to make some empties now just to represent those particular parts of the church. So I'll be back in a few moments. Okay, so I've gone ahead and created empties for the 5 main parts of the church that I'm creating, and I need to organise these a bit better at the moment because I've got it in alphabetical order essentially, which is very difficult when I want to group them by the type. So we're going to go to the view menu here and sort alphabetically. I'm going to turn that off, and there we go. We've now linked by empty, then mesh object down here, which is much better for me. The next thing for me to do is start organising these parts actually in these set scenes. So I'm going to start with the nave and the aisles, which are going to make up the main body of the church itself. We'll sort out all the ancillary bits afterwards. So I'm going to start building this up, and I'm going to use linked duplicates of these particular items in order to construct my church. So I'll be back with you guys once again in a few moments once I put these bits all together. Now, before I got going to sort these out into their various empties over here, the first thing I did was make a parts empty and put everything into that. Now, in order to start using these bits, what I'm going to do is I'm going to select them all straight away so I can use them in my model, and then go Object, Link, Duplicate. Of course, the shortcut key is Alt and D, and we've got our duplicate objects there. But they're still under the parts empty as a parent. So at this point in time, whilst they're still selected, what I can do is just hide all of the other empties apart from the one that I want to work on. I want to work on the nave to begin with. So now, because all of those are currently selected, and the last one I selected was this archway at the top, I've already forgotten what that's called, but I can now click, because the only empty left is this one here. I could have clicked in the outliner here, but I can also now select it in the 3D view as well, and then I can press Control and P to parent object, and then it's moved those linked copies, that's very important, across. That also means that now I can make sure when I select the parts and everything under the parts itself that we can move that to layer 2. In fact, all of these other ones need to be on layer 1 that we're working on. Okay, we need to select everything under here, and we can do that by control clicking on the nave itself and then try moving it to layer 1. Now when we have a look at layer 1, we should have all of our bits there. Layer 2 will also have all of our parts. Brilliant. So let's go ahead now and assemble this. I am midway through my construction at the moment, and I will just say at this point in time that the wireframe mode is incredibly useful for lining things up. If I didn't have wireframe mode turned on, that's the Z key just to remember, or you can do it down here on the 3D editor header bar, switch to wireframe, and then when I'm looking at it from the sides, I can actually move things exactly into the position they need to be in. And of course, if I'm zoomed in enough with the increment snap turned on, it
allows me very fine control. Excellent. Let's carry on with the building. Okay, I'm finally at the end of my assembly stage. So I've assembled, as you can see, some corner pieces here to make a funky outside. I know we're working on interiors, but I thought that looked pretty cool, so I did it. It's as simple as that. From the top, let's zoom around to the top. We've got the rough shape that we want going on there. I've added a bit of a side door. In terms of the organization of this, I have in each area, so whether it's the entrance, the chancel, the tower, etc., I have sub areas. So in the entrance, I have the entranceway ceiling, the walls, the floor, etc. And what that enables me to do is, whilst holding down control, is I can start to remove bits from the scene very quickly by control clicking the little eye icon there. So I can go through here and remove the tower, then I can go through and, let's say, move the aisle's ceiling, etc. So there's lots of powerful things that I can do by going through here. And because I've built it up in such a way, I can actually just remove bits as and when I want. Now, a couple of things that I have made local here. One of them's this bit at the very end. So I have basically made this part to fit in here, and I can take it out of the scene and work on it otherwise. I'm going to actually turn smooth shading on this particular part whilst I'm here. So remember, so that part has now been made and is ready. So it's the last bit at the end of the church there. None of these are changed from their standard layout. I'm probably going to add some sort of funky window in there. Again, I'll look up reference material to work out that, but that's later on. That's a bit of detail. I've added a doorway down here, and let's just turn back on the tower and the entranceway. The tower's got a unique part at the top as well, because that's a slightly smaller one than the main roof sections down here, but it's a similar style. It's just been made to fit this area here. So that's also a local part, as well as this one on the end here. Brilliant. How did you guys get on? I'd love to see the church designs you've come up with. Remember to share them in the discussions, and I will see you guys in the next lecture. Welcome to walking and flying around your model. In this video, you'll see how our scene looks and feels by walking around it, using the fly and walk mode. Show you how to see the scene in Unity. Understand that I'm only using Unity to keep the iterations quick and simple at this early stage, and that Unity is optional. Anything external to Blender that we do, you can watch to see how it works and how it is coming across, so you can see the impact of what's going on. You'll gain a better understanding of external programs when doing this, and occasionally you may want to work with external programs, whether it be art packages or other 3D modeling packages. Now join in if you have Unity installed and are interested in learning more about this particular prototyping method. So let's hop straight on over into Blender. Right, now that we're back in our church scene, at the moment we've been manipulating this by simply using the mouse, scrolling it up and down, holding down shift and panning across, but that has its limitations. For example, it's very easy, as we've all experienced already, to run out of zoom when you can't go any further and you have to refocus what you're looking at. And we can get around that by hitting shift and F. That enables fly mode, and we can start using the W, A, S and D keys, if you've ever played any first-person shooters, to move around our scene. So we can strafe, like panning with A and D, W moves forward and S moves back. Now this looks like a painfully slow speed that we're moving at the moment, but you can speed that up with your scroll wheel or page up, page down. And we can see that as I'm on a Mac here, so I'm scrolling down, I can pick up speed and whiz around the model. Of course, we've got my little mannequin in here for scale. It helps just really set the scene. And I can see that walking around, I can adjust this so I get a much better feel. And, well, that's looking pretty good. Okay, what else can we do here? Well, we can turn gravity on and off by hitting the Tab key, which enables us to walk on the surface of our model.
And when you hit the space... Oh, there we go. I've fallen away. So that's why one of the reasons why you wouldn't necessarily want to put gravity on. I'll just use the scroll wheel to whiz back up here. But wait a minute, there's a quicker way of whizzing about. See that little crosshair in the middle? Well, if I put that on a particular part of my model and then press the space bar, we will hop to that part of the model. So it's very easy to quickly hop around if I target my mannequin and go bang, straight there. Very powerful for skipping around large models. And we can see there are further controls on the bottom of the screen. Now, when you come out of our fly mode, with the right mouse button, it goes back to the previous viewpoint before you started flying around. Now, you may, of course, want to fly into your model and to a particular place in the model to have a look at it and keep that. And we can do that with the left mouse button, enter, as well. And there we go. We've got that viewpoint. It's incredibly powerful for moving about a model, especially one that's getting quite large and potentially quite complex. And then, of course, we can hit Shift and F again and press space to move to the tower and go up to the top of the tower and look down and lord over everybody beneath us. Brilliant. Okay, so I don't want this viewpoint, so I'm going to right-click to go back to my previous one, which is a much better viewpoint of the rest of the church and the entranceway over there. And let's go have a look at what this looks like in an external package. And I'm going to be using Unity for this example. Now, a quick side note here, Unity does support opening up blend files. However, what it's really doing is, in the background, it's opening up Blender. It's exporting the model as an FBX, and then, and only then, is it opening it up. So it's quite a lean way of doing it, but if your model starts to get complex, that can really bog down Unity, and I've had it spend 15 to 20 minutes trying to open up every time, and that's just unmanageable. We can't wait minutes and minutes and minutes just to open up a program. There's nothing lean about that. So what I'm going to do in this case, and one of the other things to make sure that we do, is if we ever export our model, at the moment, if we just export as an FBX, we'll get all of the parts as well. So if we turned on the second layer here as well, we will end up with whatever we get, these other additional parts and the extra mannequin there coming across as well. So we need to make sure that we're only exporting the bits that we want to export. So we can select individual items or the entire lot. In this case, I'm going to import the entire lot and walk around it. Although you may wish to reconstruct this in an external package as well, in which case you would just export the parts and then give full control to the level designer or whoever to put all the parts together how they deem fit. Because obviously if I give someone a big model like this, it can be quite annoying to have to deconstruct it first to reconstruct it how you like. But this is a great example about how all those pieces fit together. A bit like when you buy some Lego, you get a picture of what you should be making, and then of course you ignore that and go and make some other cool stuff. So now what we can do is just make sure that the things we want selected are the ones that we're going to export. So I'm going to totally ignore the parts bits, but select all of the other empties. But I'm going to select these empties whilst holding down Control, so it selects all of the meshes underneath as well. So I'm going to want to select that, and then I'm going to hold down Shift, add to that selection, and select the other bits in our scene. So I'm just going to go down here and select those. I don't need the lamp or camera. They are completely irrelevant whenever I'm exporting because they are controlled and have settings really only in Blender. So now that I've done that, I can go to File and Export and go to FBX. That's a standard one for most packages. If you're doing 3D printers, then it'll be STL is a standard one, and obviously there are some other ones that you'll notice here. If you're working with SketchUp, Collada is the one it supports. It doesn't support FBX, and this, of course, natively supports 3ds Max as well. So I'm going to click on FBX, and it's almost ready to save. You can see I've already saved it in the past, but one of the important things here, and pretty much all we need to do at this moment, is put a tick in the selected objects box, and then we know when we export in a few seconds time we'll only get those selected objects and not everything that's in our scene. Then we're going to go ahead and click on Export. Now, a word of warning, it doesn't ask you, are you sure if you want to overwrite? It will just overwrite the file if it's got the same file name or you've accidentally clicked on something else. So do bear that in mind. There is no going back now. I've overwritten that file. There was no "are you sure?" Which is odd. We're so used to "are you sures" and undos and the computer guiding us along, but it doesn't do that. So let's go have a look at how this opens up over in Unity. Okay, so I've set up my scene over in Unity. I've imported the Gothic church and I've imported some standard stuff so I can have the first person controls. I'm going to go ahead and hit play. And then I should be able to walk around my scene. Just going to make this bigger for you guys. There we go. And this gives a much better impression of the actual scene as we walk around it. Hello, mannequin. Now, these yellow patches here, don't worry about those. That's just reflecting the ground. And it's directly parallel with the ground. It's going to do that. You see it's happening there and to some extent under the arches. I don't have any... Oh, I've actually walked out the door. That was very good. I was going to say I don't have any colliders. So, well, I do on the floor, so I don't fall through, but I don't on the walls or anything like that at the moment, so I can go in and out of the model. And this is really good for seeing how it's going to work. So I can already see some problems. And it's good that I can see problems at the moment because, well, I can fix them sooner rather than later. And here we see this one's working, and that's because it's a solid model. So I've also identified at this point that when I moved these into the scene, and indeed all of these vaults, these ceiling pieces, the modifier, the solidify modifier, did not link as well. So I'll need to set that up again on them all. I can also see around here, where is it? This bit here, it looks like there's a piece misaligned. Oh dear, bad construction there. Or is it a secret panel to a secret area of the church? Who knows? But we can start to see here that this is feeling right. It's feeling pretty epic. It's feeling big. It's not feeling too big. This is a 1.6 meter mannequin. It's actually a very handsome chap. It's modelled on myself. Okay, so this is great because we get to experience how it is looking and how it feels by just walking around it. Now, obviously, because these are made out of modular parts, the game designer, or yourself if you're wearing multiple hats, can now start fiddling about with the layout inside the game engine or whatever else you're working with straight away. Okay, quick challenge for you guys. I'd like you to explore your model. Move around your model and get a better feel for the space that you are creating. Remember to make any alterations immediately, working lean, and walk around again and test those alterations. Now, optional for those with Unity or another game engine or another external package, import your model and walk around it or fly around it there too. If the import has problems, remember that is a good thing. We're being lean about this and taking it to one of the end stages that we want very quickly to make sure that there aren't any glaring problems. So pause the video now, give that a go. Now, I've already identified some problems with my model, so I'm going to go and fix that. But I will see you guys in the next lecture. Welcome to Better Camera Control. In this video, you will use a different way of moving the camera. See, this gives you better control over what the camera is pointing at, combined with fly mode for good control, and learn how to track a target. So let's go play with the camera and hop on over into Blender. So we're back over in Blender here. Just a quick fly around my model, really quick, just to let you know I've sorted out these ceiling pieces, or at least solidified them for the moment. I'll work on them more later. I sorted out a whopping great big hole that was in this tower, and I don't think I actually moved this place down here because it doesn't look like it's actually out of alignment. So I think that I've already moved that and corrected that. The only place that I haven't sorted out yet is this hole over here, because I'm going to make a specific roof to cover this area. I might try and make it out of those primitives that we've already made up and see how that works. But now more on about camera control. In fact, what we're about to do not only applies to cameras, but you can also use it to move other objects with other objects. So it's universal in many ways. So first of all, let's have a look at combining it with fly mode. So this is very straightforward and of course very powerful.
So we've already seen that we can get a particular view very quickly. If this is the view that we actually want, we can actually move the camera to that viewpoint straight away without having to then go and grab the camera and move it to the appropriate location. So we're all aware of going to the camera itself, going to the properties and locking the camera to the view and then being able to move it around. But we do have to be looking through the camera to do that. So if we press 0 now, we're now looking through it and we can reposition the camera like that. That's absolutely fine. We can move it in and out, but as you can see, it's quite granular. It skips quickly. So yes, you can fiddle about with that for a while, moving it here, rotating it, coming in, etc. But eventually that's going to become quite tiresome. However, if we combine this with the fly mode, we can move to a position that we want just simply by hitting Shift and F. Now we can fly around and go to the new viewpoint that we want, so we can look in through this window. Hello everybody, where's the mannequin? There he is. Okay, so that's one way we can do it, but we've already got a view set up over here, so let's just hop out of there. Looks like I have moved my view, unfortunately. So let's just sort this out. Let's hop back into fly mode real quick. Zoom back to where we were before. So say we wanted this particular view and we didn't want to faff about with trying to get the camera into the right position. We can actually go to the view menu and go to align view. And there's got a series of options here. So we can align view to active. So we can look down, up, left, right, etc. But one of the very powerful ones in here, sorry, let go of the control there, align active camera to the view. So we've got an active camera, which is the main one, and the one whose viewpoint we will see if we hit render, but we can assign or align the active camera to the view, and we can see that's Control Alt and number pad 0 if we want to do that. And when we click that, there we go, the camera automatically moves to this position. Now, it is, of course, useful to have multiple cameras in the scene, so you don't have to keep moving one, but we'll leave that for a bit. Now, another way that we can actually track something in the scene is either placing an empty, or in this case, I'm going to use my mannequin as an example. I can track that object through the scene, and this is very, very powerful and very useful. Now, what we're going to be doing is constraining the camera's movement based upon certain parameters. So in this case, we go to the Constrain tab on the Properties window, and we're going to add an object constraint, and there are lots of constraints that we can do. And we want, under Tracking, we want it to track to a particular object. And I'm going to select my mannequin here. 0, 0. I want that one because that's the one that's in the scene. Now, this may look a bit odd at the moment, and it will look a bit odd because we've not set up the tracking constraints properly. But typically, if you want it to rotate around, you're going to want these particular settings. You're going to want it -Z and Y. And then wherever we move, so that's 2 -Z and the up is Y, can be a bit confusing, and we'll go through that in more detail in a moment. But basically now, when we move our mannequin about, the camera automatically tracks. So if I lock him to the Y-axis, the camera stays still and tracks him moving down the church. In fact, if I turn off snapping, it'll be a lot smoother. There we go. So there he goes down there, and the camera is tracking him. That's very powerful. The other thing we can do here is move the camera itself. So if I go and pick up the camera and move the camera, so let's go to the camera, here it is, and go ahead and move that, it's also constrained and looking at the object again, whether that's the focal point that you want to use or anything else. So I can pop the camera over here, and then if I go and grab this mannequin and move it outside, there we go, still following no matter where we decide to put the mannequin. Very, very powerful. Now let's have a look at the constraints themselves, because we can get the viewpoint to follow in many different ways, and the easiest way of visualizing this is to actually track the object when it's in line with it, and then we can see what's going on. So I'm going to move the camera itself to, no, I'm not on there yet. I'm going to move the camera to 0 and 0, which is by the entranceway of the church. There we go. We're looking at that. And I'm just going to move the camera forward a little so it's a little bit closer. And then finally, I'm also going to move the mannequin so the mannequin is at x equals 0 as well. So they're in line. Now let's move out of this viewpoint itself. Lock camera to view, turn it off so we can whiz around and see what's happening from above. There we go. So at the moment, if we go to the camera itself and look at the constraints, if we lock it to the x-axis, we see that it's now looking along the x-axis. And of course, minus x-axis looks the other way. So if we go, and z looks backwards. So that's good if you've got an object moving forward and you want to track it from the other side, so looking at sort of a selfie, if you will, rather than a tracking camera following behind. So X looks along the X-axis, and that's very powerful. If you imagine if one viewpoint was being followed and perhaps tracking, trying to search for something here in my head, an aircraft in flight. If you were flying in formation and you wanted the other plane to control where the camera was going, but keep them relatively close to one another, you can do that. And of course, you can turn down the influence a little here to actually control that with a little more finesse, so it's not so spot on. Now, obviously, when you move an object too far, if the influence isn't one, eventually it will disappear out of frame. So we can set here the up direction of the camera. Now it's quite confusing that up is Y. If we pick Z, we see it looks down, which is the default position a camera would be if you imported it into the scene. So because it's been rotated 90 degrees to look forward in this case, we see, whereas Z used to be up and down, it's now in a completely different orientation. In fact, now Y is up and down. Now we can experience with it locked to the 2 on X. If I go ahead and move this mannequin now, it will track it as if it was very much next to it. So very useful in certain circumstances. Perhaps if you were controlling a different object rather than a camera, it's quite important that the camera is actually focused at the object we want. So in that case, let's go to the camera, go -Z, and then no matter where these two are positioned, whether the mannequin's over here in the sky and the camera's over here, it automatically tracks our object, which is incredibly powerful. And of course, I've got a challenge for you guys now. I would like you to set up some cameras. So set up multiple cameras so we don't have to keep moving just one. Introduce a placeholder or an empty for a tracking camera, much like I've got my mannequin. And then render your building from a couple of different camera views and share. Remember, we're mainly focusing on the interior, but if you've got a cool exterior, please share that as well. Now, do remember that you need to set a particular camera as active in order to render from it. So pause the video now and give that a go. Okay guys, welcome back. I'm going to go and set up my cameras now so I don't have to keep moving them about all the time. Right, so I'm back over in Blender, and the first thing I'm going to do, well, I don't need to do the tracking camera. I've already set that one up, and he's tracking the mannequin. I don't mind where that's positioned for the moment. Well, I might actually move them into a bit more of an interesting position. So let's look from the viewpoint. That's no good. This is, well, perhaps it's an angel floating through the church. Who knows? Well, let's try one there. That looks a bit better. Looks like I've not set his origin at his feet, which is causing me a few problems. This is one of the reasons why you will want to make sure that you have the origin in a logical place for using with your model. So there's my mannequin. Let's see what the view looks like at the moment. That isn't very interesting. So what I'm going to do is I'm going to move him around but lock him so he doesn't go off the floor. And, ooh, where shall I pop him? That might be an interesting render. I will set that. I'll just get my camera and move it around just a little so I can see more of those roofs. I'd love to see how they're rendering out. Okay, so that's one camera all sorted. I'm going to go ahead and just duplicate this particular camera. So I'm going to hop out of its view and duplicate it. Of course, it's already going to have some constraints on it. So I'm going to call this exterior.
So I do want to just have a quick peek at my exterior as I'm working. I don't want it tracking to anything, so I can remove that. I'm also going to create an empty at this point that's going to control all of the cameras, or just store them in the hierarchy. So plane axis, do I care where it's placed? Not particularly at this point. Oh, I've opened up that. The empty here, I'm going to call that cameras. It looks like I've managed to open up my entire hierarchy, which may be a bit problematic, but I'll just shut it back down. So I've got camera here, and let's call this one tracking camera. It's important I know what they are, so let's lift that up and put that under camera. Exterior, let's put that under camera, and I want another one, and I'm going to just duplicate the exterior. Don't know where it is at the moment. I'm going to call it interior, and I'm going to leave it there with 3 separate cameras. So let's make this the active camera, and of course what we can do here is go to the camera properties. Here, cameras, active camera is numpad 0, and then set the object as the camera is control numpad 0. So there we go, this is now the active camera. I'm going to set the interior one right back towards the entranceway. And let's look at the view. I'm going to switch on lock camera to view. That's looking pretty good. In fact, before I do that, I'm just going to zoom in a little so I'm seeing what the camera's seeing rather than a slightly zoomed out version. Let's lift the camera up ever so slightly. Let's make it look epic by placing the camera a little bit lower. And it's being framed by the door or the walls there, so that's absolutely fine. So that's that camera setup, and the exterior one. Well, it's not exterior at the moment. So again, I'm going to use the shortcut here, Control and numpad 0 to switch around to it. And I'm going to fly that one out. Now what I could do here for the exterior is certainly have a ground plane as well. So I'm going to add that in a few moments. In fact, I'm going to add it in now before I do anything else with this camera, because if I start doing other things with the camera, I might actually push it below this plane, and that wouldn't be very good. So I'm just going to scale that up massively and then move it slightly in the Y, and that just gives me a bit of a ground plane. I'm going to set it slightly below the surface as well. It turns out that that is roughly 100 by 100, so I'm going to type that in, and it looks like I'm going to have to look down a little. Yes, I'm going to have to move it slightly below the surface. Let's go up to the actual position, that always helps, minus 0.1. Okay, so that's in the right place there. So let's go back to this exterior camera. In fact, we can just look from its viewpoint and lock the camera to view. Well, that actually fills up the lens quite nicely, but I want to look down on it ever so slightly. Do I need to be back here or a little wider angle? I want to have a slightly wider angle, so I'm going to go to the camera properties and change the focal length here down to, let's say, 24. Then I should be able to fit more of the ground and more of the church in. I'm going to go slightly wider again, going to go for 18. Of course, you do risk stretching and distorting the image, but if you want to fit the whole thing in, that might be what we need to do. Of course, now I'm going to render these out and see what they're looking like. I hope yours are looking pretty good. Here are mine on the screen right now. I hope you've shared your work in the discussions, and of course I will see you guys in the next lecture. So let's talk about what you can export. In this video you will understand what will export, realise some elements of your models will not export, or will once, or not properly at all. It does depend on the target package that you're exporting to. So what will appear on import? Well, often you will have no problem with mesh data, including the UV maps. Armatures and animation data will appear too if supported in the target package. So for instance, if you were moving a mesh and the animated lamp that we've done into something like Unity or Unreal, you'll find the animation is there. If you're trying to import that into something like SketchUp, which doesn't support that type of animation, then it just wouldn't be there. Now, textures may appear that once, this is one of these odd ones, or the simple base diffuse texture that comes when you make your model. But often that will appear the once and then not update anymore.
So what we have to do in a lot of cases if we're working in another application is a lot of reconstruction. So textures often have to be reapplied, whether they're a normal map or a diffuse map, and we'll go over those types of map in much more detail shortly. Shaders, how it actually renders the image, work differently in other packages. And what that basically means is any of your materials would have to be remade. So we've got our textures on one level, whether they're a bump map showing us artificial surface detail, or whether they're a diffuse map which show us the base color of a material. The materials themselves will often have to be reconstructed. So that means if we're working primarily in another package and we're just using Blender to model with, then you shouldn't be focusing too heavily on materials within Blender. You need to focus on materials within the target package. Particle systems are local to Blender. So if you've made something with hair and try and export it, the hair won't be there. You can solidify the hair, sure, you can make it a mesh object and then it will come across, but that might put your polygon count through the roof. Of course, one of the best things you can do is test. So if you want to move from one package to the other, just test what you want to do. Be very lean about it. Just make a hairy cube and see if that opens up in an external package. If it doesn't, ask yourself, well, why is that? And then you drift back and you go, well, it's a particle system. Or you've made the cube look like glass, so it's a glass paperweight on a desk, for instance, and then you test it and it just comes across as a cube. Well, then you need to set up the material in the target package. So what we don't want to do is waste time in Blender if you're moving your models straight over to an external package. Of course, that's not what we're going to be focused on entirely here because it is a course on Blender. So we'll be focused on actually all of these things within Blender and how to get them out as well if you want to use them there. So a quick challenge for you here. Where's your model's endpoint? So where is the model you are making going to end up? Is it going to end up in a game engine? Is it going to end up in a completely different package? Are you moving between the two? We need to make these decisions now before we start moving ahead and wasting time in one package when we should be putting that effort, for instance materials, in another. What do you need to do in Blender versus the external package? Pause the video now and give that some thought. Okay guys, welcome back. Now I'm going to go through my challenge answer. Well, I'm going to remain in Blender for the entire project. So of course it's a course focused on Blender, so I'm going to be doing that. And so the materials will be fleshed out in Blender. Textures will be made in Blender but kept unpacked. So before we've had them packed into the blend file, I think I've still got it default set to being packed, so I'm going to have to sort that out. When I looked at my data block, it did show me that they were packed, so I need to change that. And then I can use any textures I create across multiple models, because they are not going to be stored in the blend file, they're going to be stored on a folder, probably a textures folder, on the actual computer itself, which is incredibly useful. Now, I just need to bear in mind that if I do move my models out, and I will do throughout this section to make sure that they're working externally, that things, if I decide to make a particle system, I just need to be aware that that isn't going to come across. The lighting in a scene, that's not going to come across, etc., etc. There's lots of things that potentially I could do that have no impact in an external file. So that may aid Blender, but it's not going to aid anything else moving out. So I'll just bear that in mind, and wherever possible, limit things like the particle systems and special lighting effects, etc. How did you guys get on? Are you working in multiple packages at the moment? Please share how you're working, what packages you're working in. Are you moving between two 3D modeling packages like SketchUp, 3ds Max and Blender? Perhaps you use one for one thing and one for another. I know a lot of people out there use ZBrush for sculpting and then hop back into Blender for rendering, etc. Or are you working with a game engine? Please share in the discussions, and I will see you guys in the next lecture.
Welcome to Relinking Blend Files. In this video, you will make a commit. Trust me, at this point, there's possible data frustration, almost inevitable if you don't make some sort of go back point. So whether it's a commit, whether you're zipping up your data folder, your current working folder, just make sure you've got a backup before you do anything like this, because it's potentially highly destructive. Understand the order you need to do things in if you wish to change a linked file or its data blocks. And we'll also see what happens if you change a link. So first of all, moving or renaming blend files. Make a commit so that if something does go wrong, you can go back to it. Copy the files to a new location, even if that means they're in the same location or an entirely new folder, that doesn't matter. But what does matter is we do not remove the originals at the moment. They must stay there. Rename the copied files appropriately. So if you've made a fundamental change, then obviously you can rename them. Or in my case that I'm about to go through, I just want to shorten the names and make them a bit neater. Doing it in any other order will break links. And any links broken when you save the blend file will be lost forever, which of course will result in more work reconstructing. And as we've seen with certainly with my Gothic church so far, there are a lot of parts that are reused. There are only about 8 in total that do the whole building. Certainly the window parts and the blank wall paints, if those links were broken, I'm going to have to put a lot more parts back into my model. I don't want to do that. Then we've got moving or renaming data blocks. This isn't so straightforward. There's a completely different method to preserving them should you want to move or rename them. Remember, make a commit so you can roll back at any point. Copy the files. Then open up that copy and make your data block adjustments. So you might want to change the mesh name of an object, or even the object name, or perhaps you want to change the material name that you've assigned. Perhaps it wasn't appropriate, but you need to make these adjustments in the copy. Then we'll go ahead and link the new file into the scene, make links to the new object, replacing the old one, and then finally you can go ahead and delete or archive the old blend file, and that, as we will shortly see, will happily remove that link from Blender anyway by the act of doing that on the next save. So let's go experience all of this and hop on over into Blender. Okay, so back in Blender, the first thing that I'm going to do is demonstrate what happens if we do something to an existing blend file that's linked into our scene. So let's go ahead and go to the file system here, and I'm going to do the front door, because it's one of the least used pieces. So if something goes wrong, at least then I can sort it out. So I've got church front door here. If I go ahead and delete the numbers at the end of it, which is one of the things I want to do, because I think I'm going to go for more of a standard format with these. I'm going to accept that they're going to be 2x4 or 2x2 or 4x4. And the thickness I'm going to stick at, again, 0.2s or maybe even multiples of 0.2, but as long as I know there's a standard across the building that I'm doing, I shouldn't have to put in all these extra details. Okay, so now that I've renamed that, if we went ahead and reopened our church, there we go. The front door has disappeared, and I think it's used over here as well, so that one has also disappeared. And we can have a look in the outliner itself. We can see that the parts, there's actually an empty there now in the parts, and that no doubt will be the church door. So here we go, having a look in the outliner. The church door is now an empty where it used to be. Now, if we go ahead and save the blend file at this point in time, we will destroy that link forever. We'd have to relink the church door into the scene, which is not always a bad thing, but imagine having to do that for something that's repeated a couple of 100 times. I'm not sure how often in this scene so far the blank wall piece is used, but it's used an awful lot, and I wouldn't fancy having to reconstruct it all because I'd made a silly mistake with moving something. So instead of doing that, what we can do is go back, and I am just going to highlight those numbers. Fortunately, the naming convention meant I could just do that because we named our file the same as we named the mesh data and the object data. So now that I've renamed that, that should restore the file. The important thing is that you don't go ahead and save. And that's easy to do. For instance, you may not notice that a wall piece, you will notice if a wall piece is missing, but if you've got a small, let's say a candle or something in the scene, and you're looking at it from the outside and you're making some changes from the outside, you might not notice that disappearing. So now that we've reverted and we've changed the name back, we've got the door back there. So if we wanted to move our object, the first thing to do is make sure that we're using relative or absolute paths. Now by default it's using a relative path, which basically means that it's not reliant on whether or not you're in the exact user directory on a particular computer. What it does mean is as long as all of the stuff is grouped in a similar way on every computer, so in this case I have my project folder and meshes, as long as, and the other folders that are associated there, as long as that folder structure still exists on another computer, it will work. So let's go ahead and just check what we've got. So when I go and link a file, there on where the operator panel would usually sit on the lower left hand side, we've got relative path ticked, and that will be ticked by default, and we will also want to leave it ticked, so we will leave it ticked. Going to click cancel to come out of there. We've checked that. So the first thing that we'd need to do if we wanted to move information about or rename, and renaming is what I'm going to do so I don't have to type too much, let's go to the file system and copy the blend file. Now that we've copied the blend file, we can just rename it, and for speed purposes I'm going to call it Church Front Door CFD. Lowercase. Now case does matter, it is case sensitive. What we don't want to do is inadvertently break something by not getting the case right. So I've named it CFD. Hopping back into Blender, I can then go to the data blocks in the outliner. Once I'm in the data blocks, we'll need to go and find the libraries. Now this is going to look a bit messy. We think we've named everything, and in fact we've missed something. These libraries, but that's okay because they're hidden away. But since we're here, we can actually go in and name them. Now I've gone into this section a few times, so I know straight away at mine library 004 is the door, and we can see the file path down here links to the door itself. Now because the data blocks in the file itself have not changed, all we've done is move the file position, we can update this to the new name or even the new position if we moved it to another folder. The first thing I'm going to do is actually call it front door on the library so that I know what it is just by looking at it. So if I need to come back later, I know where it is. And we can see here it's a relative path, it's got the two slashes, dot dot, meshes, and then we've got the file name there. So one of the reasons why I want it shorter is sort of this area and a few other areas in Blender. I can't widen that, so it's just too long. So we had it Church Front Door, and I'm just going to go back and make sure. Oh, no, that wouldn't work. You do have to make sure this is named perfectly. So if it does mean you look here and then you hop back and go cfd.blend, lowercase, etc. It's in the meshes folder. Well, I've not changed anything there, so that should be absolutely fine. What we can now do is go ahead and save the blend file. Don't make a mistake, and don't make a mistake. Do double check that you've got this right before you click save, and then go ahead and let's reopen the file again, and all should be okay. If you're doing things like this, for your own sake, do them one at a time and commit in between each one so that if you do make a mistake, you know where you've made the mistake and you can just go back to that point. If you've got to change all of these pieces out or just move them all to a new folder and you're doing this to keep it nice and sane for you, then of course you will need to make that commit in between, because what you wouldn't want to do is do the whole lot again. Okay, so now that we've done that, the other thing is if we do a data block. Now that's something slightly different. Again, we need to take a copy of the file. So let's take a copy of the CFD file in this case. So I'm going to take a copy of that file, and it's going to be called CFD2. That's really, really deep. And I'm going to rename the mesh data here actually what I want to call it. So instead of going down this route, I'm going to rename the blend file in a moment. I want to call this level of detail A, since it's a lower poly mesh. It's a very basic mesh. And I want to call this then front door. I know it's a church because that's what I'm building. You may call it whatever is appropriate for your particular model, but front church, that's great, isn't it? I say the word church, so I type it. LODA, because it's the basic model, front door. Don't need any more details than that. I'm going to go in and update the mesh data as well to reflect the same name. That at the moment is important. Now CFD2 is not the right name at all, so I'm going to go ahead here and go save as, and I'm just going to call it front door. Again, it is explicit that, and let's just put underscore in there, it is explicit that it's going to be a church that I'm working on. I could even move it into a church folder if that was at all necessary. So I'm going to save that and go back to my file system quickly and do a tiny bit of clearing up. I'm going to delete the CFD2 that I created. Okay, so now when I go back into the scene itself, the Gothic church scene, I'm going to have to link that new file in. Meshes and front door. Object. LODA front door, and then we could pick higher levels of detail if necessary. So we're going to pull that in. It's come in, and we're going to make it a proxy, and it's on layer 2 here, which is absolutely fine. Oh, the ground is not on the appropriate layer, so let's move that to layer 1 so it's all together. There we go, ground's back on. So in order to take that object data from that newly imported object, what we need to do is first select the ones that are going to receive that data, which is, oh, we don't want that corner piece, which are these two front doors. I'm not doing very well with selecting. There we go. Now I've selected those two, I'm going to turn on this other layer, which has got the last door on, and select it. So the active object has to be the one giving the data. And then we can go to Object and Make Links. And we can see the shortcut there is Control and L. And this is where we go Object Data. Now, nothing would have really changed because they're both the same actual mesh underneath. They're just called something different. If we go ahead and save the file now and come out of Blender completely, and let's go here. Now, that's named CFD. So I'm going to delete, I'm going to take a punt here that I've done that correctly. I'm going to delete church front door and CFD completely from my archive. I can do that safely because I've made a commit. And then I'm going to make sure that's saved and revert. And there we go. It's still there. They haven't disappeared. Now you can use this for other things as well. So say I wanted to replace this wall piece at the very top, because they're modular, they're all the same size. It means that I can then select the door down at the bottom, go Control and L, and do the object data. And when I do the object data, you can see it replaces it. And that is incredibly powerful. It allows you to modify your project very, very quickly. And as you saw in that list there, there's some other things you can do as well. So say we came up with an awesome color for the church itself. So I'm going to create a new material on this wall piece here. Now it's going to apply to every single wall piece that has inherited, which is the rest of the wall pieces in the model. And let's just say we've made it an awesome orange, and let's call it awesome orange. It's my new favorite color, awesome orange. And I'm going to hop into materials just to make sure that's applied. That's quite bright. And say we wanted that on all of the vaults. I keep forgetting what these things are called. We would select the vaults first, all of them, if we wanted it on every single one. And then, and only then, we would click on the donor, and then we'd go Control and L and select materials. And there we go, it's inherited those materials. Very, very powerful and can save an awful lot of work having to assign those individually. Brilliant. Okay guys, I'd like you to check your naming and filing. So ensure all the basic building blocks are named appropriately. I'm going to be using the prefix LOD_A for mine, which means it's the lowest level of detail model I'll be working with. Make your names as concise as they need to be. So I have personally decided that I don't need the prefix church, since the whole project is going to be about church. If you're doing a different type of interior, maybe kitchen or something like that, name your project folder appropriately rather than having the individual name tagged on the beginning of the file. It's entirely up to you. This is one of those things that's more of a personal taste, and I've decided the numbers at the end might just be a bit clunky, so I'm going to cut those off as well. I know that all of my building blocks for this particular scene are going to be 4x4 or 4x2 or 2x2, so they're going to fit together nicely, and I'm going to stick to that standard width of 0.2 unless it's some sort of special part, in which case it's probably not going to be modular anyway. It's going to be a special part. The method for data blocks, by the way, works if you're renaming and moving the whole file too. So if you're going to be doing both of those tasks and not just an organizational task, then you will probably be better off doing the second method, but do them one at a time and remember to commit or back up your work before you do any of this, because it can be very destructive. What I don't want you guys to do is obviously have to repeat a load of work because you made a tiny mistake in naming something. And this is going to be another one of those lectures where I'm going to leave you to it. I'm going to go off and rename all of my files, and I will see you guys in the next lecture. Welcome to Profile Modeling by Extrusion. So in this video, we'll understand what profile modeling is, potentially speed up modeling by mirroring, use a series of methods to produce a profile that we can use in our scene, and then in the next few lectures we'll use the same profile in a couple of different ways which have significantly different effects. So what is profile modeling? Well, profile modeling is the outline you get when you view something from a particular angle. One of the best things to do is imagine slicing through your model. Now realise we have used them in the past. We've used We've got the lamp base, which was produced with curves, and the pin was geometry based. So the methods we're going to use up ahead, we're going to bump up our extrude speed so we don't have to keep pressing E every time. We're going to be using the bevel tool for constructing and defining sharp edges, and a subsurface modifier for making the surface nice and smooth. So let's hop straight on over into Blender. The first thing that I'm going to do now we're over in Blender is open up one of the pieces that we've been working on. So I'm going to go ahead and open up the front door. So now that I've got the front door, I'm going to be producing a variant with some more detail on it. So first of all, I'm going to take a duplicate of my object. It doesn't have to be a linked duplicate, just a normal duplicate. Now in the outline, I'm going to name it straight away what it is. So this is going to be LODB because it's going to have some more detail on it. And I'm just going to call it front door. And I'm going to do a couple of variants at this particular level of detail before I bump it up any more. So I'm going to call this front door 1, etc. So down here, the mesh data itself, I'm going to update to also have the same name. Now that we've done that, we can start doing something. So the first thing I'm going to do is create a profile and work from there. So I'm going to hop into edit mode. I'm going to, well, there's a couple of options here. I can hide the LODA mesh from my scene, or I can shift it to another layer. In this case, I'm going to move it to another layer, or rather move the B mesh to another layer, and then switch over to that layer. Remember, there's a little orange blob for the active object. It's highlighted orange down here. Okay, so now that we've done that, we can start adding some detail. So I'm going to hop into edit mode and first of all, put the 3D cursor where I want it. So I want a bit more of detail going around this archway here. So I'm going to, first of all, select a vertex that where I want to create the new geometry. I'm going to move the 3D cursor to that place with Shift and S and cursor to selected. Once I've done that, I can hop out of edit mode and I'm just going to add a basic cube and we'll work from that. Now that is far too big, as you can probably see, so what I can do here is literally scale that down to roughly the right size and then move in and focus on it. Now you can see there the camera clipping is happening, so I've got to be careful not to go too close. I don't want to muck around with my camera clip, but I can change that down here in the view options. If we go down here under view in the properties, where is it, start clipping here, we can lower that right down and then I can get really close to the model in theory. There we go. Of course that can cause problems later on, but we're not going to worry about that. That's if you want to get inside a model to see what's going on. So we've got this archway here, so it's going to be a new object for the moment, so I'm going to call it LODB archway, so that's the level of detail it applies to. And let's start adding some detail here, because that would be a pretty boring profile. So I'm going to use the bevel tool to very quickly add some detail. And so we're going to hop into edit mode, select a couple of edges, press Control and B for the bevel, and let's just move it in and add some detail there. Now I can change the profile here, so I can make it a bit less curvy or even inverted, which would make an interesting door. So I'm going to move this one out so it's a little higher, select this edge and bevel it to about the same degree, and then make the profile go the other way. That's looking pretty good so far. It's a nice basic profile. I can add to it as and when I want. I'm now at this point going to add a subdivision surface modifier, and this is going to cause us a problem that we'll go and fix straight away. And we can see the problem there. It's made everything all collapse in on itself, and the reason for that is because this object currently has a top and bottom face. If I remove the top face here by clicking on it, pressing X, and deleting the face, you'll see that the top now falls in line with the model. Almost. It's still a bit smooth going around these sharp corners. So we'll use another bevel in a moment to define that sharp edge. We can, in some circumstances, make this edge sharp, but since we're working with a profile, in the end, we're not going to have a three-dimensional shape, so that edge is not going to exist at all. So let's go ahead here and remove this bottom face as well. And there we go. We've got a much more, a much better shape. It's not caving in on itself. So now we've got this shape here, we can go ahead and select a couple of edges that we want to keep sharp and add another bevel. About 3 segments is absolutely fine. And I'm going to lower the profile right down. Nope, bring it all the way up, other way. And that will mean that we now, when we hop out, have a much sharper edge. Now, there's not enough subdivisions here, so I'm going to up those, or turn on smooth shading. I'm going to turn on smooth shading in this case. And we can see there that's got a much better defined edge. So now that we have a profile, we can start using it. And the first thing I'm going to do is delete this top edge, because that's not where I want it to be. So I can hit the X key and delete the vertices, and that will get rid of these upright edges as well. Now, because we've got this edge loop running around here, it's very powerful. We can hold down Alt and select the entire thing and start extruding. Now, we're going to extrude in a very quick manner, but it is important that you control where the extrude is going. So you can hold down Control and click, and it extrudes to that location. Incredibly powerful. However, that has been moved in some sort of random 3D space. Well, it's not that random. It's to do with the plane that your view is from. However, that's not very nice and it's not very controllable. So what we can do here is I'm going to undo those random extrudes. I'm going to flip round to the view that I want. So I've gone around to the front view. And now I'm on the front view. What I can do is not worry about it drifting in the y-axis. It won't do that. And now I can roughly click on these points here. Now, this isn't going to be overly accurate. I can put it over here if I want to. It's just the profile that I want needs to follow the door. And of course, you can add a bit more detail if necessary. Now, of course, here, there's a decision to be made at the top, whether or not we use a mirror modifier. Well, if we do use a mirror modifier, we do need to go to this point here first. Otherwise, we end up, if I go back one, we end up with this triangle here that when it's mirrored, will actually make it look horrible. There'll be a hole in the top and we'll have to join all that up. So if we go to here first, and then go ahead and delete that edge loop that we've got here, so we go ahead and delete the vertices, that ends up still being upright, or near enough upright. We can go in and edit it to make it exact, and of course then we can work on only one half of the door. And if we were going to do that, we could actually chop the door in half as well. So let's go ahead and apply a mirror modifier. Arguably at this point in time, it may actually be quicker to just carry on extruding down, but for the sake of showing you the mirror here, I can put the mirror on. There's a couple of options in terms of its reflection axis. X is the one I want because it's going along there, but we see that it's reflecting around the origin. So we can either pick a mirror object. So often I will introduce an empty to the scene where I want a mirror to be, and in this case I am going to do that. Now I want it at X equals 2, so I'm going straight here into the properties pane, going to the 3D cursor location, finding X and putting it on 2. That will move the 3D cursor there. Hop into object mode and add ourselves an empty, and I'm going to call it, there we go, mirror. Now I can go back to my mirror modifier that I've got going on and actually select that, and it will reflect around. And we can see here that the vertices themselves aren't quite lining up, and this is where this merge limit can come in. So if we've got the merge ticked, well, if we keep increasing that, eventually those will snap together. We're going to have to increase it quite a bit, but there we go. That has now merged those. So if we apply that, I'm not going to apply it at the moment just in case I want to change something, but when we apply that, that will then be nice and smooth. And we can see straight away we've got an archway built up, and it's really, really neat. Very quickly, we've got that detail there. Okay guys, a quick challenge for you. I'd like you to create some more extruded profiles. So try using extruded profile on other models. So we've got the window, you could use it around there, and you can maybe even put some detail on a wall. Now do remember this can be used at a macro and micro level, so it can be used for many different levels of detail, from archways to arms of a bench, for instance. So pause the video now and give that a go. Okay guys, welcome back. Let's go add some detail to a window. Okay, so first of all, I'm going to make sure I've got everything named appropriately. Great. And I'm going to save my work. I'm going to go and find and open up my window. It's a lot easier to find it. Now it's just called window. And we're going to add a profile around here. So I'm going to move the 3D cursor to where I want this detail. In fact, I can add a couple of profiles. I could do the window ledge itself and the archway, but I'm going to focus on just the archway. And I'm going to go all the way around rather than mirroring because I want a slight asymmetry to it anyway. So I'm going to flip over into vertex select, select a vertex, and using the cursor movement, I'm going to move the cursor to selected. Once I've done that, I can add in a shape that I want to work with. And I'm going to add in a cube and scale it all the way down. It's nice to work with that. So now we've done that, we just need to add some detail. So I want it actually quite pointy here, so I might need an extra level of detail. But again, I've got to remember that this is going to be, oh, I've jumped straight ahead and I've started adding to the level of detail A. So what can we do here? Well, it's very straightforward to sort this lot out. Fortunately, I haven't gone too far, I've jumped ahead of myself. I'm just going to hit undo a couple of times, and then go ahead and duplicate that object. There we go, duplicated the object, and let's move it to layer 2, rename it LODB, and then Windows, absolutely fine. The 44 just describes the size. I don't have any other sizes at the moment. It's going to be a bit, I'm going to leave the 1 on the end there. I may need to sort out that naming convention later on, but as long as I'm consistent, that should be absolutely fine. So I've renamed all of those things, hop to layer 2, and now we can start modeling. Fortunately, the 3D cursor is still in the same place, so I can go ahead and add that cube. I do want to add it as a different mesh object at the moment, So let's go into object mode. I could add it to the other mesh, but I don't want to ruin the underlying mesh just at the moment. Well, I don't want to ruin it at all, of course, but I don't want to disturb it. So let's go ahead into edit mode. Click there, and let's move this edge right in to make it nice and pointy. Now I'm going to use this profile to stick it in a little and pull that. So we've got a nice sort of curve going on there. I like that, but it's slightly in the wrong place, so we can start moving things about. I've got snapping turned on to whole increments. I don't want that, so I'm going to hold down shift to do some smaller increments. Once we finish the bevel, of course. Select everything and let's move it with much smaller instruments. With much smaller increments locked to the x-axis. So let's move it on the x-axis. And yes, I'll go to that, maybe not that depth. Let's go and see where it's placed here. And just move it back. So it's just inside the wall. That's perfect. Now I'm going to grab this face here, extrude it slightly this way. That's not slightly, that's lots. I'm going to turn off snapping to do that. There we go. And I'm just going to do that bit by eye. So that's okay. Now I'm going to round off this particular edge. Again, using the bevel. I'm not going to go for an inside round, so I'm going to change the profile and make it move the other way. And then finally, I'm going to add a bit of detail using a subsurface modifier, but I'm going to delete those top and bottom faces first, so it looks nice straight away. So top faces and bottom faces, delete those. Then we can add our subsurface modifier. I seem to have zoomed in, so let's select something, and there we go, perfect. So now we've got that there. I just need to make this edge here sharp and the one on the inside as well. So I'm going to bevel to do that. It's already on the round setting, so I know that. And I'm going to bevel there as well. Now, if this was being mirrored on the other side, this would need to be totally sharp or near enough sharp, otherwise it will look silly. So what we can do there to make it absolutely sharp is couple of options. I'm going to bevel, but make it an incredibly small bevel. And I can change it here on the amount by 0.1. There we go. So that's absolutely tiny now. Okay, now we've got that, I can delete this top edge loop. Select the bottom edge loop and start modeling. I'm going to whiz around to the front. And I'm going to go all the way up and all the way down. So let's control and click. I'll click there. Now we can see there it started slightly off center, but that's okay because we can go back to it later on and sort it out. It's one of the benefits of this. It's also slightly at the wrong place down here, but that's okay because we can select that bottom edge loop and start moving it and straightening it out. Again, don't have to be perfect unless it's a model that absolutely requires it. I'm going to turn snapping on here and faces, and moving it in the Z-axis only, I'm going to snap it to this bottom face. Now that's looking pretty good. There's a couple of things that we can do to make it look a bit better. We can go and grab an edge loop running around here, for instance, and scale it only in the Z-axis, and we can give it a much taller or thinner approach. So that's no, I don't like thinner. This would probably work a bit better on the door, and I've got snapping turned on, which is not making it very smooth. But I can make that smaller or thinner if I want. I'm going to make it slightly bigger. And around these edges here, I'm having trouble selecting them. We'll get there eventually. That edge loop there, and this one. Oh, missed it. That one there. Hopefully that's got the entire edge loop selected. What we can do here is add a small bevel to those areas to help define that shape a little more. And of course smooth shading is not turned on here, so we can go ahead, hop into object mode and turn smooth shading on. And that's looking pretty good. Let's check it out in rendered mode. There's no light in our scene. So this is one of the downsides about removing a light. So we can go ahead and add a lamp into the scene. The sun, I'm just going to randomly rotate. See if we can get a good light source come in. I can always hop out and sort that out, but that looks pretty good. How did you guys get on? What sort of extruded profiles did you make? Please share them in the discussions, and I will see you guys in the next lecture. Welcome to Profile Modeling using Curves. In this video, you will create some alternative detail. Convert mesh objects into curve objects, then use two curves to create geometry. And then use those two curves to create geometry. One controlling the profile, the other a path. We'll see that this is great for more accurate path following. So let's hop straight on over into Blender. Okay, so we're back over in Blender, and the first thing before we move on to the curves, I noticed when spinning around my model that it looked a bit odd at the top here, and when I went all the way around, I saw that I've got crossed over geometry. Oops, I think when I was scaling, I've inadvertently managed to push the model through itself. Now, whether or not that's going to have a massive impact on the end production, it probably will, so now I've spotted that mistake, I will have to go back and correct that. Make sure you check your models over. Make sure that you haven't pushed any geometry through itself. I didn't spin round, so I didn't see it. I was just looking from the area that looked good, unfortunately. But there we go. So let's move on to curves themselves. So first of all, I'm going to select this object, the window frame that we've made, and I'm going to duplicate it because I'm going to use the same profile that I've already created to generate the next curve. I'm then going to hide the original window frame, hop into here, and I'm going to call this window frame profile curve for the moment, so I know exactly what it is. Once I've done that, I'm going to hop into edit mode and remove all the unnecessary geometry. Now, you can limit vertices to visible if you want to with the toggle on the 3D editor header. I do prefer using the wireframe mode because then it really is explicit that you're going to be able to select items through your model. I'm going to go here and grab, and we can see the mess at the top there, I'm going to go and grab these top vertices here and delete those. And then I'm going to grab the ones down here as well and get rid of those. And that leaves me with the profile itself. But this is a mesh profile at the moment. So what we can do is hop into object mode and go to object and convert, and that's right at the top here, convert to curve, and obviously convert to curve, yeah, so curve from mesh. And here we have Alt C just to remind you what that is. So now it is a curve object. I do not want to keep the original in this case, so I'm going to leave that unticked, and that will remember the last setting you had. So if I had kept one before, then it would still be there. The next thing that I want to do is generate a curve. Now, I could go through creating a curve and lifting it up and through. Now, one of the things that you can do is obviously duplicate this edge that runs around here and use that as a curve. So let's go and try that now. Let's go ahead and go to the appropriate model. I'm just going to hide the other one as well from the scene, or it's done automatically because it's on a different layer. Okay, so let's go ahead and hop into edit mode. Select the edges we want to be used for a path, which are these outer ones here. Once those are selected, we're going to duplicate them. We're going to separate them. And there we go, we've got here, and I'm going to call this, I suppose I should call it window frame path, because that's what it's going to become. Now in object mode, I can use Alt and C and once again convert from a mesh to a curve. And again, I don't want to keep the original. So let's go and see how this works out. So we need to give the path a bevel to go around. So whilst the path is selected, we can hit the curve data. And down here, we can bevel it around a particular object. And in this case, we can use the profile curve. And there we go, we end up with a very similar curve as we did before. If I hop out of wireframe, aha, you will see here that the normals are in fact the wrong way around. Now we're not going to deal with that right at this moment. We'll just have a quick look around the rest of the model first before sorting those out. Let's just check that that's right. Does that fit the curve? It doesn't look quite right in the middle. Is something missing? Okay. So when I selected the outline originally from the window frame, it looks like I've missed a bit. It hasn't come back out here at all. And it should have done, or is it inside the model? Okay, so there is a rotation going on here. Now, it's a rotation of the path itself. Even though it's a line in 3D space, it has rotation. So what we can do is hop into the path's rotation. So going to go into edit mode for the path itself, and we can see it's there. I'm going to select all of them and change the mean tilt, which you can see here over in the properties panel of the 3D editor. And that will twist it along that path. Looks kind of funky. Obviously, if you keep going round and round and round, if I hop out of wireframe mode, we can see that as we tilt that round, it then appears the right way. So at this point, I think it's going to be minus 90 to put it in the right place. No, more than that. Oh, that's minus... I didn't type the right number in. Is it minus 90? No, that looks wrong. Let's try 90. That looks right. And of course, at this point, if we wanted something the other side, which we haven't done yet, if I wanted something the other side, I could apply a mirror modifier. Now, I have in this do I have the mirror plane? Was that the doorway? I don't seem to have a mirror plane here, so I'm just going to try mirroring around. Nope, none of these options are going to be good enough, so I'd have to create an emptier mirror around that. I'm not going to do that at the moment, but there we go. That's a nice and simple path. The normals are the wrong way around, and that will be generated from this profile curve itself. That means the normals of this curve are in fact the wrong way around, so we can sort that out now. Now we can convert this to a mesh object and flip the normals. We know how to do that. However, we can also change the direction that this curve is being generated, and it's the profile one that's causing this normal inflection. And we might not want to remove the curve object from the actual blend file for various reasons. So in this case, we can flip those by selecting all of the points along the curve, the profile curve, and then going to curve, segment and switch direction, and there we go, that has been reflected. Of course, at this point we can play with the resolution of the curve, so we've got a couple of resolution points here. We've got the one that follows its round, and we can't really make that any sharper than it already is without manually editing it, and we've got the profile itself, so we can go in here and change the preview for both of those. It doesn't get any better by changing the profile curve because it's already got as many segments as it needs. And the window path, well, let's just try changing that, and surprisingly or unsurprisingly, it doesn't make a difference either. And that's because the path it's fixed at certain points, so there is no bend, so changing the resolution doesn't matter. However, turning smooth shading on can help it look much better. Brilliant! And of course, it's time for a challenge. I would like you to create some curve-driven geometry. Try using a beveled curve on your other models. And remember to share your work in the discussions. Pause the video now and give that a go. Okay guys, welcome back. Let's hop straight back over into Blender. So I'm just going to make sure I've saved my work here. So I'm going to go File, Save, and then I'm going to go to my door and demonstrate a similar thing on the door. So I'm going to copy the archway and so duplicate of that, perfect, and name it archway. This is going to be profile, and we'll convert that to a curve in a moment. Now I'm going to do the LOD door as well and select, excellent, I could just select the edge loop there. It's got all of the information I need. Yep, so let's duplicate that, separate that, and there we go, we have it down here, and I'm going to call that archway path. Okay, so now that we've got the archway path and the archway profile, we need to sort out the profile itself, so it is actual just a single profile rather than the entire work. So let's hop in, and of course it's mirrored, so this is going to be even quicker. We can just select those there. In fact, if I hop into wireframe, it'll make it even easier to select everything. X for delete, and delete all the vertices. Okay, so let's hide away the front door archway that we've created. There we go. And we should now be able to convert that. Oh, there's one the other side as well. That is the mirror modifier. I'm going to hide that to prevent myself getting confused. Or in fact, in this case, I can, well, just remove it altogether. Okay, so now I've got that. I'm going to leave the subsurface modifier hidden for the moment. I'm just going to see how much of a difference that can make as well. So I've got my profile ready. Let's go ahead and convert that into a curve, and the same with the archway path as well. So now those two items are done. We can go straight into the path, curve data, scroll down to the bevel object, and select the archway profile. Now, is it the right way around? And are the normals the right way? Normals are the wrong way, but this time the archway itself has actually been generated the right way around, which saves me a lot of time faffing. The only thing I need to do here is go to the profile itself and go to go into edit mode, curve, segments, switch direction, and that is sorted. It's gone all the way over. Let's just see if the subsurface division makes any difference whatsoever. I don't think it will. So let's go to the path itself, add a subsurface. Oh, it's made quite a bit of difference. That helps smooth out the archway really nicely. A pleasant surprise there. Of course, this one's actually got the mirror object in, so I can go one step further on this particular model and mirror it around my mirror point. And now he says it needs to be on the y-axis that we do that, not the x. Okay, and there we go. We've got that in roughly the right place. Now it looks like, okay, the mirror object is not really in the right place for doing this. It needs to be in the middle of the door itself. So I'm going to go ahead and grab the mirror, and in its location, transform on the properties, I think it's going to have to be minus 0.1, its location. So minus 0.1. There we go. Now the archway is on both sides of the door. Now, interestingly here is that, yeah, there's a little bit of a dent here where it's being constructed, but that's okay. That adds to the detail in the door itself. That is coming along really well. How are your models coming along? I'd love to see them. Please share them in the discussions, so everybody can see what you're up to and your designs. If you're going for an alternative style, I love seeing those as well. If you're not following along with the Gothic church, what are you doing? I can't wait to see it. So remember to share them in the discussions, and I will see you guys in the next lecture. Welcome to profile-based modeling using mesh objects. In this video, you will use the array modifier to repeat a mesh object along the length of a curve. We'll then deform the array using the same curve data, and hopefully end up with some pretty awesome results. So let's go hop on over into Blender. Okay, so over in Blender, I'm going to use my door scene to demonstrate this next task. So I'm going to need a copy of the archway not the archway profile, the archway path. So I'm going to duplicate that whilst I've got it in front of me, and then I am going to rename it. And this is going to be archway array or something along those lines, because we're going to use an array modifier in a moment and we need a control for it. Now I'm going to go into the modifiers tab and remove any modifiers that are associated with the archway array. Make sure that is the one you have selected before just hitting the cross on those. And now we've done that, we need to just, in the data itself for the curve, I'm going to remove the bevel object. Those are the only things that are different, and that should leave us with a single curve moving round. Perfect. So now that we've got the curve itself, we need some mesh data to work with. So there's a couple of ways that we can work from this. I can start from the LOD archway that I've made here, or alternatively I can go backwards and work from the archway profile. I'm going to work from the archway profile in this case, so I'm going to duplicate that, and then I'm going to call that archway array, and from that I'm going to convert it back to a mesh object, and we can check there's a mesh object here. Excellent. I'm going to hop into edit mode, I'm going to focus down on this area here. I'm going to select it all and fill it in. Then I'm going to grab that face that I've produced and extrude upwards. Now at the moment, yes, snapping is turned on and that's going to cause me potential problems. So I'm going to turn it off. So I don't know how high to make this. In fact, I'm going to go around to the front view so I can get a better idea of scale. I'm quite happy with that. What I do need to do here, however, is turn off my archway path so I can see what I'm doing. Now I'm going to select everything here and duplicate it again while still under the same mesh object, only moving it up in the Z-axis and leaving a little gap to imitate where mortar would go. Then I'm going to select these faces here, and in this case I'm actually just going to pull it like this to make it slightly bigger on the x-axis, zoom round to the front again and just check the relative size. I'm happy with that and I'm going to come back out into object mode. So now we have our two brickwork pieces that we can work with. We need to first of all apply an array modifier. So I'm going to go across now to the modifiers, go to an array modifier, and first of all we can see it's moving in the x-axis. It's going to want to go in the z-axis, so let's change that first of all. And I'm probably going to want a little bit of a gap there as well to imitate mortar between the blocks themselves. It looks like it's going to be even smaller than that. There we go. That will do for the moment. We can trim it later. So we have fit type. At the moment we've got this fixed count, which is all very well and good, but it'd be good if it just matched the length of the curve that we've produced itself. And we can do that by changing it to fit curve. Okay, that hasn't done what I thought it was going to do. And I think I know why. Just glancing at the scale, I can see it's currently set to 0.1. Now I don't want to just turn that up because it'll get really, really big. But that means that this is actually a tenth of the size of what it would be in edit mode. So I'm going to go to my object and apply the scale. I should see that then shoot up. I also need to select the curve itself. So if we go to the archway array, that should now be as tall as the curve is long. The next thing we need to do is bend this in direction that the curve is going. So we've got the right length, but not the right bend in it yet. So we need to add another modifier called the curve modifier, and it's under the deform column, and it's the fourth one down there. And we need to select a object in which to deform it to, and we're going to call the archway array. Okay, so that's not looking great so far because it's gone off in a random direction and it's deforming in the x direction. Of course, we don't want it to do that. If we click -x, well, it's going the other way. If we click y, nope. -y, also no. So let's try z. Now that's looking much better. But there appears to be a twist going on and it's moved as well. So we need to be careful when doing this that we set things up in the right location. So let's just see, how has that rotated? Quite extremely. It looks like it's rotated, yes, inwards this way. So let's go ahead and go to our curve itself. So I want the archway array. The first thing I'm going to try and do here is literally go into edit mode and change the mean tilt. Okay, that appears to move it round, but not quite in the same way that we would expect it to. The other thing that we can try here is moving the actual mesh object itself. Now this will take a bit of playing with, but that's okay because this is quite a powerful tool. I'm going to set the mean tilt back to, well, let's see what happens. We've got 0, 180 goes the other side and has almost the same orientation as if we've reflected it. So I think 270 is going to be the right one, but it folds in on itself. So it's not as straightforward as that. And that, again, is because the curve itself has a rotation to it. This mean tilt isn't sorting it out because of the other modifiers applied. So what we will need to do here is actually move the piece itself, and that can cause a few problems because then you lose relative position of where the piece is to where this is. The other thing that we can do is actually generate our own curve. That can solve this particular problem. So we go ahead and in the archway array in edit mode, I'm just going to delete. And that puts it right back here. Now I need to make sure my origin that I'm working from is going to be smack bang in the middle of where we're starting. So that'll be, let's go into vertex select this object here, select that one, put the 3D cursor over that. And then when we can create our curve, I'm going to do a Bezier curve. Don't rotate it. You're going to just have to move things about. So I'm going to pick the first and end points first of all, and then I can flesh out the rest afterwards. So the beginning point is obviously going to be on this point here, but it's currently halfway along. And the end point is going to be on the other side. So I'm going to turn on vertex snapping. I'm going to move the beginning of the curve. Oh, there's lots of things in the way. So what I can do here is start hiding some stuff. So hop out of here, hide that piece there, grab the curve again and put it in the right location. And I'm going to do the same with the other end of it. And that should align things how I want them to be. Perfect. Now we just need to grab these handles and position them in an appropriate location. And the same with this one and this one. Okay, so I'm just going to check here that the coordinates, by looking at them, make sense. They have different Z values. That's fine. We've got a curve moving across. Let's work with that for the moment. And we've got a Bezier curve here. So we need to change the archway array mesh data, which is currently hidden, and change the array to the Bezier curve that we've made. So it's the right length. So it's a lot shorter now because this curve is a lot shorter. And we can change the curve deformation to the Bezier curve as well. And that is already much better. So we're not having to deal with trying to fix a curve, rather just remake one based upon the actual archway itself. Now that we've got these pieces here, we see they are still tilted the wrong way around. So we need to go into the curve properties. By selecting the Bezier curve, hopping into edit mode, and the first thing, as always, I'm going to try mean tilt and rotating it round the right way. So it's going to be something along those lines, again about 270 or minus 90, of course. That is looking pretty good. I think it is actually 90 looking at these. Of course, I can move the curve at this point in order to put things in more, a better location. So at this point, the curve is there. I can drag it forward slightly and put it in the right place on this side. Again, with snapping turned on, that can be a little bit problematic. So it's going to need to be approximately there. So that is looking pretty good. It just needs to be the right size. So we can hop back into the Bezier curve itself and keep editing that until it's the right size. And of course, what we can do now is change the resolution of this curve so it's low enough to just snap to these points going through our model. So in that case, we go to the curve properties and change the resolution. If we don't do that, it tries to interpolate between those control points and you end up with a very wiggly line. So in this case, we'd want to lower the resolution down to 1. And we've only got one control point at the moment. So we need another 1, 2, 3, 4, 5, 6, 7. So I'm going to subdivide that. And the number of cuts will be, let's see, that's 2, 3, 4, 5, 6, 7. I can now align the control points, not the handles, but the control points themselves with the appropriate place on the model. Now, at the moment, I'm not sure they are in the right place at all, so I'm going to select them all. And the Y coordinate here needs to be level with this wall in order to get this snapping right, otherwise we'll end up twisting. So let's just make sure that we move the whole lot in 1. So let's go ahead and move whilst it's locked to a face, and we'll lock it to this face here. So, oh, not F. Didn't want to fill that in. Undo that. Let's move it, locking it to the Y axis onto this face. That's good. Now we can go about grabbing these control points whilst it's snapping to vertex and literally just move them to the appropriate location. Now you can see at the moment it's going really crazy, and that's because it's trying to snap to itself. But as it's trying to snap to itself, the geometry is changing, so it goes all over the place. There's a couple of ways we can deal with that. We can go ahead and turn self snapping off, which is this little toggle to the right of where it says closest, or indeed is turn the geometry off itself because we're only editing the curve. In this case, it is a lot easier to just remove the array from the scene by hiding it, and then we can move things without it going really crazy. Now I'm going to grab these other control points and quickly pop them in position. Okay, so that's the last control point in position. I can turn the array back on, and there we go. That's starting to look pretty sweet. Now, I'll just demonstrate what I meant about the resolution. If you set it too high, it starts to try and interpolate between the points with extra bends, and we don't want that. As you can see, it starts moving things around. In fact, in this case, it starts to twist around as well. Now, the great thing is we've got complete control over where these things are placed, and that's turned out actually much better than I thought it was going to turn out. If we hop into object mode there's a really nice level of detail throughout the entire archway. Should probably turn smooth shading on. Not sure I like the smooth shading on here. I think I need to define some of the edges a bit better before I go ahead and do that. So I'm going to leave it on flat as it was a nice bit of chiseled rock. Okay guys, it's challenge time. I'd like you to create curve-driven mesh objects. So this is an incredibly powerful tool set, however can be confusing and a little frustrating. So we really need to nail this. What else do you think? What could you use this method for? I'm going to throw one in there straight away. A wobbly path winding through a woodland, something along those lines. A brick path, obviously. Maybe even the yellow brick road, who knows? So go ahead and add some more detail to your other models using this technique. Pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender. Hey, welcome back. So let's have a look at making this window a bit more interesting. So I'm going to borrow the curve that we've used to generate and the profile to make a basic brick that we can use in our model. So let's go ahead and duplicate that curve down there, and I'm going to convert that straight away to a mesh. Let's get the curve that's going on here. Let's duplicate. Oh, that's a different curve. We don't want to keep duplicating it. Let's get rid of that. I did duplicate it in that case. Where's the... There we go, the path itself. That's the one I want, so let's duplicate that as well. And I'm going to call that array. I can do some renaming later, and I'm going to call this array profile. Okay, now we've got those two parts enabled. We just need to make sure that the array isn't causing us any problems and hide these other two so we know what we're working on. So let's go to this profile itself and hop into edit mode, select the edge loop, fill, and then extrude up ever so slightly. I'm going to make these bricks quite thin so we can have a lot of them. And once I've done that, we just need to set it following the path. So we're going to need an array modifier and set its fit type to fit a curve. And we want it going in the Z direction. And in this particular case, what I can do is Z relative offset by 1. I could actually bevel the edge just here so that when they join together, oh, not B, but Control and B, when they actually join together, I'm not sure if I've got enough fine control over this at the moment. I need to zoom in a bit more. But when they join together, these will actually have some natural gaps between them. Okay, so now that is done, let's hop back into the modifiers and do the curve deform using the same curve. Now, it's not happening at the moment, and I'm guessing it's a scale problem going on again. So let's just have a look at the transform properties. Yes, so let's apply the scale. Now we're back up here. Something still isn't working properly. Let's have a look at the array and turn the curve off. Let's do one thing at a time. There should be lots of those. I haven't assigned the array itself, the curve object to the array. Now let's go back on to deform and see whether or not we need to generate our own curve. Yes, we do. So let's go ahead and create a Bezier curve that will follow this path. Fortunately, I already have the origin in the right place. So here I can move the cursor to the selected, because that will move it over there. We can add ourselves a Bezier curve and start moving control points about. And whilst I'm doing that, I will fast forward the video. I'm going to remember here to set my resolution down at 1. And now that the curve is complete, I should be able to go back to my array profile and change the properties here in the modifiers to follow the new Bezier curve. Okay, that's looking it's looking kind of right, but kind of funny as well. I think what's going on here is something gone wrong with the curve itself. Let's have a look at that Bezier curve in more detail. I think it's probably these control points. Yes, it is. So I'm just going to turn off self-snapping and snap it to the same point there. And that should bring it back round to looking pretty decent. Yeah, that's looking pretty sweet now. That's really good. I like the way that that's come out. I think it's probably a little thick, but we can always obviously modify. Okay, there's a bit of rotation going on here. I can see that's not the profile I'm looking for. So let's highlight everything and mean tilt. Last time it was 270 or 100 or minus 90, and that looks spot on. There's a couple of other things I'd want to do here. There's some odd stuff going on. Is that a rendering artifact or something else going on? I might have crossed something over at some point. It being a rendering artifact wouldn't necessarily be a bad thing. I think that looks pretty cool. I can investigate later on as to what's going on there. How are your archways and how's the rest of your building coming on? I'd love to see your results. Please remember to share in the discussions, and I will see you guys in the next lecture. Welcome to Light Portals. In this video, you will learn how to use light portals, understand the limitations of their use, see that they can dramatically increase quality given a fixed number of samples, and see they're especially useful for indoor environments lit by environmental lighting. So to talk about portals, we need to talk first about cycles and how the lighting works. Light rays are fired out from the camera, the active camera, until they hit a light source. Now this sounds a bit counterintuitive until you imagine, well, that light source could be projecting light in any direction. And to make sure we don't waste time, the rays are fired from the camera so that we are capturing light that only the camera can see. With a lamp, Blender knows where the light source is, so only fires rays that will eventually hit the light source, and this often ends up with a nice clean image. Now with emissive materials, Blender doesn't know where the light source is, so when the camera fires those rays, some of them will never reach a light source, and this introduces more noise. With environmental lighting, when you've got a sky map in the scene, or an HDR, high dynamic range environmental lighting, in an interior with only windows letting light in, the rays bounce around a lot and only a few actually manage to go out the window and reach the light source. This introduces a lot of noise in the final image, given a certain number of samples. So how do portals help? Well, portals help by telling Blender where to aim those rays. This produces much less noise in the final image. However, they do have some limitations. Portals are a cycles lighting feature, which means that they won't work externally to Blender and they won't work with the Blender internal rendering engine. They increase light calculation time. However, that's offset by the fact you don't have to render as quickly. so they produce much less noisy environments. Portals only work with environmental light. Using them otherwise can reduce quality. And they have little impact if you put something in the way. So let's go have a look at a couple of examples before we hop into Blender. So this is an emissive plane that's placed outside that hole in this box, and there is no portal. If we put a portal in the way, well, it actually looks worse and noisier. So that's an example of it not working and in fact making things worse with an emissive plane that's outside. So what happens if we bring that emissive plane so it's faking being the window? Well, this is with no portal. It's a relatively clean image. And an emissive plane acting as the window and a portal there to guide it, well, you can see it actually makes it worse again. Now let's have a look at an environmental light. So at this point, the environment is just white to be consistent, and there is no portal. You can see that image, it's very hard to even work out what that is. Is it a cube or is it just a bunch of noise? Well, with a portal, it makes a phenomenal amount of difference. And just for example, this is a sun lamp placed outside with 1,000 samples, and you can see, yes, the lighting's slightly differently because it's not an environmental light, it's a point light source in the sky, being a sun lamp. It's still noisier than the previous one. So some examples of when you stick something in the way, and we're going to see some familiar faces here. Hey, there's some bunnies and lamps and bowling pins and a chess set. So we have 4 different scenes here that we're going to run through and show you the difference. The top 2 are with and without a portal, and so are the bottom 2. However, the bottom 2 have a glass window in the way. So let's go have a look at these in a bit more detail. So this is the scene rendered with a portal. So you can see it's only 30 samples in this case, so there is still noise in the scene. It took about 30 odd minutes to do this particular scene render on a GTX 980, just to give you an idea of times taken even at 30 samples, because there's a lot of complexity in this particular scene. Now, if we see it without a portal, you can see that it's much more noisy, especially in the darker areas of the scene. Now, it changes slightly when you go and put a window in. So at the moment, that's just a hole in the wall. If we go and put a window in, well, much less light actually enters the room because it's bouncing in and out of that glass, so less light comes in. So one of these has a portal, and this next one does not. Well, did you see the difference there? This is before, and this is after. Well, I struggled to see the difference there. And that just goes to show that if you stick something in the way, like glass, that you think, well, actually, if it's an environmental light and yada, 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 the glass, it will help guide the rays. No, unfortunately, certainly at the moment, that doesn't help at all. In fact, in this case, it seems to make no difference whatsoever. So let's now hop on over into Blender and play with some light portals. So let's start off with a basic cube in our scene. So I've opened up a brand new Blender file and we'll take it from there. The first thing that I'm going to do is remove the lamp from this basic scene because it's no longer required. And we're going to add a different light source. So we're going to go to the world properties. We're going to change the color of the world to a white and just go ahead, hit render and see how that comes out. That's exactly what I'll be expecting for it to happen. This cube is uniformly lit from the outside, so we can't see any details because it's white all around. Perfect. So let's hop back into the 3D view and let's make this cube much, much, much bigger. So I'm going to hop into edit mode and scale it up by, let's make it 10 times bigger, and then we can exist in it. And I'm going to lift it up by 10 on the Z-axis too, and that should place it on the ground. Excellent, so we can easily be inside here, and if I switch to the camera mode, I'm inside it. So we've created a fake building very quickly. The next thing I'm going to do is subdivide this cube. So I'm going to come out of the camera mode. I'm going to subdivide this cube a couple of times. So I'm going to use the tool shelf here, and I want it so I can just remove some of these faces. So I'm going to go ahead here and remove a zigzag pattern going down. And those two there, why not? In fact, let's just remove those there. Perfect. So let's delete. I want the faces gone. So there we go. There we go. There is our funky window in the wall. And the final thing we're going to do before we actually start playing inside is to add a modifier, which is a solidify, which will make the walls for us. And that's under generate, solidify. And I'm going to increase the thickness to 0.1. Now, one of the things you have to watch out here for is if you look through is that there's a bit of a curve going on. And if we have a look, in fact, this is a very thick cube, so I'm just going to make it maybe 0.4 so we can see more. What's happening there is it's moving around the edge. Can we see in wireframe mode more detail? It's not exaggerating it that much, but basically if you tick even thickness, it will make sure that the thickness is applied evenly throughout the model. So let's hop inside, and I'm going to move my camera about so I can see more. So I'm going to use the walk around feature. So we've got our window there. This is quite a large room, and I think I've just gone through. So I'm just going to come out of wireframe and do that again. So I know when I pass through, and I might want a wider angle lens. In fact, I think I do in this case. So I'm going to go ahead and change the camera properties so it has a wider focal length. I'm going to go for 18. There we go, we can see much more. So let's see how this looks at the moment. There we go, we have quite a noisy scene. Now, on the render results down at the bottom, I'm going to change where it says slot 1 to slot 2 so we can compare in a few moments. And I'm just going to make this a bit larger so we can compare them much more closely. So let's now hop to the 3D view. And now in order to go ahead and add in a portal, it's actually a type of lamp. So I'm going to add the portal here, and I'm going to cover all 4 windows with it. If they're close together, you can cover them all together. Obviously, the number of portals, if you have too many of them, may add up and cost you more in calculation time. But in this case, we can just cover this middle square because it doesn't really matter compared to the other ones around it. We could, of course, add 4 portals. So let's go and add a lamp of type area. And in the properties for the lamp, we can change it so it says portal. That's all we need to do in terms of setting that up, apart from we need to rotate it round. So I'm going to rotate it on the y-axis, and I'm just looking down there, so it's going to be y by 90. And you see that dotted line, that white dotted line, now orange, coming out of it. That's the direction it wants to face. The light is going that way. So the final thing here is to do the size. Now, there's an option over in the properties to have it square or rectangular, so you can have it different proportions. I'm going to leave it set square since it's there, and I'm going to just go up and up and up. I think this is end up going to be 10. Nope, 12. There we go. So 12 covers the entire thing. I'm going to add a little extra. And now when we go back inside the building and hit render, we should end up with a much less noisy image. Now, I've got the default settings here, so that's 10 samples, and the difference between that and... Oh, okay. That was a great example. I didn't switch to slot 2 before hitting render, so let's just render it without. So there we go. This one is much noisier in slot 2 than without. Now, one thing that should be noted at this point is that the rough render did take just over 3 seconds, and the other one was, I think it was 5 and a bit seconds. Well, we can quickly go and check it. We go to slot 1. I'm going to turn my area lamp back on and then render again. Now, these aren't optimal squares for this particular render. They need to be made a bit smaller. So there you go, 5.6. So it's taken a bit longer. But let's see if doubling the sample count on slot 3 makes a difference. Because I don't think it will. I think that the one at 10 samples with a portal is going to be much cleaner than 20 samples without a portal. So it should take at least twice as long to do. This is the one with the portal at 20 samples. And let's go to slot 4 and do the one without the portal, just to demonstrate that it's still going to be noisy. And we can see straight away it's going to be much more noisy. So let's just have a look through these then. So we've got slot 1, which was 10 samples with a portal. Slot 2 is 10 samples without a portal. Slot 3 is 20 samples with a portal. And slot 4 is 20 samples without a portal. So if we compare the one that's taken nearly the same time as our first one with a portal, you can see it's still much, much cleaner. So now we understand about portals and how to put them into a scene. I've got a small challenge for you. I would like you to add some portals to your interior. So add an environment texture, or indeed just adjust the world surface like I did in the example. Hide or remove any other light sources, so it's a fair comparison. Render your interior at about 20 samples. Render your interior about 20 samples first for a baseline. Add light portals to those windows and then render the scene and share in the discussions the difference it's made. Pause the video now and give that a go. Okay guys, welcome back. Let's go add some portals to our interior. So I've made sure my camera's in roughly the right position. I managed to make it a little bit wonky. And the first thing that I'm going to do is do the render, but make sure the render settings are fair. So let's just check the number of samples. The number of samples is at 50. Let's drop it down to 20. Go ahead and hit render. The moment that's done, I haven't added my environmental lighting yet or removed the other lights from the scene. I'll be back in a few moments. There we go. I've added an environmental light. It's just going to be a white one for the moment. And now I've added that, I'm just going to see how that renders out. Looking pretty noisy at the moment. It'd be interesting to see whether it makes a difference once we add light portals. And the reason why I say that is because there's a lot of gaps in the building at the moment, which may cause or may not cause some problems. But there we go. That gives us a nice base level. Now I'm going to go ahead and add portals to the rest of these. Now I've got two choices in this particular case. I could go and add light portals to the original mesh and then re-append them into the scene. Or I could stretch one along this entire wall, for instance, and then the rest of groups of two. In this case, I am going to do that rather than modifying the original, having to re-import and change over these bits. Not going to do that at the moment. And there we go. So I've added several portals into my scene. I think that for future iterations, I probably will make the portal within the models themselves so that I never have to redo this. But for the sake of this particular model, I've gone ahead and done it anyway. And I'm just going to go ahead and render the image. So I've overwritten my original, which is pretty silly. Okay, so straight away I can see that this particular render, I inadvertently overwrote my first one for comparison. This one's taking significantly less time. I can see straight away it's quicker. The rendering with the light portals took 1 minute 24, and this one's already on 24 seconds because it's counting up, and it's I don't know about the quality though. This is going to be one of these things where I'm not sure whether the big holes in here are letting enough light in anyway that we won't see much of a difference. But now it's rendered. Let's go and have a look. So I'm just going to make this as big as I possibly can for comparison. So we're looking through the doorway here, and this is with portals. Without, with. Okay, I think in this particular instance, portals aren't going to help us until I've got this roof sealed in. I can do a few checks to see whether that is the case, but otherwise I think that's just not letting, or it's letting enough light in already that the camera is finding a light source. And that's especially true at the moment because the camera is facing these big gaps. So there is a lot of light that will naturally just bounce off of these floor bits, etc., and automatically end up hitting this skybox in the background. That's something to bear in mind. The areas perhaps where that's not the case, where it doesn't have a great big hole in the wall, may be slightly different. So I'm going to move the camera around and just check that hypothesis as well. So I'm just rendering here without light portals, and then I'll enable them and compare. And here's the final render with those light portals turned on. Once it's finished, I'll compare the two and see if my hypothesis that facing a giant light source anyway with the camera is going to mitigate most of the benefits of a light portal. Okay, so looking at the two, I can quite comfortably say at this point I think enough light is entering our scene that we don't particularly have a problem lighting it. So with that in mind, I'm not going to add any more light portals at the moment in my particular scene. I think if I didn't have quite so many windows, we might be able to see more of an effect if this whole building didn't have this great big open archway at the top as well. So I will keep the portals in mind for my particular model. If it starts to get noisy, I can start adding them in later, and I will start adding them into the actual pieces themselves. So when I link the more highly detailed models in, it will bring across the portal information as well. I'd love to see your models. Did using light portals make your scene less noisy? Did it make no difference at all like it has done mine here? Please post in the discussions, and I will see you guys in the next lecture. Welcome to Using Source Control Resetting. In this video, you will go over how to extract a previous version of your files and become aware that Blender files that are made up of linked files need to be accessed and restored in a slightly different way. So first of all, let's have a look at source tree. Okay, so in front of us, I have some uncommitted changes. Now, I have some unstaged files down here. Now, this might look slightly different to how it looked before, and that's because I've gone for a flat layout. So on the top of this particular section, there is a little button that if you click, you can change the view type. So I did have it on tree view like this, but I was getting fed up of having to open these folders up in the hierarchy to see what was going on. So I've changed it to a flat list. Single column is absolutely fine, tells me exactly what's going on and where things are, although I can break it out so the path is separate to the others. So I've changed the scene, the Gothic church. I have, oh no, that is a test for this lecture, this particular lecture. So that's been added to the working directory that we're in at the moment. I've got a couple of tests I've been doing with stained glass windows for you guys, and a glass test blend file that I've been working on. Now, if I want to go back in time, I have to go to the next layer up, and I've got all of my commit history going here, going back and back and back in time. Now, if I want to pick up a file from within any of these historical events, see this as a timeline. If I want to go back in time to, let's say, here we go, GAP16 linking blend files, I created a version of the Gothic church at that particular point. If I go and right click on that, I can open the selected version, and that will open up that particular file. And we get a big long error message. Now this is because it contains linked items. If this was a non-linked item, so let's say the doorway or the archway, the items of which we're linking, then we wouldn't have this error message. But because we've got linked items, it causes us a problem. So if we just have a look at the blend file, once the error message is gone, we can see that pretty much everything has gone. Every bit of linked information, and it's been replaced with empties. So you'd have a couple of choices at this point. You could relink them all by re-importing them into the scene and then replacing the appropriate empty with the right mesh, and that would be a real pain if the scene, well, even with this relatively straightforward scene, it'd be a real pain to do. So we don't want to do that. So what we need to do instead with linked files is actually go back in time completely. and we can do that by the following. Notice at the top here, the name is complete gobbledygook. So it says Assets Seen Gothic Church before, and then a serial number, and that's coming from the database that everything's stored in. But because this is existing within that database and not within the actual file structure itself, the current file structure, it doesn't know where anything else is. And this is perhaps where absolute links to our files would work better than relative links. But that aside, what we need to do now is basically close that down because that's of no use to us. What we can do, however, is right click on there and check out this part in history. When we do that, it gives us a warning. We can go ahead and click OK. Now my file structure is exactly how it was when this commit was made. So if I go ahead, and I can double click these as well, if I go ahead and open that up, we can see that it works. Now that is pretty cool. At this point, I can go in straight away and go File, Save As, and call it, I don't know, it depends on what you're calling it. Recovered. Say I'd made some major mistake during my model, or added a load of nonsense to it, and I didn't want to go ahead and delete things when I could just go back to a previous happy state with my model. So recovered Gothic Church, I'm going to save that blend file. Now what I can do is go back to source tree and go forward in time and go all the way back up here. So then I go to the last commit and check out that commit. That pushes everything back to how it was before we went back in time to check everything else. And when we go to our uncommitted changes, if I just make this area a little bigger, we will see that now waiting there for us is the recovered Gothic Church blend. Now when we make our new commit, it would have saved that, and we would have got back any potential data that we had lost, or a model that we now want to take perhaps in a new direction. That is brilliant. Now, I would like you to give this a go in a very small challenge. I would like you to go back in time yourselves and restore a previous version of your interior scene. Pause the video now and give that a go. Okay guys, welcome back. Let's do that process again, and I'll show you a couple of other nuances as we go. So we're back in the file structure itself down here, and I want to go back. Now at this point in time, I can see here that I made a commit that contained the Gothic Church. So if I wanted to go back before, just one step before that, I never committed, I never made any change to the Gothic Church. So it can be a little confusing sometimes. If I wanted to go back just one stage in that scene, I'd actually have to find when I changed that. It wouldn't necessarily be just going one back. So I'd go back here and go, no, it's not in there. And this is where the flat layout really helps, so you're not diving in and out of folder structures. So no, it's not there. I'm just looking for Gothic Church blend. And as we go down here, this is looking a bit bigger, and there we go. So I didn't change the actual scene itself, didn't save that scene, change anything in it, way back here in GAP 20. So at that point, I could go back and check out that area, click OK here. The folder changes, I can double click and open up Gothic Church. It should work when it opens up. I might need to Alt Tab into it. There we go. I'm just going to close that down and try double clicking that again. There we go. So that is how it was before I started adding all of the portals, the light portals in the previous lecture. And I might actually want to go back to this state if I don't want all of those portals in, because it turned out that at the moment I've got enough light coming in that the portals are having very little effect other than slowing my scene down. So at this point I'm going to go File, Save As, and I'm going to go Gothic Church before portals. And then, of course, I can fork that and go off in a different direction with it. So let's save that as the blend file. Now, remember, at this point, I'm going to have to go back to the commit that I made, or the most recent commit in this case. And I should have in uncommitted changes, a list of items, and here we go, recovered Gothic church, that's the one we've done, and Gothic church, yeah, put my teeth back in, and Gothic church before the portal. Well, before light portals, I could have been a bit more descriptive. So then I can go and stage all of my files so I don't lose any of the recovery that I've just done. And of course, I'm going to call this one appropriately. And there we go. I'm going to make my commit and everything's done. Okay, brilliant. I hope you guys restored a previous version of your interior scene. And I will see you guys in the next lecture. Welcome to Introduction to UV Unwrapping. In this video, you will no longer ask what UV stands for. We'll do an overview of the mapping that in the upcoming lectures, and understand that we'll be creating these maps from scratch, and then using them again to speed up further workflow. So we've had this section so far where we've looked at everything in macro, how the pieces are all fitting together, what the overall building or interior is going to look like, and now's the time to start zooming in on a bit of detail. So what does UV mean? Well, X, Y and Z are already used for the coordinate system within Blender itself, and U and V are like the X and Y coordinates of an image. So UV mapping is the process of projecting a 2D image onto a 3D model's surface. And the UV map itself, as we'll soon see, has as the geometry as the map, and it's placed upon the picture. So let's have a quick look at something we're all familiar with, a map of the Earth. And if you're interested in seeing more images like this of our wonderful planet and indeed some other wonderful photographs, I've gotten this from the NASA website. All of their images are free to use. So if you actually want to make a planet Earth, a model of that, and we'll be doing something very basic like that in a few moments, then of course that's the place to go to get these wonderful textures from. And remember, the word texture or image is interchangeable when it comes to Blender. Now, one of the problems with a map of the Earth is Antarctica really isn't that big. And nor's Greenland. Greenland's actually tiny. So the South Pole is Antarctica right at the bottom there. Now, obviously, that is a 2D representation of the Earth. So one of the dramatic things to highlight here is mapping can cause distortion in an image, because that image then has to be compressed onto a 3D shape. Now, we all know that the Earth isn't flat like this. It in fact looks more like this, a sphere or spherical in nature. So UV tells that texture how to apply itself to a 3D surface. So what do these maps do? Well, they do lots of things. What we looked at a few moments ago could be called a diffuse map, which is creating the illusion of colour on the surface. In fact, it is adding colour on the surface in this case, but they also create the illusion of surface detail by mapping part of an image to the geometry on our model. They can be applied automatically, which is great for your basic models, and that generates a UV map. But generating a UV map yourself does give the best results. So two of the basic maps that will be coming up in the near So two of the basic maps now that are coming up in the next couple of lectures. We've got a diffuse map, which is the base colour of the geometry itself. So up until this point, we've really only dealt with making either individual faces of a certain colour or applying a certain material to them, or we've been dealing with the whole model having the same material applied to it. Now, the great thing with a map is it allows us to only use one material, but use a texture or an image in order to control the diffuse colour. Another one is a bump map. Now that tells the shader how to react with light. So a quick example here, we've got this rough moon, I'm going to call it a moon, and we've got this one. Now apart from the slight lighting differences, they're almost exactly the same. But can you tell which one's which? Probably not, unless you start looking at some of the micro details in the shadows. So we have this one, which is the high polygon version. In fact, it's 1 million triangles, just over 1 million. It's rendered with 1,000 samples and rendered at a full 1080p. So it took a little while to render. In fact, it rendered at 7 minutes 4 seconds in terms of its render time. Now, instead, we go down to the low poly model, and if you look around the edge, you can see that it's a bit jagged around the edge. In fact, this whole model is only 1,000 triangles, again rendered with 1,000 samples, and rendered at 1080p. Now, that rendered in 5 minutes 4 seconds, so that reduced our render time by around 20%. Now, what that means for us in Blender is that we can make a highly detailed model, bake that detail down to an image, apply that image back to the model, and save a shed load on our rendering time. Now, on the one-off image, it wouldn't be worth it. If we were rendering that image over and over again, like on an animation, then suddenly it becomes worth it. Instead of spending 10 hours rendering, you'd only spend 8, or maybe less. Who knows? Depends what you're rendering on. Now, of course, this has the added benefit, if you're rendering diffuse maps and normal maps and bump maps and all these other type of maps, we can then reassemble our whole model externally to Blender as well. So this has a benefit both within Blender and when making assets that you're using elsewhere. So let's now go make a very basic UV map over in Blender. Okay, so go ahead and open up a brand new Blender file, making sure you've saved and committed the work you're currently on. So we're going to start off with a default Blender scene like this. I'm going to remove the cube from it and add a UV sphere. The name may sound familiar. I don't know if there's any direct link between UV maps and UV spheres, but here we go. Now, in order to make this a bit more easy to see, I'm going to lower the segment count quite significantly, and the same with the rings. So it's going to be a very low poly globe. Now, I know this is a bit abstract since we're working on an interior, but I think a globe is a great way of representing a map and then applying it in 3D and understanding how the relation works between the two. And we'll have more detailed interior models coming up soon as well. I'm going to make the size of my globe just a little larger than 4. So make it 5. I'm going to make it a little larger than 1 because 1 is boring for a globe. 5 is an epic globe. And I'm going to turn on smooth shading so it's as smooth as it can possibly be. Now this has currently got a default material on it, which is fine. I'm going to add a new material and call it Earth because that's the picture I'm going to use. I'm currently using nodes, which is great, and that'll become apparent why that's important in a few moments. Color, I'm going to set the color to use a picture for the color. So I'm going to go here and use image texture. So click on that little dot and then image texture. And I'm going to select from the game asset pack sections the world diffuse NASA map. And there we go. This should now be showing, he says, the map of the world. So I'm going to go to material, and it's not. And why isn't it? Why can't we see it? It's because Blender doesn't actually know how to map that image to this object. So we need to tell it. And we tell Blender by unwrapping our 3D object. We go from a 3D object to a 2D object. So let's drag out and create a UV image editor. Hop into edit mode over here on our globe, on our 3D object in the 3D window, and we can go mesh and unwrap, and we get a series of options. You see the shortcut key there is U. Now if we just go ahead and hit unwrap, now there isn't an image properly applied yet, but it's also managed to grab that because it's using the image itself and it knows it's a UV mapped image. We can see that it's mapped to every face. And that's not what we want. And that is essentially what this square in front of us is showing. It's showing us that the whole image, whatever the image happens to be assigned, you map it to every single face. And that is no good for this example. So let's go ahead and open up that image so we can see what's happening. And because it's already loaded into memory, we can click the image drop down, or drop up in this case since it's at the bottom, and select the image. We're going to have to scroll out a little here, and we can see the aspect of the image is quite wide. It's got quite a wide ratio. And now, and you may need to do this a few times during doing any unwrap, we're just going to reset the unwrap by hitting new and going reset. And that means that any of the previous settings stored when unwrapping will have been wiped. Now I'm going to speed things up here. We're not going to go into too detail about altering the UV map, but actually the generation, we can get away here with going a sphere projection, because ultimately we're mapping it to a sphere. It's not a complicated object like a face or something like that. Now we can see that it's not got it right, not straight away anyway. It's truncated half of the America and the Far East, and Africa has gone really wide on us. That is no good. So what we can do here is go over to the UV image editor and use the controls much like we would if this were a mesh that we were altering. So what we can do there is literally scale it with the S key, making sure that this area is selected and hitting the S key, of course. And remember, we can accidentally invert it, which will make it all upside down. But here we go. We can scale it out so it's the right sort of height. And then we can scale the width as well with S and X. So X is across and Y is up when it comes to your pictures. And then we can use the G key and move it about. So all of these are very much like we're used to. You can also grab the individual vertices representing this 3D object and move them as well to straighten out the UV map if you wanted to. Now remember, we're telling Blender at this point which one of the faces is represented on the image. So we can move things about and really skew up the image if we're not careful. So we do have to be careful when we're moving these about. A lot of the time you'll be mapping to an image like this, or even generating your own image, in which case the alignment with it doesn't matter because you're creating everything. Now we don't have to worry about this disappearing into the ether over here. It is literally going to warp around to this side of the image and continue. So I'm happy with that. Now let's have a look at our globe. How has that turned out? I'm going to hop out of edit mode so I can look around. Okay, it's a little jagged around the edges. The poles seem to be roughly in the right place, which is not bad for a rough unwrap. Occasionally these things can go completely adrift and look horrible, but that's not a bad unwrap for such a low poly model. Okay, remember earlier I said that using nodes was important? Well, it is if you don't want to create a separate material when working with Cycles and Blender Render, because sometimes you may want to hop between the two. So here's a little tip for you. Because Cycles uses nodes by default, when we switch over to Blender Render, we can turn use nodes off. We see at the moment it says earth material node and then no nodes are associated with the Blender render, and that's fine. If we turn use nodes off with this button next to the material name, we say use shader nodes to render the material. If we click that, it disappears. We can't see the image anymore. And that's fine. We can also turn this off, by the way, under the node editor itself. There's a little thing on here on the node editor header that we can tick and untick use nodes. Now, if you want to go back to Cycles, you need to remember to retick that or press this button again. Now, Blender Render, we can't assign a picture to the diffuse straight away. We need to do it by the form of a texture. Now, we've already unwrapped our model, so it doesn't need any more unwrapping, anything special done. All it requires is a texture applied. We need to create a new texture, and to that texture apply that image that we've already got in memory, so we can click on this drop down, or in this case drop up, and click on the NASA World Diffuse image. And there we go, it's straight on. A couple of things I would do to change this straight away is the lighting itself is not very good. So let's go into the lighting properties and put sun on. It is the planet Earth after all, but we're not going to mess around with any of the settings for the sun. And equally, if we're in Cycles render, of course the image now goes white because we haven't selected use nodes, but we don't select use nodes on the light, we select it on the material. If we start, I'm not sure about this, but I think if I use nodes here and I go back to Blender Render, oh, it does still work okay. That is good. I thought it might not if we switch the lighting across. Sphere here, we need to go to the materials option and click use nodes again, and the object is back again. Brilliant. I think it's time for a small challenge for you guys. Okay, I would like you to add a wall texture. So use your own or the wall texture in the asset pack. It doesn't matter which one you use. UV unwrap your basic wall. So it's going to be that basic wall piece without the window in it or anything else. We're going to start nice and simple with this unwrapping. Apply the texture to the wall in both Cycles and Blender Render. If you find your texture is 90 degrees out, try rotating the UV mesh. Now, I must emphasize at this point, as long as there is a texture on the mesh in both Blender Render and Cycles, you have succeeded this challenge. We'll nail down the actual quality of the unwrapping later on in this section. Pause the video now and give that a go. Okay guys, welcome back. Let's go map our wall texture to our wall and hop on over into Blender. Okay, so I've opened up my wall, my LODA wall, and we're going to start adding some detail to it. So this is just going to be texture detail, so it's still going to remain an LOD wall at this point, an LODA wall, so no extra geometry involved. So I'm going to go straight to my materials tab and add a new material named wall. Following that, I'm going to not colour it in white or this slightly off-white. I am going to use an image texture to define the colour. I'm going to go ahead and open up, go to the asset pack and open up this one called Cinder Block. Now that that's opened, we need to tell Blender how it's mapped. So I'm going to close down my tool shelf and properties of the 3D editor. I'm also going to, and I've moved it across, switch my viewport rendering to material so the lighting doesn't matter. We will need lighting, by the way, to see it in Blender Render, otherwise it will be black. So before I hop into edit mode, I'm just going to plonk a sun lamp in the scene, and sun lamps, the direction doesn't really, or where it's placed doesn't matter, only the direction counts. I think that will be okay. I'll literally hop into rendered mode quickly. Yeah, that looks absolutely fine. So let's hop into edit mode on this. Everything is selected by default, and I'm going to just do a basic unwrap, nothing special, and we'll see how that turns out. So that's looking pretty good. We just need to go to the picture down here and add the cinder block. Also looking pretty good. Are we in material mode? No, we're not. Let's have a look. Okay, so we've got that at 90 degrees. How's this side? And this side is right. How is the edge? Okay, that's good. We can see here, looking at the edge on the UV, not on the UV, sorry, on the 3D view here, it's compressed because the whole edge has been compressed. So this whole image has been compressed onto the edge itself. It looks okay actually because of the way the mortar line is still pretty much aligned in the right place. Not a great alignment, but that will do for this initial go at it. That's really good. Well, it doesn't require much in the way of fixing. Now, this is a bit wonky here. I'm not happy with that. And of course, what we can do here is select that face, making sure we're in face select. And then we're not going to rotate the face in the 3D view. That causes all sorts of horrible artifacts. But because that's now selected, in the UV image editor, we can actually rotate it. And we can see it's kind of granulated at the moment, so we can go around in notches. I'm just going to type in 90, because it is 90, and press enter. That should have sorted that out. Perfect. So we've got our first wall piece absolutely sorted. Now, I really don't care about this bottom piece. At the moment, I don't care about it. I might have to make it a separate piece actually, because if these are stacked on top of one another, it's going to make a line. Now, whether or not that line makes it look odd, I will have to see later on and be lean about it and check that it works. So that's that texture applied in Cycles, and it's looking pretty good. If we go into the full viewport rendering, we can see that that is coming across really well. And that's just a diffuse texture. We now need to make sure that it's working in Blender Render, so I'm going to switch across to Blender Render. In the materials properties, I need to make sure it's not using nodes. So there we go. We can now see our object and make a new texture and then assign an image to that texture. Because it's still in memory, I can just select it there And there we go. Now, obviously with Blender Render, the specularity is automatically applied as well. So if we go to the materials and go down a little, we can see that the intensity is quite high. If we go and turn that down, we'll end up with a much lower shine to the wall. Now, walls aren't generally shiny unless they've got gloss paint on them or they're wet. And in this case, I want neither. So I've turned the intensity. In fact, I'm going to turn it right down to nothing. It's a full diffuse texture. How did you guys get on? Did you manage to map a basic image to the wall? Did you use your own texture? I love to see what you guys come up with. And as always, please share your work in the discussions. And I will see you guys in the next lecture. Welcome to Smart UV Project. In this video, you will understand some more about unwrapping. By the end, you'll be able to unwrap more complex models and realize that this is a great starting point for a lot of meshes, and see that it gives a basic unwrap that we can work with straight away. And that is really important at this point in our modeling. We don't want to spend ages doing any modeling until we know what we're going to end up with at the end. And we also don't want to spend ages unwrapping things, because the moment we change our mesh, we'll need to re-unwrap and optimize anyway. So just a few points on why we need to unwrap. So a reminder here that a UV map is a projection of the 3D mesh to a 2D space. So that often accompanies with a lot of distortion as well, especially with organic models. And we'll work on optimizing those maps later on. Now, whilst unwrapping is actually necessary in order to project an image onto a three-dimensional surface, we can let Blender guess how to unwrap our model. Now, unwrapping gives us control over how your model is mapped in 2D space, and obviously letting Blender guess how that works can end up horribly wrong, or it might just be the perfect unwrap. Following on from that, it is essential when using assets outside of Blender. If you haven't performed any unwraps, then someone outside of Blender is not going to be able to reconstruct your model. It's also essential in Blender when using textures, so that Blender knows where to apply them properly. It is necessary if you want full control over how something is looking. And just a quick example before we hop into Blender. This is one way in order to unwrap a cube. So we can see there a 3D object is becoming two-dimensional, it's becoming flat. Now that is just one way to unwrap a cube. So long as the faces of the 3D object now lie on a 2D plane, it doesn't matter how it's unwrapped, apart from the point that if it's unwrapped in an awkward way, it will be awkward and a nightmare to work with later. But we'll go into more about optimizing the maps and how to actually unwrap later on. So let's go hop over into Blender and play with the Smart UV Project. Okay, so we're over in a default scene in Blender, and I'm just going to change my properties panel here to a UV image editor so I can see the UV as it's produced. Now let's just recap. If we hop into edit mode and unwrap our model by pressing U, we can just click unwrap, and that applies each face in its entirety to our entire image that lies underneath, and that in most cases is going to be unsuitable. There are occasions when that might be suitable, and that's if we've got a repeating texture here that repeats all over our particular model. Perhaps it's a bump map to make it look slightly bumpy, in which case that might be an appropriate way of getting it there. Providing it doesn't cause any graphical artifacts, that might be one thing you could do. Very quick to unwrap like that. So we've seen one way of unwrapping a cube. It can be unwrapped into that sort of cross shape. But if we unwrap and use Smart UV Project, which is the second option down, then it gives us a series of options: angle, limit, island, margin, and area weight, and a tick in the correct box. Now for the moment we're going to forget that it has those options there and literally go ahead and click OK. Now we can see in the UV image editor here that the unwrap is not quite like you would expect it to be, because you can't fold this shape back up into that cube. Now if we go into face select and go start polling these actual faces and seeing where they exist, we can see that those two faces there lie next to one another. but this one here is diagonally opposite. So that would cause some problems if we had a line running over the top of this cube from minus x to positive x as it goes over the top there. You would have a problem because the UV image here would be very difficult to make it start in one place and then continue over here, imagining there's an image underneath. And that would be very confusing to work with. So that wouldn't be a great UV unwrap for this particular cube. Something like the cross we saw earlier would be better. So let's go try this now over on our door. So I'm going to go ahead and open up the door that we've been working on. And now hop to the 3D view so I can see what's going on. Now I can see here that we haven't quite nailed down every other bit yet and made our full LOD level B. But let's leave that for the moment and hide everything else but the A. Let's work on a more complex shape than our wall, but nothing too complex at the moment. So I'm going to hide everything else from the scene. I could have also selected it and pressed Shift H. I'll just do that now to make sure everything else is hidden. And I'm going to open up a UV image editor as well so we can see what's going on. Now once that's open, let's first of all just try what we've done before, which is selecting everything in edit mode and then just unwrapping. Now we need something here. It's currently stuck on render result, so let's close the render result down, and we've got this. Now I have no idea how our brick texture is going to map to that, so let's go ahead and open up the brick texture that we've used before, the cinder block, and apply a material to our object. Got no materials in our scene at the moment, and I'm going to call this wall door. And the colour of that is going to be the image texture, and because it's loaded into memory we can click on it from the drop up there because it's not a drop down. So now we've got that in the scene, what we should be able to do is hop over to rendered mode. I'm going to turn my sun back on so I can at least see it properly. Oh, whoa, that's not looking too good, is it? I don't know if you were going for that effect. It might be perfect for you, but it looks an absolute mess. That's not how we want it laid out at all. However, Smart UV Project might be able to get us part of the way there or even all of the way there. So I'm going to select all of my model, make it in edit mode and unwrap. I'm going to reset the unwrap and then I'm going to use Smart's UV Project and I'm going to leave it at the default settings and click OK. Okay, that's starting to look better, but I can see straight away that if a whole face is only mapped to around a quarter of this image, the bricks are probably going to be quite large. So let's go ahead and go to rendered mode, or indeed we can go to textured mode as well. Down here we can go to the material mode, and well, it's getting there, isn't it? So the UV Smart project has helped quite a lot here. So we need to select everything again and see if we can scale this up so it fits properly. Now at the moment, if we go and scale, it's scaling around an arbitrary point. And that is going to make it very difficult to actually work out how big it's supposed to be, unless we've got some sort of guidance on the model itself. So in this case, what we can do instead is use some of the very similar methods we've used in the 3D editor, but this time in the UV image editor. So we've got a series of selection methods along the header bar at the bottom, and you can also gain access to them with Control and Tab, much like you can over on the 3D editor, where you can select the edge, vertices and faces. So over here we've got a fourth option. We've got vertex, edge and face and island. Now I don't think we've got any islands in here. Oh yes we do. It has separated them out into individual islands. So what we can do here, just to demonstrate whilst we're here, is we can scale something. I'm going to scale it by something I can scale it back up by, so I've scaled it by half, and that must be the other side of the wall, and look, we've got even bigger textures there. So that demonstrates how you can use different parts of your model slightly differently and map them onto an image completely differently, even though you're not changing any of the model itself, you're just changing the mapping of the model. I'm going to undo that rather than scaling it back up by 2, and this time select everything. Now I want to scale it, but I want to really scale it around a point in the corner, so I've got a bit of guidance over the size that I'm making this UV unwrap. I'm going to select, oh, I don't want an island select here, I want vertex select, and I'm going to select this vertex in the corner.
Now, just to let you know, I am fully aware that the 2D cursor that we're about to move is already in a corner, and we could utilize that. But I just want to show you guys how to move that 2D cursor and how similar it is to when working in the 3D editor. I'm now going to use Shift and S to move the cursor to selected. So much like we can move the 3D cursor, we can also move the 2D cursor. Finally, if we set the pivot point when we've got everything selected, where's the pivot point? Down here, next to View, to the 2D cursor. Now when we scale, we'll be scaling up from that 2D cursor, which makes it a lot easier to fill the image up. Now that is looking pretty good. Apart from... No, that is... I'm not sure, there or there. I'm going to leave it there for the moment. I can always make minor adjustments later. Now, some of you will be aware that this is obviously upside down. Does that matter? Probably not with this brick texture. It may matter when we start tessellating it with other wall pieces, but also at the same time the scaling might be slightly off as well. So that's something we'd have to standardize and check against the other models as well. So there we have this now unwrapped, starting from a smart UV project. We've got ourselves almost there. Then we've scaled it up so it fits properly. And if we have a quick look around our model now, let's just have a look if there's anything else we need to do. So the sides line up reasonably well. How about the archway? Can we get a look inside the archway? Yes, that's also lined up reasonably well. I'm quite impressed how quickly and easily this smart UV project has actually worked without causing some major problems, which sometimes it can when your model gets more and more complex. Okay, so now we've gone over the smart UV project feature, I'd like you to try out this challenge. I would like you to go ahead and use Smart UV Project. So try it out on your window model and map a texture to your window. Share your work in the discussions, pause the video now and give that a go. Okay guys, welcome back. Let's go use Smart UV Project to project our blockwork texture onto our window. Okay, so let's go and try out the same thing on our window. Is it in my quick select? No, it's not. So let's go ahead and open it up. Window, there we go. So this is going to be very similar to the door, apart from it's not got a join at the bottom. So I'm going to select everything and let's have the UV image editor already open so I can monitor how things are going. UV image editor. Okay, so I'm going to select everything in edit mode and use Smart UV Project and click OK. And it's stuck on render results, so I'm just going to undo that. And similar to the archway, it looks like we've got a pretty good unwrap to start with. Now I'm going to straight away highlight all of this and rotate it by 180 on the y-axis. No, it's not rotated around quite how I'd expect it to. So let's rotate. Oh, it's rotating fine now. There we go. So that's now rotated round and it needs scaling up. Now I'm going to first add the picture to what we're, or the texture to what we're doing here. So the cinder block. Now that won't show up in here just yet until we have applied a material. And I'm going to, in fact, these materials should really be called something like window cinder block, so I know what it is. But I'm going to call it window wall again, since they're all matching at the moment. Again, sometimes you have to accept that you may have to go ahead and rename something. So that's now mapped there, and just like before, let's go and turn the sun on so I can see. Where is the sun in my scene? Okay, this isn't really lighting up my scene quite as I'd expect it to. But let's go and scale this up. I can still see as much as I want to or need to. In fact, I can turn to material and just see how that's being mapped anyway. I suspect that sun is on a layer that I currently don't have enabled. So I can scale this up now. And again, I'm going to set my 3D cursor. So let's do everything here, and it's already in the corner, but I really want it in this corner. So I'm going to move my 3D cursor to the corner. Oh, move cursor to selected. Not selected to cursor. I misread that. So cursor to selected, select all,
and make sure the pivot point is set to the 2D cursor and scale up. Now I'm fully aware here that it is likely that I need to also shift it slightly this way as well. If I hold down shift for a bit more granularity, it's more likely to be like that, I think, where the whole face is covered up and then we've got these extra bits either side. I think that's much better that way. So let's go and check around the model that things are lining up as we'd expect them to. So I'm going to hop out of edit mode, so I've not got lines everywhere. So this one is a little more problematic. It doesn't look that great around the window itself, and that might be because there's not enough detail there, but also you very rarely make a window out of a block in that manner. So a couple of ways that we can sort this out is, number one, move the mesh, make it slightly wider so it fits in the brickwork itself. So this point in the archway seems to line up pretty well with this mortar line at the top. However, this bit down here, so that's where you'd start making your geometry match your textures, which is a slightly different workflow. But if we're working with textures that we haven't created, we may have to do that, a bit of artistic license, if you will, in order to make sure that the texture maps well to our model. In fact, then we're making our model map well to the texture as well. So it's a symbiotic relationship there. Now, if we have a look on the inside, it's not as neat as before either. So that's something we can work on. Again, not at the moment because, yes, it's a bit unsightly, but that's the detail. We don't know what this window is going to end up looking like. We may end up covering up those details with other bits of geometry. So at the moment, they really are superfluous. They do not matter at all. Now, looking around the other side of the texture, it does appear like this is much better matched up to the image itself. So this is another example of, well, let's give it a go now. This is lying over here, and I'm presuming if we select one of these faces, let's go to face select and select here. Yes, this is the one that we've actually lined up properly over the top. So if we go to island select on our model and select this island, we should be able to move it so it's almost right on top of the other one. If I turn off snapping, that's going to give me much, or rather turn on snapping, but we want it locked to vertex, and now we can overlap these perfectly, and then when we spin round our model, the other side looks exactly the same. And doesn't that look much better now that it's mapped with the blockwork? That's not planned, by the way. That looks near enough perfect. In fact, we can make the geometry slightly wider or the mapping slightly wider. So we can go in here and, of course, alter these mapping points so that the texture is mapped slightly differently across these faces. I'm not going to muck around with that at the moment because that's too much detail, as I've mentioned at this point in time. But that small alignment there has made all the difference, and I feel much better already about the texture fitting the model. How did you guys get on? I'd love to see your progress. Please share in the discussions, and I will see you guys in the next lecture. Okay, so how is it coming together? In this video, you'll check that things are looking right in your main scene. So I'll be hopping over to my Gothic church scene and just see if the materials that I have applied and the textures that I've applied are actually coming into my scene as I'd expect them to. And also, I'll be checking externally to Blender that the model is working correctly. So we're being lean about it. We've changed a couple of things in our model itself, some of the basic building blocks, and I just want to make sure that those changes are actually the changes that I need and want to make. So let's hop straight on over into Blender. Okay, so the first thing I've done here is gone ahead and opened up my Gothic church scene that I've been working on. Of course, you will open up your interior model / exterior model that you're currently working on. The first thing that I'm going to do here is literally turn off all of the portals. I've already discovered that they are not helping at this moment in time. I'm not going to go ahead and remove them at all from our scene. In fact, what I'll probably end up doing is adding them to the mesh objects themselves and bringing them in that way. But otherwise, I'm ready to start exploring my model. Now, I can see that the door is sorted. So we've got, I'm just going to click on it and zoom in. So the main door has block work over it. The windows have block work over it. The corners are still missing detail. And this bit here should be the plain wall. And that doesn't have any texture on it, and we've definitely added a texture. So let's go have a look at what's going on there. So let's go and open up the wall piece and hop into render mode here. Okay, we seem to be okay. We are in Blender Render, and it has remembered that. So let's switch that over to Cycles. Remember to click Use Nodes on your material. So we've got that back in. Brilliant. And, well, save the file. Now it will remember that it's Cycles, that object, again, we're copying the object data blocks over, so it's expecting it to be in Blender Render at that point. And touch wood, when we go into a 3D view here, I'm going to come out of camera view and have some perspective. It's tense. Yes, there we go. We've got some texture applied to the rest of the model. And at this point, we can start to see, one of my concerns was where it goes under, there's going to be a line of squished material. But actually, I think that adds to our model. And in fact, it lines at the edge of the wall was going to be one of my concerns, especially where I don't have a corner piece. That seems to have worked out pretty well as well. And of course, it's more of an interior scene, and it's quite fuzzy inside, so it's going to take a while for rendering that out. But that is looking good. The main point here is what we have been working on is immediately taking effect in the scene that we're working on. So I'm just going to go ahead and once again unhide all of these. So I didn't save it before. Let's go see how this is working now over in the Unity game engine. So I'm going to go ahead and open up my Gothic church scene. Now the way that Unity works is it does convert the blend file into an FBX in the background, which doesn't give us much control over how that happens, and we seem to be lacking textures. I would expect to see textures in here almost straight away. No, I would expect to have to apply the textures to these parts. So let's just give that a go. I'm going to click on one of these and see whether... Okay, it's got the texture applied. I wonder whether I just need to save the changes to my scene here first before it will update properly over in Unity. Come to think of it, I think I exported it as an FBX. It was a while ago now, I can't remember. I don't think we're having Unity open up the blend file. I think we're manually doing the FBX. So let's go ahead and do that now. So now I'm just going to try selecting the various parts of our scene with control held down to make sure that, I'm going to bring the mannequin in as well, just to make sure that the various parts of the scene and the hierarchy underneath are included. New parts, I don't need to bring that in. Then I'm going to go File and Export. I'm just going to try exporting the whole thing as an FBX. I'm going to overwrite my previous FBX and make sure that selected objects on the Export FBX is ticked. Let's go ahead and export and hop back on over into Unity. Now this Gothic church that we've got here, I'm not sure, I'm just literally going to delete that from our scene completely. In fact, in this case, I think I was working with that, so I didn't need to. I forgot I was working with an FBX. There we go. That's why that wasn't working. I needed to refresh it. So can I undo that delete? No, I'm just going to have to re-import it. So let's import a new asset and go find that. That's in my scenes folder, if I remember correctly. So assets, scenes, Gothic Church FBX. That's what I've just changed. And let's drag and drop it into the scene. Aha, excellent. That is starting to look pretty good. Now, I wonder why it has applied to some and not others. Again, let's go here. Yes, I just need to apply the map. The UV map should have come across, so we just need to add the texture map to it. And the same for this doorway. Okay, so that is working over in a game engine as well. As we can see here, I do have to rebuild it slightly, but not much. And if we go ahead, hit play, we should be able to walk around our scene. So I'm going to make that full screen so you guys can see what's going on. How about that? That's looking pretty good, and that is quite lean. It does mean that I need to remember to export the FBX before I do anything else. I don't know why I jumped through the window. That's habit, I suppose. The ceiling is solid, but it is also letting light through, as we can see on the floor here, so that can be improved. I don't see anything else around my scene. Oh, that looks a bit horrible there, and probably here as well. No, just there and there. Okay, so that doesn't look too hot there. And this is the great thing, you know, we've exported it. We haven't done much, and we can. Thought that was some sort of artifact. It's not. It's the light coming through one of those gaps. This is coming along pretty well. As you can see, it's very lean. I can now go ahead and change things. I just need to remember to export that FBX. And of course, it's time for a challenge. I'd like you to check your model. So check your model for any glaring, obvious issues that need fixing. And of course, being lean about it, fix them straight away. Or at least make a note that some things need altering. If you can't fix them straight away, because it's going to have a big impact on something, do make a note so you don't make the same mistake again of what's going on there. And of course, share your progress in the discussions. Pause the video now and give that a go. Okay guys, welcome back. I'm just going to take a quick tour around my model and see if there's anything else that I need to note down. Now I'm going to look around my model since I've got it already loaded into Unity and just see if there's anything here. There have been a couple things that I've noticed that will also make a difference in Blender. So one of the things I have noticed is a graphical artifact. If you look at this corner piece here, it is flickering backwards and forwards, and that is because of how the mesh is aligned. Some of the parts, as I've been putting them together, overlap with other parts, and I think they're overlapping by that 0.2 of a Blender unit, or about 20 centimeters, I suppose. But as you can see, it's causing a horrible glitching artifact. It's certainly in Unity, and I'm pretty sure, and there it is again on that doorway corner piece there, I'm pretty sure that if we start rendering things in Blender, it's also going to rear its ugly head there as well. If you remember back in the lamp section, I had the two meshes on top of one another, the original curve that made the lamp base, and then the mesh I made from that curve, and they were both being rendered at the same time, and that caused some horrible artifacts, and I'm pretty sure this is going to happen as well. So that is a very big thing that we need to sort out, otherwise an end render is going to look quite horrible. Hello, it's me again. Okay, so and the other part that I need to start focusing on really is just neatening up these corners. There's great big holes there, and these vaults, they need a bit of work. They're a great stand-in placeholder asset, but they're really starting to let down the rest of the scene now. They're nowhere near the quality level of the rest of this scene. So I think that's the next thing I'm going to be focusing on a bit of detail on. And then of course we've got to put something in this church. I mean, at the moment it's just an empty building. So how did you guys get on? Did you find out some glaringly obvious errors like this one I've made here with my alignment of my mesh? That itself is probably going to take me tens of minutes to fix, so I won't bore you with me moving about pieces in this particular lecture. You'll see the end result shortly. Please post your results in the discussions, and I will see you guys in the next lecture. Welcome to Adding More Detail. In this video, you will go and do some organisation to the outliner before things get out of hand. If it's like mine is at the moment, it's not too bad, but it's starting to get a tiny bit unwieldy, and we need to make sure we name things appropriately. We'll get an LODB level mesh object ready to be linked into our main scene. So let's go hop straight on over into Blender. So I am going to go ahead now and open up my, where is it here? Front door. Let's work on the front door itself. I'm going to make the UV image editor a bit smaller, but I'm going to be using that in a few moments. So let's go ahead here and just have a look at this outliner itself. It's a bit of a mess. So the first thing we can do here is create a couple of empties to organize things. I know immediately, I need to be in object mode. I know immediately I'm going to need an empty, and I'm going to use a plain axis as I do normally, and I'm going to call one LODA, but I'm also going to here put in that it is the holder, because that's what it's doing, HOLDER. Now, the reason why I've done that is when we import them into another scene, none of these have, when we link them, they all come across as objects, little square blocks, because they're object data. It doesn't tell us what type of object they actually are, which can be a little bit confusing on first glance, and if you haven't named them correctly, well, that's going to be a very sore point as you start moving things about. So I've duplicated those two LODs, and I'm going to make it an LODB holder. And the other one is going to be called archive. Oh, I can't spell archive, but there we go. And I am looking around my model itself. If I enable these things, I really do like this smooth archway, but I'm going to go with my block work instead. So I'm going to move those two archway profiles, bear in mind they're curve objects anyway, to the archway profile. Now, this archway array, I'm just going to hold down Control there and make sure I turn off everything under the archive empty there. So I want this one. That's the one I want to move across. So I will move those two. I'm not going to rename them at the moment, but I'm going to move those two into the LODB holder. I've got an LODB front door, and that is the actual door itself. So I'm going to put that there. The LOD, that needs to go into there, and the archway itself. Is that the... I'm not sure what that one that is. Let's hide everything else. Well, it'll be useful to have the actual doorway on itself. The LODB archway. Ah, yes, that's the one we extruded manually. I'm not going to use that one at all, but I'm not going to delete it at the moment. I'm going to call this LODB. Well, it's not LODB. I don't want to confuse it with the actual LODB mesh when we solidify it in a bit. I'm going to call this extruded archway. Might as well say what it is, hey? Okay, and I'm going to pop that in the archive as well, so it's out of the way. Of course, if you really don't want those, you can just get rid of them. Just delete them out of your scene, especially if you're using version control. If you are using version control, then you don't have to worry about doing any of this, because you can always go back to how it was at this point anyway. Now, I am using version control, but I just want to show you this particular option. Later on, when I start trimming out all of the nonsense, I'll probably want to get rid of anything I really am not using, just to keep things simple. So the archway array that we've got here, that needs to be moved to LODB. Okay, so now we've got that, I'm going to turn off LODA and go to the B. So this is what we want. We want this as one solid object so we can just import it as a whole. The issue is, of course, at the moment, this isn't one mesh object. It is a combination of two mesh objects and a control curve and a series of modifiers. So we're going to have to be careful about how we go ahead and apply these things, because some of them, once we've applied them, we can't undo them again. So with that in mind, I want to join all of these bits together. But first of all, let's get all the texturing and everything else sorted. So the wall itself, I'm going to switch over to rendered mode. The wall itself is going to have the same material, wall door material. Now, it's not quite there yet because we've not unwrapped it to tell it how to put the texture on the wall. So the material is already set up with the texture in it. We've just not defined how the texture is mapped. So I'm going to go into, well, I'm going to come out of rendered mode, go into edit mode, select everything, hit U and smart UV project. That worked before, it should work now. I'm going to pivot this around the 3D cursor. It's already selected. I'm going to select everything and just scale it up so it's roughly right. Again, at this point in time, it doesn't really matter if it's not accurate because we're bound to make some changes once we start building up detail. The changes themselves are the detail, essentially. So, with this in mind, let's hop into rendered mode. That's absolutely fine. If I go ahead in object mode and select the bits going around the outside, the brickwork, I'm going to call it brickwork, I'm going to give that a new material, call it brickwork. Oh, no, arch block work or something along those lines. If I call it brickwork, that's kind of got a different meaning, and we want to avoid, I want to avoid confusing myself because that's so easily done. And you can give it whatever colour you want. I'm going to go a bit outlandish at this point in time. I can always change it at any point, but just to make sure it's really apparent that the materials have come across individually after we've joined all this lot together. So looking at the modifiers tab, what's going on here is we've got a layer here of 4 modifiers in total, and some of them, when we turn on and off, don't make any difference whatsoever in terms of the general layout. And in this case, I do want to keep it as low poly as possible, so I am going to actually just turn off the subsurface modifier. It's not difficult to reapply at any point. There aren't any special settings. I've just gone for 2. So with that in mind, I'm literally going to delete it from here. The array defines the length of the repeat, and the curve defines its shape. That's sorted. Now, if I was doing this with a bit more detail, I would probably remake the curve so it stops halfway, and then mirror that around and around the other way as well, so it comes on both sides of the door. And that way we get a much better lump at the very top. So it's not asymmetric, so it's symmetrical at the top there. So with that in mind, we are going to go ahead now and solidify these and make them into one object. Now that we've clicked apply, we've got 2 mesh objects left in the scene. I'm going to select the archway first, and then the thing we're joining it to, which is the blockwork behind. And I'm really going to hop out of here so I can see what I am selecting on. So we've got a dark orange around everything that's selected, and then finally the active object has the light orange, and go Control and J. That's now joined them together into one mesh, but it's retained all of those material properties. And that now, if I make sure the naming is appropriate, so LODB front door, I don't need 1 there, LODB front door, that is what I will need to import when I go to my main scene. And with that in mind, I've got a challenge for you guys. Now, this challenge can be as big or as small as you like, but I'd like you to up your models to LODB status. So increase the level of detail of your building blocks you are using in your scene. You don't really have to up the level of detail of a wall segment at this point in time, and you certainly need to be careful around the perimeter, otherwise you will cause it to look horrible when they're joined together. And we'll go into more detail of how to ensure that works properly later on. And I'd like you to link them back into your main scene. And remember, replace your LODA parts with LODB where appropriate. So if you don't need the extra level of detail, don't worry about adding it at that point. As I said, of the wall part, I'm not going to do anything to that at the moment. And of course, the floor, the wall and the floor at the moment can stay as solid blocks. We don't need any extra detail at this point in time. So pause the video now and give that a go. Okay guys, welcome back. Let's go get my doorway into my scene. Right, so let's go ahead and make sure that it is saved before we do anything else, and open my Gothic church scene. So let's go ahead, and as you can see here, I've set it so it renders a bit vertically from the outside from this camera, and just to show you guys real quick, and then we'll link this other part in. I have literally just reversed the resolutions here. So instead of being 1080 wide, 920 wide, it's 920 high by 1080 wide, and that gives us a wide screen on its side. Anyway, so let's go in and first of all go and grab that. So we need to link the file. Let's go to our meshes, front door, object, and here we go. This is why I was saying naming is really important, because if we had lots of things that were similar in names, then you wouldn't be able to pick which one it was. And as you can see here, they've all got that object data block. Now, of course, you can filter in the menu options at the very top here. We can turn on, is it a scene, is it a curve, is it an object, is it a mesh? Well, not in this part of it, etc, etc. So we can filter up the top here, and we can hold down shift to turn more than one of those on, and I'm just going to leave them all turned on, otherwise it can get very confusing. And I'm going to go ahead and link in the front door. There it is, and I'm not sure what layer it's on at the moment. Has it gone to the right layer? Yes, it has. And of course I need to select that and make it a proxy. Then I can start doing things with it.
So we've got a couple of options here as to what I want to replace. So I've used the archway itself at the very top of my church, but I don't know at the moment whether I want the fancy bit around it. But I know I certainly want this one down here. So this obviously has its own object data block here. Now if we just go and try and change that, my initial thought was that would be one of the best ways around doing it. I can't type that in there. I need to first of all select here. If I now go and type in LOD_B, there it is, the front door proxy, it doesn't actually do anything. It literally just changes backwards and forwards all the time. What we need to do is change the mesh data. So let's go to the mesh data part of it and select LOD front door 1. There we go. That's in there. Now, the one thing that we've got to be careful with here is when we've got multiple objects in our scene. So we've got another one of these doors over here, and I can't select everything else. Now I've selected this one and changed it over. So what I could do before actually applying that, and let's do it with the walls, for instance. Let's go silly with the walls. We selected the walls. And then we can use our linking options as we've done in the past when we've been creating these and moving them about. So I can go Shift and L to select all of the ones that share the same object data. And then it's highlighted all of the wall 44s. Now I can go in and change that by making the selected active one this door down at the bottom, because that's already in the scene. I could also change one of these to the door and then go Control and L, and then we can make a link. And if we do object data, we end up with big doors all over the place, or windows, of course, if they're high up. I can then set it back again if I wanted to, but since I'm just toying around here, I'm just going to undo. Of course, now I can go in and move the other parts in as well. And I will see you guys back in a few moments where I'll add those in. So I'm midway through constructing my window piece at the moment, and a few things. As you can see, the outliner is nice and neat at the moment. One of the things that I've realised is that I want to use the material that I created in the last project, the actual door, the blockwork. I think I called it blockwork, door blockwork, archway blockwork, I think I called it. But anyway, I can go in and go File, Link, and as I've already gone to it, but I need to go to my front door blend file, into the material this time, not the object, but we want to go and grab the material, and there it is, arch blockwork. Once I've linked that, I can make sure I've got the appropriate mesh selected, and under the materials tab here, we can see it's linked, and apply it to there. I've also decided to make the texture slightly smaller because I don't think it was making it look a bit noddy actually. The blocks looked far too big. I think this is a better scale for them. One thing we have to watch out for with scale is repetition starts to become more and more apparent the more and more you scale or tile a particular mesh. Even if it is already a tiling texture, it can become apparent that you've tiled it if we're not careful. But that's absolutely fine. I need to alter the other ones as well. I'll continue working on this particular model, and I'll see you guys again in a few moments. So now I've brought the window itself into the scene as well. Everything's coming together nicely, and this is going to give me basically a go-ahead or not on whether the textures themselves. Oh, I need to do the wall. So here we go, being lean about it, I need to do the wall as well. But whether the textures themselves, if that's the right size. Now that does look much better. I'm going to change the wall and see how that looks as well, because that takes up a vast majority of the entire rest of the model. Okay, so we're back in the church, hop into rendered mode, and that block, well, we can see a bit of repetition, but otherwise that is looking pretty good. Does it match up with the model underneath? Yes, it does. It pretty seamlessly as well. I'm liking how this is coming on. I might go ahead and obviously change the color of this. It's almost terracotta at the moment, and we can see one of those rendering artifacts that I've mentioned coming through just on this area here. So I still need to sort out the actual alignment of the building and lots of other things to do with that.
But I did want to make sure I got all the brickwork and everything right first before I start messing around with the underlying structure. How did you guys get on? How are your LOD level B pieces coming along? Please share them in the discussions, and I will see you guys in the next lecture. Hey guys, welcome to Problem Solving. In this video, you will realise that starting again is sometimes the best option. So a little background story here. I was busy reorganising my parts. I accidentally did something and the whole scene just fell apart on me. And I had a choice at that point. Do I try and fix the problem, or do I just put all the pieces back together again? It turns out that after I made my changes to my nave, that I had a problem with the scale and position of a lot of the other bits of my model. So in an essence, starting again was actually the best option, because trying to move everything else subtly in between was just not an option. So we're going to see that even the well-prepared scenes can be broken by subtle changes. Now, we're going to get help with problems that you may have run into when making your building as well. So what we'll do now is hop on over into Blender and just go through some of the annoyances that I had during the construction of my building, especially with modular parts. There won't be a specific challenge in this section, but I would like you to share the challenges and production methods that you've gone through so we can all share our group knowledge and help each other out when it comes to constructing more complex items from individual parts. So let's hop over into Blender. Okay, so I have started a brand new Blender file here and re-imported all of my pieces. What had happened that had made it go horribly wrong is that at some point during the construction I had hopped into edit mode on my pieces and the origins had moved and the alignment was no longer working as it should have done. And when you hop into edit mode and move your piece, you're moving it in its own local space, which of course means that when you hop out of edit mode, all of the other pieces that are linked to that one also move and your whole scene falls apart. Rather than trying to fix that problem, I'm going to build myself a new church with my new pieces and put it all together. Whilst we're thinking about how it's constructed, one of the things we need to take into account is how the pieces actually interact. You can see here, yes, they are still only linked models. I haven't made them a proxy yet, but we can see where the corner piece intersects with these other pieces. We've got a graphical glitch going on. Now, one of the ways of making sure that you avoid graphical glitches, like the one in front of us, and tiling problems in general, is to either create parts as a whole, which is difficult because I like the idea of having it modular. One of the other things we can do is force the issue. And what I mean by that is making this corner piece bigger slightly than the pieces it joins to, and that introduces a natural break in the image, in the actual geometry itself, and we don't end up with any overlapping, which means if we do need to push a part inside another part for whatever reason, that it's not going to cause a graphical corruption. So for instance, this one here has this funny hash here, so I'm just going to save the file that I'm working on. Now, in the corner pieces, have I got a shortcut to it? No, I haven't. Let's go to the corner. What I can do here is hop into edit mode and actually pull these faces out slightly. So I'm going to extrude. I want both of those faces. I'm going to extrude here by 0.1. Doesn't have to be much. Now, this is speculation of how it's going to look, but I'm going to be lean about it and try it. So extrude this way by 0.1. Okay, so now the corner is ever so slightly bigger than anything that surrounds it. I haven't changed the origin or anything else of this model. Hop out. That looks okay so far. And let's go ahead and save it. Now when we hop back into our Gothic Church in New, we see that it's automatically creates this little ridge. Now I can see straight away if it's matched up in that way, it's going to ruin the door because we've got the door and the window on top of one another there. But this piece itself is now, if we push another bit of geometry into it, like a plain wall piece, is not going to complain, at least not on this side. Now we've got to think about the other side, which is also going to have some graphical corruption. Of course, we want to make these changes subtle and not make them so they stand out too much. So one of the other things we can do here, and it will vary from model to model, is opening up our corner piece again. This is one of our structural pieces, is actually taper these outer edges in. So there will be a slight warp in the surface itself. So if we grab this edge here and with snapping turned on, and merge vertices turn on, and if we snap to a vertex, I should be able to bring it all the way in. And then that will look like that from the top. This is its profile. And I'm hoping that's going to look all right. And again, this is all about lean production. We've spotted a problem. We're going to try and fix it in creative ways or useful ways. So we've also got the issue on the inside as well. Now, I am going to grab the face here, extrude by 0.1. I'm using 0.1 here as an example. It doesn't have to be, of course. And I'm going to push that corner back into itself. So I'm just going to move it to there. And I'm going to do the same with this face here. I'm going to extrude it. Oh, I've hit R by mistake. I'm going to extrude it by 0.1. And then push this edge that we can't see. If I can select it, even through a model. No, I have to hop into wireframe mode to do that. And then try and get the right one. So that one there, this is more tricky when you've got it. I'm going to have to do the whole operation in wireframe. So let's zoom in here and see if we can find the right one. And we're going to move it to that point there. Okay, so now let's have a look around our model in object mode. It looks okay. It looks slightly wonky from the top, but that's okay. It will be slightly wonky. And that should help us when it comes to corner pieces. Now, I don't know how it's going to look. It might look absolutely atrocious, in which case, back to the design board and we'll remodify it. But this will stop me having too many artifacts. Of course, if I push something into this model, so I want a shorter corner piece, the issue will still be there that there will be a tiny ridge here, so it doesn't quite solve that issue. So, anyway, enough of me speculating. Let's see what it's like in action. So back into here, and that looks fine from the outside and looks fine from the inside as well. It's no longer going on top of one another. In fact, that way it looks like I've skewed it the wrong way. I wasn't thinking. Oh no. And this is why hopping backwards and forwards is very powerful. I've put a lip in when I didn't want a lip. I've moved them in the wrong way. Silly Mikey, silly. So, of course, we can go back and correct that. And I'll go and do that now. And then I'm going to reconstruct my model because of the fatal error that I did earlier, where I moved one of these in edit mode and it caused the whole scene to fall apart. I literally destroyed my church in a few clicks. The other thing that changed the fundamental design of the church was the vault itself. I didn't realise quite how this would modify the scene that I'm working on. As you can see here, it's slightly wider than the other one, and this is where the pillars of the church are going to be sat. And because of the width of it changing ever so slightly, it caused the rest of the model to need to have a rebuild anyway, compounded with the problem that I created. Well, I suppose I created the vault as well, but compounded with that problem, it's going to be far quicker to just reconstruct my church in a very similar manner to how it was before. So welcome back, and I'm in the middle of constructing my tower piece at the moment. I just want to show you a really quick way. You probably already know about this, but might not be doing it. So I'm going to hold down G and Z, and then hold down Shift and move that up to micro blender units. I don't know, 0.10 of a blender unit. And I'm going to duplicate this again and move it up on the Z axis, and then up another 2. And obviously I'm doing some micro adjustments here as I go, just to make sure that everything is aligned properly. Oh, I forgot to duplicate it. So GZ, up to there, GZ. I don't need to do that twice. So I'm happy with that being 4 stories here. I can select this and move it down so it's covering up the right there we go, that's roughly in the right place. Okay, so now that's constructed, but that looks, well, silly. So now I've got all the basic pieces in place, and you can do this not only with these. I could have used blank walls and then put window. Well, if I used blank walls, I could have put a door in here and windows down here. But now I've done that, I'm going to select my blank wall piece, which is over here, and make sure it's the active object, and of course go Control L and make links to the object data. And there you go, I've replaced all of those parts very quickly. So you can build up a basic building block very quickly and then just substitute the parts in, providing they all match. Brilliant. Now I've just got to make the rest of the church. See you guys in a bit. Okay, so finally, after moving lots and lots of bits about and making sure they're looking nice in this hierarchy over here, so then I can turn off individual parts of the church as and when it's necessary, it's all come together rather well, much better than the first attempt at it. And it's taken a couple of hours to get to this point with all the tweaking and moving and the additional parts. I've utilised a right-angled triangle to make a roof section going along there and here. And over on this side, I've got a right-angled triangle just there so that when we're inside the church, let's go to fly around mode, we can actually have a decent line coming in and not a square like it was. I was just using a wall piece previously and it just looked absolutely horrible. Okay, this is coming along really nicely. What problems did you come across when you start adding level of detail to your model? Did you have to remodel anything? Did you have to rescale anything? Did you accidentally destroy your model and have to start again? Don't worry, we all do it. Okay, guys. So remember to share your work in the discussions, and I will see you guys in the next lecture. Welcome to UV manipulation. In this video, you will realize sometimes the smart UV project is 99% of the way there, but something is not quite right. It could be that a face is being projected the wrong way around. It could be that it's just unwrapped it in slightly the wrong order. Now we'll move on to more manual control with seams later on, but if it's almost there, you might be able to work with what you've already got in front of you without having to worry about anything else. So we'll be using the UV image editor to change individual parts on your mapping. So let's hop straight on over into Blender. So I'm going to be working on my corner piece. At the moment, my Gothic church itself, let's just have a quick look at it. My new Gothic church after accidentally destroying the old one. It's coming along nicely, and when we hop into rendered mode, we can see here that the corner pieces, sometimes they look okay because they're a different colour. That's absolutely fine. They look okay, but around this window down here, for instance, so let's zoom in down there, it just looks horrible in that instance. So what we need to do is give these a texture, but they're a slightly more complicated shape than we've dealt with in the past. So let's go ahead and go back and open up that corner. I'm going to open up a UV image editor so I can see what we're working with, and I'm just going to hop into edit mode and do a smart UV project. And there we go. We've got our UV map there. Now what we don't have is a material yet. And instead of repeatedly creating the material over and over and over again, what we can do is go ahead and link. We can't do that whilst we're in edit mode. So let's go and link. I'm going to go up to my meshes and then to the wall. Was the wall the first piece we put it on? It was, yes. And then material, and grab the wall material. And then in the materials properties, we just need to assign it. We can see it's linked, but it currently has no users. So let's go and click on that, and there we go. We've got the texture on our model, and it's looking pretty big at the moment. Now, I've already counted my brickwork, and I know that there are going to need to be 12 bricks, but it can be very difficult with a UV map to work out where the bricks are, etc. So I'm going to load the image in here, hop into edit mode. Now I've got what looks like that some of these pieces look like they may be upside down. So looking at, I'm just speculating here, but we've got this edge loop around the bottom that shows us the bit that's under the ground, and parts of it are up and parts of it are down. So let's hop into face select and just, yeah, so that one's up, that one's down, and what will happen is if we start moving the UV, so if we go over to the UV editor and select all of the points there. If we start moving things up and down, you'll see that one side goes up and one side goes down. And if we whiz around the other side, does it do the same there? I'm guessing not because of the layout here. So once again, move up and down. So that seems to be working in a reasonable manner. I'm guessing this edge does the opposite. Yes, it does, because I can see it's opposite, it's upside down over here. So there's a very quick way we can fix those problems, and that's by selecting the face that you want and just rotating it by 180 degrees, but not in the 3D editor. I need to move over to the other window first, so let's go there. Over here and rotate it by 180. I'm going to do the same here. I'm going to select that face, go over the UV image editor and then rotate by 180. And I don't know the other face that was moving the wrong way, so I think it was this one here. So let's go and grab, oh no, it was this one here. So I'm going to grab that and again rotate it. Now I have just noticed a little red mark has appeared. That is a pin. You do have to be very careful with pinning. It can ruin your day if you do not realise it has happened. So I'm just going to highlight all of my geometry again, and we see here that one of the points there has gone red. That means it's pinned. Now under UVs we can pin and unpin with P and Alt and P. And those themselves are very powerful. We're not going to use them at the moment, so I say we actually want it unpinned. So make sure that that is selected and then Alt and P, and we can unpin that. I'll look at why that's not actually unpinning. I presume that's a pin that we put there. Let's put another pin in. Yep, that's what a pin looks like. I'm guessing I've not actually highlighted the right one. Alt and P. Oh, there we go. It's cleared it that time. Don't know what was causing that before, but sometimes you have to try a couple of times. So this face here is also upside down. So I've selected it over here, rotate, and rotate by 180 in the UV image editor. And I think I probably have to do this bottom one as well, although this bottom one doesn't really matter because we're probably, oh no, it does matter because we will sit at the top of any of these pieces. So let's go and select those in the UV image editor and rotate that one again by 180. Now what we should see when we select everything and start to move things up and down, we should see that it all moves at the same point this time. Now you can see there's a misalignment, and that's to do with the placement of these. Now we can move any of these about very easily. So I'm going to make the 3D view a lot smaller there. And now I'm going to see if I can align these bits here. So I'm going to go into face select and select this whole face here and see if I can move it. I can move it, and as you can see, I can map it to any area. What would be nice though is if it snapped exactly to the other bits that make up this section of wall. So I'm going to turn on snapping, and it's already on vertex snap, and that's almost hidden off my screen there. So we've got the magnet and the snapping type vertex. Now when I try and move it, it will snap to the appropriate one, and it's right next to it, so the texture is going to flow across. We could have it share exactly the same texture that's on the other one, but that'd be a waste of our texture at this point. And that is pretty good. I'm happy with that, but the one thing I'm not happy with is its position. There's not enough bricks, and what we can do here is move the entire object down to this cursor. So I'm going to highlight everything and move the UV map down. Oh, I appear to have snapping on, and that's causing me problems. I'm going to move it down so it's in the corner, not exactly, it doesn't matter so much, but just roughly in the corner. And then I'm going to set the pivot point to that 2D cursor and scale up from there. Now, if we watch the UV image editor and the 3D viewers with scaling, we can see that we're adding more bricks. And the top isn't really changing, but we're adding bricks in from the bottom. So that is 1 brick, 2 bricks, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that should now match up with the rest of our model. So let's go and save that and check it. We've applied this. Let's look around first. Yep, that's looking okay. Let's go to the Gothic church, or your interior if you're working on something different. And, well, I'm going to switch over to textured mode rather than material mode, sorry. Aha, and that is looking much better. One of the issues that we can see is there's a tiny bit of misalignment here. Whether or not that's an issue at this point in time, I'm not going to call it an issue. However, it is something that we need to pay attention to. It looks pretty well aligned here. It actually looks like the wall texture may have a different number of bricks in it, which is why it's getting misaligned in places, because it's perfectly aligned with the archway itself, and I think we need to alter some of the other ones to a standard. This one doesn't look right as well. So we've got a few other ones to modify so they all line up, and I'm going for 12 blocks in my case, and if you're using a completely different texture, obviously there'll be different numbers as well. But that's coming together really nicely now, and it's not making it look so horrible. There are a couple of other pieces that I will need to make sure are unwrapped suitably and a texture applied to them, an appropriate texture applied to them. And of course, with that in mind, I've got a challenge for you guys. I would like you to manipulate your UVs. So get your brickwork texture aligned across your basic building blocks, the ones that require the brickwork texture on, of course. Now, it doesn't have to be perfect at this point, but get it close enough. Remember, we're still working at a relatively low level of detail. It's starting to look pretty good, even at this low level of detail, but we don't want to go over the top with trying to align things absolutely perfectly when things are still subject to some change. Pause the video now and give that a go. Okay guys, welcome back. Let's go through manipulating some more UVs. So I am actually quite happy with not faffing around with these particular textures at the moment in time. They're good enough as placeholders, and I'm only going to be minor tweaks, and as I say, I may even change this texture, so I don't want to faff around with that. But this actual large object here and these here might actually be worth texturing. Now, these are not separate objects. I have built them in this scene itself, so that means I need to do all the unwrapping, etc., in this main scene. And the reason, of course, why they are not a linked object is because they're bespoke to this particular scene. I'm very unlikely to use these parts anywhere else. So let's go ahead and unwrap. I'm going to use a smart UV project, so I'm going to go into edit mode on that and unwrap the model. I do need to select everything first. Let's try again. There we go. So now we've done that, I'm going to have a look at the 3D. Have a look at the image editor. And we were on render result. This is always confusing when that happens. So I have a couple of roof parts here and these two triangles. In fact, in this case, I'm going to open up my cinder block, which is a linked object there, and in fact I'm going to apply, but not to everything. I've got to be careful here. I only want the cinder block texture on these faces that I can see, so it's worthwhile actually resetting the UV completely and then going ahead here and doing a face select and selecting the faces that I want. So those ones are fine. The rest is a roof piece. There are some internal faces that I need, so I'm going to grab those as well. So that's those done. And we've got some on the other side. Or have we? No, we haven't got any on the other side. So that's fine. That's all we need to unwrap for the brickwork texture. We'll need to unwrap the rest of it for anything else. And the other side is very similar. We don't need to worry about the other side at all. And we've also got a right angle triangle at the top there that we will need to unwrap. I probably won't do that in this video. I'll do that outside. It's a very similar process to this one. So now that we've done that, what we can do is apply the material, which is the wall material, which is fine. Now it's applied it to everything on our model. That's okay, we can go and change that later. But we see here it's applied this all skewed. So what we can do there is go over to our UV map. Well, we haven't unwrapped yet, so let's go and unwrap. So there we go. We've got a much better UV unwrap. We just need to move these round so they're at a more appropriate angle. So I'm going to first of all select in face select. Oh, let's go. I've whizzed round to the other side of my model. So I'm not editing this. This is a linked one. I need to go over here. So there we go. That's my confusion. So I'm going to select this lot first. And in the UV image, just literally rotate it round until it's facing the right way, in which case it's going to be like that. I can now move that to the lower corner, as we would usually do, and then scale it up around and set the pivot point to the 2D cursor. I keep forgetting that. Now I'm just going to move the corner without snapping turned on, so it's roughly over the 3D cursor. Then I'm just going to scale up. Now I could literally scale this up until they match, and in this case I think they do there. So let's quickly zoom in and have a look. Oh, I've missed it slightly there. Is that it? No, we need one more layer of bricks. There we go. So you can do... Oh, no, I don't think I've got the right number of bricks here at all. And you know what? I think I'm going to get it close, but not perfect. Because, again, we can manipulate that around later as well. Now, I'm just trying to work out why it's gone a bit skew with. And I think it's the extra corner bit down at the bottom, the extra 20 centimeters or so part of the wall there. But I'm happy with that. I just need to make sure that is then adjusted on the inside as well. So here I said that's it, and it looks absolutely atrocious. It needs to be more like that. So let's turn snapping back on. Turn it off again for moving it. I'm going to place it in the top corner because it's easier to work that way. And then I need to move the 3D cursor. But because its position on the image isn't critical to working anything else out, I can pop it down here instead and scale it from there. And, oh, we need to scale it from the 3D cursor, of course. So let's select the pivot point as the 2D cursor. I will get that right one day. And I'm going to scale up from there until they, once again, roughly match, which is going to be about that. Oh, no, not there at all. About there, give or take. They look about the right size there. So, yeah, I think the issue there is that extra 20 centimeters or so that's in there. But looking at it from afar, I don't think we can spot the difference at this range. I certainly can't tell the block work isn't consistent there at all. It's made the roof look quite interesting, actually, because it's scaled them up. Now I'm going to go ahead and do my other parts as well, and we'll have a look in a moment at the finished model. Okay, so I've gone around my model and I have altered a few bits and bobs. I'm just going to go to material mode so we can just have a quick look. I've done this area here, and this is the one UV map that we're looking at the moment, and I've matched it up to the bricks. I'm just going to leave this pseudo tiling on the roof there. Obviously it's different directions there, but it gives it a little bit of interest. I wonder if anybody will spot the difference between the tiles. Anyway, and I've changed the colour of the door archways. That terracotta colour was a bit bright. Now the rest of the image itself, the rest of the church is improving slightly. I've got those bits lined up, and I also went through and just sorted out the alignment here best I could as well, because that was quite a bit off, and if we were close you'd see it, and it works reasonably well from the inside at the moment as well. How did you guys get on? Please share your newly textured churches or interior environments in the discussions, and I will see you guys in the next lecture. Welcome to Complex Shapes and UV Mapping. In this video, you will have a quick tour around my church vault. It is by far the most complex model that I've got in my entire scene. And we'll see the challenges that we can have with more complex models. We'll go ahead and troubleshoot some common unwrapping issues that you may run into, and work out ways to make an unwrap easier and quicker. So let's hop straight on over into Blender. So the vault, just to remind you guys, is the bit that we haven't really done anything with yet. There are several of them in the scene here. As we can see, there are a few issues. They overlap one another. There's some strange edges poking out of them as well. I'll have to have a look at that in time. It's come together really well, but it's starting to look out of place and a little plain. So it could probably do with, probably not this texture, but we can slap that one on anyway, just to give it a similar feel, even if it's scaled slightly differently. It's certainly going over the top of itself here, and in general, I don't think it's suitable at the moment for just unwrapping. So let's go open the file up and have a closer look at it. Okay, so here is the church vault itself, and I will first of all just take you through how it's constructed, because what you're seeing here is the end result, and that's not very helpful. In fact, I'm going to probably have to go back from the end result anyway and remake some of it, but that's fine. That's sometimes something we have to do. So I'm just going to turn on all my layers as well. So I've got something else turned on somewhere. There we go. So the whole thing started with the LOD-A, which was a very simple... it's looking funny there because I've got backface culling turned on. So I'm just going to turn that off for the sake of trying to show you stuff. There we go. So I constructed this basic vault and then used it as a basis for some curved base geometry. So I've gone ahead and created that curve there. As you can see, it's more of a square than a curve, but that makes it easier to model with as well, because I can link things to this midpoint in between. And then I made one going the other way, and this one looks a bit different, but it's not that different. It's just got smooth shading applied to it. And then I went ahead and did some other things on top. I put some fake bits where the pillars would go, so start to build it up, and yeah, that's it basically. And then I joined all these bits together and started skinning. If we go to the actual mesh itself, let's turn off these other bits. If we go to the mesh itself and turn on flat shading, certainly helps us see what's going on. I then went ahead and I've got some more stuff turned on here. I'm just going to turn off the length. I don't know, I must have been measuring something at some point. So the whole part is only this 1/4, and as you can see, it's then mirrored to get these other pieces out. Now, looking at the model itself, you can see that the original archways are here and here and under here as well. Now, the reason you can't see some of the other bits, if we go into wireframe, you can see the original arches, the ribs, I'm going to call them ribs, there we go, that make up this, and there are simply faces on top of them to give it a top and bottom surface. So now that I've got all of this sort of laid out, one of the problems with a UV is, well, if I try and utilize this, so I then condense that down into this, I'm in edit mode, so I can't hide it, this final model here, which isn't perfect by any stretch of the imagination, but it's a good halfway house at the moment. And it's not very suitable for unwrapping. Let's see what happens if we try letting Blender do it for us, so we can see the impact of having a more complex model. And we can go into some details in a moment of other things we can do. So we've got render result here, so I'm just going to clear that, go into select it and go into edit mode. I've still got those length items turned on. I'm going to select everything, unwrap, and I'm not going to do unwrap, I'm going to do Smart UV Project. Wow, look at that. Now, whilst that is a unwrap, it's not very usable. I don't know which bit's which, and I'd have to do a lot of cross-referencing. So this model is too complicated for a basic Smart UV unwrap. In fact, it's too complicated just full stop. If we just get rid of the UV image editor for a moment, this is made up of actually more than one component. These windows and the window frame itself, so this area here, that doesn't need to be a part of the main model. That can be a separate item, and that will make it both easier to UV unwrap in the first place, and also when making the vault and introducing it to the main church, I can put windows where there need to be windows. The other thing that stood out, especially on the Gothic church, let's go see this in situ, because we need to be lean about it, not just talk about it abstractly. So we have let's just go in here and just have a look at the aisles and naves. Nothing else on here. Now, one of the issues with this particular model at the moment is that these bits going across, these braces, if you will, don't really make any sense. They make sense to me when I was putting the window frame in as the base of the window, but I didn't really conceive what would happen if I put all of these bits together. And one of the problems that I run into is when we go along, and let's find the transept and put that back on. And, well, let's just enable everything else. You see that the window is facing this way, and we need another window here. And that's going to be pretty difficult to do without a separate window piece to go in. So there's another reason why the window piece needs to be separate. Now, it's worth bearing in mind at the moment that this bit on the end is a customized piece, and so's this one over here. Or is that just a scaled version? That might be a scaled version. But this is completely customized, which means that any changes I make to these ones will not come across to here. So I might have to rebuild that, but that's not a problem because that was a very quick scale in the Z direction and then put it all back together again. And you can see it doesn't quite align anyway, so it needs to have some more stuff done to it. So what can we do to our vault to make it better? Well, one of the things we can do is to separate out the things that we don't want as part of the main model. We could go so far as to separate out the ribs and then separate out the roof and then separate out this, that and the other. That might be a bit over the top, but certainly the main vault itself, the support pillars and the roof or the ceiling, depending which way you're looking at it, they are definitely all one item. The window itself is a separate item, and so it should be a separate mesh object as well. In fact, I can call it LODB Vault Window to be explicit about it. So I'm going to have to redo this, separate them out. Fortunately, I kept the old data. I duplicated it before solidifying it down to one mesh object. Turns out that that's not ideal in this situation. The other thing that I didn't realise at the time, of course, is these vaults share the same place when we've got more than one of them. We put them next to one another and we end up with it intersecting like that. So we end up with meshes on top of one another. Of course, when we end up with meshes on top of one another, we end up with it getting quite horrible and nasty, and we end up with lots of artifacts in our model. So a quick challenge now for you guys. I'd like you to think about breaking down complex models. So do you have any parts of your scene that are going to cause you a headache if you try and unwrap them as they currently are? Are they actually made up of multiple components, in which case it's likely that they need to be separated anyway? Can they be broken down? Are they really more than one model? Something to take some thought on. So pause the video now, look at your models that you've got, think about if you're going to increase the level of detail to LODC on any of these. Is anything you're doing now going to impact that model further down the line? Pause the video now and give that a go. Okay guys, welcome back. Let's have a look at my vault and break it down into its components. So just looking at my model itself, I do have separate items as I've kept them. I think first of all they need sorting out, and so before I do anything else we'll remove the modifiers that I have applied. Obviously if you've built yours up without modifiers this won't be that much of an issue, but in this case I'm going to remove the those can have both modifiers gone. The window outline, again, modifiers gone. In fact, this outline here is completely irrelevant because it's part of a window base. So this and this are all part of one object. So the question is, they should be part of one object, shouldn't they? And we can sort that out. So let's make sure that we've got, well, we don't need the mirror at all for the moment on any of these bits. So I'm going to remove the mirror there as well. And you can see I'm using the mirror to my advantage and the solidify as well. And I've got a few other bits that I need to correct on here. That straight edge that was somewhere down the base here. And I'm going to remove these feet completely and make them part of the pillar rather than part of the vault. Oh, looking at that, I've also got intersecting geometry here as well. So there's lots of things to go ahead and fix in this particular model. That doesn't look like it's straight down there either. No, it's not. So there's plenty of things to go through. In fact, I'm probably going to remodel this with just making the window by itself. Now here I am, I'm working on the window at the moment. I've set up a bevel object, a circle for our curve to follow, and I've decided to use curves because they give some quite awesome results. So let's just give this a go now. So I'm going to select the first point and control and click here and here. Okay, we can adjust that in a moment. Come back through here. All the way down here, across there. We can see straight away that we can start to get some really, really nice shapes going on. Obviously, some of them need tweaking, so they're not so random. Okay, that's quite nice there. It's a bit cluttered in the middle here. I like trying to get things to all cross over at the same point. Then it looks deliberate. So there's three things crossing over here. I will move that in to pass there. There you go. It's a bit more of an interesting shape. So you can end up very quickly with a sort of a pattern. That might be a little sparse for a window this large, but one of the other ones that I was working on came out and looked a bit like an angel, which I thought was rather cool. If I get around the right way. So I thought that was pretty cool there, and then I tried another random shape, and I also tried setting it to vectors to get more of an angular display as well. That's pretty powerful on how to get those sort of quick shapes out there and make it look a bit more like it was made of obviously stained glass or something along those lines. Hey, okay, so I've been enjoying myself and playing around with various window designs, and I've come up with a few. Great fun making them this way, very, very quick to do. So I've got this one in front of us, named Window Y, don't know why, but there we go. The standard window profile, similar to the one we had first of all. I've got my angel, and I've got this, which was my first attempt at squiggling over the window. So all that's left for me to do now is convert these curve objects into mesh objects and then make the various windows from them. Right, so I've been in and I've done my conversions that I need to do. So now all those curves are mesh objects. I created each one of the windows individually with its own frame as well. I don't think that needs to be separate. So that's gotten all the complication of the actual window part out of the way. I've removed the base bits that don't matter anymore. So that just leaves us this still somewhat complex object. It's not just like a solid object. It goes back on itself. So in order to get this done and cut it up appropriately, we're going to have to use something called seams. And we'll talk about that in the next lecture. Welcome to the introduction to marking seams. In this video, you'll realise that UV unwraps will have seams in them. Well, most of them anyway. You can do an unwrap where all the faces are on top of one another, so it's all been squished together into one location. And of course, that's useful for certain circumstances, but usually you will want to have seams to define how you want Blender to unwrap. We'll be learning how to mark seams where you want them, and understand that this gives us the most control over our model's unwrapping. So we've said seams lots. What is a seam? Well, it is a cut in your model, telling Blender how to unwrap the model itself. Now, if you imagine seam, most of us would associate a seam with a bit of clothing. Now, a bit of clothing becomes a 3D model, but essentially it's made from 2D fabric. So that's a great way of visualizing how something two-dimensional is then put together to three-dimensional, and of course the reverse. If you were to unstitch along those seams, your shirt or your trousers would end up being a flat bit of material, and they may not resemble much of the original. Clothes do look odd, and so do UV unwraps occasionally. It allows you to separate parts of your meshes from one another and apply texture to those parts individually. So a couple of tips for making seams, and we'll go more into this later on as well. Now, seams can easily cause distortion and misalignment of textures, so you do have to be careful where you put them. Seams often occur on hard edges. Now, on organic models, that's not too much of a problem. You just need to hide them out of the way. But on more industrial or what we call hard surface, non-organic models, a hard edge and a seam often coincide. They are made where you are least likely to see them, so if there is any distortion and misalignment of textures that you're applying, you're less likely to see them and they won't ruin your model. And understand, as I've said before, that this gives us the most control over our model. So let's go make some seams now and hop on over into Blender. Okay, so we're going to start in a default Blender scene and not try anything too complicated at the moment when it comes to marking seams, but I'm going to get rid of that cube and go ahead and add in a UV sphere, and we're going to play with that for a moment. I'm going to give myself an image editor as well, so we can see the unwrap as it happens. We don't particularly need an image there, but if you want to play with the picture of the world that we were playing with before, then by all means go ahead. Okay, so let's have a look at what impact it has when we just unwrap. As we can expect, it produces this everything piled on top of one another, and that has its uses, but it's no good if we want to map something across the entire sphere in this case. So let's try adding in a seam. And now what we need to do is select the edges or edge loop. That's often very powerful, not always, but sometimes. I'm going to select the edge loop here that goes all the way down from here to the very bottom. And we'll just start with that one. And we need to tell Blender that that edge is a seam. And we can do that over in the tool shelf under Shading and UVs tab. We can click on Mark Seam. It's also available under the Mesh menu under Edges, Mark Seam. And of course we can see the shortcut for the Edges menu is Control and E, so we can hit Control and E and Mark Seam. Now when you mark the seam, it goes red in colour. If I just unselect that edge loop there, we can see that it's red in colour. Now let's select everything and see what happens if we unwrap. And although it's different, it's still a bit difficult to use because of the stretching and distortion I can see in front of me. So let's try perhaps adding in another over the other side. So I'm going to hold down Alt to select the edge loop running the other way. It's not quite central. Let's select the other one. And I'm just going to click Mark Seam in the tool shelf, select everything, and unwrap again. Okay, that's a bit different, isn't it? We've got 2 UV unwraps. Now these, because we've sliced all the way through the model, they are now separate islands. If I just expand this out so you guys can see more of the header bar down at the bottom here, remember we can select the vertices, the edges, the faces, and then there's a 4th button there, which is island, where you can actually move these individual islands about. And if there was an image underneath, it would be changing on here as well. Now we can add a seam around the equator of this sphere. So that would be this one here. I'm going to go Control and E and mark a seam. I'm going to select everything and unwrap. And we get something completely different. I think during that last key press I must have accidentally created some doubles because we've got this ring around here. So I'm just going to select everything. I'm going to search for doubles and remove doubles. Yes, I did inadvertently create a ring of doubles. So let's unwrap that. And that's created 4 separate islands. As you can see, I've cut the model in half one way and the other. Now, there will be times when you've misplaced a seam. So let's try removing a seam now. So it's very similar to what we've done before. By adding a seam, it's just another option there. So I'm going to select this edge loop running along here and the one the other side. Now I've done that, I can either go to the tool shelf or Control and E, or down to the menu if you want to go through the menu system and clear the seam. Now when I go into edit mode and select all and unwrap, we have a different unwrap this time. As you can see, there's lots of ways that you can cut things up, and depending on what you're trying to apply to your model will depend on how you decide to cut it up. In this case, all of these are valid unwraps. Some are just easier to work with than others depending on what you're doing. So this would be a brilliant unwrap if you were working on an eye, but a not so brilliant unwrap if you were working on a map of the world, mainly because none of these can be stretched to fit a map properly. Of course, you can go really silly and you can select everything and mark it as a seam. I don't know quite how this is going to turn out. It's probably just going to turn out with a lot of little squares. So let's go unwrap. Yeah, there we go. It's literally every one of these faces is now its own island. Obviously, that's a bit extreme, but you might want to play with the various options that you've got here. So I can select a couple of segments here as we go round I'm just going to select them at random. Oh, don't want that inner ring. There we go. So I've selected a load of segments. I can mark them as a seam, and we'll get some probably crescent-shaped unwrap when we go and unwrap it. There we go. So you've probably seen maps of the world that look like this when they're unraveled. In fact, that's how a lot of early globes were made when they folded all the bits of paper that they printed the map onto a globe to make them. One final thing that you can do, rather than hitting U and unwrap every time, is after you've made a change, so let's make one final change here. I'm going to highlight everything and clear those seams, and I'm going to set it back to that equatorial cut that we had before, which is that one there. I'll mark the seam. Okay, so now we've done that, if we select all, we can go over to the image editor, and unfortunately it's not the U key, it's actually the E key will perform the unwrap again. And that's also available under UVs on the menu option and unwrap. As you can see, that's very powerful. It stops you having to muck around over in the 3D editor all the time. Incidentally, these other ones kind of ignore your seams. So if we go Smart UV Project, it's pretty much ignored those seams altogether. In fact, that's totally unusable for anything that I can think of at the moment. Let's go ahead and give your knowledge a little bit of a test with a challenge. Okay, so this one's going to look a bit straightforward, but it can be conceptually hard to work out how to place seams on a 3D object, which are going to make it convert to a 2D object. So what I'd like you to do now is place the appropriate seams so that you can unwrap a cube so it looks like this. And we've seen this animation before, so we end up with that cross shape. That's how I want you to unwrap a cube. So pause the video and give that a go. Okay guys, welcome back. Let's go ahead and unwrap a cube. Okay, so we're done with this sphere for the moment. I am literally going to hop into object mode and delete it. I don't need to start up a new blend file, and I'm going to add in a cube. Okay, so we've got the cube in front of us. I'm going to hop into edit mode. Now I've got to visualize chopping this up. So I'm going to select a couple of edges. I'm going to bring up the tool shelf here so I can just go, yep, definitely that one. There's going to be a top to it. So this square I'm going to represent as the top of that cross shape. So that is going to be there. Oh, mark seam and there. So that's definitely one bit. Then it comes out. So that would be the middle bit of the cross. So it needs to come this way. So it's that one there. Mark seam. Then this one here, mark seam. Or is it? Oh, this can be confusing. So that there, no, it's not that one there at all. This is why it's conceptually hard in 3D to get this in your head. So it's actually there of all places, and that creates the cross, and there's no seam across here to this bit here. So that seam's there, and then this is following around, and then we end up with two bits there and there. So we just need to chop. Oh, I've lost my bearings now. So we've got that bit there, a seam here, and I think it's there, there, and there. Of course, what we can do at any point, instead of filling those in, I'm just going to see if I've got that top bit right. Well, we've got some of it right, as you can see, and then it's twisted and distorted the rest. So let's put in those three seams there and mark seam. I'm going to go over here, select everything, hit E to unwrap. Okay, so we're getting closer. I've obviously joined the wrong two together, so I'm going to try that seam there. I think that's actually the one I had the first time. I've rotated this thing round so much, I'm not surprised I'm not dizzy. So let's try the unwrap again. Yes, there we go. We've got that cross shape. So what does that look like? That looks like, let's just clear the selection there. That looks like two C's or two ends joined together either side. So that's worked out pretty well. As you can see, it can be quite challenging, even with a cube, just to get the right seams, the ones that you want, or in this case, the ones I wanted you to get, just right in order to do the unwrap. This is a great first step to understanding how to unwrap models. Now, it's not an exciting procedure. Now, I've never met anybody who relishes the idea of unwrapping a model. It's one of those things that has to be done in order to do it, and it can be a bit mind-boggling. It is very satisfying, however, once you manage to get it right. And of course, next time, we'll be looking at seams that are on slightly more complicated shapes. But until we get to that point, remember to share your work in the discussions, and I will see you guys in the next lecture. Welcome to painting in the image editor. In this video, you will create your own image using Blender. Become more familiar with the image editor. We're about to use it quite a bit in the upcoming lectures. We'll realize Blender's limitations when it comes to image editing, and understand that you may have to use external packages for better control. This isn't as powerful as Photoshop, nor GIMP, or any of those other type of packages, but it does still have some great versatility. So let's go explore this now and start painting over in Blender. Okay, so before we go and hop into the image editor and start working, I just want to show you this setup that I've got at the moment. Now, I don't have a Wacom stylus or a Cintiq or anything fancy like that. I do, however, have an iPad and a Mac, which means I can use a program called AstroPad to use the iPad as a second screen. Now, when I do that, I can literally start doing things on the screen itself, and it's just mirroring the other screen. And this is going to become quite useful for me when I'm sketching. Now, by all means, you do not need a stylus in order to do any form of graphical art on a computer, but it does make it a lot easier. A bit like having a 3-buttoned mouse makes Blender and the 3D viewport so much easier to use than trying to use a trackpad or a lot of other control interfaces. My stylus, by the way, is not pressure sensitive or anything along those lines, so I'm not going to be able to do some of the fancy tricks where if you press harder the line gets wider or something like that. So let's now hop into the image editor and start doing some painting. Okay, so I've just changed my 3D editor to a UV image editor, and this is what it looks like. Pretty boring so far and not much to do. So let's go ahead straight away and add a new image. Now you can do that in the image menu using the shortcut keys Alt and N, or of course hitting the big new button there. And it gives us a couple of options. So I'm going to give my image that I'm about to create a name, and I'm going to call it Test Image. Underneath we have width, height, color, alpha, blank, and 32-bit float. Well, the width and height, I'm going to leave those as default, and I suggest you do too at the moment. Later on, we'll go into texture resolutions and what size to pick and where to pick them, etc., and what size to pick them as well. The color will just be the base color that appears, so in this case it's going to be black. I can set that to anything I want, and not really important at this point in time either. The generated type, well, it gives us 3 different types. We've got blank, which is just that solid color, UV grid, and color grid, and we just want it left on blank, and click OK. Now you will see that image now has a star against it, which means that it's not saved. But before we go ahead and save this image, I just want to have a look at the properties of the image editor. So I'm going to hit the N key to bring up the properties tab. Now this gives us an option up here to rename our image, change the type of image it is, etc., etc. It allows us to change what aspect ratio we've picked. So we can go ahead and change the X and Y coordinates. Now do bear in mind if you do and alter any of... Now do bear in mind if you go and edit any of those after you've started doing something with the image, it will wipe the image because you're essentially overwriting your default settings for the image, and therefore everything will go that you've done, and there's no undo for that. Here we have the UV grid and color grid that we could have selected before, and the color down here, we can go ahead and pick any color we choose on the color wheel. That's all we're going to do in the properties for the moment, so I'm going to close that down. I'm going to go and open up the tool shelf because we're going to be using that lots in a few moments. Now, at the moment, we cannot actually do anything painting-wise because we're not in the paint mode. So we need to switch the image editor to paint mode, and I'm going to do that where it says view. I'm going to change that, not this view over here. Keep going all the way over here for the mode selection. So much like we've got edit mode, sculpt mode, and object mode in the 3D editor, there are 3 modes here where we've got view, paint, and mask, and we want to switch it to paint. Okay, now we've done that, we still haven't saved our image, so let's go ahead and do that. Now, the first time you save the image, you're not going to be able to quick save it as you can once it has saved, because at the moment it doesn't really exist anywhere except in Blender, which is dangerous because if Blender crashes, your work that you've been doing will go. So we need to make sure we off that to a place on our hard disk straight away. So I'm going to save as image, I'm going to use test image and click save. Now that the star has gone, it's been saved. If I make any other changes to this file, so I'm just going to literally click and draw something on here, we see that it's got the star there, and I can now use the shortcut key Alt and S, and that will save the file. And once that asterisk is gone, it means that it's safely stored on the hard drive. That change I've made, I can now pick up the file and use it in any other program, including Blender. So let's go through the tool shelf now, and we're going to focus only on this paint section. There are a couple of other sections and we'll get to those later on, but just this top paint section for the moment. Firstly, the top one is the brush type, and when you click on that you'll see 6 brushes and wonder why are we trying to do anything with only 6 brushes. Well, they're quite versatile brushes and they can be edited and changed quite significantly. So much like most things in Blender, we've currently got text draw, and if we click the 2 next to it, that will create a unique brush, and now I can call that my brush. Now the problem with the name my brush is it means nothing, so of course you would want to name your brushes appropriately based upon what they do. At this point it's a demonstration brush, so my brush is absolutely fine. Underneath we have a colour wheel, and we can go and move this little white dot around and basically pick any colour that we want. There's a little slider to the right of it which enables us to make the colour lighter or darker. Now you'll notice that the left hand little panel underneath the colour wheel is the only one that's changing. So these are your 2 colours that you can pick from very quickly. So we've got our brush colour there and our secondary colour. That's what Blender calls them. Now you can switch between them very quickly using these double-headed arrow button just here. In fact, it says when we hover over that, the foreground and background brush colours. That's what you will see in a lot of image editing packages as well. Now we've played with radius and strength before when we were weight painting the particle system over in the bunny, and that basically is the same here. So we've got radius and strength, and we can control those with F for the radius and Shift and F for the strength, with it being stronger when you move towards the center. Okay, so underneath we've got a blend, and there are lots of different options, and I'm not going to go through them at the moment. They basically change when you layer things on top of one another, colors, how they mix together. And accumulate is something that is very important under certain circumstances. So if I set the strength down to, let's set it to 0.2. If I set it to 0.2 and start drawing, because accumulate is off, until I decide to click again or start drawing over the same part of the image but starting a new stroke, only then does it apply the next level of colour. If accumulate is turned on, it doesn't matter. If I stay over the same place, it goes white very quickly because white's the colour that I've got. We're not going to use gradient at the moment because it changed a lot of the different options that you have here. It is very powerful, but we're not going to use it at this early stage. Now this is possibly the most powerful feature of all, and that's your palettes. Because at the moment you've got no way of storing your colours after you've selected them. Sure, you can click on the, let's say, the foreground colour here and go to the little pipette and go and pick up, let's say, this lighter mauve at the top here, or purple or pinky colour, whatever it is, and that's great. We've picked that up again and we can start painting with it. But that wasn't the original colour that caused that. Whatever the original colour was a lot stronger than that, and we were just painting with it at 20%. So we would want to store that colour. And how do we do that? Well, with a palette. So I can go ahead here and under the new option, go ahead and click that, and we get a plus and minus symbol appear next to the colour wheel. If we go ahead and click the plus, it adds the currently selected colour to a palette. If we hit the minus, it removes it if it was the one that was selected. Now, if I go ahead and name this palette warm, and let's say go and add some warm colours, so yellow is just going to be orange and red and things like that. So I've now got 4 colours there that I can use and go back to at any point and continue using. And the great thing about building up a palette like this that has a style to it, like whether it's warm or cold or nature or water or whatever you've decided to build up, it means that you can then access that color palette from another blend file. So this is a data block, so are these brushes. So if you linked this data block in a new blend file, when we went to this drop down here, we would see that there would be a 0L warm. At the moment in this particular blend file it will say F warm, and if you appended it, it would just probably say 0 warm. Of course, if you don't do anything with it at that point, you will end up with it being lost when you saved your file, of course. And you can do the same here. We see that all of these have got F next to them, because if they didn't, the moment we saved Blender and shut it down and reopened it, all of them will disappear. So there are more options underneath here as well, but they're more advanced and we're not going to touch them at this moment in time. But I do have a bit of a painting challenge for you guys. I would like you to create a quick image. Remember to have some fun. Paint a couple of simple pictures. I'm not asking you to be artists at this point. I'm asking for some simple pictures. Like very, very early on in this course, you remember when I was asking you to draw things like simple cups and simple planes and a picture of a boat, and they're not real in terms of that. I'm not asking you to be a super artist at this point, and it also does not have to be related to the current project. It's more important at this point. This is to make sure you're familiar with how the image editor works when we are going about painting. So have some fun, sketch some things, simple things, as I said, depending on your skill level, and make sure you're having fun as you do it. Pause the video now and give that a go. Okay guys, welcome back. Let's go create a quick image over in Blender. Okay, so in front of us I've got something that's not that great at the moment. Let's see what we can do with it. So I'm going to zoom in just a little bit more so I can work on my image. I am going to probably clear this down, and one of the quick ways that I can do that is clicking any of these colors and dragging it over the top. It will actually replace everything if I do that. So let's click here and drag and drop. There we go. I've got a white canvas to start with. So I am going to do something really dull probably, but here we go. So I've got a radius. I'm going to increase that and do the sky. I'm actually not using my stylus at the moment. I'm using the mouse. Turns out when I'm recording, it's actually more awkward to use the stylus because it's, it's in the way. I'm trying to look at something that's directly beneath a microphone, which is quite difficult to do. So there we go. We've got some basic stuff in there, and let's do that. I'm going to do a house, I think. So let's make this radius a lot smaller, not too small. Yep, about there. And let's have an orange house. I might as well utilize what I've got there. I'm going to zoom in. So zooming is very important because it does allow us to have some more control over what we're doing. Now at this point in time, I need to increase the strength of that brush. I'm going to undo the stroke that I just did and just do that again. There we go. That's much better. I'm using the stylus for that square, by the way. Whoa, okay. I thought I zoomed in a lot more than that. Okay. Losing reference with the rest of the image can be quite critical. So there we go. I will put a roof on my house. That's not too great. I'm going to change my fill type brush to a fill type. Oh, I need to select the color that I want. I'm going to select the slightly lighter orange. I'm using a couple of different brushes. There we go, that's looking pretty good, even if I do say so myself. What else can we do here? Let's give this house a car. I'll just swap that around, and I'm just going to draw a car there. Nice simple car, like I would draw with my children. Hey! Now obviously, joking aside here, if you spend the time, you can actually get some really nice images going here. I'm being as simple and as straightforward as possible with my drawings here. I hope you're having fun doing yours. Remember to share your work in the discussions. And of course, there we go, some smoke. I will see you guys in the next lecture. Welcome to the diffuse map. In this video, you'll create a hand-painted texture in the UV image editor and apply it to your models. Now, we've already created an image in the UV image editor, and that was great fun playing with those settings. And now we're going to put those skills to the test that we can actually use on our models. We'll be creating the diffuse map from scratch, and we'll also be explaining what the diffuse map does. So before we continue, let's start with that last point. What is a diffuse map? Well, it is the most common map, and it's the one most people think of when you say texture. It defines the colours and patterns on a surface. Now, of course, what we could do is build up a load of geometry and then paint those little bits of geometry different colours, assign different materials to different faces, and build it up that way. So in a way, a diffuse map is a baking of detail that would be too arduous to do. In fact, we can get away with just painting it ourselves in many cases. And we'll move on to more baking in a few moments. So diffuse maps in general, well, they can be challenging to imagine a surface without a light source, or rather with a uniform light. Obviously without a light source would be completely pitch black. So you often end up with quite bland looking textures. Now that isn't a problem because we're going to make sure that the contrast is going to come from a light source rather than baking it into our diffuse map. We're going to avoid creating detail that would usually be generated by bumps on the surface, for instance, which means we're going to avoid painting shadows too. Now, that also means painting light in. If we do that, and I've said this word a couple of times, this is called baking into the image, and we do have to be careful that we don't do that. If you go ahead and paint shadows and light into our diffuse map, that can be great. It can be a great optimization. However, if you plan on changing the lighting in your scene, this can cause some discontinuity with the scene it's in, to the point that it looks outright wrong, because the shadows won't align with where they should be. And we can use other types of maps, specifically normal maps and displacement maps, to control the way that the lighting happens on the surface of our geometry. Now, we're not going to deal with that at the moment, however, we will touch upon those in a few lectures' time. So now let's go ahead and play with diffuse maps and hop on over into Blender. Okay, so we're back over in Blender, and the first thing I'm going to do is go work on a basic model, and the best one here is the wall piece that we've been working on. Now, I want to use the existing texture we've got as a kind of a reference for my block work. It means that we can almost apply it straight away to our model without needing to worry, and we've got to make a few tweaks first. So one of the first things I've noticed, and I'm going to have to change this in all my other files that I have currently saved, is that I am leaving the textures packed into the blend file. And that might cause me some problems later on when I think they're not packed, and they in fact are. So in this case, I'm going to just go to File, and external data. I'm going to turn off the automatically pack into blend, and then I'm going to save the file so I don't forget to do that. I'm going to unpack this image by clicking on the UV image editor header at this box with a file in it that shows that it's packed. Click to unpack. I'm going to do that, and I'm going to use the file in original location, and that should be absolutely fine. Use file, and that's fine. We can go and check the properties panel now and make sure it's linked to the right place. That looks absolutely fine to me. If I click on it, I can see it's linked in the right place. There's not really much space there. If I expand that, we can see that it is there until I run out of space completely. Anyway, so now I've got that. Before I go and overwrite on this image, I'm going to have to make sure I save a copy. And I'm going to call this one, well, I don't need it in my section assets, so I need that in my textures folder. And I notice here it's called a TIFF. Now, I do prefer PNGs where possible, so I'm going to call this church blockwork, and on the left hand side I'm going to make sure that I switch the save as image, where the operator panel would usually be over here, I'm going to save it as a PNG. And do I need any compression? A PNG is lossless, so I don't think that's going to make too much difference, to be quite honest. Color depth, I am going to go for 16, however, and I'm not sure whether I am going to include an alpha channel. So at this point in time, with a wall texture, no, I'm not going to include an alpha channel. So I'm going to leave it as RGB. Okay, so that's fine. I'm going to save as image. That's great. Can we pick it up from here yet? No, we can't. So I'm going to go ahead and open up the image we've just saved, because that is important. I wouldn't want to start working on the wrong image. I'm going to go into textures, church block work. There we go. And of course it will look exactly the same, but the name will have changed down here. And if we open up the properties window, we can see that it ends in work. So there we go. Church block work. It looks like I've typed it block in twice. Never mind, I can deal with that later. Okay, so now we have that loaded in. We can use it as a base to start working with. But before we do anything else, I just need to make sure that the actual texture is being applied over in the 3D editor so I can see what happens as I update it. So I'm going to go down to the materials properties down here, and because I've already loaded the church block work, I can select it there and switch that one over. And of course, if I wanted it in the Blender render, I would also need to first of all not use nodes, go over to my textures and switch it out down here. Let's scroll down. So currently the cinder block, we change that over to the church block work. I like that name. I think I'll keep it. Okay, so now that we've done that, we can go in, and I'm just going to get rid of my 3D view for the moment and just have a closer look at this. I can use this to basically paint over. So I've got a right scale. I'm happy with my blockwork scale as it is at the moment. So essentially I'm not happy with this particular texture, but it's a great placeholder to make sure that the scale and everything else comes out about right. So I'm going to open up my tool shelf, go into painting mode, so I can start doing something. Now, before we do anything else, this texture that we've got at the moment is a tiled texture. Okay, so we want to make sure that anything we do is also tiled. And that is a real help, especially if we're putting lots of these together. If we produce the image and it's untiled or not tiled, we will end up with visible shifts in the texture as it goes from one piece to another. And we want to avoid that where possible, because the moment we introduce that, it will look rubbish. So we need to make sure they're tiled, because we're going to have them next to each other lots. Now, over on the tool shelf, the bottom one by default is tiling. And if we turn on X and Y, it means that if we go off of one side of the image, we come straight back onto the other. Pretty effective. And we can also, from the top and bottom, also do the same. Pretty powerful. Now, if you want to see what this texture is looking like tiled, that can be pretty difficult when it's just a single image. In the properties window, we can actually turn on tiling. So down here under display, so I can get rid of the game properties, under display, we've got coordinates and repeat. If we put a tick in that box, we can see it repeating. The problem with this is we don't know where the edge of the image is anymore, because it is a tile texture. It's going to look pretty seamless. So we can flick in and out of that to see how it's looking in general as well. Now, this graffiti that I've placed on the wall, I'm going to undo for the moment. And then I'm going to close the properties panel. Oh, I actually want it so I don't see the repeat. And I can start painting. Now, one of the great things with painting, obviously by hand, you can get a lot of detail in. However, this is a wall, so we may want, it depends on the type of wall you're going for. If you're going for a bit more jagged block work, you probably won't need straight lines, but if you do want straight lines, you're going to have to select a different paint stroke. So if we go down in the tool shelf itself, we can see paint stroke. If we open that up, we've got a stroke method, and dropping down here, we've got a series of options. Now, the common ones that I would use are space, occasionally dots, and definitely line. Now the great thing about line is we can click and drag and we get a reasonably straight line. The reason why it's bumped up over the top there and down here is because when we went from one side to the other, we actually went on to the other part of the image. As you can see, as I went down here, I went onto the top of the next bit, which would have been down here, or indeed in this corner down here. So that can be quite confusing at first when you're working with a tiled image, but now when we put all of these bits together, they will be seamless, which is very powerful. Let's just turn the repeat on and we can see that it is pretty seamless. Now, depending on how much detail you've got and how often it's repeated, you kind of get that look and feel, especially from a distance, that it is a repeated texture over and over. The big ones here are these darker textures. As we have a look at it, you can see the repeating two blocks here, 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 etc. And that really does stand out on my model. So what I'm going to try and do is make sure that essentially my brickwork is a little more bland than this one. I know that sounds an odd thing to do, but it's going to make it a bit more uniform. The shapes, however, I can make a bit differently and make it a bit more exciting than these squares. I think I'm going to go for a more of an authentic kind of stone type look, but I'm going to paint it and see what effects I can do. And of course, with that, I've got a challenge for you guys. I would like you to paint a basic tiled texture. So start with the wall, as it is the simplest piece that we have. Hand paint a new texture. Now you can use the reference image that we've got underneath and base it upon that, or of course you can do any other type of texture that you would like, but I'd still have that reference image underneath, because if we align it with that, then we know it's going to work across our model without scaling or manipulating our current UV maps. If you do something that's that much different, you may have to adjust your UV map or create a new one to match up with your texture. Do make sure that the texture is tiled and avoid baking in highlights or shadows. That is important. We'll deal with those later on. So pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender and paint a basic tiled texture. Okay, so in front of us we have the wall texture that I'm going to base upon. I'm just going to see here if I can undo some of those changes. Brilliant, I can. Now I'm going to go for a slightly different colour going over the top of all this. First of all, I'm just going to block out my lines. So I've got tiling turned on. I've got a line on there. And if we move the cursor over, I'm going to use a mixture of my cursor and my iPad in front of me here. Now we can see that that is just too big for a line. That's going to look ridiculous. I also need to turn up the strength initially. Otherwise, it's going to not do the job. So I don't know quite how wide my radius needs to be. So let's go ahead and whack it down to 2 and see. Oh, it's going to be about 5 by the looks of things. And I'm going to increase the strength there. Undo those other ones that I've just put on for testing. And I'm going to actually use my mouse for this one. Yeah, that's absolutely fine. So at the moment, this is quite a fun task, as you can probably see. I'm just drawing lines across the screen. And we're going to go too far, because if I get that wrong, it will look horrible the other side as well. So let's just make sure it's tiled, but it's also lined up. If we can avoid putting bumps on either side, that would be great. Okay, so what you do need to be careful is the very edges. It's very, very easy to forget about the edges, like the top edge and the bottom edge. Otherwise, you'll end up with mega blocks without a line under them. So I'm just going to put a line there. And we can see that we get a faint one on the bottom as well. And the same's true of these vertical lines. So I'm going to paint these vertical lines in, and I'll see you guys back in a few moments. Okay, so I think I'm pretty happy with that. Of course, I'm going to quickly hop out and go into repeat and just make sure that's repeating quite well. Okay, I'm happy with that bit, so I'm going to come out of there. And what I'm going to do now is I'm going to lower the strength to about there, I think. I'm going to add a new palette, and I'm going to call it Stonework for the moment, because that is essentially what it is going to be.
Okay, so we've got a stonework there, and now let's go in, oh, I don't know, a kind of a creamy colour that I quite like. That creamy colour. I don't have a reference image on me at the moment to have a look at, but I'm going to stick with that for the moment. And if I say for the moment once more, you can highlight that for me. Now, is that going to be enough for us? I'm going to increase the fill threshold to 1. Oh, no. It needs to be less than 1. Let's go ahead and try that again. That looks pretty good to me. That's getting most of the detail that I want in. Hey, I don't know what's going on here, why it won't accept input on there. It's quite odd. I can go in and paint it. That's not a problem at all. Of course, this pixel size is quite small, so I'm going to increase it now and keep the strength low. I'm going to make sure accumulate is turned off because I don't want it to build up. And what size is that brush? That's pretty big. I want to go over the image now and make the whole thing just a little bit faded. Oh, I've got it online. Oh, silly me. I completely forgot I had it online. That's why it wasn't. I'm moving this cursor around like a loony. So, of course, you do need to change your brush stroke. So I'm going to go back to space. And now I should be able to go over the image and cause it these heavy lines to be a bit more faded. And now I'm just going to hit the F key and make this a bit smaller and do this area in here as well. Okay, so that gives me a rough idea of the guide. I'm probably going to go over a couple more times and get this looking a bit better. I'm not going to go for the square feel. I'm just going to use those as a basis. And I will see you guys back in a few moments. Oh, but before I go, what I will do here is I'm going to go into the colour picker and go and grab this mortar line. I like the colour of that, and I'm going to add that. It's ever so slightly different, but it will allow me to add the mortar kind of colour that I want into the model where necessary. I'll see you guys back again in a few moments. So I've done a bit of painting now, and I just want to see how this texture is actually looking. I've done the majority of the base sort of layer. I can continue adding detail to this, the undulations of the brickwork, for instance, but that's a good start for us. Now, I'm not using nodes. I'm guessing that's why I can't see my blockwork. And there we go. That is starting to look pretty good. I think that's much better than the one we had to begin with. I'm not happy with some of the lines look a bit wobbly. I'm not sure where that one is, and I don't like this one here. So there's a few improvements that can be done, but that is coming along reasonably well and is looking much more church-like, I suppose, rather than the sort of breeze block that we had before. How are you guys getting on? I hope you spent some time adding a bit more detail than I've got time for here. Remember to share your brickwork. What have you come up with? Have you gone for sort of like this creamy colour? Have you gone for a completely different style of block? Have you gone for different shaped blocks? More like some, I can't think of, like stonework, where large stones and small stones are all put together. I'd love to see your results. Please post them in the discussions, and I will see you guys in the next lecture. Welcome to using images for control. In this video, you will learn how to use images to control your materials with better finesse. Understand why these control images are black and white, and create a simple stage for our building once we've understood all of this. So why black and white? Well, these grayscale images define values on a per pixel basis. Now, the reason why I say values is it does depend on what you're applying the image to, what you're having it control. Whether that be the factor in a mix between two shaders, whether it be something else that you want to control. But basically, black represents a value of 0 and white a value of 1. So black means that there is nothing to do with it, and white means there's 100% of whatever it is you're applying it to. And you would map this image to your model like you would any other image. So let's go explore this now and hop on over into Blender. Okay, so we're over in Blender, and I'm going to add some materials to this cube. So the first thing I'm going to do is I'm just going to lift it off off of this plane, this XY0 plane, and just add in a plane. And that will give us some ground to work on. I've just inverted that. There we go. So we should now, when we hit the render button up here, or indeed just switch into rendered view, it looks like it exists somewhere, which is very powerful. So let's go ahead and add a material to this cube. And I'm going to use nodes, and I'm going to set the color to an orange. Why not? Okay, so now we've got that there. We need to have an image to control something. So let's go ahead and open up an image editor and create ourselves a quick image. I'm going to create a new image, and I'm going to call it control texture, because essentially that's what it's going to be. I'm going to stick with 1024 as always and click OK. Now that I've created our image, I'm going to now go into paint mode, and yeah, that is working. Earlier on, this wasn't working for me. I had to save my file, restart Blender, and it suddenly started working again. I think the graphical interface just stopped responding or updating or something along those lines. It was very confusing, but saving my work, restarting Blender and opening it up seemed to have fixed it. Anyway, that aside, I'm going to crank this up to a strength of 1, because that means the center of the dot or dots or whatever you're doing is going to be pure white, or pure whatever color you've got selected, and I'm going to make sure that this is white. Now that I've done that, I don't want that size, I want slightly larger, so I'm going to blow that up so it's about there and hit it smack bang in the middle. Perfect, that's going to be my control image. So it's white in the middle, so everything, 100% of whatever we apply it to will be in the middle, and the outskirts will be black. It won't apply to it at all. So I've got that texture made, I just need to go ahead and save it. Oh, let's make sure I save it in an appropriate location. I'm going to pop it in my resources. No, I'm going to pop it in my textures, just in case I do decide to use that. Control texture. Excellent, so now I've got my control texture ready, I can just get rid of this screen altogether. In fact, I'm not going to get rid of it, I'm going to convert it into a node editor. Okay, now we're in the node editor, we can do a couple of things here. First of all, let's make sure that that image is applied correctly to this particular model. So I'm going to add in an image, so let's go texture, image texture. I'm going to link it to the color, just so I can test it. It's not so important that it's there at the moment. And of course that isn't working. And the reason it's not working is because we've not told Blender how to map the image to the model. So we can go about that by unwrapping the model, but let's go and make sure we set up the node structure so that is implicit, so Blender knows how it's doing that. So this vector input here, we can add something to that. So let's go ahead here and add an input texture coordinate. Now that is explicitly telling Blender how that is mapped. And we can try these out. We can pop generated in and see what we get. We get one dot on the very top. Now that might be what you want. Brilliant, done. If we go normal, well, it's not going to do anything. We actually want UV. And we can get around this very quickly because I don't really mind how this cube is unwrapped at the moment, just the fact that it is unwrapped. And if we just do a basic unwrap without being conscious about it, we're likely to get, as we can see here, the image on every single face that exists. And I'm happy with that. That's absolutely fine for this test. So now we've got our image loaded up. We know it's working. We've plugged it in and it's on our model. So what can we use it for? Well, we can plug it into other parts, so we can control certain aspects of our model. Now, at the moment, or of our material that we've made, so at the moment, it's just controlling the color, which is useful, but not in this case. So I'm going to unplug that so we get our orange color back. Now, I'm going to use it to control the difference between two different shaders. So I need to add another shader. Now, you can pick a different one from me if you'd like. I'm going to pick a glossy shader. I'm going to add that in there. And of course, because we've got two shaders, I need to mix them together. So how am I going to mix it together? That's right, with a mix shader. Now, let's think carefully about the way of linking these two together. Which order do we need them in? Well, let's just play with these from one side to the other. So in this configuration, when the factor is set at 0, we get gloss. Okay, when it's 0%, we get gloss. So it means 0% of the bottom one. And when we turn it up, it's 100% of the bottom one. So in this case, if we were to plug in the image texture into the factor, what do you think it would do? Remember where the black is. The black is around the outside. Now, I would want gloss to be 100% in the middle. So if we're controlling 100% of the bottom one is like this, we're going to have to flip these around so that the gloss is on the bottom. Because it's white in the middle, when we go here to colour and plug it in, there we go. We've now got a gloss shader on the middle bit and diffuse on the outside. Very, very powerful. There are some other ways that we could go about fixing that. For instance, if we unplug both of those and we plug them back in how they were before, obviously we get the outside being glossy, which may be desirable, but in this case it's not. So what else can we do? Well, we can invert this image texture. So I can add in a color invert. Obviously I can search for it, and the moment I put that into our model, we can see that it inverts the image, and therefore where it was black on the outside, it's now white on the outside and black on the inside, which gives the same effect. The great thing about adding the invert is it does actually give us another degree of control between those two states. That is powerful in itself as well. So now we've added all of these bits and bobs in, there's one final thing to do, and we haven't told Blender that it is explicitly not a color channel, it's not color information on the image texture, it's non-color data. And then it does actually make a difference to our image. If we go here to color, we can see that it's not actually applied the entire black and white realm on there. If we go to non-color data, it has applied it properly. Now, the technical reason for this is it stops Blender from applying color spaces to the image. And that basically means that instead, we want Blender to interpret that image as a numeric value, i.e. that 0 to 1 that we were talking about earlier, rather than a perceived color value, which can be different. We can see it's similar in this swap around if we switch it from color data to non-color data, but the actual non-color data gives us exactly what we want, because if the value is 0, it's definitely black. The value is 1, it's definitely white. But the steps in between are going to be accurate on a pixel by pixel basis. Okay, so now we've experienced that, I've got a small challenge for you. I would like you to create a simple stage, and by that I mean that previewing your models is best done with them on some sort of stage, not in nothingness. A lot of the time you end up producing a lovely model and it's kind of sat there in limbo with nothing around it. So it's good to have it having some sort of presence, and a ground beneath the object is one of those things, and we can use a control texture to make that ground a little more interesting. So what I'd like you to do is create a plane under your building if you haven't done already, and using a control texture, make it have a circular fade. And just so you know, here's an example of the kind of look that I'm going to be going for. With the Gothic church that I'm working on here, of course your building might be slightly different from this, and we've got this fade going round it. Whereas that used to be quite a jagged square plane, it's now nice and smooth towards the edges. At that white that you can see there, that is simply the environmental light. I've just got it set at white at the moment. That could quite easily be a skybox or something else if I wanted. Anyway, enough of that. Pause the video now and give that a go. Okay guys, welcome back. Let's hop back over in Blender and make ourselves a simple stage. Right, so we're back over in Blender, and the first thing I'm going to do is hop over to the Gothic church. Okay, so now I'm in the Gothic church. Mine's coming along quite well. That's my chosen interior/exterior that I've been working on. Now, I believe that I haven't updated, and no, I haven't. As you can see here, some of the textures have been applied and come across for the detail that I was adding. It's come across quite nice. I think it needs to be a little lighter than that, but that's something I can sort out later. But I do need to make sure these other bits are set. So let's go ahead and complete the challenge and then come back and just make sure all of these other ones have inherited the right material. Right, the first thing to do is, well, it doesn't really matter in this case which order you do this in. I'm going to select my plane and just unwrap it. That's that done. The next thing I need to do is give it a material. So let's go ahead, bring this out for the materials tab. I'm not going to call it plane, I'm going to call it ground. I'm going to be good and name things properly. I'm going to go to the mesh data and also name it ground. Object data and mesh data now called ground. Okay, that's good. Now I'm going to select the materials, add a new material, and I'm also going to call that ground. Now it's entirely up to you. You could assign a grass texture if you've got something here. That's absolutely fine. I'm just going to go for a basic sort of a green, a darker green for sort of like a fake grass, and then I may apply a texture later if I do any outside shots. It's just for the moment to demonstrate this technique. So I need to now bring in that texture and use it. So I'm going to go into the image editor first of all and see if it's in our scene already. No, it's not. So I'm going to go ahead and open and go and find that control texture that I've already made. Okay, that's looking good. That's in our blend file now and ready to be used. So I'm going to go ahead into the node editor. And I'm keeping these full screen with a rough idea of what's going on in the background. Now, I'm going to want some transparency. So I'm going to need a transparent BSDF. That's fine. And I'm going to need a mix shader. So let's go ahead and shaders, mix. I could have searched for that probably quicker than finding it there. Okay, so let's plug them in. Is this the right way round? Let's think. It's white in the middle, and so we want 100% of the diffuse where it's the bottom one, 100% of the bottom one when it's in the middle. So these are the wrong way round. So let's plug it in there. That'll swap them over. Now we need to bring in a texture coordinate, and that UV needs to be plugged into a texture image or an image texture. So let's go UV to vector, color to factor, color to non-color data, and then finally the control texture. Let's go into the 3D view, and that is looking almost there, but not quite. If we view it from the top, you can see that with non-color data, where the values aren't 0, we still end up with information there. So we need to recreate this image. Now, I don't mind overwriting the image that I've already got. So I'm going to go into the UV image editor, bring open the tool shelf, switch the mode to painting. I'm going to drag this black color from the secondary color on top of the image. That makes everything black. I'm going to up the strength, and this time I'm not going to make this circle so big. I'm going to make it roughly there. I'm going to click a couple of times to make sure we've got a nice white area in the middle. Now that that's done, I need to make sure I save my image, which is now done. And if we hop back to the 3D view, that is looking much, much better, apart from its position. So there's a couple of things here. I don't think it's large enough for the scale of our church. So in that case, I'm going to scale it by 2. And I'm going to also move it. I think Y is that direction. Yes, it is. So it's roughly in the middle. Okay, so that's that part of it sorted and looking pretty good. What I am concerned about here is not all of my textures have come across as I had expected them to. So let's go ahead and have a look at these wall pieces first of all. So I'm going to save my work there and open up recent. There's my wall. So we've got this. Is it applied to our model over here? No, it's not. Okay, so I've got wall old and wall, and I'm going to assign. That's come across. I'm going to save. And now I'm going to make sure I enter the other models and actually assign them this material in here. So if I go ahead and change this material, it affects every one of the other ones rather than just the model itself. So we'll just test that first of all. If we hop into rendered mode, that's done. So I'm going to need to do the doors and the windows by the looks of things. So let's go and do that now. So open up our meshes, front door, and here where we've got arch block work, I'm actually going to remove those altogether. I'm just going to remove them completely, those materials, and link in the wall, material, wall. Then assign it, so wall, have a look and hope for the best. That is looking pretty good. I don't think I wanted to delete the one around the edge there. I'll deal with that bit later. Okay, so file, save, and let's go ahead and open up the window as well. I think, where's window? There we go. So again here, let's have a look at the materials. Window wall, I'm going to remove that completely. I'm going to go and link in, oh, it's all remembered the wall before. I'm going to link in that wall, link from library. Going to assign it to my model. I'm going to quickly hop in and make sure it's there. It's not quite there. Something's not gone to plan. Have I selected the wrong one? Probably not. Here we go. That was the problem. I didn't undo the right material. So let's go ahead, link in wall, because it's remembered, and then assign it. And there we go. We've got our texture all loaded. Let's go ahead, save that, hop into our Gothic church. There we go. And, well, I should just be able to hit render and see how that's looking. That is looking pretty good. How's yours coming along? Please share in the discussions. Oh, that's the wrong file. That's the wrong Gothic church. That's the old one, which I accidentally destroyed. I should really just get rid of the file now. Oh, no. Gothic church new. Here we go. Look through the camera. Oh, it looks like I need to set one up. That is looking pretty good. I'm going to go and set up a camera and render it out. I'd like you to do the same. Make sure you're sharing in the discussions. And of course, I will see you guys in the next lecture. Welcome to Illusion of Detail using bump maps. In this video, you will use a texture to control how light is interacting with a surface. We'll see how to use that texture as a bump map in Blender Render, and use generated textures rather than handmade just to speed the process up. If you want more control, of course you can make the texture by hand. So before we hop into Blender, let's have a quick overview of bump maps in general. Now, normal and height or displacement maps are both types of bump map. The term bump map is often thrown about, but it does encompass both of those because they both change how light interacts with a surface. We're going to use a displacement map in this particular example. We'll move on to normal maps later on. Now what they do is they tell a shader how to interact with light. So as a light ray goes across a completely blank surface, it usually just bounces off in a certain way. However, what we can do is use a texture, and this can give the illusion of detail on a surface. It fakes highs and lows, so we get some detail on our surface. They can increase render speeds versus using geometry alone, and not only that, they can speed up construction speeds. As you'll see in a few moments, there's absolutely no way that without using a texture we would ever be able to make a brick look a bit more brick-like. So let's have a quick look at height maps versus a normal map and see the difference. Here we have a very simple jagged surface. And as you can see, the low point of the surface is dark and the high point is white. And you can see there that they drift from one level to a mid-grey, then to a black again, and then to white as it reaches the highest point, down to mid-grey and up again. Now that is showing the height differences, not necessarily the direction of the faces. With a normal map, they don't display any height information. They simply show the direction that the faces, when we fake them, would be facing.
So we can see here that despite the fact that the faces themselves are higher up, there's no change in the normal direction of that particular face. And of course, we'll cover normal maps in a bit. So let's go play with displacement maps now, or height maps, over in Blender. Okay, so we're back over in Blender, and I'm going to apply these bump maps, this displacement map, to my wall piece first of all for testing. And I just want to show you here, the texture does look slightly different. I went in, spent about another half hour, 45 minutes or so, just adding a bit more detail to my base color there, and I think that's turned out rather well. It's obviously not super detailed, but I like the way it's come out. I am going to switch to Blender Render. Oh, that's Blender Game, Blender Render. Okay, and I'm just going to sort out my windows here so we can see what's going on. I'm going to turn on rendered mode in the viewport shading, and we don't see anything, and the reason we don't see anything is because we're still using the node setup. So I'm going to untoggle that. Of course, you can use nodes for Blender Render. I've just elected not to, so I can switch between these two setups. I'm going to move across to the Textures tab and add in a new texture. Now we have a list of textures at the top here in Blender Render which we can use within our model. And for the moment, what I'm going to do is go down to the next texture slot and add a new texture. I'm going to change the type of texture to something. I'm going to choose clouds. I think that's going to work out pretty well. We can see over in the viewport it's gone a bit odd, and I'll explain what's happening there in a moment. And this texture here is not very well named, so I'm going to call that displacement. Oh, very badly displacement. There we go. And this one here I'm going to call block work. Not block work, but just block work. Okay, so we've got this texture underneath this one, and it does work in the order here does matter. It does work its way down. So if something is here in the second position, if we move it to the first position, we can see it's overwritten with block work. We can't see this other texture, and that's because both of these are trying to control the color. They're trying to influence the color. If I scroll down here until we get to where it says influence, we can see that they're both trying to control the color, and in this case the texture itself, the black and white texture, is saying where it is black I don't want it to control any of the color, and where it is white I would like it to control the color based upon this color down here. So if I change this to blue, it will be the cream and blue. If I change it to any other color, it will be the green and cream. Now I don't want those clouds to control the color. I would rather they controlled something else, and I can have them control the specularity. And if I turn the intensity down a little, let's go for 0.8, let's say. Now when I move around, you can see that this particular wall piece is reflective in certain places and not in others. And that's to do with that texture. It's saying where there is reflection and where there is not reflection. Now, since we're working with displacement maps, you may think that the right one to pick here under geometry is displace. You've probably been reading down here and gone, oh yeah, he's about to click on displace. Well, let's do it. And we can see there it doesn't do anything. The reason for that is in order for a displacement map to actually displace something, it has to have something to displace. Now that does sound like a tongue twister, but basically there's not enough geometry in this model currently for anything to be moved about. And we'll actually discuss using textures to control geometry later on, not in this particular section. This is all about the illusion of detail, not creating detail. So we'll want to put a tick in the normal box. Now, even though that black and white image isn't a normal image, Blender Render can work with it. And here we see that we end up with a bumpy surface based upon those clouds that it's generated. If we go in too far, we see that it's not perfect. We see the squares going on here of the pixel changes. So we might require something a bit more high res at some point, but for this stage it's absolutely fine. Now if we control the normal amount, obviously if we bump that up, the maximum is 5, it looks really, really bumpy. Now that is no good for a wall, but that might be good for some muddy floor or something along those lines that has a lot of bumps and ridges in it. If we set it to something like 0.5, then we get a much more subtle effect. If we decide to go negative, it simply inverts the colours. So the highs become lows and the lows become highs. Now that is going to produce a different pattern to this. If I whack it all the way back up again, but essentially it is the same pattern, just where it's faking going in and out. Now, one thing to bear in mind with the illusion of detail is where it breaks down is the edges. If I rotate this round, we will see that there aren't any bumps. There are no bumps in this model at all. And that's where this illusion can break down, especially around edges. So that's something to bear in mind. Now, I've been playing with this, and I think a normal value of 0.5 is actually about right, and that comes out pretty good. And there we go. That's displacement maps in a nutshell using Blender Render, and I've got a challenge for you guys. I would like you to create a cycles-based bump map. So render yourself a nice example of the Blender Render setup and use it as reference material so you've got some guidance to how you want the new cycles render to look like. Use a bump node to control your diffuse shader's normal input. Experiment with the nodes to get a similar appearance. Now do bear in mind there is no correct method, so remember there is no right way of doing this. There will be multiple solutions, however you can use a minimum of 2 nodes, a generated texture node and a bump node in order to do this. Being creative can end up with awesome results, so sometimes the unexpected can end up being better than what you planned. So remember to play around with these settings. And remember to think through your nodes logically. At the end, I'll go through some alternatives and the pros and cons of using those as well. A couple of hints for you. There is no cloud texture in Cycles, so you're going to have to use something else, and there is lots of choice. And I'd like you to plug the texture into the diffuse color input to see what it looks like. You don't have to do that, but it's a great idea to get an understanding of how that texture that you're using to control actually looks. So you can just plug it into the color input of the diffuse shader and see what it looks like. And then you can replug everything back else in as well. Pause the video now and give that a go. Okay, so let's go ahead and set up this in Cycles. So I'm going to go to my materials and enable nodes and switch over to Cycles Render. Now I'm not going to have my reference image on the screen because I've got it quite busy as it is at the moment. I'm just going to try and create myself a little more space on here. And, well, this is one of these examples where a floor would be quite useful on our model, so we can see it a bit more in situ. So I am literally, I hope that's on the ground, I'm going to go into object mode, create a circle, just for it to exist on, and scale that up. Oh, it's way over there. That's not going to work quite as I expected it to. Let's just add another circle. I'll delete the other circle in a moment. There's too many circles now. I'm going to add a circle and scale that up. Well, there's an invisible circle at the moment. It's kind of cool. Why is that invisible? That's a very good question. It's because it's not filled. There we go. So that's roughly on the base of this, just to give it a bit of presence. And I am going to make that, in fact, slightly glossy. I'm going to go for glossy, so it looks like it's reflecting, and increase the roughness. So it's a rough, glossy material. That's looking good. This sun isn't looking particularly bright. It is a sun lamp. The strength, I'm going to turn it up a little.
Okay, so now we need to set this up in cycles, which of course will be slightly different. So first of all, let's switch across to cycles and make sure we're now using nodes for our material. Use nodes. There we go. So we've got our base diffuse texture back again. Now I've got a reference image off to one side. I can't fit everything on my screen, unfortunately. If I bring everything on here, it'll just get confusing. So I need to modify this. So let's zoom in a little and see how this is laid out. So the output is what we're seeing, and we've got a diffuse shader based on here, and the color is being controlled from that image. Great there. So that's that bit set up. So we need another texture to use for control. So I'm going to go ahead and add in texture. Now, if I had an image texture that was appropriate, I could use that. That's no problem at all. I can pick one of these other textures. Unfortunately, clouds isn't there, so we're going to have to play with a couple of these and see what we get. So I'm going. Oh, I've just slipped off the menu there. I'm going to first of all start with brick texture. Does that work? So I'm going to plug in the color to the diffuse shader and just see what happens when I try this. Well, it doesn't seem to be producing any sort of textures at the moment anyway. I don't think that one's going to help us. It might do, actually, if we have the vector plugged in. So none of these at the moment are being told, none of these textures are being told how they are to be mapped. So let's go and add in an input texture coordinate and say you are being mapped with UV coordinates. So let's map in this brick texture and see what happens. Oh, okay, that's interesting. That may help us. I'm not sure. I think I would have to match up the two blocks really well in order to use that. But I don't think in this case that's going to help. If we had an already blank wall, that might actually be helpful. If we wanted those square style bricks. I don't. I want my other one. So let's find a different texture. So let's go ahead and add in texture. I'm going to try noise. So the vector, it's been mapped via UV, and the color, let's plug color into color. Oh, okay, so this one's got color noise in it. Let's plug in the factor into color. There's our black and white channel. Brilliant. So now we can go ahead and using the color, the original diffuse texture as the diffuse color, and let's see what happens if we plug factor into normal. No, that's not done what we want it to. So let's pull that out again. By the way, when you're doing this, there is a preview over in the materials side as well. So we can open up the preview that's here and see how that's looking on different types of objects. So this is what it looks like on a sphere. This is what it looks like on a plane. This is what it looks like on a cube, Suzanne, etc. Quite powerful options there on seeing what it's going to look like on other shapes. So let's try factor into there again. No, that doesn't help at all. All it does is make our image rather dark. So we need something to convert that so it's compatible with this normal input. And we use a bump node to do that. So let's go ahead and find bump node. Well, it's under vector, or of course you could search for bump. So I'm going to add the bump node in there. And using the factor, I'm not going to control the normal, I'm going to control the height. And then the output here, I'm going to plug into that normal. That is starting to look much better. Starting to get that bumpy feeling again. Of course, it's not going to change the edges or the actual geometry at this point in time. It's only controlling how the light looks. So we can change this distance here. I'm going to set it at 1. And then turn the strength down. Well, no, 1's a bit too much. I think I would rather have it with a distance of maybe 0.2, but slightly stronger. Let's up that. Okay, I would like it to be a bit more subtle than that. So let's try 0.3 and 0.5. Yeah, that's starting to look much better. And of course, we can tweak these to our heart's content and be happy with one moment and with the next. And we can also change the texture itself. So I can make it a bit more bumpy. That's starting to look a bit more interesting. I'm liking how Suzanne is looking at this point in time. So that's more of a kind of a rendered finish if I bump this scale up. What does the detail do? Well, let's lower that back down. I think I am going to boost it to maybe 20 or so.
This detail, if I lower it all down, it's always good to go to extremes with these. Well, with no detail, it's kind of a smooth bumpy, and it tends to get, well, noisier, I suppose, with more detail in it. Okay, and distortion, oh, that starts adding swirls. That's kind of cool. Okay, so this is what I mean by the experimentation. In fact, Blender's gone a bit laggy whilst it's rendering things out. There we go. With experimentation, you can, okay, this is no good for our particular wall that we're working on, but that's something to remember for later, I'm pretty sure. So I'm happy with a slightly larger scale there, and I'm not going to go for too much more detail. The 8 there, that's absolutely fine. Now we've got that, as we can see here, I can't see the texture underneath anymore. So I'm going to have to bring the strength down so I can see the underlying texture as well. That is looking pretty good. I think I'm going to have to increase the distance here. And again, these are tweaks you can go backwards and forwards to your heart's content and do. Now, at a certain distance, it seems to make no difference because based upon this strength here, I'm going to lower that back down to, let's say, 0.2. So now our wall has a texture on it. That will change based upon the light hitting it, which is very important. That means we haven't baked the lighting information into any texture. It's being generated based upon where lights really are in our scene. Now, a couple of other things I would like to do here, of course, is add a stage for it. But I'm not going to do that in this particular solution. I'm going to play with these a little more until I get to roughly the right point where I want to be. I mean, you can play with this all day long. I'm quite happy with that. Now, one of the questions that you might have is, well, why didn't we just plug this factor straight into that displacement? And I'm just going to remove the normals that we've created. Now, there's a couple of reasons why we haven't done that. The first one is we want to control the diffuse shader, how the diffuse shader is being handled, not how everything at the very end is being handled. So there's a slight distinction and difference between the two. But this is also a valid solution for the right effect. Again, like most things in Blender, as long as you get the end desired result, a lot of using Blender is kind of a mixture of knowledge and just trying things out and making sure you're logical with how you plug things in. So in this case, we do want to specifically control the diffuse shader and how that interacts with light. If we plug it in all the way into displacement, it changes how the whole object or anything else that this material is applied to interacts with light. So I'd love to see what textures you came up with and have applied to your wall. How did they look when you moved them across to the building that you're creating? Remember to share in the discussions, and I will see you guys in the next lecture. Welcome to Using Displacement Maps. In this video, you will create real detail using a texture. So we're going to take this texture and use it to actually modify geometry. So we're going to use a displacement map to alter geometry. You will understand that you need geometry first in order to modify. If it's not there, then there is nothing to modify. We'll use the displacement influence in Blender Render, and we'll also use the displacement modifier in a similar manner as well. We'll see how you can do that at render time, and we'll see how you can do it in reality as well. Now, talking about reality, there is an important reality, and that's the fact that, going back to the point, that in order to do this, you need geometry in order to modify. So it's not suitable for certain things. So it's not really suitable for generating a final brick wall, for instance. It would be quite tempting to use a black and white checkered image, so to speak, to produce a brick wall, but a very high poly count is required. Now that's fine if your computer can handle it. Mine can't for doing you're going to have a supercomputer. In fact, you end up with a brick wall being a silly high polygon count when it's completely unnecessary. What would be better is combining a low polygon bumpy map, so it's almost the right shape but not quite, with another displacement map or even a normal map, and we'll get onto those shortly, in order to fake some additional geometry as well, where we can't really have too many polygons. Now, they are useful for applying details, for example, scales on a lizard, fish or dragon, or if you don't have a bump map yet, we can use a generator generated one to create geometry and then bake that back, and we'll come on to baking very soon. We can bake that back down into a texture and then reapply that. So there's lots of techniques we can use going backwards and forwards. Now, talking about creating geometry, they are great for creating or generating geometry, and then of course optimizing. So not leaving that as your final model, leaving it as a halfway point to get you to certain positions much more quickly than it would be possible to do otherwise. And they're great for larger items like terrain, where fine detail is not required. Where with a large terrain, you can make it bumpy very quickly by using displacement maps. So let's go play with displacement maps now and applying them, and hop on over into Blender. Okay, so we're over in Blender and there are a couple of things to show you. The first way of doing this displacement is only going to happen at render time. So that's either when you're in the rendered view of your viewport, your 3D viewport, or when you go and hit F12 or go to render and render image. Okay, so we'll start off with Blender Render. So we need to switch our rendering engine to Blender Render, and once we've done that, we've got our cube in front of us. Let's go create a texture in order to use. Now I'm going to be really quick about this, and I'm going to use a generated texture. So I'm going to go to our textures tab and go new. I'm going to go to where it says type and change that to Voronoi. Now I've chosen Voronoi simply because I know it exists on Cycles as well, so I can show you something that's very similar. Now that we've done that, we need to go to we need to scroll down. Have we got a material? Yes, we've got a material. Okay, so we can scroll down. Notice I needed to go to material first for this lot to appear. And I'm going to untick color because I don't want it to affect the color. And I'm going to tick displace and turn the displace up as much as possible. And again, we don't see anything at the moment. We need to switch into rendered mode. And that is not looking too great at the moment. It's had zero effect on our model. Quick look up and down. We've got text here, type, none. That's why. Let's change it back to Voronoi. There we go. It's doing the displacement that I wanted it to do. And it's only moved some... Oh, yes, we've only got 8 vertices in total to move, so it can only move 8 vertices, even at render time. So what we'll need to do here is give it some more vertices to actually start moving about. Now, of course, when we're dealing with a cube, there are several ways to... add more geometry to the model. We could go in and just add more geometry. I could subdivide it, that's one quick way, but I'm going to use a subdivision surface modifier. That is going to change this cube into more of a ball shape, but we will see that this is the effect we get. I'm just going to zoom in and have a look. I'm going to set the shading to smooth. That is a pretty cool effect and very quick. I haven't done anything to set this up other than those few quick settings. Now do bear in mind this is at render time, so if we switch the viewport to solid mode, it still looks like that ball. If we go back to rendered mode, you'll notice that this is what it looks like in the viewport, but when we go and render it, it kind of looks horrible. And the reason for that is in the subsurface modifier settings, the render settings are only set to 2 subdivisions. If I set that back at 6 and hit the render, it looks the same as it does in the viewport. So there's something to watch out for there. So let's have a quick look now at the Cycles variant of this. Now, this is an experimental feature, so we're only going to go over it very quickly, and I suggest that after turning your experimental features on, you turn them off again after we've played with it. So I'm going to have a 3D view open, and I'm going to have a node editor open. Okay, so the first thing to do is on the feature set on your render properties, change it from supported to experimental, and be warned, from here dragons may approach and destroy everything. Not really, but it does enable some features that may crash Blender, so use with caution. Okay, so now we've done that, what we need to do is go and apply the texture to the displacement. So first of all, we need to make sure we've got a material. I'm going to go ahead and click Use Nodes, and in the node editor we can see we have a material output and this diffuse. That's fine. We need to go ahead and add ourselves a texture, and here we go, we have Voronoi again. And I'm going to plug the factor onto the colour and just check what it looks like. That's what it looks like, and you can see there that this is a bit larger than it was before, so I'm going to increase this scale. There we go, that was about right. So now I'm going to take this factor and plug it into displacement instead. Now this will initially give us like a bump map rather than actually changing the geometry at render time. However, if we go to the mesh data properties here and scroll down, there's this new area here where we can see displacement. Now I am just going to do a quick tweak and on our lamp settings make it use the sun so it's just a bit brighter and a bit more uniform light across there. So let's click on our object again, go to the data properties, scroll all the way down, and displacement. And as you can see at the moment, it is set to bump. If we change that to true, we can see it's actually changing the underlying geometry. But once again, it does require geometry in order to work. So if I turn the subdivisions down, you can see that eventually it ends up back at a cube again and not this wonderful shape. Now, in fact, if you have both turned on, so if we go back to the mesh data here and go to displacement, go to method and do both, we get a much crisper and cleaner appearance. I'm not sure which one I actually like the best. I think I do like this one, but both obviously have their places. Now bear in mind, once again, this only appears at render time, not when you're looking at the model and working it in solid mode, not when you're working it in texture mode, or even material mode. So that's worthwhile bearing in mind. Now let's go in and use the subdivision surface modifier to give us some geometry, and actually the displacement modifier as well, so we can see what's going on in the viewport. So I'm just going to unplug this Voronoi texture. I'm going to get rid of it, and I am also going to go to my render properties and change the feature set back to supported, because I don't want Blender crashing on me. That's quite disastrous when that happens. So I'm going to move this window up and get rid of it, and there we go, we're back to our ball, and we're in material mode at the moment, so I'm just going to switch back to solid. So now we're in here, we can go to our modifiers tab and add in a displacement modifier, and the displacement modifier is under the deform column. It's the fifth one down there, displace. Now you will see it just gets slightly larger to begin with, and that is simply because it is just displacing everything as if it had a uniform texture applied to it. Now bear in mind you can do your own textures if you'd like. In this case I'm going to use another generated one. So in the textures area of the displace, I'm going to hit, is it already stored? That's the first thing. There's no point in generating another one. So let's go to use this thing. I always think that looks like a paracetamol pill or something, but I'm going to click on that little icon there, and it's actually taken us over to the textures tab. And under this drop down, we can see we've got displace, brush, and brush mask. At this point, we do want to make sure it's only affecting the displace. I'm going to click on this drop down here, and we'll see there's already 2 in memory. And the text, I think that's what we were using here with the Blender render. So we can click on that, and there we go. We've got the Voronoi texture again, and we've got some ways of altering it. So now we've actually got a texture modifying our geometry. We can tweak it a bit more by going to the modifiers tab and just playing about with them. So at the moment we can see what texture it's using, the direction. So you can actually have all of these modify in the Y direction, and you get this kind of I don't know what to describe that as, but I'll leave you guys, sharing the discussions if what you think that looks like. Windswept, I think I'm thinking of. I'm going to leave it to normal, so it goes out sort of evenly across the entire model. Texture coordinates, well, if it was a mapped UV texture with very specific displacements, i.e. very specific colours, we could go in here and switch this from local to UV and use a UV map. Vertex group is very powerful. It allows us to control what parts of our model are affected by this particular modifier. And we've got mid-level, and we can see that by moving that it changes where the modifier is taking place, and the strength of course changes the actual impact that this is making on our model. So if it's set really low, we get a nice dimpled effect. If it's set really high, we get a more explosive effect. Now of course if you go into the negative numbers, instead of it
the blacks representing low points, they start to represent high points, and you get a completely different effect. In fact, I think that when you move it out like that, it looks like one of those flowers. Is it hyacinth? I don't know. I don't know my flowers at all, so I'm probably completely wrong there. So there's lots you can do, and it's very quick. You can see how quickly we've managed to actually get to this point with very little modification of the geometry. In fact, still underneath, remember, it is a cube. Now, what you can do is in the modifiers tab itself, there's a little thing that looks like a cube with 4 dots on it, and that will display the modifier in edit mode. And that's kind of fun because when you're in edit mode, that does mean now you can grab vertices and move them about and change the underlying shape that these modifiers are being applied to, and obviously generate new shapes coming from there. So the other thing we can do here is just try a couple of different textures. So we can go into the textures tab and from Voronoi choose noise. And wow, that looks a mess, which isn't surprising. And we can go into the modifiers tab, go down to the displacement, having it this way round, have it set that way round, and wow, we've got ourselves a bulrush or a spiky caterpillar or something. And we can look at this in render mode as well. Oh, I've lost it for a moment there. There we go. So we're looking at it in rendered mode, and if we go ahead and render that, well, that's quite cool. That is like a bulrush on the end of a bulrush. Is that what I'm thinking of? No, I'm thinking of a thistle or something along those lines. I don't know. I'm rambling on now. And of course, that usually means it's time for a challenge. I'd like you to go ahead and make your ground more interesting. So what do I mean by that? I would like you to use the displacement map and the displacement modifier to create a not so flat ground around your model. It's just going to create a bit more of a natural feel and make it a bit more interesting, basically. And I want you to combine that with something. I want you to use vertex grouping to isolate where the building sits from the bumpy ground. And that's going to prevent the inside of the building from getting bumpiness inside it. I'm not sure that's technically the right language to use, but we don't want undulations underneath the building itself. That needs to be nice and flat, just like you would build a real building. So pause the video now and give that a go. Okay guys, welcome back. Let's go make some ground more interesting and hop over into Blender. So I'm going to say goodbye to my thistle for the moment and go and open up my Gothic church that I've been working on. Let's go to the 3D view and have a look. How's it coming along? Pretty well. I have decided, by the way, and I might do this on camera or off camera, I haven't decided yet, but this top part at the top here, I've actually looked at some reference material and most of them don't have such fancy tops to them on the actual bell tower itself, so that'll probably go, but the rest of these lovely archways will actually remain. So let's work on this ground. So I'm going to click on the ground and it doesn't have anything any geometry at the moment. Now I've got a couple of options. What I want to do first of all is just see if adding a subdivision surface modifier is going to shrink it too much with a level of 6. So let's go to the rendered mode and note that looks absolutely fine for the moment. I may have to adjust the scale of it slightly and bring it out. There we go. I'm just doing that by eye, nothing referenced really. So that is looking pretty good. Let's go and start modifying it. Let's add a displacement modifier as well. Aha, so it's lifted it all the way off the ground. That's not too great, but we'll deal with that in a bit. Let's add oh, is there a texture in memory I can use? I'm going to use the displacement we've already got linked in. Wow, okay, check that out. It's my church in a mountain range. Don't think we want the strength quite that high, so let's lower it down to maybe 0.2. Okay, that's slightly more realistic. But what we're missing in here is, as you can see, it's modifying the ground underneath the church. And not only does that make it bumpy inside,
That's no good. That looks like a landslide or something has happened. But it also means that the church is floating in places as well, and that's no good. So we can do this in any order, but I've chosen to do it round this way simply so I can show you the impact if you hadn't done it. So let's go ahead. Now, in order to use vertex grouping, we are going to have to apply this modifier. I don't believe we're going to be able to do any vertex selecting because the only real vertices are these 4 on the outside of this plane that I've got. So we're going to have to apply that. Can't apply in edit mode, fair enough. Let's apply that. So now I've got some actual geometry that I can work with. I'm going to hop into edit mode and we can see all the little squares, and I'm simply going to draw around them and remove them. So I'm going to go to circle select, and holding down my middle mouse button, of course you could deselect any number of ways. I'm just going to remove some of the ground around my church, or rather some of these vertices. Now I don't want it too close, because if this one gets pulled up, remember that it will, and it is selected at the moment, remember we're vertex grouping, this particular vertices here, if that gets pulled up, then it's going to pull up anything connected to it. So we actually want to make sure that it's actually going to be quite wide around here. So if this one gets pulled up, it won't affect. If this one gets pulled up, it will affect. So we want to remove those as well in order to make this work properly, and that should be okay. We'll do that. I'm going to go over to my mesh data, and I'm going to scroll down to vertex groups and add a vertex group, and I'm going to call it bumping ground. Why not? Because that is what it's applied to. And I'm going to assign. So I'm going to deselect everything and just select. Yeah, that's absolutely great. So now we've got that vertex group assigned, we can go to our modifiers, vertex group, and bumpy ground, and there we go. Now when we hop out of edit mode, the actual ground itself around the church should be flat, which it is. Now, we can see at this point there are some sheer drops around it, but that's okay because it means that the ground inside and that it's placed on is absolutely fine. Of course, now we can go around and tweak a load of stuff, so we can make the church sit down, or we can make the church sit up, and we can see here a bit more clearly what the mid-level does. If it's set in the middle, then it's going to oscillate either side of this midpoint, that's the area that's flat essentially at the moment, and obviously the strength, I think 0.2 is a little high. I'm going to go for 0.1. I'm going to just render that quickly and see what we've got. Or maybe 0.2. Yeah, I quite like that. But I am obviously not going for that low poly look, so I'm going to open up my tool shelf. And the operator panel's got itself very large. Just make that smaller. I'm going to turn on smooth shading. That is looking pretty good. How did you guys get on? Did you try this technique on any of perhaps the block work in your building as well? You could start adding detail to individual areas and making it a bit more unique as well. Make sure you share your work in the discussions, and I will see you guys in the next lecture. So we've mentioned them lots, and it's time to discuss normal maps. So welcome to normal maps. In this video, you will understand that they are a type of bump map. You'll gain a greater understanding of how normals actually work, and also that they contain direction information and not height information, and we will go over the fact that there are 3 main types. So first of all, height map versus normal map. A height map with a value of either 0 to 1 describes the particular surface height at any point, and we can see that can be used to displace our model if necessary and provide some level of control and even a basic bump map. It can make something look bumpy. However, a normal map is slightly better in the way that it controls the direction of light across a surface. Here we have a normal map of the same surface. Now, obviously these are 2D, and when we work in 3 dimensions, we can have a whole different gamut of colours. But in this instance, we can see that this zigzag repeats itself, so we've got the lower half and the upper half. And when we look at the normal map for that particular shape that we've got in front of us, imagine it was a profile of a 3D model, we can see that the normals are identical. The first 3 are identical to the second 3, and that gives us no indication of height differences between those surfaces. So So normal maps themselves, they contain direction information, not height information. I'm not going to stop repeating that because that is important. A lot of people get the two confused and think that normal maps convey some sort of height information. They in fact do not. The RGB color channel values define the direction of a particular normal across a surface. And the XYZ components are also defined with red, green and blue. Have you ever noticed that the 3D gimbal in any package that you work with always sticks to these three colours? There's not a coincidence to that, I'm pretty sure. So let's have a look at the first one, and I'll hop over to my iPad and just draw this out for you, and we'll talk about tangent space normals. Okay, so let's talk about normals in a bit more detail. If we make ourselves a triangle of a shape that we're all familiar with, it will be made up of 3 edges and 3 vertices. Each one of these vertices has their own normal associated with it. Now obviously I'm stuck in 2D space when I'm doing a drawing like this, but this also applies to a 3D space. Now these edges that are joined, this particular one here will have a normal that's something like this, 90 degrees to this particular edge, or indeed if we imagine it's a face side on, that would also apply. And this particular normal is an average of this normal and this normal here. Now ordinarily when light comes in, the shader controls somewhat how light is bounced off a particular surface, but in general if light were coming in here and hitting this surface, we would expect it to bounce off at this sort of angle. If it was a highly specular surface, that would be what it looks like. And we can take control of that when we map an image. Now obviously we need a face to map an image to, but in this case we'll use a 2D representation. So let me remove those light lines. So we still have some light coming in here, but instead we've mapped an image to the surface to tell the surface how to react to light. So at these 3 points that we have, we can control how light is actually bouncing, as if there was more geometry than there actually is. So if we pretended, for instance, that the surface looked like this at this point, that it looked like this at that point, and it looked like, that at that point. And we can do that with a normal map. Then we would see that the light would bounce off considerably different. So at this point, it would bounce back off like that. Here, it is likely to bounce off like that. In fact, that might be a bit overkill in that case. And this point here will bounce back off like that. And we can see that this gives us a great deal of control about how light is interacting with our surface itself. Much more control than a simple height map. Now, often these two things are used in conjunction with one another in order to make a model look more realistic. Okay, so let's have a look now at tangent normal maps, an example of them. These are one of the most common ones, along with object space normal maps as well. So we'll cover tangent first. So here we have a view where we can see that smooth shading makes a difference. Where flat shading is, you can see that on the normal map. And where the cube is, well, hang on a minute, why can't we see the cube on the normal map? And the reason for that is because the top of the cube is the same direction, it has the same normal direction as the plane itself. And therefore, it has no direction change and no color change on the normal map. So a normal map's appearance, when creating normal maps, they are affected by whether or not the mesh object has smooth shading turned on. Normal direction is very important, otherwise the map will end up useless and you won't be able to use it properly. So if we take the same scene again, but this time inverts the normals of all of the objects that we're mapping, we can see that we end up with a much bolder normal map happening. And that is actually going to be useless for us if we're using tangent space normal maps. It's not going to look very nice. Now there are other normal maps. Now I know at the beginning I said there are 3 types, but there are 4 I suppose in general. A couple of them really aren't used and 2 of them are very similar to one another. So there are 3 other normal types. We've got the camera, world and object. These are all reference points for the normal map, and they all have their uses and issues, as all of these things do when we've got choice. So using the camera normal space, that is highly restrictive. This is the normals according to the camera view itself. So if you've got a static camera, it's going to be possibly fine to use it in here, but you cannot move the view of a scene without breaking the illusion of detail, as the lighting effect will get worse the further you deviate from that particular viewpoint, because it's the camera that's changing how the normals react. Using the world space. Now, this is also quite restrictive, not as much as the camera. You cannot rotate, deform anything made within the world normal space without breaking the lighting illusion. The moment you do that, especially if you change the lighting, it will break down. So using the object normal space. Now this is a more optimized form and is often used in games because it takes less computational power, because there is a one-to-one mapping to your object. So you can only use it once, as it has this one-to-one mapping to the object. So we can't reuse a normal map across multiple items. Let's say we've got a brickwork type normal map. Well, you could use that over lots and lots of different models. However, an object normal space, well, it's got a one-to-one mapping to that object, so unless another object is either incredibly similar or the same, we cannot use it on anything else. Now, this is also called local or model space as well as object space. Now, it can generate higher quality maps as the normals are replaced, not adjusted. So with a tangential based, it is the normals are adjusted, whereas with an object they are replaced with more normals. So slightly better rendering performance can result from this, and it's easier to visualize, because if something is facing down, it will have a completely different normal than if it's facing up. Now with tangent space, we often see that if a normal is 90 degrees from that particular face pointing up, it will be the same color wherever it is on the model. So using the tangent normal space, where is that used? Well, they are great because they are reusable regardless of scale, deformation, or etc. of a model. So they're great when used with animation, for instance. It can be difficult to avoid smoothing issues. They do save memory and bandwidth because we are calculating, but because we're calculating, they have a slight impact on performance. They can also be tiled and scaled, etc. So that's great if we want to use a tiny normal map that we've made on one object, much like we did with the displacement map a moment ago, where we changed the ground using a normal map that already existed in our scene. That's a great, it wasn't a normal map, sorry, a displacement map, but you can see there that we can reuse these things over and over again, and that obviously saves us a lot of work if we can reuse something, and it's not too noticeable that we're reusing it. And especially when you're working on models of completely different scales, it's unlikely that you would notice that the same texture was being used across multiple models. So using normal maps outside of Blender. Now some external programs or engines will interpret your normal maps differently, so adjustments may be required. That's just a word of caution when you're exporting. Most are going to be absolutely fine. However, there will be some times where it doesn't quite work how you wanted it to, in which case we would have to adjust the normal maps accordingly. Okay, so it's challenge time. I'd like you to think about which technique would you use. So looking at the various normal mapping options, which ones would you use in your scene and why? Now there's a hint here, you can use any of them. The why is the important part. Share your ideas in the discussions. Pause the video now and give that a go. Okay guys, welcome back. So which technique would I use? There is no right or wrong here, as with most things in Blender. Now I will be using tangent space for the majority of my models, and the reason for that is I am still prototyping and want to reuse maps wherever possible across my model. I don't want to have to create unique ones every time for every individual model. Now, if I had a unique item that I knew that there was absolutely no chance, I may also use an object space normal map. For instance, I suppose if I produced a lectern or something like that, I may use an object space for that. But everything else, I think I'm going to end up using tangent space for. What did you come up with? Did you share your ideas in the discussions? I hope you did. I look forward to reading them. And I will see you guys in the next lecture. Welcome to Baking a Normal Map in Blender. In this video, you will create a normal map. You'll understand when to create a normal map. We'll be using a process called baking, and see that baking is the fundamental process for creating other map types too in Blender. And we'll understand about cages and why they are used. Mapping textures to a model. Well, whenever they are being used, it is a form of optimization. So you should always be asking yourself, does this need optimizing? If you already have a low polygon model and it suffices, then you don't need to do any more. However, if you want to keep it a low polygon model, but you want to have the illusion of a lot of surface detail, whether that be a bit of clothing with the weaving in and out, or whether it be a wooden box with the slats and the gaps in between the slats, then we can start optimizing and not having to use geometry to create that. It allows high detail to be baked onto a lower polygon model and have almost the same appearance. In some cases, you can't tell the difference. Decreases render times, especially if exporting to a game engine. Now, one of the things you've got to consider if you're making assets for a game engine is that people demand 60 frames per second or something along those lines, and we want to make sure that they get that, and by using normal maps and other type of mapping techniques, we can increase render speed. When it comes to Blender itself, of course, a render of one scene may take 5, 10, 15 minutes, who knows? By using normal maps, we might be able to cut that down by 10, 20, 30% in terms of its rendering time. Now, for the one-off scene, that probably doesn't matter so much. But if you are doing an animation, this is where suddenly that saving really starts to compound and saves you a shed load of time when it comes to sitting there and waiting. Of course, when you're rendering, your computer is going full tilt, so it's also going to save on your electricity bill and wear and tear on your computer. Poor thing, we do put it through lots with Blender. So let's go ahead and create a little shopping list of what we're going to need. We're going to need a high polygon source model in order to get the detail. We're going to need a low polygon model, same model of course, just a lower polygon version in order to put that detail on. If we're just going to stick with the high polygon model, then a normal map once again won't be necessary. Possibly a cage. Now that would depend on the model that you're doing, and I'll give you a demonstration of when you will need a cage. We're going to need a UV unwrap of the low polygon model so that we can have an image ready to receive the normal data. So now that we've got our shopping list ready, let's hop on over into Blender. Okay, so we're over on our default scene here, and we need a high polygon source, and of course a cube isn't particularly high polygon. So I'm going to make this really quick, and I'm going to use a subsurface division modifier and crank that up all the way to 6 and apply it, and that's going to give us lots and lots of geometry. While still in object mode, I'm going to create another cube, and I'm going to apply another subsurface division, and well, let's go to 3 subdivisions and apply that. So now if we check how many triangles, we've got 768 on the low poly, and the high poly has 50,000. Okay, that's a great extreme example between the two. Now I'm going to want my both mine to be on smooth shading. So there we go, we've got smooth shading. And we can see a bit of occlusion, it's a little bit jagged around the edge, but I think that is okay for the purposes that we're doing. Of course, we need to name these, so let's go ahead and name this high poly ball and low poly ball. Otherwise, I won't know which one's which when I'm looking at the outliner. In fact, I'm going to use the outliner in order to do this particular work with selecting, because these two need to be on top of one another, because we are going to be projecting from one onto another. We're going to be projecting from the high poly onto the low poly. So in order to do this, we're also going to have to unwrap the low poly ball. So I'm going to hop into edit mode and unwrap. I'm just going to use Smart UV Project because during this demonstration, I don't really mind how it actually unwraps it. In fact, it may even highlight some problems if we don't take control over that unwrap. So now I've done that, I just need to make sure that that has worked, and I'm going to open up a UV image editor and quickly check it. Okay, so we've got a UV map there, but we don't. That's going to control the mapping of the normal map that we're about to create. So it's telling Blender where to place the information, but there's nothing to place it to. So we're just going to have to create a new texture, and I'm going to call it normal map because that is what it's going to be. And I'm going to click OK. Now, before we do anything else here, there may be the occasion where you have more than one UV map for a particular model. Where perhaps you've used one UV map at a certain scale on a diffuse texture, and that's worked wonderfully, but now you want to use a different UV map with a different scale. Because we're projecting, all of the UV map has to be within that one image, otherwise it will tile and look horrible. So if we do want to create an extra UV map, or more than one, we can go to the data properties of the low poly ball, scroll down, and we can see we've done vertex groups before. Below that we've got shape keys, and below that we have UV maps. So we can create a new UV map and call it normal map, or whatever you want to call it if it's a different type of map. So now we've done that, we can go ahead. I'm going to click the little camera there, so that's the one that we as active for rendering. That's the one we want because baking is a form of rendering. So now we have that, we can see that we're looking at the normal map as well because the UV image editor has changed. The active UV map is the normal map. So let's go ahead now and go to the rendered tab and have a look at our baking options. So we're going to have to scroll all the way down to the bottom, and I'm going to open up bake. Now what I'm going to do here, in case I need to flick backwards and forwards between other settings, I'm just going to split this window here so I can see bake all the time so it's not disappearing. Hopefully I won't need to dash about left, right and center, but if I do, I can get back to bake really quickly. Now we've got the bake button, and if we click that, it's not going to do anything because we've not really told it what we want to do. Now here we go, no active image found, add a material or bake to an external file. So in this case, has our low poly ball got a material? No. So let's go assign a material to it, and I'm going to call this normal map just so I don't get confused with any other type of material that we set up. And I'm also going to scroll down here and set the surface color to an image texture, and I'm going to change it to normal map. Now this isn't how you apply a normal map, we'll go to that in a moment. This is just so I can see real time on the model what is going on. I'm also going to hop out of edit mode there into object mode and change it to material. So there we go, we can see both are black. So what we need to do is bake from selected to active, so from the high poly to the low poly. So let's go ahead and click on high poly, hold down shift and click on low poly, and you can see why I'm using the outliner to select rather than the meshes that are on top of one another. I'm going to change my bake type here to normal, there it is, and make sure selected to active is ticked. Now I'm going to hit the bake button and let's see what happens. Okay, so that's not surprising. That is exactly what I was expecting to get because both of them are pretty smooth. So let's go ahead and add some detail to the high poly ball, and I'll use the sculpting tool to do that, just so we can see what's going on. And I'll create some highs and some lows, so I'm going to use add and subtract when it comes to that. So I'm just going to hide our low poly ball. I'm going to go into sculpt mode, so let's go back to solid. I've obviously not got it selected. There we go, sculpt mode. And I can't see much of what's going on, so let me rearrange my screen really quickly, and I'm going to draw a smiley face. Who wouldn't draw a smiley face? There we go. So we've got ourselves some... oh, I've got symmetry turned on. Oh well, it's two smiley faces. Excellent. Now let's do a subtract as well, and let's say there we want two ears, and there we go.
It looks more like a love heart there, but never mind. Okay, so we've got some detail now on the surface of our model. Let's see what happens if we go and bake that. So selected, high poly, shift low poly to active, and I'm going to click, oh, can't see it, so let's enable it and then bake. If it's not there, we can't bake to it. Okay, so we can see that the indents that we've made are appearing on the normal map, but these raised areas seem to be cut out. In fact, if we change to material, we can see the normal map actually being applied to our model as a diffuse texture in this case, and we can see that the raised areas are just ignored altogether. And that is no good. We want to include them. Now, there are two ways of including them. Three ways of including them. We can make the low poly ball bigger. So we can go in here, scale the low poly ball up. So let's go to object mode, select the low poly ball, scale it up. Okay. Now go to the high poly, low poly, and bake. And there we go. So that's one way of doing it. But now we have a problem. Essentially, the lower poly model is bigger, and we don't really want to do that. So let's undo that step. But that is one way you could go about it. The other way you can go about it is to add a cage. Now, a cage has to match the low poly model in terms of its triangle count. So if we duplicated that and then made it match as close as possible to the high poly ball, that would enable us to use a cage to make that. Now, the ray distance is kind of similar to scaling up the model. And if we go and scale this up, well, it's not really scaling, but it kind of gives the impression it moves the projection a bit further away from the surface. If we now try and do that, let's see what result we get. So at point 2, we seem to get a relatively good result. Now, bearing in mind this can cause distortion on more complicated shapes, you have to use that with caution. And if you've got something that's massively different, that juts out from the surface, these are not really that exaggerated. They're not that extreme in terms of how far they stretch away. But if they were to do that, you may want to use a cage rather than just adjusting the ray distance. But it seems that point 2 in this case results in a relatively good normal map. That looks pretty impressive. So now that we've got a normal map made, what we need to do is apply it. So in order to do that, we're going to need to go over to our node editor. And this is the material that's currently set up. And this is another great thing about applying it to the diffuse texture straight away, because the image texture is already loaded and ready for us to use. So once again, I'm going to hide the high poly ball from our scene altogether. And I'm going to make sure the low poly ball has it applied. So let's go ahead and let's go down here. Yes, it's got the normal map applied to it. That's absolutely fine. Now, it may be tempting, of course, let's unplug that so we can see what's going on. It may be tempting to plug the color straight into normal. Well, that didn't work. And there's no surprising that that hasn't worked. We haven't told it anything at the moment. So let's be explicit. Let's tell Blender that the input, the texture coordinates, are UV based. So let's join that in to there. Now, we don't want the colour being mapped to the normal. We need it to go through some sort of filter. Now, we could plug it into the bump mapping that we used earlier. We could also put it into a normal mapping. So if we go ahead and add a vector normal map and pop it in between those two areas there, we see that the colour is controlling the colour. We've not selected a UV map here, but we can select normal map in this case. And looking down here, we should now see that this is starting to change our model. Let's go into rendered mode and have a look. There we go. That is looking pretty good, but it does have some problems. We can see it's jerky around these edges, and this is one of the artifacts that can happen if you don't take control of your seams. Let's make the light a bit more exaggerated. I'm going to go for a sun lamp. And what we should be able to see here is if I just line this up, when we go ahead and move the sun lamp, so I'm just going to rotate that sun lamp on the y-axis or something along those lines.
what we should find is that the shadows change. It's as if there is real geometry there, and that's the whole point of using these normal maps. That's a good example there. You can see that it's light on one side, and if we rotate it all the way around, it will become light on the other and then dark. Now you can see here some artifacts that are being caused by having such a low poly model here. Let's just check that we do have smooth shading turned on. Yes, we do. It's just unable to interpret the model, and of course the normal map is causing this horrible jaggedness. Oh no, wait, I see what is going on here, and I have forgotten to actually change the type of image that this thing is. Let's change on the image texture itself. We haven't said this is non-color data, so it's interpreting the RGB values as color. When we don't, we want the RGB values to be treated as individual values. There are 3 channels there, from a value of 0 to 100%, and each one of those we need it to be interpreted completely individually, not a blend between the two. So we can do that by changing it to non-color data. There we go. That is the look we're looking for. And now if we go ahead and grab the lamp, rotate it around an axis, we can see here that it changes. It's as if the geometry were real. Now the question is, of course, if I have that there and I put the other one there, oh, I've turned the lamp off instead, can you tell the difference between the two? I'm going to render these out now side by side, and I'll show you how great this is. Wow, okay, so I've blown these up to full screen and tried to fit them on as best I can, and I want you guys to guess which one's which. Okay, I'll give you a clue here. If we look for occlusion, so even though the outside is relatively smooth, we can see the eyeball on the other side, on the right hand side, in the shadowed area at the top left, we can see a bump of that eye that's hidden around the back of this particular smiley face. Now, the great thing about this is the one on the left is less than 1,000 polygons. I think it's something like 768. The one on the right is nearly 49,000 polygons. There's a huge difference in there, but there's very little image quality difference at this point. So you can see how a normal map can really help you out. And of course, if we combine that with a displacement map as well, we can get some really impressive results. So bearing that in mind, it's time for a challenge. I would like you guys to create a normal map similar to how we've just done. So take one of your models up to at least an LOD-C or D level of detail. And so we're going to take a duplicate of the LOD-B or A that you've currently worked on and really add some detail to that model. Then go ahead and create a normal map based upon that and apply it to a lower polygon model. So apply it back to the level of detail A or B. And finally, of course, share it in the discussions, the two side by side, and see if people can guess which is which. If you do it really well, it'll be very, very difficult to tell. I'm going to not pause the video at this point because we've almost run out of time for this particular lecture, and we'll go through the solution in the next lecture. See you soon. Welcome to applying a normal map in Blender. So this is going to be the continuation from the challenge in the last lecture where we create a normal map. Just to remind you of that challenge, we're going to take one of the models up to at least a level C. Now I've already done that because it takes quite a while to do some modelling. We're going to create a normal map of that and apply it to a lower polygon model. And then finally I'll share the two side by side so we can see which is which. So let's hop straight on over into Blender. Okay, so I've opened up my window and this is the file that I have been working on. I've got my LOD-B and I've also been working on an LOD-C. So let's enable that. And this is what it looks like. It's got a few quirks here and there, but overall I'm happy with the outcome. It looks much more higgledy-piggledy than another one would. So there is a couple of things that we need to think about before I go forward, and the first one is this material.
Now, in a moment, I'm about to build up a new material based upon the original wall, but it is going to be unique to this particular model. So in that case, I don't think I need it linked anymore, because as soon as we apply the normal map that is specifically for this model, simply because it's got a hole in the middle, we can't link it anymore. So we can actually break that link completely. And I've clicked the little icon there, so it's now local to this particular model. Okay, so now that we've done that and broken that wall link, we can now start working on the model a little further. I'm not sure what order to do this in. It doesn't really matter in many ways, but I'm trying to go through it in a logical manner. I think I need to deal with the multiple UV maps. I know with an image, so let's create a new image and call it window normal 44. Oh, that's badly spelled normal. There we go. And if we now have a look at the UV map, if we try and bake to this image, it's going to cause us a problem. And I'll show you that now. Let's see if we can bake straight away. So LODC to LODB, that's fine. Active to selected. Let's scroll down here, go to bake. And we want normal, selected to active. And the ray distance, I'm going to go for 0.2. Not sure if that's going to be... Okay, no active image found in material wall. Okay, so we run the risk here of overwriting an image if we're not careful. So let's proceed with caution. Okay, it's currently assigned... We've got the wall texture here, and the wall material, and the texture that we're trying to write to is a generated texture. So we need an image texture, and here it's the church block work. We don't want that, we want the window normal. So I've swapped it over to that. That's now our active image, and I'm going to hit bake. Excellent. So that's done exactly what I thought it was going to do. It's updated the... well, that looks absolutely... Don't know how to describe that. Anyway, so you can see here that the UV map is too big for the image. So we can go and sort that out. That's not a problem at all. We need to basically scale that image in. So I'm going to go ahead, or scale, not the image, sorry, the UV map in. But we need a new UV map first. So I'm going to go to UV maps in the data properties. I'm going to add a new UV map, and I'm going to call it normal map instead. Now that I've got normal map there, we can go ahead and let's just bring this up so I can see what's going on. I can hide LODC from my scene for the moment so I can see what's going on. And what I can do here is just hop into edit mode real quick, bring this back down so I can see what's going on. And I actually only need one of these on this particular image here. So I'm going to scale that in. Is snapping turned on? No, it's not. I'm going to scale that down and move it. So I don't need the whole image on because I actually only care about the front. So let's move that down to there. Now when we're actually mapping, I do care about these two being on top of one another. So this bit here and this one here being on top, the front and the back being on top of one another, because they'll be projecting different normals onto one another. And now that I've rearranged that, we can bake. Oh, no valid selected options there to there. Make sure we can see it. Okay. That is exactly what I wanted. Now that I've done that, if I so wish, I can go back to the UV here and move this area on top of the other one so they share the same data. And I'm going to do that right away, actually. So I'm going to select this, and with snapping turned on, where's snapping? Snapping to vertex. I'm going to move that so it sits right on top of the other one. And that should mean that both sides now share the same normal map. Hopefully. We shall see if that works. So I think I'm done in the image editor for the moment. Wow, that does look interesting. That's been mapped funnily, but that's absolutely fine because that's how the other image was mapped, not this one. So that's coming along well. And what we can do here is go to our UV image editor. No, I want the node editor. Let's have a look at how it's set up so far. So we've got the material output and the diffuse shader. Now the diffuse shader has an image defining it, which at the moment is this really wacky one, and we want to change it back to the blockwork image in a moment. And that is being, well, it's mapped according to the texture coordinate of a UV. Now because we have more than one UV in our scene at the moment, I want to make sure that this is more explicit, because at the moment just UV is not enough. So I'm going to clear that and remove it from our scene completely, or remove it from the node editor completely, and add in an input. And if we scroll down, we had texture coordinate. Right down at the bottom is UV map. So I'm going to select UV map and I'm going to duplicate that, because we're going to have one for the normal map and we're going to have one for the UV map. I'm also going to duplicate the image texture. So we've got Windows Normal here and the Church blockwork. So there we go, we've got the blockwork back again, and I'm going to turn off LODC for the moment because I don't need to see it anymore. So I'm going to add this UV map to these two here. Perfect, that's exactly what I want to see. This image texture is being controlled by the normal map, so we're going to plug that in. Won't see anything yet. It's very tempting, of course, to just plug them in like that. That's going to give us an effect, but not the right one. We need to explicitly convert this into a normal map. So let's go to vector and normal map, and we can plug the color into the color and normal into normal. And there we go, that's starting to look much better. And we can see there are a few little things that need tidying up here. This is horrible, this line here. That doesn't gel with me at all. Have we got anything else like that? Not particularly. Okay, so this line here. Now the question is, do we fix it and remake our normal map? Or can we fix it in the image editor? So let's give a go to the image editor. Let's zoom in here. I think we can fix that, so I'm going to go right in as close as possible and change this to paint mode. Let's make that a bit smaller to work with. I'm going to open up the tool shelf, and using the colours there, the primary colour, I'm going to pick something purple and then literally start painting over what we've got here. I'm going to make this even smaller. I'm going to turn accumulate on so I can go backwards and forwards really quickly. And as you can see here, I am a bit clueless as to how this is going to turn out. I'm going to assume it's going to come out okay. I'm going to use the smear now to just make these bits blend in so it's not so sharp. Of course, I'm being careful here not to go over the lines. I remember as a child trying to colour within the lines. I don't want to break that. Now the question is, after I save that, so save it as window normal, that's absolutely fine. After I've saved this, so I might as well go over that one as well. So image, save image. Okay. The question is, does it make a decent impact on here? The answer is yes, it does. Brilliant, that looks much, much better. So I'm really happy with that and how that's turned out. Oh, I haven't checked the other side, of course. How does the other side look? I can't really see the other side because of the sun. I'm going to duplicate the sun in this case. And it doesn't actually matter where it's facing. I'm going to rotate it Y90, Y180. I'm just going to move this round until we get extra light. Let's lock it to the x-axis. Can we get it on this side as well? Almost. So let's see what this looks like on the other side. Okay, yep, that's worked pretty well as well. We've got the normal map being applied across the other side as well. It looks a bit odd down here, but I will forgive that. I'm going to make sure that's saved. And of course, once I've done that, I can hop over into the Gothic church and actually see how it's looking in situ. So into the Gothic church, and we've got a couple of windows here. In fact, I think the last camera view I had, yep. Let's switch into rendered mode. Okay, we have a series of them here around the side, and I'm going to render that out and see how that looks. It's going to take a few moments to do, but a rendering is often the best way of seeing how things are looking. Okay, so as this is rendering out, one of the first things I can see is a seam joining these together. It's not that pronounced. I'm surprised actually. I've actually given it no consideration. However, some of the more powerful features are standing out quite a lot. And that is this area to the lower left of the window. It stands out like a sore thumb, and this dark patch here. It really does stink of repetition, essentially. Now, I thought this line going down here would be the worst thing completely, but it turns out that isn't actually the giveaway. My eye is drawn to this light spot again and again and again and again. So that's something that I can work on. And let's go take a look now and see how it's looking over in a game engine. Okay, so here I am. I've misapplied a texture there. So here I am just walking around in Unity, and we can see that the normal map has applied really well. Now, I did have a few issues trying to get it to actually adhere because it's on the second UV channel. It doesn't look like Unity supports a third UV channel. I'm open for correction on that. I'm not a Unity expert, but here we go. We've got it applied to our model, and it's looking pretty good. Considering that is absolutely flat, that looks like there is detail on the wall. And again, we can see that bright area to the lower left really standing out. Whether or not we need to do something about that at the moment, I'd say no, but maybe later on. How are you guys getting on with your bump maps? Have you decided that some of your model should be left as just geometry? Post your results in the discussions, and as always, I will see you in the next lecture. Welcome to Texture Resolution. So in this video, you will understand that resolution will control the level of detail at a particular distance. We'll go ahead to realize when a texture is either going to be too large or too small. We're going to learn about the power of 2 and why and when it is important. So let's go from the bottom up and start with the power of 2. So a bit of theory for you all here. Computers work with binaries, zeros and ones. A lot of external programs need power of 2 textures. That is important. Now, they aren't necessary in Blender, but are a good standard to adhere to, especially when working with external programs. And they don't have to be square, providing the length of the side is a power of 2. So I've been saying power of 2, and some of you will be scratching your head, go Mike, I kind of get these English words you've put up here, but I don't understand what the power of 2 is. So which numbers are power of 2? So if you imagine a rectangle, or a square, and the length of the sides there. So mathematically, there will be 2 to the power of n, or as shown there, 2 to the 5, etc. equals 32. So if you've been around computers for a while, you will recognize this sequence, 2, 4, 8, 16, and so on. And you will notice that your RAM will fall into those. Hard drives tend to fall into those. Lots of different things fall into these particular numbers. And this is where we do the power of 2. So you can have 256 on one length of the side by 1024 on another, or you can have 1024 by 1024 and it be square. Each one of those is okay. Now, it is important that you kind of adhere to these standards, especially if you want to export your textures. But there is one critical thing to remember, because it's very tempting to say on, let's say, your diffuse map, oh, I don't need much detail here, so I'll make it 32 by 32. It just needs a slight gradient change, let's say, across it. And then you go ahead and use a normal map, let's say, or a bump map, displacement map, to add more detail, but you need that super fine detail, so you do 2048 by 2048. Now, that is great, but you're going to have a problem when you come to textures of different sizes. First of all, they need their own UV map. That is important. If you decide to have textures of different sizes within Blender, they're going to need their own UV map.
They're probably not going to be exportable either due to the need for multiple UV maps. Most programs, when you import them, say you're exporting as an FBX, they'll take the primary, the first UV map you've created and use that. So the other textures, obviously if they're a different size, they won't match up with your UV unwrap. It is best to stick to one texture size for any given unwrap. So if you've unwrapped one particular model and you're going to give that 2048 by 2048, that is great. And you can, of course, do another model that's doesn't have to be as detailed and do it 512 by 512. You're going to have to play with these, and there's several things to think about when you're dealing with textures of what size you're going to require. We'll go on to more of that in a moment. But the important thing to remember here is larger textures require more memory. If you had a texture that was 256 pixels by 256 pixels and one that was 512 by 512, you may think the difference there is 2. It's not. It's quadrupled. That's going to take up quadruple the amount of space as the 256 one is, and so forth as we go up that number chain that we saw a moment ago. Okay, so what size textures? And this is a very good question. It's very tempting to just say, you know what, I'm going to use the largest size textures I can possibly use, then nothing can go wrong. Well, as you'll learn and develop skills, you'll find that you run out of memory very quickly if you decide to make the largest possible textures, or Blender will slow to a crawl, or your game won't work, it won't be able to load into the graphics memory. There's lots of different problems you can come to. So, there are two main components to how large a texture needs to be. And they're quite logical when you think about them. So first of all, how far away is the camera from the object / the texture that you are using? Or of course, camera, you can place that with character if you were in a game situation. So if you're looking at a building that's across the street, but you're never going to get any closer to it, there's going to be a finite amount of detail that you can actually resolve. And so there would be no point, for instance, probably going to 8,000, and it depends on the size of the object as well. So these two oscillate between one another, so we do need to be careful. I was going to say it doesn't matter, you shouldn't go for an 8K texture. Well, actually you might need to if the object is really big. Of course, then you may split it up into smaller objects itself. But for instance, kitchen tiles, now they're a lot smaller, but you get a lot closer to them. So what we have decided to go for here is thinking about what's the retina texture level. Now, we've all heard of Apple's retina displays where you can't see the pixels. So we're going for an utmost upper limit that your texture size would be, and things beneath that would be okay. So the retina limit is really pushing it, because that is when you can no longer see the pixels on your texture. In fact, after that point, you are just wasting memory. So what is the retina texture level? Well, the retina texture works out roughly to be 3266 times the tan of the size over distance. Now you can actually use Google. You can type that into Google and replace size and distance, and it will give you a sort of a texture size, as it were, that you could use. And then we need to actually round that up or down to the nearest power of 2 that would work for it. Hey, it's Michael from the future here, and we've had quite a few questions regarding this formula. Your calculator has to be in radians in order for this to work. If you don't have a calculator that can go into radians, or you don't know what that is or how to get there, you can use 57 times the tan of the size over the distance, and that will work it out if your calculator's in degrees. And of course, there is one final thing here that we haven't actually measured or spoken about, and that is the importance of the texture or object. If it's something that's not really brought into the player's attention or the camera's attention, it's something off to one side, it's not the focal point of your scene, you can probably get away with a lot lower texture quality than otherwise. And you see this a lot in games where perhaps the scenery is not as textured in certain places as others,
and the characters tend to have a lot more detail in them than perhaps a mug that they're going to pick up. You see this all the time, and that is important. You don't want to make something that's incidental on the side, or you might do depending on the quality level you're going for, but you don't want something that's incidental on the side having the same sort of quality level as the main object and the main focal point of the scene. Now, obviously, that's your discretion whether you go to that level of detail with other objects in your scene as well. If you're going for a more photorealistic feel, where, for instance, a mug is completely circular, you can't see any of the jagged edges going around making up that, then that's absolutely fine. Just bear in mind, the higher your level of detail, the longer you're going to have to be working on that particular model. And let's say we do take the mug example forward, the last thing you want to do is spend all of your time modeling a mug when you could have been modeling the main character that everybody's watching. So it's worthwhile bearing that in mind as well. As with most lectures, we've got a challenge. I would like you to calculate the following. Now, I'm going to be a bit loose on this one and allow you guys to actually pick the size and distance that some of these objects are going to be from you. So play with them and see what you come out with. Remember, if you're going to use millimeters, meters, kilometers in the case of the moon there, remember that the size and distance have to be in the same units, otherwise it's not going to work out. So pause the video now and give that a go. Okay guys, welcome back. Let's go through and fill out this table. Okay, so the first thing, the moon has a set thing. So I'm going to go diameter of the moon. Okay, so I'm going to look this one up. I don't know, so I'm going to plot that in the table. So it's 3474. Okay, and I'm going to change that to distance. That's not grammatically correct, but I'm sure Google will work it out for me. So wow, that's a long way away, isn't it? It's going to take us a while to get there. So now I know that, I can actually plonk in to my equation. So it was 3266 times, and then tan. I can group that together there. And I don't think I need the open bracket there. I need it here. So tan, and we need to go in and do size over distance. So 3474 over 370300. And that will give us a result of 30. So there you go. That is quite low. So that's going to be 32 by 32. You could actually get away with a 32 by 32 texture if you were standing on the planet looking at the moon, because it doesn't take up much size. I'll just make sure I've got my dimensions the right way round there. So we've got size over distance. So size over distance. Brilliant. Okay, so a building. I'm going to pick a 100-meter tall building, and I'm going to be stood a distance of 1 kilometer away. So I'm going to be stood at 1,000 meters and 100 meters. So then we go, I'm just going to hit the back button here, and hopefully, no, there we go. I've got back my equation. So that'll be 100 over 1,000. So this is one of these things we can leave open in a tab here, and we get back to it. So that's 327. Now this is a good one, isn't it? I've picked something where the power of 2 has ended up halfway in between. So I've got to make a decision at this point, well, not necessarily at this point, but ideally at this point, whether or not I'm going to get any closer to the building. If I am, I'm going to go for 512, or I could probably get away with 256. Remember, these are retina pixels. So at this point, you as the viewer would not be able to see any of those pixels. It would be perfectly resolved. So in that case, I'm going to go for 256. Okay, a kitchen tile. Well, I'm going to do that in centimeters. I'm going to remember to put my units in here as well. That is very important. Okay, so a kitchen tile. I'm looking at kitchen tiles at the moment, and they're about 10 centimeters across. So 10 centimeters and a distance. Well, if I was washing up, I'm going to be stood roughly about 90 centimeters away from it. So up to about a meter, depending on where I am. So I'm going to go for 90 centimeters. Oh, let's say I lean forward. Let's go for 70 centimeters. I'm picking out a dish from the liquid there. So that's going to be 10. So I can adjust these figures here. 10 over 70. Okay. Let's see what we come up with here. Okay, so that's close to 512. Okay. And finally, a car. Well, a car is approximately, well, it depends where you are in the world. I've driven a smart car that's very tiny, and obviously some American cars, like a Humvee or something like that, are huge. So I'm going to go for a 4-meter car. So a 4-meter car. Now, if you're, let's say, walking along a pavement, then this is the distance thing again. So the car's never going to be any closer to me than, let's say, a meter. But it's 4 meters long. Okay, let's see what that works out as. So 4 meters and by a meter. Okay, this one ends up very large. In fact, that is closer to 4096 than it is anything else. So let's bring up my chart here. Now, did any of these shock you? Did you think, for instance, that the moon was going to be a lot higher than 32 by 32 in order to accomplish a sort of retina level? That did shock me, and the car was particularly high. I wasn't expecting it to go quite that high. The building, it didn't puzzle me too much. I thought that would be around sort of 256, 512. I didn't anticipate the kitchen tile being quite that high. I thought because it was quite a small object, I'd be able to get away with a lot lower. Now remember, it is very important that these are retina level textures. You could probably get away with a lot lower than these, probably half of these themselves. Okay, I hope you found that incredibly useful. Did you come up with some other size and distances? Did you come up with some crazy figures? And just as a side note here, most game engines at the moment don't support over 8,000 odd by 8,000 odd pixels, so you can't go much higher than that without causing yourself some memory problems. So that's worthwhile bearing that in mind. I'd love you to share your results if you came out with anything wacky there, and I will see you in the next lecture.
Welcome to the multi-resolution modifier. In this video you will learn how to use the multi-resolution modifier. See the similarities to the subsurface division modifier, and see that it is great for multiple resolutions of a single model. We'll learn how to control sharp edges using another technique that also works with the subsurface division modifier, and understand that it is best applied to a base mesh that is close to the final lower poly version of the model you're working on. So let's go hop straight on over into Blender. Okay, so we're back over in Blender, and the first thing we're going to have a look at is the subsurface division modifier. So I'm just going to go ahead and apply it straight away to this cube. So we've played with these before, and I'm going to take that up to a level of 5. So we end up with 12,000 triangles, and we end up with a relatively smooth ball shape, especially if we turn on smooth shading. Now, one of the things that we can do when we're in the subsurface division modifier is when we hop into edit mode, we can actually see the effect of what's going on. And that isn't the case with the multi-resolution modifier. And the option to turn that on and off, if you ever did want to do that, is on the modifiers tab over here. There is a cube with 4 vertices highlighted, and that means display the modifier in edit mode. Not all modifiers can do that. The subsurface division can. So let's talk about creases, how to make something sharp. So there are a number of ways of doing that. So one of the ways that we already know about is perhaps to add a loop cut in and then pull the vertices closer together, and we could even inset the face here, or even put them on top of one another. And when you do put them on top of one another, so let's just move them on top, we end up with a very, very sharp edge. And this is one of the examples where perhaps you did want to put geometry on top of one another. Unfortunately, you don't generally get really sharp edges like that unless it's a knife in real life. So I'm just going to undo those steps there, so we end up back without that extra geometry. The other thing we can do in order to make sure we don't have geometry is actually select edges. So you can use the vertex select or face select to do that. So I'm going to select the 4 edges at the bottom here. And if we go to the properties panel, we can open up that and go to edges data and go to mean crease and turn that up. And we can see we get to a very similar level we were at before. Very, very powerful. However, because we don't have the extra geometry there, notice how you have some shading artifacts around this edge here, because the shader doesn't quite know what to do. If we were in flat shading mode, need to be in object mode to do that, you will see that it looks sharp again. So there are benefits to having an extra geometry there, because it helps the shader know really what's happening underneath. So that's one way of making things sharp. There is a shortcut for that, which is Shift and E, and then you can control that level with the mouse. And obviously that's much quicker to pull together a certain shape. And you can see here, because we've got, fundamentally, we're starting with a cube. If we look at it, it pinches in 4 separate corners here. And that's where those shading artifacts have come from when that is set at 100% and when you put smooth shading on. So let's go smooth shading. You can see it pinches here, here, and here. And it's ultimately, that's just adhering to the underlying geometry. So now we've played with those particular tools, let's see how that works if we go ahead and add in a multi-resolution modifier. Nothing happens initially because we need to go ahead and hit the subdivide button. Now, as always, be very careful when you're working with anything that does subdivision. You can very quickly end up at a crazy level. So whereas the subdivision surface modifier caps out at about 6 levels of subdivision, we're already on 8 and at 786,000 polygons. We can go to 9, which is 3 million polygons, and I'm not going to click subdivide again because there's a good chance that I will either lock up Blender or cause it to crash, so I'm not going to do that during this demonstration. Now, we do have to be careful when working at such high resolutions. But this high resolution is very good for sculpting because it gives you a fine control over the geometry of your mesh. So what we can do here is actually turn down the preview amount to, let's say, something like 2. Now that's going to be a bit too dense. I'm going to turn flat shading back on so I can see the underlying mesh that it's creating there. So that's quite low polygon. You probably could get away with one lower. Yep, let's do that. But when we go into sculpt mode now, we see that we've got a lovely smooth surface which we can start working on. It's a little bit jerky at the moment, but it's got far more control than the lower poly version. When we hop out of that into object mode, we can see the effect that it's made on the lower poly version. So it actually changes the lower poly version too, which is incredibly powerful. Now, there are some caveats. If we go into edit mode, we just see the cube again, which isn't very helpful if you've got to modify the geometry. In this particular case, this is what I mean by when I say when you're close to the final low poly version. It doesn't have to be the final low poly version, but you need something that resembles the lowest level on this preview that we've currently got set. So a preview of 3. So what I'm going to do there is not do any more sculpting because that is going to be a waste of time. What we need to do is actually go ahead and apply a certain level of detail first. Now, you may have made this manually, so I'm just going to close off the modifier completely. I'm going to use a subsurface division modifier to generate a low poly. Let's call it a bullet. It kind of looks like one. Here's my low poly bullet, and I'm going to apply that. So that's my low poly model. When I go into edit mode, I can see physical geometry there, which is great. Now when I go back into the multi-resolution modifier and obviously crank that up, it's very tempting to click on the actual preview level to move it up. You don't. You click on the subdivide, and I'm not going to go any higher than 5 on this count. I'm going to drop the preview back down to 0 because that is ultimately the preview, and it's nice and fast in the viewport at this point as well. And then when I go into sculpt mode, it goes to the high resolution version. Now, if I decide to add some detail on here, let's just wiggle about a bit and get that on there, and then put some, let's say, smaller spots on. It doesn't really matter the amount of detail we're going for here, but this is detail that won't resolve when we have a look at it in edit mode. Notice that it hasn't changed. In object mode, the geometry, we need a preview level of at least 1 to see that. The underlying geometry changes, but in edit mode, it does not. There is a button here called Apply Base, which will sort that out for us. So if we go to Object Mode and say we're happy with that level of geometry and the shape that it's created, we can go ahead and Apply Base. And once we've done that, we can then go back into Edit Mode and see how it's really changed the mesh, and then alter it accordingly if we wanted to. That is an optional step, of course, and gives you more control. So when we're in object mode here and we can see the underlying geometry here, what would be really cool is being able to bake the detail of the higher poly version onto this lower poly model, and you can do that as well. Now we're not going to do that in this particular section, but you can already see how if you had a high poly model, whether it be a character or anything else, you can actually get high detail and transfer it to an exact low poly version of it very quickly using the multi-resolution modifier, because we've got the low poly version here at only 3000 polygons if I'm looking up here at the top right. And if we hop into sculpt mode, we can see that we're really working with underneath 786,432 polygons, which is significantly more than the low poly version. But we can probably get all of this detail applied to that low poly version through normal maps and bump maps, etc. And it look pretty much the same. In fact, I'm going to use this as a demonstration, not in this lecture, but in a future one. So I'm going to go ahead and just save that file after I've made the blob and call it blob. Why not? Oh, I'm in the wrong area. Make sure I'm in the right area. And I do, as always, I do recommend, especially when you're playing with modifiers or rendering, that you make sure you save, because there's a good chance Blender might crash on you. So I'm going to pop this in my resources folder and call this multi-res blob, because that is all it is at the moment. There we go. Save that file. Excellent, all sorted. Now, of course, I've got a challenge for you. I would like you to go ahead and use the multi-res modifier in your scene. Now, I will be making a basic pillar, getting the size and shape right, and then increasing it to a level of detail, sort of B type of level. I may even go above that. Of course, if you've already done pillars or you need to make something else, you're not making a Gothic church, for instance, perhaps find an ornament, or if you are doing a church, perhaps an angel or something like that. Really challenge yourself at this point to make the best use of a multi-resolution modifier. Now, I would suggest applying a multi-res of around 4 subdivisions. That is usually the right difference between the low poly and the high poly detail, and it gives you a lot of scope for modifying. Of course, choose whether or not you want to use a bit of sculpting in there to perhaps add a bit of asymmetry. A lot of the things we build in any 3D modeling package tend to be very symmetrical until you start prodding and poking vertices. And of course, the sculpt tool is a great way of doing that. Set the origin to the center of the base of whatever object you're doing, and the reason for that is it enables you to position it a lot easier than if it's not, because then on the object, when you're in object mode, you can actually just move it to the floor, for instance, or move it to a certain height or position with great ease. So I'm going to be setting the origin to the center of my base of my pillar. Remember to use the mean edge crease to keep the desired shape. So just to give you a heads up here before we plow back into Blender, we're going to start with a low poly model, something looking similar to this. We are going, I'm probably going to make mine in some sections. We can see we've got a base there. We've got 4 sections there that look the same, are very similar. And then of course we've got this area here and the top one at the top. Now, when I say apply mean edge crease, when you go and apply the multi-resolution modifier on something like this, it ends up looking a bit like this, which is, well, it doesn't look quite right. Now, of course, we can construct this with detail using similar methods to the chess set that we've done, but just applying the mean edge on it will make it look much better, much more crisp in places. You can see the difference there, and also the rendering artifacts tend to disappear as well when you make it a bit neater. So that's brilliant. So pause the video now and give that a go. Okay guys, welcome back. Let's go use the multi-resolution modifier. Okay, so we're back over in Blender, and I've got a few things that I need to work on first of all, and that is, how high does my pillar have to be? because I haven't a clue. I've completely forgotten to manage my measurements here. So let's go to my Gothic church. I'm going to go into walk around mode. Oh, not with the camera. I'm moving the camera if I do that. So let's position that and just move away. So at some point in here, oh, loads of things have appeared there. We're going to have pillars coming up to these points. So I need to have a look at what height these are at compared to the rest of our model. And I think it's going to be 8.2 because we've got a 0.2 underground, then we've got one wall section, two wall sections. So I think we're going to be at a level of 8.2. So I'm going to go for that. And we've got the width here. So what I'll probably do is import one of these vaults into a separate file and use that as a reference, and then just remove it when necessary. And I seem to have everything turned on at the moment. Anyway, I'm also going to sort out this bell tower because bell towers don't look like that. I've actually had a look at reference material, and as cool as that is, it doesn't really... I thought it didn't look right, and now I know why. It's because they don't look like that normally. Brilliant. Okay, so I'm going to go and get all that stuff ready, and I'll see you guys back in a few moments. Okay, so I've set up now a basic column, as you can see here, at the appropriate height. I'm not making 4 of them because these are butted up next to one another. I would end up with them overlapping, basically. So I'm going to place them in the scene manually and use arrays. But there's my basic column using this vault as reference. As you can see, I've still got some legacy stuff left over from the vaults. I'm going to clear that down now. I'm happy with the height. I will after I've compared it in the Gothic church scene. So let's hop over there and see if this column fits. So I've imported, I've appended it into the scene, and I'm not going to save this particular one because it's just for testing, but I can see here that the pillars are indeed the right height in my scene, absolutely fine. They are too big, so they're the right height, but they're too big. So this is one of these great examples of doing things as lean as possible, bringing them in. Arguably, I should have brought them in earlier if I was being lean, because then I wouldn't have this oddity around the roof line. Perhaps I'll make that into the model. Since it's interior, I might even just leave that. No one will ever see it, although we've got an exterior. But that's in case you're looking out the window. So let's go back into the church. So I'm happy with the height. I'm not happy with the width. They can be a lot thinner, and obviously a bit more shapely as well to reflect the opulent nature of the rest of this building. So with that in mind, I'm going to go in and model my pillars, and I will see you guys back in a bit. Okay, so I've moved my final pillars in. Well, perhaps not my final, but the ones I'm working with at the moment. I've altered the top of the church, as you can see there. And let's go and fly on inside and take a look at the pillars. So I've added some detail to the pillars and made them a bit smaller. And of course the final thing is just to do a quick render here and see how it pans out. Now there's some alignment it looks like I might need to do in between these. That one looks spot on, as does that one actually. I think this one's just looking odd because of the corner. So there's some extra bits of geometry I can put in there. I'm not an architect after all. But that is looking pretty good. So the final thing is to render it out and see how it looks. How are yours coming along? I'd love to see them in the discussion, so please share them so I can see how you're getting on, and so the other students can as well. And of course, as always, I will see you guys in the next lecture. Welcome to baking using the multi-res modifier. In this video, you will learn how to bake detail from the higher multi-res to a lower one. And you'll realise it's very similar to the baking you've done before, but this time only one model is involved, so we don't have to have multiple models on there. So let's go explore this now and hop on over into Blender. Okay, if you remember last time we had our multi-res blob. If you didn't save that, don't worry. Let's go and create a new one right away. Just a good bit of practice there. So I'm going to go ahead and delete my object there. I'm going to keep the save file there. I'm going to add in a cube. I'm going to go to the subdivision surface, add a couple, probably 3. That's fine. Then I'm going to simply go into sculpt mode after I've added in a multi-resolution modifier. So let's add that in. I'm going to actually take it all the way up to 6, which should give me, 3 million polygons to play with. That is lots of polygons. I'm going to lower the preview setting down to 1. And I'm going to go into sculpt. And I'm going to add some detail. I'm going to move the strength of the brush I'm using up, so I get some dimples. Now, of course, these dimples, the size of them is actually the distance I am. It's measured in pixels from the image. So if I move in, I can put smaller dots around. Now, obviously, I can go through to my heart's content and make dots and squiggles all over here until I don't want to do it anymore. There we go. I add some fine detail in there as well. It's just a squiggle. It's just a squiggle. It's fine. Okay, so now we've played with that. I'm actually going to put a recess in as well because we don't have a recess. That's quite a big one, so that's fine. Let's see how that has come down in the preview. So if we go to object mode here, we can see that it has affected the model ever so slightly, but not much. And of course, this looks nothing like, if we go into sculpt mode again, it looks nothing like that. It's close, kinda, but really nowhere near it. So we have this here. I'm going to set it to smooth shading because it's going to be smooth shaded anyway when it's done. That's important because when we bake the normals, and that's what we're going to do in a moment, it needs to be smooth because that's the style I'm going for. Now, take note of the render setting here. The render setting here is going to say from which level it's going to bake downwards. That is very important. So before we can do any baking, we need to go and add a material to our object. That material has to have something associated with it. I'm going to associate an image with it now so I can bake straight to that image. So I'm going to go to image texture, and there isn't an image yet. So let's go ahead over to the 3D editor. I'm going to hop into edit mode and just unwrap. I'm going to put my own seam on here. Let's see, where's all the detail? In fact, I'm going to smart UV project it and show you guys what happens, hopefully what happens if it puts the seams in the wrong place, basically. So now I've got that, I've unwrapped it, we can go to the UV image editor. Okay, that's looking good. We need a new image there, so I'm going to go new image, and I'm going to call this blob. I'm struggling to see the keyboard here through a microphone, but there we go, blob normal. I'm going to keep it at 1024. That's okay. I'm going to select it over here in the material properties. So that's now assigned. We can then go over to the render tab. Now remember, when you do any form of baking or rendering, you are rendering, and therefore Blender can be unstable and crash. So we want to avoid that if possible. Or certainly we want to avoid it crashing, but if we can't control that, we can control whether or not we've saved our work. So I'm going to go ahead and save. Right, let's scroll all the way down to the bottom and go to the bake options and scroll down a little more. The bake type here, I'm going to go from combined to normal, and I'm going to just go ahead and hit bake. Now, it's at a high resolution, the 6 subdivision resolution, quite a few polygons there, and that's going to take a while to go through. So it's come out here, and we can see it's relatively smooth. Now, before we move on, I just want to show the impact of lowering this render setting. So if I lower it down to 1 and then go and bake, it's a lot quicker, but you're losing all of those fine details. So it's that render setting there that you also need to keep nice and high if you want to bake from one level down to another. In this case, we are baking down to where it is actually 0. So if we go ahead and go back here, go bake, it's going to take a while again because it's at that higher level of subdivision. And here we go. So we've got these normal map all made, and now we can go ahead and apply it to our model. So I'm going to leave that alone for a moment. I'm going to go to the 3D view. I'm going to go to object mode so I can see what's going on. And I'm going to go to rendered mode. So this is what happens with seams on here. Now, at the moment, this isn't very bright. So I'm going to put a sun lamp in and turn its strength up to 4. So we can see here that we've got some seams here, and the reason why you end up with some nasty seams, in fact it looks like it changed the direction of the normals there midway through. Now the reason why these seams exist is because you need to split up the model somewhere to cut it in half, but the reason why it can't match them up perfectly is because it's got two different normal points placed on top of one another. When you wrap this image together, essentially they lay on top of one another, and of course that can cause graphical artifacts. And we'll see those in action in a few moments when we go and apply this normal map as a normal map rather than a diffuse map. So first of all, I'm just going to hide my tool shelf and properties and move that across and open up the node editor. So we're going to play with the materials. Now I'm not going to call it cheat here, I'm going to call it efficiency. We do want the image, but we don't want it to control the diffuse color. So I'm going to unplug it. There we go. So that's that bit sorted, but we've still got the image texture in here. Now, as you've remembered before, what we're going to have to do here is set it up to be a normal. So we need a couple of other things in this chain. We need to tell Blender how to apply this image texture, and also that it's a normal map, and give it some control so we can control the strength of the normal map. And of course, that leads me on to a challenge. I would like you to go ahead and apply the normal map. So finish off the node setup and use your baked normal map to control the normal of the diffuse shader, the normal input of the diffuse shader. Pause the video now and give that a go. Okay guys, welcome back. Let's go ahead and apply that normal map. Okay, so the first thing I'm going to do over here is hide that, so I've got a bit more space to work with. So we need to define how the image texture is used, and I'm going to use a texture coordinate and link up the UV to the vector input of the texture. Now, of course, you could also use at this point, if you had multiple UV maps, you may have to use this particular technique. There, where is it hidden? It's under Input, UV map, and we could also do that and select the only UV map we've got in here and plug that in as well. But I'm going to leave it as a texture coordinate. We need to make sure that we're not using color, that we're using non-color data. Otherwise, the normal map won't be interpreted properly. Finally, what we need to do is add in a vector normal map. And then we can take the color and plug it into color output of the image texture and plug it into the color input of the normal map, and then take the normal output and plug it into the normal input of the diffuse shader. Wow, okay, that's starting to look pretty good. I'd like to see these two side by side at the end, but that is really effective. That's worked really well. Now, where that normal map was a bit funny, that's also worked really well. I'm actually quite surprised that that hasn't decided to look a bit awkward. We can see that we're working with a low poly model here because of the occlusion. You see the jaggedness around the very edge, and of course that doesn't actually raise up as high as it would have done otherwise. Of course, we can go ahead here and add in the first level of preview, and that really does accentuate the normal map itself. It adds the geometry in there at the same time as some of these dimples, but it doesn't give us the smoothness. It gives us quite jaggedness there. So we've got two options there of which ones we can use. I'm going to let it preview one here, so I've got some of these high points that I've done. And of course, what we can do is just render that out. What we don't know what it looks like at the moment is what it looks like when it's fully rendered. So the first thing here is to turn down the render from 6. If we leave it on 6 and then we go and do a full rendering, it will just be the high res model. And I can demonstrate that straight away by going to the camera view and zooming in. And that, yeah, this one's here is absolutely fine. Let's try and fill up a good portion of the frame with it. In fact, if we make the black, I'm just gonna do this. I love doing this sort of thing. I'm gonna make the background completely black, and then it does look like some sort of funky asteroid in space. And I'm just gonna go ahead and hit the render. Now again, because I've got the render level set at 6, it's actually going to take a while to do all the computation it needs to do to render out those 3 million polygons. So that's quite a high level. And you can appreciate that if this was something you were going to use in a different package or only part of your scene, you probably don't want it that many polygons. So here we go, it's filling out all of these things, and we've got a lovely crisp outline here. That's brilliant that we've got that, but it comes at a cost. That detail comes at a cost. And here we go, looking almost in the center of this picture. If you follow my cursor there, you can see where there's a seam here. That's an artifact of where the seam is. So we can control where seams go, and we certainly don't want it there if that was the bit that was facing the camera. So I'm just going to change the render slot to slot 2, and I'm going to drop the render level down to 1. So we've still got some geometry there, otherwise it's just the sphere again. And we'll do one without the sphere as well. Let's render that out now and see what that looks like. And you can see immediately how much quicker that was to do the work. So let's go between the two slots now and just see the difference. Okay, there is a difference. There definitely is a difference. Now what we can do here, of course, is potentially turn the amount of normal map up a little. That is a possibility. So we can do that live over here. If I zoom in, we're on preview level 1. Let's turn the normal map strength up to 2. Okay, and now let's render that out at this lower level. Obviously that is nice and quick because it's lower, and we can see that the shadows are darker here. And if we switch over to slot 1 to compare, okay, they're a little bit too dark in this case. So once again, oh, we've got some horrible artifacts going around the top there. So perhaps this is a bit too low a poly for this particular level of detail. So we can up it again. I'm going to leave the render, basically take it up a level here and hit render again and see what we get out there. That is starting to look much better. And of course, we can tweak these things, etc. But of course, we're now at 12,000. But that is a lot less, of course, than 3 million. So it looks like 12,000 is going to be the sort of sweet point here before we start having too much detail in our model. But that is looking really, really good. And obviously, compared to the 3 million polygon one, I'm going to try here a value, a strength of 1.5, see what that comes out at. I'm going to use slot 2 again and just render that out. Okay, I think the shadows here are looking a bit better now, so we should be able to compare slot 1 to slot 2. Yep, very close now in terms of their tonal quality, and that is really, really impressive. Now the final thing I want to try is, what does this look like when it's baked all the way down to literally as few faces as possible. So this is what this looks like now on just a sphere. You lose all of the occlusion around the outside, but you've still got this detail here, and that in itself is very powerful. Now, on a static image like this, it doesn't really show off what is really going on. However, if we go to the 3D view and I go and grab the lamp, I'm just going to leave it like this for the moment on this no subdivision level. If I go and grab the lamp and just randomly rotate it, hopefully, there we go, we can see the shadows are changing. That in itself is incredibly powerful. That means that the light hitting that surface is being affected by our normal map. And there we go. That looks like the sun or whatever it is, if this was an asteroid, is pretty low in the sky. Now, of course, if we go and select our object that we're working on again and bump that up a couple of levels, we can see that we can still use our normal map to great effect. Without the normal map turned on, well, we can test that. We can simply unplug it, and you can see immediately the difference. This is what it looks like without the normal map. We put that normal map on, and boom, it suddenly comes alive. Amazing. How are you guys getting on? Did you make a funky shape yourself? If you did, or you applied this to some other model that you're working on, I'd love to see the results you've come up with. Please share in the discussions, and I will see you guys in the next lecture. Welcome to copying mesh properties. In this video, you will learn how to copy attributes of a mesh object. See that this is actually really useful when you have lots of components, for example, that need the same material applied to them. and understand that it is a destructive operation. That is, copying materials from one mesh to another will overwrite a mesh's current materials. So let's go explore this now and hop straight on over into Blender. Hey, welcome back over into Blender. So I've noticed as I've opened this up that I've got a warning, and that warning's just disappeared. But what I can do is expose the window associated with the info header, and we can see what's going on. So not much has happened here. We can see that it's brought in its red library for the mesh data and loads of other things, and we've got this red line here. So we've got a warning, that was the box that appeared a moment ago, that the wall is missing from this particular file, and I think I've renamed that, and it's ended up being wall 001. Now it doesn't seem to have any impact on my 3D view, so let's just have a quick look around our model and see if we can work out where this has gone wrong. So a wall piece, for instance, and while all these blank areas here are wall pieces, incidentally I have noticed that the wall pieces, I've not applied the texture to both sides, so it looks good here, but if that piece is flipped round, it's still rather plain, and I can see that on the inside of the church as well. So okay, so I suspect that it's this roof area here that's perhaps causing the problem. I remember that having a texture on it, and it doesn't anymore, and I can't remember removing that, and it does say wall in the materials properties here. So in order to select linked materials, i.e. other objects that may use the same material, well, as you probably already guessed, it's in the select menu. If we go down to the select menu and go to linked, at the very top there, we can see we can select anything that's got the same object data, material data, texture data, etc. So if I go ahead and click on material, we should find that that selects everything else that uses the same material. Now that it's done that, I can go ahead and change the material for all of those. So I can use the drop down here and just change it, let's say, to linked wall, one that does work, one that's in our scene. Just going to save the file before I do any rendering, and let's render that out. And now it's got a similar color to the rest of the wall. In fact, it's probably got a texture on it. Yes, it has. Okay, so that's one way we can go about selecting everything that has the same linked property, everything that shares something similar. But what about the ones that we want to make the same? So what we can do here is I can select, I'm going to go out of rendered mode again, so it's a bit quicker. I'm going to go ahead and select this roof line here, and then go ahead and select the new roof line just here, this sort of archway into the model itself. So then what I can do once I've selected them both, holding down the shift key there we go, I've got them both selected, I can go ahead and go to object and make links. So I can make links to the materials. Okay, now all of this overwrites what they were using before, so let's go and see what's just happened. So it's gone the other way round. It has taken the last selected item, so the active selected, and applied that to all the other selected objects. So everything that did have it has now gone backwards on both sides there. So we need to be careful about which way we select things. So if I wanted this material at the top to share the same material as the wall, for instance, I would need to select the wall last. So I'm going to go ahead and select the roof. I'm going to do it so I can see what I'm selecting. I'm going to select these areas here, the little bit sticking out. I still don't know the name for that. And then finally I'm going to select a wall piece. Now I'm going to use the shortcut key, which was Control and L, and select materials. Now when we go into rendered mode or material mode, we can see that it's now using the same material as the wall piece. We can also see areas that are not using that. So this area here, for instance, this little triangle in the top corner here, we can go ahead, select that, select the wall piece, and again Control and L and select materials, and now it will share the same material as before. So it's the last one that you're selecting, the active selection, that is going to be the source for the material to be copied to the other selected items. And that is incredibly powerful, especially when working with a large object like this, where otherwise I'd have to go around and select each one individually, and that would be a real pain in the backside to do. So this is coming along really nicely now. I'm still not too sure on the roof pieces here, and I certainly need to change the colour of that, but this is just a demonstration of how you can move those about. I think the roof does need to be a different colour than the walls, otherwise it does look a bit odd. But of course, now we've explored linking these objects, I've got a challenge for you. I would like you to explore different material choices. So just as a reminder here, make sure you save your file before exploring. With anything you do in Blender that's potentially highly destructive, such as changing materials about willy-nilly, you may want to make a backup of your file or even use save as and progress from there and give your file a version number. Explore different material options for your models in the scene, see if you can come up with anything that's slightly different, see how that affects your scene. And remember to use the linking to quickly change a large number of objects at once. Pause the video now and give that a go. Okay guys, welcome back. Let's hop back on over into Blender. So the first thing I'm going to do here is actually heed my own advice, not device. I'm going to save my work, and I'm going to save as, and I'm going to just add material exploration on the end. And then when we save as, we find that we're working on that brand new file, which is very powerful. We certainly don't want to muck up our original file. And this now opens up the realm for exploration. And I'm going to change to material mode here so I can see a bit clearer what's going on as I move around the model without having to wait for it to render all the time. So one of the things that I can do here is literally select absolutely everything. Now when you do that, it's the last selected object that becomes the active object. So if you had selected, let's say, one of these vaults on the top or whatever you're working on, and then pressed A twice, it's still the active object, the original one that you selected, and then it has everything on it. Now, of course, because I've selected everything, if I go and apply the materials, everything has that one material applied to it. And that is interesting, seeing that brick texture over the entire world itself. Now the question is, have we lost all of the properties altogether? So these are sort of the explorations that you can do. So the answer there is yes, we have. So even though we've not lost things like the displacement modifier and items like that, we have actually lost the fact that I'd set the material to use another texture to alpha it out around the edge here, so it became more and more transparent. My sky texture obviously hasn't changed at all. That's still the default sky. If I go over to my world tab here, you can see I've picked sky texture and I've just left these as defaults here. So that is looking a bit more grayscale than it was previously. Obviously this doesn't change the geometry, however we can use this to change the geometry as well, which is incredibly powerful. So let's undo that. And Blender has crashed. Now, I didn't plan this, but this is a warning that when you start mucking about with things, it's very easy to crash Blender. So I'm just going to click reopen there and see where we were before. So I'm going to open up Material Exploration. It's probably just where the save was before, which was where I was going back to anyway. So let's say, for instance, I select this wall piece in the middle and then go ahead, Shift and select the window on top. I can go Control and L and link object data. And there we go, I've got another window in place. Very powerful for swapping things in and out as well as changing materials. Brilliant. How did you guys get on? Did you do any modifications to your model after exploring different materials? If you have, make sure you share your work in the discussions, and I will see you guys in the next lecture. Welcome to optimizing a UV map. In this video, you will be using Blender Render. So even though we're doing our full renders in cycles, for the actual texture setup and UV mapping, we're going to use Blender Render because it gives us a real-time view in the viewport, which is far better than waiting for cycles to render out. We're going to be making your UV map more uniform, so making sure that we're minimizing distortion and optimizing the image use. We're going to be understanding the use of margins and how they are important. And then we're going to learn more about seams and their placement. So let's now hop straight on over into Blender. Okay, so back over in Blender, what we're going to do is we're going to experiment with optimizing our UV maps, not on our church scene, but on something a bit more complicated. So I'd like you to go ahead and make sure you've saved your work, of course, and go ahead and open up a new Blender file. We are going to go ahead and delete that default cube and add something a bit more interesting to work with. And we're going to add a mesh and the monkey's name is Suzanne. Now that we've got Suzanne in the scene, what we can do is straight away apply a uniform texture across this model so we can see how that texture is being distorted. So we need to be in Blender Render to do this, so I'm going to change my rendering type to Blender Render. I'm going to just pull this area out here and change it to the UV editor. So there we go. So let's go ahead and first of all, let's go and unwrap our monkey without any seams or anything. And we can see there that it is quite a horrible unwrap. I think this area in the middle of this splodge is the face. However, it's not particularly clear, and some areas are they're all packed together really tightly. So I think that's going to be reflected when we actually come to applying the texture. So let's do that now. Let's click on New for a new texture, and this time I'm going to name this actually. I'm going to name it UV Grid, and the generated type I'm going to switch to UV Grid. And click OK. Now this gives us a uniform texture, a UV grid across our entire model, and this will help us identify areas of distortion. We can't see it on here at the moment. Well, we could if we went to textured view, but the problem with going to textured view is that it's shadowed as well, which makes it difficult to see. So there's something else that you can do, and that's enable textures in solid mode. So in the 3D Editor Properties pane, which you can open with N if it's not open already, scroll down to where it says Shading. Now at the moment the option won't be there because we're not in solid mode. So let's go ahead and switch to solid mode, and what we're looking for, textured solid, will appear. Brilliant, now we can see the checkers on there, and I'm going to hide the tool shelf and the properties window, zoom in a little and hop into object mode so we've not got the mesh or all the edges and vertices appearing, and we can see here that we've got a bit of a problem. We've got some areas like around this eye where it's really compressed, where these squares are very, very small. However, around the back of the head, we've got, we've got one square almost taking up the entire back of the head. So there's a lot of distortion going on there. And that would make it very difficult to do anything with that texture. In fact, it will be stretched and distorted all over the place. So how can we make that better? Well, the good use of seams will help with this. So let's go and split Suzanne and unwrap her. Now, one of the best ways of unwrapping a head is going down the back, because the back is not the focus point. So if we go from this edge here and just go backwards, I would select an edge loop, but I'd end up having to undo a load of edges rather than adding them. So I prefer in this case to add them themselves. So we have got a continuous edge around to the bottom of the chin. So let's go ahead and mark that as a seam. Select everything again and unwrap, and let's have a look at how it changes. For a start, I can see the Suzanne's face on the UV unwrap. And not only that, but the model itself, the squares on it, are much more uniform. There's a little bit of distortion around these eyes still, but it's much, much better, much more uniform. Now you can see that one of the problems with generating a seam down the model is there is some distortion where the two halves meet. And it can be very challenging to make sure that these two halves actually match up. Alas, that is a topic for another day. So now we've got this looking a bit more uniform. There's a couple of other things that we could go ahead and do. We could separate the ears and make them their own UV map. And we can certainly add a few more seams to help break this apart. But this gives you a good idea of how to start optimizing the layout of any UV map.
Now, having a look at the UV map itself over here, what we can do is start doing some extra bits and bobs. So in the UV's menu, there are a series of options which can help with distortion. So one of the things is packing islands. Now the islands themselves are these individual items. So the eyes of Suzanne are two separate items, as is the rest of the head. So what we can do is change the distance between those, and this is very important when it comes to games, because you can end up with some horrible effects happening if these margins aren't big enough. So what we can do here is just increase this just ever so slightly, and in the operator panel, and you do have to do this in the 3D editor header, we can change the margin. And you can also do that when you originally unwrap as well. And you can see that moves the actual eyes away from the rest of the model. And in a bit, when we come to painting, that can be incredibly useful. You also get this, as I was saying, when you actually go and do the unwrap, we have a margin there as well. So once you've played with those options, there are a couple of other things that you can do. So you can pack the islands, and that tries to optimize the space on your image via these islands. And then we can also go ahead and average the island scale. Now, it doesn't look like that's going to do much in this case, but if these eyes themselves were much, much larger on this UV unwrap than the rest of the model was, it will help average it out so these squares are more uniform across our model. Another option for us is minimizing stretch with Control and V, and you can use the scroll wheel there to go backwards and forwards, and this can help control the model itself. Now at the moment it looks like a blend of 1 is a good option for us there. And we can also see down at the bottom there, we can use the plus and minus keys. I'm presuming, I don't have my number pad with me today. That's probably the number pad to go plus and minus and move that in and out. Looking at the UV map itself, it's certainly better looking like that. Brilliant. So one final thing to consider when you're placing seams. Now, can you identify where the seam is on the model? So this is going down the back of the head. So if I was to highlight a particular face, so I'm going to switch to face select, let's say this face here. If I was to highlight that particular face, would you be able to tell me where on the model it actually was? If you can't easily work that out, obviously sometimes you do have to think about it a little. If you can't easily work that out, then it might be challenging later on when you're trying to apply textures or even more detail to the model itself. So it's important that you unwrap not only to minimize the distortion that you can have and make your UV map more uniform, but also so it's clear for you to work with, so you're not spending your time trying to work out what's going on. So with that in mind, I've got a challenge for you guys.
I would like you to optimize your current unwraps. So pick an object and check its unwrap. If it's something you haven't unwrapped yet, then you can start afresh and make sure it's optimized from the beginning. Load in the UV texture, image texture, to check for distortions on your model. So go ahead, pause the video now and give that a go. Okay guys, welcome back. Let's go optimize a UV unwrap. Okay, welcome back into Blender. So I've decided to work on my pillar that I've gone, or column. So I'm going to hop into object mode here so I can see what's going on. Now, I'm not sure. In fact, I'm going to hop into edit mode, select everything and unwrap it. I'm going to use a smart UV project to see what I get with that. I don't think I've actually unwrapped this one at all yet, so it'll be a good practice right from the very beginning. And I'm going to add a new image here. And I'm going to use the generated type here, UV grid, and click OK. So this will give us a good indication on our model here of how it's looking. So let's go into texture mode here and just see how that is working out. I've not applied this yet, so bear with me a few moments. Let's go assign a new material, and I'm going to set the color as an image color. I'm going to just go around and do it this way. Untitled. There we go. So I'm not seeing much on when I've got it in edit mode because of all the edges are highlighted, etc. So I'm going to hop out of that and just go around the model and see how it's unwrapped. Now, Smart UV Project here may actually do everything that we want it to, so there's always the chance that I don't need to do anything more. Now, this area around the top here strikes me as highly distorted. We can see it's got loads of joins in it, so loads of little I suppose, folds in on itself. But actually, I'm not too fussed about that. And the reason for that is quite simply you're not going to see it. And that is the best place for distortion, if there is any, where no one's going to spot it. So let's have a look along here. So this looks okay. The squares are all of an equal size. Let's scroll down a little. Let's hit the right key. Let's pan down rather than scroll. Okay, so that is looking okay around there as well. We can see there's a seam there. I don't think that's going to cause us any particular issues. In fact, there's a lot of seams around the bottom. So this is one of the places where I can take an opportunity to perhaps create a new set of seams running straight down the middle so it can peel open. I'm going to give that a go now. So I'm going to hop into edit mode. And if I had preserved my edge loops, I'd be able to select all the way up in one foul swoop. Unfortunately, when I did this in setting, that did break that functionality. However, I should, with a bit of care, be able to continue all the way up the model and... Oh, I've selected the wrong edge loop there. I want that one there. So I think that's all joined together relatively well, going all the way up the top. So I'm going to use Control and E and mark a seam. And I'm hoping what this will do is unwrap it and fold it round relatively concisely. So let's just have a look at the UV map. Okay, so we might need to do something else here. I don't know whether it's meeting at the top. That looks like it needs to be cut open and separated so it's not pinching. But more importantly, what does that do to the actual texture on our object? Does it distort it massively or not? So that looks obviously much better at the top now. That's flowing around really well. We've only got the one seam around our model, so we won't have too much distortion going on. So the top bit there looks okay. And does the bottom look okay? Well, as we can see on the bottom, we've got some... Well, there's drastically different size squares here. So we've got these ones here, and those are kind of similar. But these ones on the bottom, that is very much distorted. So what we can do here is, again, hopping back in forward to and from edit mode, I'm going to decide where to cut these off, and I'm going to, if I can select the first edge loop, there we go, around the middle there, I'm going to add another seam in, and that's just going to completely separate it all together. I can select everything and unwrap again, or of course in the UV image editor, I can just hit E and it will unwrap again. And that's starting to look, well, it looks much better here, and looking at the model itself, these squares seem to be a little less distorted. Again, they are going around and pinching, and I just wonder if that's because of the base here. Well, that looks okay. In fact, again, on the bottom here, we can see they're nice and big, which is great, but we're not going to see it. So we don't really need to concern ourselves with that. So that's looking much, much better now. I don't think I need to do anything around the top here. But again, if I wanted to try and minimize this pinching going on, I could select a particular edge loop. I'm going to select one that's lower down, mark that as a seam. So mark seam there. Now I'm going to go to the very top here and mark the very top edge as a seam. And what that will do is basically separate it into its own circle, and that will prevent the pinching altogether. So I'm going to mark that as a seam, and I'm going to do the same down the bottom. Now, of course, you've got to be careful if you make too many seams, because it can make things a little harder to handle, and we certainly don't want to make things more difficult for ourselves. So I'm going to select this edge loop running around the bottom and also mark that as a seam. And this will be the final one that I do for the moment. I'm going to highlight everything and unwrap it, and we can see there that we've actually got much more uniform size squares. That's worked out tremendous there. That's fine, and up the top here as well. So that's brilliant. actually taking this step at a time and moving forward a little bit at a time, certainly we progress much quicker and taking things section by section rather than trying to do the whole lot at once. Do a little bit, see how that affects the unwrap, continue doing that and cutting it up logically. Imagine you had a 3D object in front of you and you had to try and slice it. That's what all these seams are about. And obviously when we put the seams in the right place, we end up with minimal distortion to the actual underlying texture. How did you guys get on? I hope you managed to optimize your UV maps. And of course, I will see you guys in the next lecture. Welcome to texture painting in the viewport. In this video, you will create a hand-painted texture directly onto your model. And we'll be creating a diffuse map from scratch. Of course, we can create other maps as well, but we'll leave that until later on. So let's hop straight on over into Blender. Okay, so we're back over in Blender on the default Blender file. I'm going to go ahead and we're going to play with this painting on something a bit more exciting than a cube. So I'm going to go get rid of that cube, add in a mesh that is Suzanne the monkey. Now I'm going to add a bit more detail on Suzanne, so I'm going to go to the modifiers tab over in the properties window, add a subdivision surface modifier at level 2, and then click apply. So we've got some extra geometry now to work with. I'm going to turn on smooth shading so it is nice and smooth, and I want to paint on it. Now usually what we would do is we'd create an unwrap of our model and then create an image to paint on. But there is an alternative way to do that, and we'll go ahead and do that now. So what we can do is we can go into paint mode on the 3D editor. So here we go, we've got textured paint at the very top. If we go ahead and click on that, it won't do anything for the moment, it'll just go this bright white colour. On the tool shelf itself, we can see that we can add simple UVs. So I'm going to go ahead and click that. And then we can add a paint slot. Wow, okay, that's incredibly powerful. So I'm going to go down here and pick diffuse colour. And this will add a texture slot straight away. And I'm going to call this monkey base because it's going to be the base colour for our monkey. Now that we've done that, we can literally grab our brush and start painting straight away on Suzanne the monkey. And that is, as you can see, incredibly powerful. It allows us to paint over our entire model regardless of where the UV unwrap has decided to place seams. So that has a huge amount of benefits. Now, of course, if we decide that we want to paint on the image itself, we can do that. I'm just going to open up another window here, another frame, and go into the UV image editor. Now it doesn't seem like there's anything there at the moment. We do need to select the image itself, and there we go, we've got monkey base. And we can see that's where we've drawn over. Now of course if I wanted to paint the whole thing a base colour, I would actually do it over in the UV image editor rather than on the monkey, because as you can probably see already, as we're painting, it literally just is the bit that's facing us. So anything that's not facing us stays unpainted. Whereas in the UV image editor, we can paint everything very quickly. So I can change the UV image editor to paint mode. And I think I can just start painting. Yes, I'm just going to turn my brush strength up. And then literally I can go over the entire thing very quickly. Or indeed, I can apply the entire colour to the image if I wanted to. But there we go. That no time at all. We've managed to paint the whole of Suzanne white. And I'm just going to minimise that back down. So we've just got an idea there. Incidentally, have a look at the UV unwrap there. That's a relatively clean unwrap in terms of I can see all of the details. What I can't see, of course, is how they're all joined together. I think that's probably the top of the head, that's the bit around the eyes, maybe? I don't know. There's lots of distortion happening here where I can't follow the UV map. Now, following the UV map is only really important if you're going to be painting onto it rather than painting on the model itself. So there's pros and cons to working both ways. Incidentally, if we wanted to paint a pupil in here, there's a couple of ways that we could do that. So we'll use a pupil as an example. I'm going to swap it around to a black colour, come to here. I'm going to make sure my brush is roughly the right size and click a couple of times. And there we go, we've generated a pupil. Now, another way we could do that with a bit more control is to turn on, in the texture paint mode, we can turn on face selection masking. When we click that, we can actually go in and right click, and we see that the display has changed ever so slightly, we can right click a certain amount of faces. We can also select the faces whilst we're in edit mode as well. So I'm going to expand my selection here by going to select and select more or less, and we can see the shortcut there is Control and number pad plus or Control and number pad minus to actually select more, and we can see that expands the selection. So let's try that again, Control and plus. And that's it. That's all I'm going to do. Now I'm going to hop back into Texture Paint, and I can literally now whiz over it, and it's masked off from the rest of our image. So there's two different effects there. Obviously one's soft and one's got this sharp edge around where the faces are. But you can see how incredibly powerful that is. Now, of course, we can use this to not only paint a diffuse map, but to also paint a black and white image as to where things are specular and where things are not. Now, of course, you'll have to play with the images and set up a node system to do that, but I think that's a good challenge for you guys. Okay, so I'd like you to go ahead and paint on Suzanne. So you will need to create a new image and apply that image to the model. Now, there are various ways of doing that. Do whichever way is easiest for yourself. And remember, you're probably going to be painting a value if you're controlling something like a gloss shader. So ultimately, what I'd like you to do here is paint on Suzanne to define another shader. So perhaps make her eyes glossy, or perhaps make another part of her glossy, or even made of glass. You know, there's lots of options that you could do. You can pick a shader of your choice. I'm going to probably use the gloss shader. So go ahead, pause the video now, and give that a go. Okay guys, welcome back. Let's go paint a control texture so we can control another shader for Suzanne. Okay, so I have saved my file there. Now I'm going to add a bit more detail to this before I rush ahead and do anything else, simply because it's not going to show up too well if I don't. So this is going to be really rough and ready, and we're going to need, I don't know, a brownie colour for Suzanne. It doesn't have to be quite that. There we go. I like that one. I'm going to ramp up the brush size here and quickly go over and make it all one colour. Looking good. Okay, now we just need to do the eyes. So I'm going to go into edit mode here, and I'm going to just select everything that's to do with the eye. Now, because the eye is actually a separate mesh, I can hit the L key and it selects everything that's linked, and I'm going to hold down shift and hover the cursor over the next eye and also press L. Is that going to work for me? No, we just press L again. Okay, so now that we've got these two areas selected, I'm going to hop back into Texture Paint, switch around to the white, and just colour in those eyes. Now, of course, over on this side, I can just have a very quick look. Oh, wow, look, it's actually separated out the eyes into, wow, several areas. You can see here how this isn't perhaps the best way of making sure you've got colour all over the place, because you do have to move around your model lots, and there may be times when that's not not actually doing that entire model that you want. So now I've done that, I'm going to change that colour to black, and let's make this window a bit larger and make this a tiny bit smaller so I can go in and add a rough pupil. Obviously that's not the best pupil in the world, but there we go. In fact, I could have added an iris in there as well, but I'm not going to. I'm going to leave it kind of cartoony like that. So the next thing that I'm going to do is go ahead and make another image. Well, first of all, let's make sure this one's saved. So monkey base, we've got a star next to image, so it's not saved. Let's go save as image. And I've already obviously been through here, and I've called it monkey base. Now I need another image called monkey gloss. So I'm going to go ahead and create that new image, call it monkey gloss. Again, you can use a shader of your own, whatever you want. And of course, now we need to make sure that that is what we're painting on. So I'm going to go into, I'm going to see in rendered mode what's that's looking like. And I don't think that's applied there. So we're going to have to go over to the textures tab. I'm going to switch to textured mode here so we can see what's going on. I'm going to go to texture tab here and swap over monkey base or image texture here. I'm going to swap this over to monkey gloss, and then we're painting on the gloss. Now, because this is a black equals no gloss and a white equals full gloss, the eyes are still selected, so this is a great time where I can paint white. Now, this is a good question here, whether I go fully white, which will say 100% gloss when we use the mix shader, or a 50%. Now, I want a bit more control, so I'm going to use a math node in a moment to control how much is applied. But I'm just going to say where it's white, I just want it glossy, and I'll control the amount of gloss later on. So let's just go around here. There we go. So the eyes now have 100% on them. So we just need to make sure that we've saved that image as well. That is important. If I close down Blender or it crashes at this point and those aren't saved, that will cause me some issues. So now that I have these areas defined, it's time to open up a node editor. And I'm going to hop over into rendered mode here so I can see what's going on underneath. As always, I'm going to make my scene a little brighter. We've got a lamp in the scene at the moment. I'm going to use a sun lamp here. I'm just going to rotate it around so the face is illuminated so we can see what's going on. That's pretty good. And I'm just going to move around here so I can see our model as well. Okay. That is good enough. Enough of me faffing about here. So I need to go into the node editor now and just control how that's looking. So this is what the material looks like at the moment. Have we got a material applied? Yes, I'm going to make this a monkey material. And we can see that that's what we're working on. So the first thing we need to do is make sure we've got the two textures loaded in. So I'm going to duplicate the image texture node. So we're going to have the monkey gloss and the monkey base. So the top one I'm going to have as the gloss, and the bottom one I'm going to have as the base. The top one being a control texture. It's not a color, it's non-color data. Now those at the moment do not have any coordinates. We've not told Blender how to apply those. We've got a UV map, unwrap, and that's what we've been painting with. So I suggest we use that. So I'm going to go ahead and add an input of texture coordinate. And I'm going to go ahead here and take the UV output into the vector input. So that defines how the image is mapped. Now we're going to need two shaders here, a diffuse shader and a gloss shader. So I'm going to go ahead and add in a gloss shader. So shader, gloss, there we go, glossy. And I'm going to have to mix these two together. So shader, mix. There we go. So I'm going to add those in. Now I'm not sure which order I'm going to put them in at the moment, but I'm going to use the color to define the factor of the gloss shader, basically. So I'm going to plug the color in, and let's see how that comes out. Okay, that's actually the right way round in this particular case, because we can see that the eye has gone glossy. So let's change the color output of the image itself, the brown and the black. There we go there. So that's all very well and good, but what is not happening here is this has just gone 100% glossy, which isn't necessarily what I want to do. I want to control that amount of gloss. So what we can do here is a mathematical operation, and I'm going to multiply the color output by a value less than 1. So if I multiplied it by half, it probably this allows us to control how much of the grayscale we're using there. There are several other ways we could do that as well, but I'm going to try putting in a math. That will be under converter math. So I'm going to pop that in, and we're not adding things together. We are, let's go down here, multiplying. We could divide, I suppose, as well. Now, if we change this value here, we can see that it's going between 100%, obviously at 1, but half will make it actually shine through. The other thing we can do here, of course, is plug in the color into the color of the gloss as well to help it come across. Now I've got control over how shiny the eye is. The base color is obviously controlling the rest of it. Now, what else can we do here? Well, we can change that to glass. I'm just going to change that now and see what that looks like. So I'm going to move that out, add a new shader in here and glass, because an eye is kind of like a glass, isn't it? So let's pop that in and see how that comes across. Oh, well, that doesn't come across quite as well as I was expecting. So I'm going to remove that again and go back in and add in another shader. Let's go in and put the glossy one back. Let's plug the color in. So there we go. So now we can control the amount of glossiness is applied to the eye itself with the base color coming across there. And that is looking pretty good. Now imagine the applications for all of this, and this node structure of course can get as complicated or as simple as you'd like it to. I think that looks pretty good, and we've been able to control this gloss with some degree of accuracy. How did you guys get on? Did you decide to paint some other bits on Suzanne and change how they look as well? Did you choose some different materials, some different shader types? Please share in the discussions, and I will see you guys in the next lecture. Welcome to realistic lighting, or fake it. In this video you will see that there is a fine balance between choosing realistic lighting and faking it. And the time required is often a major factor in working out the path you wish to take. So on one hand we have realistic lighting, just getting everything hyper realistic. Now the issue with that is it can take an incredible amount of time to render, and sometimes you get a rubbish result at the very end. And of course, because it takes a very long time to render, you may not notice there's a problem with it until you spent a very long time doing it. But there are other ways around this issue where we can fake the look we're going for. And we're going to go explore that now and hop on over into Blender. So I've opened up a brand new Blender file, and the first thing that we're going to do is literally just make just a quick room out of this cube. So I've got a cube here. I'm going to go into edit mode, subdivide it a couple of times. Go into edit mode, I'm going to subdivide it. I'm going to bring up the specials menu with W and go to subdivide. I'm going to adjust the number of cuts to there, that's about right. And then I'm going to in face select these 6 here, so we've got some light coming in. But I'm not going to just delete them. I thought I was going to. What I'm going to do is actually separate them into a separate object. And we can use that to demonstrate what we're trying to do. Now in this case I'm going to have to move my camera into my box. So I'm going to do that now. I'm just going to grab it. Now I'm going to have to move it not in the Z direction and just push it in there. Let's see how that looks. Okay, that's absolutely fine, but I'm going to go for a bit of a wider angle. So I'm going to go to the camera properties and go to the focal length and make it 24. Yeah, that should do absolutely fine. So at the moment, we've not got any light coming in our scene. We've got a lamp outside. I'm going to change that to a sun lamp. And turn the strength up, so I'm going to click use nodes, and turn the strength up to 5. And if we switch over to rendered mode, it's going to be black because we're inside that cube. If we were to go and hide the cube 1, which I'm going to name now window, so I don't get it confused with anything, and make that a bit bigger there we go. So now if we render it, we've got light coming into the room. I'm not going to bother setting up a light portal at the moment, which would obviously make it a bit less noisy. So we've got the light coming into the room now, that's absolutely fine. Now if we were going to have glass in the way, we would have this window, we would actually make it a material. I'm going to make this a unique material first of all and change that to glass, otherwise I'd be modifying the original material there, which is something I wouldn't want to do. I'm going to use nodes here and change this to glass. Now when we go ahead and I'm not going to render there, I'm just going to render in the viewport, we see that it's taking absolute ages to actually put any light into the room. It will eventually get there. We're on 3 out of 10 cycles, but you can probably guess we're going to need a lot of samples to get here. Now this is all in preparation for a stained glass window in a few moments that I'm going to be making. However, you can see actually going along the lines of having a realistic room with glass in the windows, it may actually cause you more problems than you think it's going to. You want it realistic, but at the same time you don't want to wait an eon. So after 10 samples, this is what we've got. Not very good. However, what we can do, and this applies to textures as well, if we put a texture onto that plane, all it would be doing is emitting the colour of that plane, because that's all a basic texture would be doing. We can change the surface to a emission, and now that is lighting up the room. Now depending on what you're going for, that could be all you need in order to get the right view. So let's just render this out now and see how it looks. It's going to take a while to go through. And of course, it's just a basic room. So that is absolutely fine in terms of filling the room up with light. I'm not sure how many samples I've got on this render. Let's go have a look at 50 in total. So it's whizzing around there, and that's absolutely fine. Now, of course, if I change the material color and had it red, then it would be as if the room or the glass was tinted red. Now, the downside of doing it this way is you can't see through the window, which means if there's something you want to see outside through that window, this won't be the best way of doing it. You may be able to find a mix of shaders that sorts that out, perhaps putting in a transparent shader as well as something else to try and mimic the see-through ability, well, the transparency of glass. I was about to make up a word there. Dangerous thing to do. So now we've had this preparation, I've got a small challenge for you. I would like you to go ahead and create an emissive surface. So I'm going to be using an image of a stained glass window and using it to fake light coming through into my church that I'm making. Now in your scene, perhaps you have a coloured lamp, or a TV screen, computer screen, or laptop screen in your scene. There are lots of different options that you can go for. Create an emissive surface and see how you get on. Pause the video now and give that a go. Okay guys, welcome back. Let's go ahead and add an emissive surface over in Blender. Okay, so we're back over in Blender here, and I'm going to go ahead and open up my Gothic church scene, and I'm going to import images as a plane. That's how I'm going to bring my texture in. Now I want to make sure it's roughly in the right place, and I'm going to pop it on the back window here. So I'm just going to click to put the 3D cursor roughly in the right place. I can move it to my heart's content in a moment. I'm going to go and add a mesh images planes. Oh, lots of choices here. I can see it there. Stained glass window. Okay, so I'm going to go into, is it textured mode that I want here? Yeah, there we go. I can see what's going on. I'm going to rotate round on the y-axis by the looks of it. No. X-axis by 90 degrees. I think so. Let's move that up and make that a bit bigger. I'm not seeing anything at the moment. I'm going to just switch over into rendered mode. Okay, so that gives me an idea of what's going on there. And I'm literally just going to stretch this image up for the moment. So let's scale it on the Z-axis. That's looking good. And now move it only on the Z-axis until it fills up the area I want it to. Okay, that's looking pretty good. I might actually be able to scale that back down again, but I'll leave it like that for the moment. Now, I know there's a few issues around the top here with viewing the church from outside, or the building from outside, but that's not a problem because my camera view is from the inside. So let's have a look at what's going here, and I can see that it's actually a little bit too high. So let's grab that and move that back down ever so slightly. Okay, now I'm going to, it's already brought in a lot of the properties. We've got an image texture here, but it's currently set up as a diffuse BSDF, so diffuse shader. I'm going to go ahead now and switch that to a emission, if I can see it. There it is. And there we go. We can already see that that's already pumping out light into our scene. Now we can play with the strength. So I'm going to go to 5, and perhaps that's a little bit too bright, so drop it back down to 4. I'm just getting a feel of it here. And of course, the best thing to do is to probably just click render and see how it's looking. So I'm going to go ahead and render the image. Now that might take a while to do. I'm just going to check my settings before I there we go. I don't need to run it at a full 1080p or any stupidly high like that. I'm just going to run a very, very low res version because it's just a spot check how things are looking. Is light coming into the scene? I mean, that's looking pretty good so far. I'm liking what I'm seeing. Now, of course, I can adjust this. It doesn't look like it's actually filling up the entire window like I'd expect it to. But again, those are all adjustments that I can make. But that is definitely letting light in and looking much better than it looked before. It does look like I need to adjust these, or indeed get an image that matches my window, or make my window match the image a bit better. Lots of options there, but that is coming along pretty well. How did you guys get on? What did you add into your scene as an emissive surface? Please post in the discussions. I'd love to see them, and I will see you guys in the next lecture. Welcome to creating a new scene in Blender. In this video, you will learn how to create a new scene. After we've done that, we'll see a way of adding light rays in Blender using the world volume settings. There are other methods to doing this as well, just to let you guys know. However, we're going to be using the world settings as it works best in our case with the building we're doing. So let's hop straight on over into Blender. Okay, so we're over in Blender at the moment, and what we're about to do with the volume settings, well, it only works with spotlights, so the environmental lighting and any other sun lamps or any other lamps that you've got in the scene won't actually work for volumetric lighting, which is a bit of a shame, but that's how Blender is at the moment. Of course, it gets updated regularly, so more and more options may become available in the future. So first of all, what we're going to do is create a new scene. Because we're changing fundamentally how this scene is going to be lit and some of the other settings, we can go into a new scene and then we don't need to worry about it. Now, you may have noticed scene at the top in the outliner, or you may not have paid much attention to it and just worked further down here. Each individual scene is self-contained. It contains the render layers, the world, and all of the mesh and other objects you have in your scene. Now, on the top info header bar, there's a little plus button next to scene. And at the moment, this has not got a name, so I'm just going to call it Gothic Church. And now my scene is actually named. And we can see it's named up here as well, Gothic Church. Now, I'm going to click the plus button here, and it gives us couple of options. We can create a brand new scene, so it'll be an empty scene as we're used to when we open a brand new Blender file. Now this is useful if you're working on something else that's got something to do with your Gothic church or your office, etc. that you're working on, and you want to keep it all in one Blender file. We can copy the settings from one to another, but with no objects, as it says there. We can link objects. Now, of course, the good thing about linking the objects is it means that anything you change in the scene 1 will go across to the second scene as well that we're about to create. Link object data, so we can do that as well. And finally, a full copy. Now, that will make a copy, but changes will not go backwards and forwards. And I'm going to select full copy in this case because I just want to work on it as is in isolation, essentially. So I'm going to go ahead and click full copy, and it's called Gothic Church 001. We're used to this by now, and I'm going to call this light rays because that's what it's all about. So I've got this indoor scene here, and we want to add light rays to it. Now, there are various ways of doing it, but the best one is the world option. So I'm going to go over in the properties menu here to the world options itself, and under volume, there's nothing currently selected. So let's go to volume, and where it says none, we can change that, and it needs to say volume scatter. So I'm going to go ahead and click on volume scatter. Now, a density of 1 is relatively thick, and that's not going to produce a very nice result. Now, before we go and start playing with these options, I'm going to go into the render tab of the properties and just scroll down, and I'm going to change my light paths to direct light. That's just going to make it nice and quick to render. Okay, so now that that's been done, I'm going to go back to the world properties, and on the density, I'm going to turn that down to about 0.1 for the moment, and I'll see how that goes and adjust it from there. The other thing that we may want to do here, just to speed up our volumetric calculations, is under the settings, we can turn on homogeneous. And we can put a tick in that. And that just makes it quicker to render. Now, in this equi-rectangular, the volume settings just here, the equi-rectangular is good for outdoors, and the distance is for sort of indoors lit up by the sun outside and things like that. So, or if you've got a mixture of things, you can go for multiple importance. So I'm going to set that to distance. Okay, so now that I've got the scene roughly set up, let's just move on over into rendered mode and we can see that it's pretty dark. And the reason why it's pretty dark is because the light in our scene comes from two places: a sun lamp that's placed in the scene and the environment, none of which affect the lighting calculations when we're doing volume. So what we need to do here is go over and find our lamp, or if you've not got one, you're going to have to go and create one. I have got a sun lamp in my scene, so I can go ahead straight away and change that from a sun lamp to a spot lamp. Now that's not going to be good enough just yet, because what happens with a spot lamp is the light falls off the further you get away from it. So we need to make sure that that's constant. So what we can do here is go into the node properties of that particular lamp. So we go to the node editor and we can see that there's a lamp output, the surface, and it's an emission, which is great. And the strength is currently at 5. If I put that at 50, we might be able to see it. 500. No, it's too far away. It's not actually reaching the church building itself at the moment. So what we can do here is set this strength, the light fall off the further away it is, we can set that to a constant value, so it acts more like the sun as it goes through the scene. So we're going to add a node in here. So if we go to add and go to color, we see there's an option here, light fall off. Of course, if you know it contains fall off, we could go to search and type in fall off, and there it is. So now we've got that, we can line up the constant output of the light fall off with the strength, and then turn the strength up to 350, 400, something along those lines. Now, it doesn't seem to be affecting our scene at the moment, so there's a couple of things that we need to check. I'm happy with everything as it's set up here, but what I don't know is where the lamp is and where it's pointing. So that's quite important. So I'm going to go into solid shaded mode. Okay, so the lamp's over here and it's pointing into the building. So that looks pretty good to me. Quickly render that and see if it's lighting up the outside. We can see here it's getting through here. Now I think that the light is actually being absorbed by the volumetric shading that we've got going on in the environment. So what I'm going to do here is still looking from the outside, because that lamp is, it's not even lighting up the ground, so that's no good. Let's go ahead and go to the world properties here and scroll down. The density here, let's make it 10 times lower. Let's go 0.01. Aha, that is much better. Let's see what that looks like inside as well. Aha, that is looking much, much better now. Now, it's still a bit dark in there, and that's where we can use a couple of tricks to bring the light levels up. Now, at the moment, because we've got the light paths on the render tab set to direct light, there's not that many bounces going on. Certainly by changing that to limited global illumination or full global illumination, or just changing these settings here, so for instance increasing the number of diffuse bounces, the volumetric bounces as well will help here. So what we can do here is literally just render this out and see what it looks like, and then take a base from there. Again, make sure that you've got a relatively low resolution, because doing volumetric calculations is going to take a while to do. Now, of course, this, I don't know quite how it's going to look when it's finished. It looks like we've got some rays coming in. It's looking pretty good there. Okay, that is looking pretty good. Now I'm just going to pause the render there, and I'm going to switch to another render slot to perform the change test. I'm going to knock the diffuse back down to 0 and go ahead and render that again. Now this is going to be slightly quicker in its processing, but it's going to have less bounces in the scene. Now that is a style choice, of course, if you want to add more realism with the different bounces, but this is going to end up much darker because light is not going to be bouncing off certain areas, and we can see already it's had a it looks much more contrasty. So that's with one bounce enabled, so you've got some details where the light is not directly hitting, And if we go to here, we see that it's a much darker image, but I think that's a bit more atmospheric as well. So there's a kind of a toss up there between your style choice that you want to go for. That looks pretty good. And of course, with that, it's time for a challenge. I would like you to go ahead and add volumetric lighting. So you may have to use CPU rendering for this, depending on your graphics card and depending on your version of Blender as well. So bear that in mind if it's not working for you. Create a new scene and then add some volumetric lighting to your new scene and see how that comes out. Pause the video now and give that a go. Okay guys, welcome back. I'm going to hop back into my blend file now and just see if there's any optimizations that I want to make and see if we can make the scene even better. Okay, so that's looking pretty good. Obviously that's pixelated because of the amount I've turned down the resolution. I've put it at 25% of 1080p there, but I quite like that dark atmosphere, and I think if I could just bring that up just a little, it would probably make a much better impact on my scene. So with that in mind, I'm going to try, let's scroll down here. Let's try turning up the amount of bounces that happen through the volumetric. So the light that's coming in, let's see if turning that up adds to the ambience of the room. I don't want it much lighter than it already is. Adding one to the diffuse actually made it too bright for me. Let's go ahead and render that and see how it looks. And obviously pick a new render slot before I do so. Otherwise I won't be able to compare one to the other. Okay, so this render here is coming up to the end of it, and it's different to the first one. It's certainly lighter, and that is adding a lot of definition here in the pillars, in the columns that are there, and I like that. That's sort of bringing that forward. It has made the scene a little noisier, presumably because of those volumetrics. So what I need to do here, of course, is render it at a much higher sample rate. I'm happy with how that's looking at the moment, so I'm going to render it now at, I'm going to render it at a higher resolution for a start, so it's going to take longer to do. And I'm going to render it, I'm going to do the full screen render. I'm going to leave that. 500 might be a little high, but I'm happy to wait. So I'm going to go ahead, hit render, and I will see you guys back in a few moments. Okay, so here we go. Here's the final rendering. It's still a bit noisy, but more samples will certainly sort that out. But this is looking pretty good. It's got the right sort of definition in there. I can see some detail in the dark areas, which is awesome. That's exactly what I wanted. How did yours turn out? I'd love to see them. Remember to share them with us so we can all relish in your wonderful creations. And of course, as always, I will see you guys in the next lecture.
Congratulations, you have now completed this section, the game asset pack. Now there's still lots more that you can do to reapply the knowledge you've just learned, and I suggest that is one of the things you do almost immediately, is jump straight in and do another asset. Now I must impress, make sure that you make your challenges as small and succinct as possible. So make things that are simple to make. I know we all want to jump out and make a spaceship or make an aircraft or make a fast car. I mean, all of these things are noble goals. However, they are monumental. A car is made up of what? Oh, hundreds of pieces. So you don't want to start with something that's made up of hundreds of pieces. Start with things that are made up of one, maybe even 2 or 3 pieces at most, and see if you can get those imported into your assets. And that is one of the best things to do with any modeling as you develop your skills, is to make sure you can actually achieve your goals in the first place. So congratulations on getting this far. So of course, after this, we're moving on shortly to modeling a human head. So if you feel that you've absolutely mastered everything in this section, and if you say yes immediately, you're an absolute pro. If you're saying yes otherwise, then perhaps you've got to go back and try some other things. And of course, don't forget you can go back to some of the earlier sections of the course and reapply your knowledge. A lot of the time we find that students that have done that have learnt even more because they're no longer thinking about the lessons they were taught taught in that particular lecture, they're actually now focused on other more advanced things and work out different ways of doing things with the simple models we were doing earlier on in the course. Now, of course, once you're ready, hop straight back into Blender, get onto the next section and carry straight on. And I will see you in that next section. Take care.